120 grand. I'd spend a bit of time. Spend a bit of time writing stuff out.
How many Bitcoins? 500 G's? How many Bitcoins you put up? That's like 10 Bitcoins, bro.
2 Bitcoin.
2? Bro, how many Bitcoins is it? I'm about to try to prove the globe. It can't be done, though, because I would have seen it already if there was some kind of definitive proof that would sway Dave Weiss.
Every dollar that I have, if you can prove it. I can sit in a corner and just say, nah.
That's what you're doing. You just said, nah, the water existing.
No, I'm right. This is why I'm offering a level playing field. Because you decide what compels you.
Yeah, something definitive compels everyone.
Determines what's definitive.
Definitive, like water existing, something that's undeniable and objective.
Well, again, I've just been through why we can deny water exists. I'm a brain in a vat, and you're just a figment of my imagination.
That's just like I said. You've gone past the point of absurdity now, Ruhif. This is ridiculous.
But do you understand that as Globers, we think you're absurd as well? Do you understand that?
Brains in vat, absurd, really?
Oh, not far from it. Not far from it.
Riff, come on, stop. Just stop.
Okay, I'll stop. You didn't expect that, did you?
That's changing the focus from whether or not, the shape of the earth is this way or that way to whether or not we're in a brain in a vat. We can only handle one question at a time. And I think we can handle the question of the shape of the earth quite easily without going to whether or not we're a brain in a vat.
Hi, Lemon.
The brain in a vat is just a way they can say, it's the thing they use to say, oh, we can never prove anything because we could all be brains in a vat and the water doesn't exist. However, in our reality, even if it doesn't exist in the brain in the vat reality, in our reality that we're in now, all of us sharing this brain in a vat reality, the water exists in that. So it doesn't matter if it doesn't exist somewhere else. It exists to us. It definitively exists.
Even you saying we have a shared reality can be, contradicted by a brain in a vat. I could be the only brain in a vat, like pure solipsism.
Okay, if me and you are face to face, we got a bucket of water, a pool, bathtub, I don't care what, and we go in there and we say, "Look, here's the water." We could touch it, feel. Who's denying the water?
Yeah, again, that's all contradicted.
How can you say that water doesn't exist? So you can say that water doesn't exist. Okay,
I'm a brain in reality, both you and the water are just, the electronic signals sent to my brain.
Okay, but in the reality you're in, of this brain in a vat reality, the water is there and it exists, right? That's what I'm talking about.
But it's a false reality. That's not reality. That's just a figment of my imagination.
Bro, well, this is reality.
We could be a brain in a vat, Ruhif, but how do you know that, paratroopers didn't storm the lab and knock over the vials in which our brains in a vat were residing and were not dead? This could go ad infinitum. You need to say what
it actually can't.
The possibility beyond, just pure solipsism. Otherwise, it's just trivial and meaningless.
No, the brain in a vat stops when you say, I think, therefore I am. I think that's the stopping point. That's the one thing that I can say for certain is that I exist in whatever form that may be. If I didn't exist, I couldn't have these thoughts.
This brain in a vat thing's nonsense, If I can't go down the road with
you. Even Earth, Jeremy. You guys aren't too far from it, honestly.
So you're trying to use this as a tool to show how ridiculous it is, not for serious exploration. So at that point, you need to state that that's what you're trying to accomplish in the discussion, as opposed to being a serious part of the discussion. You need to state that you're using this as a tactic for dismissal rather than serious exploration.
No, not for dismissal. I'm trying to get you guys to appreciate that I've offered a level playing field, because you guys can deny everything and do deny everything.
We state the reason for the denial. We don't just deny it without an alternative. If you're talking to people that have like the AE map or the Gleason or some sort of alternative, it's not just outright denial. It's another alternative.
Right. And Lemon, honestly, you're the one of the only people who have actually put forward a prediction, which is awesome. And you gave the correct flat Earth prediction, right? But vast majority of flat earthers, well, actually, you're pretty bad at word salad as well. But when I ask for a prediction, they'll give a post hoc explanation. That's right. Oh, it's because of perspective, or blah blah blah. And that's why predictions are powerful, because if you actually understand what you're saying, you can use that knowledge to make a prediction for a observation that you don't know the conditions for, or the inputs. And you did. You actually made a prediction. I wish more people would just say, "Oh, I'll go with Lemon's prediction."
Well, the nature of the prediction from the globe is just based off of key assumptions that need to be questioned. Namely, that the horizon forms because there's a hump of Earth curvature in the way that gives you a math fraction of your height, 6 feet roughly, divided by the distance to said hump, equals the other side of the equal sides fraction, which is the distance to said hump, roughly 3 miles, divided by the distance to the other side of the Earth. Based off of that assumption, you cobble together a ball, but that assumption is really specious.
Okay, so then to make it level, to make it an even playing field, how about you? You're basically claiming that I'm sort of reverse engineering a globe. Please go and reverse engineer a flat Earth. Demonstrate, give us a model, show us how it works, and use that model to make predictions for what we should see if we go make an observation.
We could get a rough
estimate, right?
We could get a rough estimate, but basically it would be based off of the diffraction limit. Basically, looking down a hallway, we see general behavior where the ceiling appears to ramp down toward the floor, which ramps up, and you get a horizon line in the middle. We'd have to get some math formula off of that.
Okay, go and do it.
Well, Rehab, I want to go back to something Jeremy said a bit earlier, which is we can use a balloon to sort of establish about a 1 kilometer optical corridor. Wouldn't that make things like the fact that we observed that plumb bobs are not parallel valid then? Because he can't use his optical corridor because we just need one observation to establish that actual, refraction difference.
Hang on. Are you trying to use the weather balloons to establish that plumb lines are not parallel?
No, I'm just saying if we're up at altitude, so if we take that reading at, say, 1,000 feet, the same as that balloon would be at 1,000 feet, and that observation is good for a kilometer, 500 meters either side of the observation, which brings in things like plumb lines not being parallel to now be an argument that he should accept.
Sorry.
Because those measurements are done way under a kilometer, which means we've got a reliable refraction that we can utilize as an average, which means we can show that it's below the tolerance of the measurements that we're taking, which therefore means, ergo, plumb lines are not parallel because we've measured them.
Well, we're measuring plumb lines, which are physical objects hanging down physically toward the Earth, via a visual readout through a theodolite. And with the diffraction limit making everything merge and smash and smush together, like looking down the hallway with the ceiling ramping down toward the floor, you can't do that. That's a little bit too...
Over 400 feet, Lemon?
Even within a small distance.
Well, what's the limitation of your diffraction limit that we can't do this to? Is it 10 feet? Is it 100 feet? Is it 1,000 feet?
I don't think Lemon can actually describe what the diffraction limit formula is.
The diffraction limit basically says 2 separate light sources or 2 separate objects will appear to merge into one unresolvable light
criteria.
source.
Yep.
So that applies when you apply it properly to the ceiling object 1 ramping down and merging with the floor object 2, which is ramping up, and the 2 zones smashing together into unresolvability.
Okay, so something like Canigou, right, where we have 2,500 meters of mountain not visible, that's so far, like so much bigger than the diffraction limit. So how then is the diffraction limit?
Smush, merge, converged, gone. That's it.
Right, but these points are 2.5 kilometers apart, right, which is way bigger than the diffraction limit.
Well, the diffraction limit mathematically is one thing. The math numbers may give us one prediction, but the general principle still appears to be there, where the ceiling merges with the floor.
You started off describing the diffraction limit well, in that it's 2 points that. And now you're saying 2 points that are way outside the diffraction limit can't be resolved either.
The principle still appears to be there, though, with the ceiling being object one, or rather the part of the mountain that's at a constant elevation, ramping down into the floor and merging and becoming unresolvable.
Yeah, but I'm with this particular observation, Kanagu, I did the maths on it ages ago. The diffraction limit with, I think a P900, the diffraction limit meant that points of light that were 4 meters apart could not be resolved. Right? This is 2,500 meters. They can be resolved. So why can't I see the bottom of the mountain?
Probably diffraction mixed with some level of refraction. Air layer that you're seeing through that's blocking what's beyond, like looking out over the asphalt over a hot day.
Okay, so instead of word salad, please come up with a prediction. This is why it's important. It shows that you understand how things work.
Ruhif, you can't just add math to everything. You can't do that.
If my maths makes accurate predictions, I'm pretty confident that my maths is correct then, right?
Your math doesn't make accurate predictions. You have to cobble together refraction and other ways to pad your formula to explain why we see way too far over the hump of Earth curvature. So even your math.
Which observation do you think is a see way too far observation?
Let's see. We have the Canigou Mountain observation. It should be hidden by a huge hump of Earth curve.
Okay, so are you denying that light bends?
Canigou, what was that?
Canigou is good. Let's stick with Canigou. All right. So I contend that light bends.
You're cutting out.
Sorry?
I contend that mine and you cut out.
Sorry. Do you accept that light bends through a density gradient?
Not quite. Bend like a string? No. Does the path appear to deflect? Sure. So I guess, yes, let's keep going.
Okay, so that's explains Canigou then, right? Light bends. You can see more of it at the end.
No, that doesn't explain it, because we don't see light bend like a string unless it is collimated and concentrated into a shaped beam of laser light. Most of the time, light doesn't behave like that because it's not a laser.
Why is non-laser light immune to refraction? I don't get it.
I already explained that laser light is shaped and concentrated and shot out through a hole to give it a shape. Most illumination is like that. It just fills up and suffuses the medium. So we have a huge category error there.
Are you a photon denier? I'm guessing you're a photon denier.
You're invoking them being the same when you don't really have reason for them to be the same. If a laser poked you in the eye, Ruhif, you'd be blind. But most illumination is not that energetic or that concentrated to poke your eye out. So you have a serious category error there where you assume they're of the same nature when they may not be.
I actually think you're making the category error. Do you deny photons? Do you deny photons? As in having a wavelength and a frequency?
I don't deny photons. Well, they are kind of questionable. It does seem like an arbitrary division of energy. You don't really have anything with an essence beyond the arbitrary abstraction. So you could be making a photon quite easily something that it's not, without something to make the photon concrete. But okay, what about photons?
I'm missing why you say laser light does refract, and whatever the opposite is of laser light, the other light doesn't refract. Why are they
different categories? Disagree, Ruhif, but when you give light a shape by shaping it into a concentrated laser beam, of course it is going to bend once it has a shape. When you have shapeless illumination that fills up the whole medium, that's where the category error becomes apparent, because as far as we can see, light does not have that shape to bend.
Okay, so what is happening in the Deng Jos experiments where he pours like liquid nitrogen or butane or whatever? Is that not light bending? How is that? How is it not light bending? What are mirages? What are mirages if not light bending?
Duplications. You see
Yeah,
the
how?
original object and you see it duplicated in an air layer above the object. We do not see this over long distances over the Earth. That is simply assumed so that your model can survive and you can lift an image up over a ball. But you haven't proven that that's the case at all with the original image and then the duplicated refracted image on top at all.
Right, hang on,
So
you just
the
said
problem.
duplicated refractive image.
It's the same with your straw and water. From air to water, you see a noted break in the image and you see reflection between the air layers. This is not
Yeah,
seen
but
over the ball. So it looks like
we're
at best we're seeing a hazy object that's right there over the flat plane, just a little hazier. That's it.
right. We're trying to establish whether light bends and in which direction it bends in the atmosphere.
I already said that unless it is a string that can bend, no. Does it appear to change its path? Sure. But it doesn't appear to have a string shape to bend. So that's a
Okay.
bit of a problem.
So again, I bring up Dang Joss and just the fact that we see inferior mirages and superior mirages. How are they explained without light bending in our atmosphere?
We'd have to explain it in a different way without appealing to light being a string that bends.
Okay.
You could have the
There you go.
air
See,
layer
there's
just show an image like a reflection or a mirror.
right. So there's my sort of demonstration that you guys will just deny everything, right? Which is why you guys need to come up with your own model to make
Well,
predictions.
I didn't deny it, Ruhip. I just had a different explanation because we don't see strings of light that are bending. That's a bit of an abstraction.
Anyway, this is as pointless as always. So I'm going to go and have some breakfast. Yeah, my challenge is still out there. Any amount of money you like to take evidence to a neutral third party, and you guys will never do it. So, all right, brekkie time. Catch you guys. Oops, hang on, fuck. Catch you guys later. See you.
Peace out, Ruha.
Colloquially, I would say light bends, yes. But light doesn't appear to be a string that bends per se. So saying that it bends on that level is a little problematic.
Well, we're just trying to see if the refraction is force pushing the light up or down on average. That's all he's saying. He's not talking about light being a piece of string.
Well, this theory of refraction is used to lift an image up over a ball. And it's hard for me to believe that that's the case unless I see the original object in its original position with a duplicated refracted image on top of it over the ball. It's just, I can't believe that because it's just too much like begging the question.
Well, cool. If you think that's the case, then fine. I mean, for me, refraction works regardless of the surface that you're standing on. It's still absolutely fine. You can demonstrate that multiple ways in a lab, and we observe stuff in the outside world around us.
But I
don't see, no idea.
But we have two types of refraction that lead to two different types of conclusions. We have magnification, where the object's right in front of your face over a flat plane, simply hazy or distorted or diminished. And then we have the type of refraction that the ballers are invoking, which is where this image is being lifted up over an obstacle through progressive air layers. We don't tend to see that.
Well, wouldn't magnification make something larger, not smaller?
Yeah, but it would be right there with no obstruction.
Yeah, I mean, I agree with you. If the Earth was flat, then, I should be able to see stuff a long way away and, within reason, even see the very bottom of that stuff, especially as I gain altitude. But what we observe is thousands of feet are a mountain for you, for some reason, you think are smushed at the horizon line, which makes no sense because, I can literally read the writing perfectly. There's no distortion, there's no gradient to that effect. Just bam, it's on. That doesn't make sense to me, Lemon, and that's one of the problems I've always had with your so-called argument.
You're sneaking in the premise that all of the image should be resolvable at any scale. No matter how far away it is, that premise may not follow. There may be a limit to the resolution of the eye or the instrument, even over a flat plane, that makes things flatten, especially toward the surface and or the eye level of the observer.
The fact that I can read writing on the side of a boat using a pair of decent binoculars, and some of that writing then starts to get suddenly obscured, doesn't sound like you're getting towards a Rayleigh criteria, which says you'll see a blurring and a merging, rather than just suddenly it's two lights and then one light. That's not what the Rayleigh criteria says, is it?
You would have most of the squishing toward the surface, as long as it's at a wider angle up and away from the surface of the eye level.
The Rayleigh criteria
it's still
says,
beyond the angular resolution of the eye and able to be made out as a 2D image.
That's not what the Rayleigh criteria says. Going back to my point rather than the question you tried to answer, that's not what the Rayleigh criteria says should happen, is it?
What does the Rayleigh criteria say should happen then?
That two objects will become more and more blurred as they merge into each other as you get towards distance until they're unresolvable.
Yes.
Not
and
suddenly go
with the
click.
image being squished and unresolvable.
U, but now I can't see the bottom of the U. I can see the O. Suddenly I can't see the bottom of the O. That's not a problem of angular resolution. That's not a problem of being able to resolve the image. That's a problem of obstruction.
But as an object gets further and further away from you, more information is crammed into the same visual space. 2 times as much, 4 times as much, 8 times as much, whatever. And as objects get closer and closer to the surface, you're just not going to be able to make a 2D image off of the surface where everything's just cramming and converging. So it looks like the interpretation is easily there.
No, it really doesn't, because it's a sudden thing. It's not like, oh gosh, it's getting closer and closer and closer to that limit, and now we've reached it. It's cut off, suddenly it's obscured, and not any form of gradient. And that's the term you keep ignoring. There is no gradient to what you're saying. It is a sudden obstruction.
So a horizon would form in the foreground, based off of 6 feet up and down from the level of the eyes. These two zones smash together and merge, and make a horizon line in the foreground, beyond which anything that's taller in the background, like your 500-foot boat or whatever, will simply have to set behind a wall of light, if you will. The principle is obviously there and demonstrable by simply looking down a hallway.
Well, in a hallway, it gets smaller and smaller and smaller until I can't resolve it. At no point does it suddenly get cut off. And that's the problem with your argument, Lemon. It's the fact there is no gradient to your observation. And even when we use magnification to remove the problem of angular resolution, we still have that problem. So we know it's not a limitation of the eye. We know it's not a limitation of the optics. It's got to be something else, because I can clearly read the writing on the boat, which suddenly starts to get cut off. That's your problem.
As long as you're above the surface and above the level of the eyes, you're good, if you have a wide enough angle. But things will cut off suddenly if you get right close to the surface in this zone where this smashing and smushing is occurring.
Suddenly, there are no gradients at all. Mm-hmm. It just happens. Okay. And I would like to see you produce any form of evidence. Now, I can show something being obstructed, and I can show the writing being clearly visible. And then when I obstruct that writing, all of a sudden it disappears. Can you repeat that same experiment using your smushing and mushing in, say, a lab?
Ray-Chi 50 has already done it practically. Life is Short has done it practically. P-Brain has done it practically. Actual demonstrations that go beyond bland theory and go into real life.
I don't think so, sir.
So you get close to the surface, and all of a sudden you have bottom-up obstruction. So it looks like
what I want to see is writing.
Some sort of diffraction, refraction thing going on.
What I want to see is writing that I can read that suddenly starts to get cut off, regardless of the amount of magnification that I use.
So with a consistent application of the principles, Foolish, we see a horizon forming in the foreground based off of how high you are up above the ground. If you're 6 feet above the ground, that portion of your vision from your eye level down to the surface for a 6-foot person pairs quite nicely and symmetrically with a 6-foot portion of visual space from the level of the eyes up, like looking down a hallway where the ceiling is 6 feet above your head and the floor is 6 feet below your eyes. These two zones will
I
connect
accept you
together,
can't
make
do
a
that
horizon,
experiment I
and
asked for.
anything that's taller than that, Foolish, will just simply have to set in the background.
Yeah, that's fine. I accept you can't repeat. You can't do the experiment I asked for. You can't show that observation.
Experiments are one thing, Foolish. Consistent interpretation, theoretically and philosophically, is another. And the Globers appear to be lacking that. When they look down a hallway and forget how the ceiling and the floor will merge and make things unresolvable even over a flat
But I
plane.
can use a telescope in that corridor or a pair of binoculars, and I can bring everything clearly back in. We can go and see exactly where it says fire exit, or the bottom of the door, or if it's strong enough, the keyhole in that door at the end of the corridor. I can do that, and I can do that consistently. What you can't do is show me how something, where I've got nice clear writing that I can read, like ceiling, that suddenly is getting cut off by an obstruction, by something obstructing it.
You can only do that up to a point, especially if the thing is poking out of the surface, where a whole lot of merging, smushing, and smashing is occurring.
As I said, I respect the fact that you cannot reproduce that in experimental form, and that Reishi and the other guys failed to do that. That's cool.
Let's
Look at the world of Sir William Stott, I believe his name is.
Yeah, Lemon left.
That happens.
Let's move down to back to the voice chat.
No worries, man. Well, thank you for letting me in, by the way. I really appreciate it.
Yep, no problem, Joss. Always love to hear you talk.
I'm getting way more patient in my old age.
Yep. And I'll just pitch this Fridays at noon Pacific Standard Time, 3 p.m. Eastern Standard, and 8 p.m. Eastern. I'm doing this open mic hour where you can do spoken word or musical performances. So
it's really cool, actually. I really like that. I really appreciate the space.
Yeah.
I'll drop back down to the normal voice chat.
Yep, coolio.
Come on, Demok, let's get you unmuted, mate. That's really good.
Check, check. Did we make it down all right?
We're all here.
Yep, hear you.
Cool.
Evening, Jeff.
Hey, how's it going, Dress?
All my dimensions are coming together.
All right.
Well, Rumpus is here. Let's see what he thinks. If 1 kilometer is good enough, or are we guessing if we just do every kilometer?
Sorry, I've only just come here. I have no idea what you're talking about.
Basically, we've got some good news. Jeremy basically says from a single observation, we can establish an optical corridor of 1 kilometer at altitude.
All right. So we have an optical corridor. Now, how often do we need to measure in between the points of that optical corridor to know that the light's doing what it's supposed to be doing. The refraction measurements, temperature, pressure, humidity.
I'm going to take your criteria, which is every 500 meters. So we can get 500 meters either side of an observation. I'm going to use your method. I'm calling it the Jeremy criteria.
That's not.
I still don't understand what you're talking about. You can have, of course, you can have a 1 kilometer optical corridor. When we're looking at a star,
Yes.
we've got a 10 billion light year optical corridor.
All right, but if you want to know how refractions, what's happening with the refraction in between it, how often do you need to measure the points in between it with the temperature, pressure, and humidity and all that?
Well, surveyors actually only bother to measure both ends, even if it's many miles. But so they've established that through practice that that's enough to do it. And the gradient, unless you've got a sort of cold front or something coming through, the temperature's pretty uniform if you're going along sort of similar terrain for miles, really. And I'm going to be and I will be testing this in my rect thing. I've got this 6 mile thing, and I've got at least 3 thermistor arrays. One at each end and one in the middle, and I'll be able to.
How far are you doing?
6, as I said, 6 miles.
And you're only doing 3 points, bro.
Correct. Yeah, but if they're all the same, I think I can draw the conclusion that the bits in between will be the same as well.
You got to do 12 at least, bro. I mean, I don't even think 12's enough.
Well,
listen, we're a lightweight. Pretend we're a lightweight. Hold on.
Well, you have no idea, do you? You're just guessing.
Where this number comes from?
Surveyors do it over miles and only have, if they bother with 2, they normally just bother with 2. My one, I'm going to have 6 miles and I'm going to have 3. I think that's more than adequate.
All right, Rumpus, we're a light ray. All right, we're a light ray. We're traveling along, right? Yeah. We've just went 30 feet, and over that course of 30 feet, we've changed our direction. Now our path is different. It's on a totally different path. Yes,
the atmosphere will not change even in dramatic conditions. What happens over 30 feet?
Slightly in the first 30 feet will be dramatic at the end.
Barely even, I think slightly.
I used to do construction. If you mess up in the beginning, a little tiny bit, you will be off by a lot at the end.
Yeah, but 30 feet, you're talking about refraction. Yeah, you're talking about construction if you get something wrong in terms of your measurement. We're talking about
tiny little angle.
Light bending over... Light in the atmosphere does not bend strangely over 30 feet.
I'm talking about tiny little amounts in the beginning will make you be off massive amounts at the end.
Yeah.
But that's not linear.
What's up?
Well, I'm not sure if they'll be linear, right? You're talking about, for example, if for example, if in between you have the same temperature in both ends and in between of those ends, the difference that you're saying would be if between those 3 points things were different, right?
I'm telling you, you don't even know if the light ray is going through that middle point because it could have already changed positions and now it's at a different spot. Because it could have been off a low angle at the beginning and it could have been kept being off a little bit of an angle, and now you're measuring a spot that doesn't even matter.
Light does not bend dramatically, as you always seem to be.
If it was that sensitive,
that's your claim. That's your claim, Rumpus.
No, Jeremy. It's not my claim. To get the black swan, do you know how much it has to bend to generate the Earth looking flat over this 10 miles of the black swan?
A little tiny bit at the beginning, and then you have a tiny bit, and it makes it
at the beginning.
And the angle's not changing. The deviation is not changing.
Don't know that.
We do.
We do.
We do. Yes, we know this.
Jeremy,
it's been subject of scientific analysis for over a century. That level, even in mid-Victorians.
Jeremy, if it was that sensitive, if the path of light was that sensitive, images images that are far away will be very turbulent, but they're not. They're pretty much static.
If it was that sensitive, shit would be constantly moving in our vision. All the time. Oh shit, yes, that's what we see.
Yes.
Moving in our vision up and down.
No, but it takes hours for that to happen.
Look, you can see the effect of all this by just looking through a theodolite and then seeing how much things move up and down. That's so you can get an idea of the scale of the changes that are caused by refraction. And it's tiny. but it's enough to make something go up by, say, a degree or something, if something you're looking at something 10 miles away, to make it look flat or not.
Yes,
I mean,
we know a tiny bit at the beginning
right,
will
so
make
it's
it
not
be up a massive amount at the end. We
right.
know.
So it
The
can't be
direction
changing
don't.
over 30 feet, can it? If it's only changing by fractions of a degree over 10 miles, it can't be changing dramatically over 30 feet. You won't be able to
Jeremy,
find.
Listen, if you're
In fact, so it is so small you would not be able to measure it.
Jeremy, the path of light isn't changing just in the beginning. If it
it's
changes
changing the
just
whole way, I know.
exactly, so if in a smaller fraction of time, it changes a little bit less or a little bit more, that doesn't accumulate the way you're thinking, because
If
that
you
only
have
affects that part. When we're
if
talking
you
about
have
the
measured
angle of light.
Rumpus,
if
hold
you
on. Let Bacon finish, then I'm going. Please,
I
Rumpus.
did.
Let's have a little be civil about this. You're all done, Bacon. All right. I know
Well,
it changes
maybe
the
I
whole.
didn't hear it because we spoke at
I
the same
heard you. I'm going to
time,
respond. No, I heard you.
right?
So I realize it's changing the whole path throughout the optical corridor. However, once it changes over that first 30 feet, and you're measuring a different spot, you don't even know where to measure because you don't know that it hasn't changed in the first 30. Did it go up or down in the first 30 feet? You have no fucking idea.
you
So now
do.
you could be measuring a
It
totally irrelevant optical
it
you
is
corridor.
look
not that sensitive.
at things that are like the black swan and they are 10 miles away and you had a substantial change in the angle over 30 feet, the effect would be dramatic if you were looking at an object 10 miles away. The
All right, Rumpus,
object,
my bad,
hold on,
go ahead.
yeah. So an object, say, 10 miles away, if it was at any substantial angle between you and 30 feet, and let's suppose it was not refracted after that point, then the change in the angle of the position, the absolute position of something like the black oil rig would be huge 10 miles away. It can only be absolutely tiny. So there's no point in measuring. It's probably beyond measurement over 30 feet.
All right, when you're doing your...
When they, for instance, when they do a laboratory, they measure the change in refraction. I don't know how far they do that over, but they have to use incredibly sensitive instruments to measure the refraction that's caused by different gases. So there's no point in doing it over 30 feet. You would not get any measurable result unless you were using laboratory equipment. You might as well do something over a mile. Then you can start to see there's a change.
All right, Rumpus. You're gonna do your thing, right? We're at the point you're observing from. You're gonna have your equipment set up for You're measuring temperature, pressure, and humidity, right?
Yeah. Well,
where? Tell me exactly where these things are. We're looking out at your targets or whatever. Where's the measurements happening at?
Right, at the moment, I was intending to build 4, but I might just end up using 3. But I do actually have fourth one in construction. Obviously, at one end at 0 kilometers, then another one at 4, and then another one at 8.
Oh, okay, hold on. The one you're gonna have one at 1 kilometer, you said, or 0?
No, 0, 4.
Okay,
and 8
hold on.
I've got there in place at the moment, but I could put another one.
Okay, the second one out. Where exactly is it? What's it measuring and where? In one spot?
It's measuring the temperature gradient at that point. So it's measuring temperature every 50 centimeters up to 5 meters.
Oh, really? That's pretty fucking good.
It is. It's very, very.
It's going to start at the ground. Yeah. It's going to start at the ground and then go up to 5 meters or whatever. However you got it set up. It's going to measure 5 meters worth of temperature, pressure, and humidity rate every 5 centimeters.
Not pressure. I'm just measuring temperature. The pressure and the thing don't change at all over that.
Yes, it does. What?
No,
Rumpus.
That does not affect refraction. That does not affect refraction.
Pressure doesn't affect refraction. That's how dense the material. The more
no. If you go and look at any of the literature on refraction, it is the temperature gradient that is the key effect on refraction.
Okay, and you're saying the pressure doesn't affect it at all?
In effect, totally insignificant in comparison to the temperature gradient.
Insignificant. That's your claim. It's insignificant.
And all
it's less significant.
No, it's insignificant. It's insignificant. If I can give you the formula for the curvature of the refraction in the atmosphere, if you like, and it's P over T times 560 something bracket something else with P over.
How about Rumpus? Right, you already lost me. Write it down and send it to me in a DM so I can have this. This is the official global refraction formula.
It is. Well, it's the one that's most often cited. It's the one, for instance, on the Wikipedia page. It's the one that I found 2 years ago, and one that actually Walter Bislin also uses for his refraction thing in his modelling.
Oh, this doesn't have the diameter or the radius or anything built into it, right?
No, that's the refraction there. But then to get the actual refraction effect, you then have to put it how much something's moved by. You then have to put the radius in, but it doesn't change that. It tells you what the
index of refraction
absolute terms, just in absolute terms, in terms of temperature gradient. You put the radius in to then work out where something is. But the actual this is just hard refraction, nothing to do with the radius. This just tells you how much, if you have a temperature gradient of such and such at a particular pressure and temperature, and the temperature gradient, it'll tell you how much it will vary in that medium. And then Walter Bislin then uses that, and then, not with the knowledge of R, knowing where something is, then shows how much it will move up and down. Because of the obsession with the radius is only because that will cause a curve. The formula for the refraction will give you a curve, and then the reason they add in the radius is this, because what it does is, in the same formula for them working out where something is, for instance, it's the hidden value, for instance, how much something is hidden by the Earth curve, that's a function of the radius. But then when the light bends by another curve, it's a multiplier. So effectively what it does is you're just multiplying the radius by this other curve value. So it's not as though they're dependent one. There's just the fact that you're multiplying by a factor, and therefore the factor becomes 7/6, and you just multiply that by the next thing in the formula, which happens to be the radius. But the formula that I'm showing you does not depend on R. It's just a formula given a temperature gradient, given a pressure and a temperature, how much, for a particular wavelength of light, how much it would bend, how curvy it would be in that medium.
Can you post that formula on?
Yeah, okay. It's the one mentioned. Okay, let me go. God, where is it? There are other competing formulas, I have to admit. I've been going through some of the literature, and there are also other people saying they're not completely happy with it, other surveyors and things. But most of them use this formula. Right.
But is this a formula that comes from, like, made to match, like, some experimentations, or does it comes from? Is it a deduced formula or an induced formula?
It's a deduced formula, but it matches. It is deduced.
Right.
And that's the one that but it gives the results that surveyors then use. I mean, because if you're going to do it by induction, then you don't really end up with a formula. Then unless you end up with something like Newton's gravitational, I suppose you could argue is something you could deduce from data. But it's deduced from gas laws and the fact that we know, for instance, how fast light travels through a particular density of gas, and we know what the atmosphere does in terms of its density gradient. So it's denser at the ground level and it gets less dense as it goes up to Everest. But we also know that it's dependent on temperature, the temperature gradient. So therefore, if we know the density of the air is dependent on the density, that's the temperature gradient, as well as it gives you the density gradient. So there's the weight of the air. Combine that with some formulas to do with, for instance, if you want to get an idea of how you could work out what the density of the air is at the top of Everest. But that's also dependent. That gives you the density of the air, and then you also, from the knowledge of how refraction works, you then know that it's dependent on the gradient of the it's a bit more complicated than Snell's law. You have to use other laws, like Fermat's law, to work out what light will do in a varying medium. So we're using principles. When we say using deduction, it makes it sound as it's artificial, but it's based on what we know how light works in a medium that's changing density, and so it's based in sort of rock solid knowledge of a knowledge of way light works, and then saying, well, what will happen in a density gradient of something with a density gradients. So it's so yes, it is deduced, but it's based on basic principles that we know for a fact exist. Now, whether or not, I don't know how much testing there have been. I say there have been some people who've contested that other laws are slightly better. So, for instance, this law does not include humidity. That this formula that is used. Whereas there are some other people who say, well, there is a small humidity factor which you should throw in as well.
How could you think you have a good sense of refraction without humidity being involved? That would be that's one of the most.
Well, how do you? Well, tell me how. Well, how do you think then humidity is involved? Why do you think that's silly?
Well, I didn't say it's silly. I just said that it doesn't seem like it would be.
You said how can it? As though you know about refraction, as though you're familiar with the formulas that determine what's refraction, and then you're saying, well, why aren't you including humidity? What makes you think humidity is a major factor?
No, I'm just saying it doesn't seem like you'll have a complete picture of refraction if you're
Why
not.
do you think that? Why am I getting an echo? Who's echoing me? Is it you, Gio? Someone's giving me a huge echo.
No, that's no longer happening. Go on.
Does anyone else hear an echo?
I heard once, but no.
Well, I have a. Well, sometimes it might feed back through my mic. If it happens, let me know. I can change the volume.
It's
but
okay now. It seems to be okay now.
No, I'm just saying. Moisture is one of the most common things in the environment, so that would have to be accounted for.
Well,
That's all I'm saying.
If it doesn't affect refraction very much, then we don't care. There's radiation is also a factor in the environment. We don't take that into account either, or magnetic effects or electrostatic effects. We don't take those into account either. So you need to understand how refraction works before. Are you aware, for instance, that if the air is more humid, it's actually less dense? Are you aware of that?
I don't really buy into your claims of what density is, so no, I wouldn't.
You don't know what? Oh my god! You don't know what density? Do you know what density is?
I didn't say I don't know what it is. I said I don't buy into the system at which you define density.
You mean so? How do you define density of something?
I don't.
Oh Jesus Christ!
What do you understand by the word?
That's just amazing. I mean, that's just so basic. I mean, you're just dealing with the most basic. It's a definition. We define density to be something. It's not up to debate. It's a definition. We say density is equal to this formula for something.
Right. So I don't buy into that formula.
But it's defined as that.
Yeah,
that's
the formula.
Definition. It can't be wrong because it's defined to be that.
Yeah, the formula isn't a claim.
It's a definition. It's the scientific definition of density has that formula. It's not derived from anything. We say density is defined as this thing. It's like saying defining that 2 is equal to 1 plus 1. Or we're defining what the color red means in terms of wavelength. It's a definition. Definitions are not up to that. You don't deduce them or induce them. They are defined. They are stated as a fact.
Yeah, but if that's pulled from an assumptive model that isn't reality, then it's useless.
No, it's defined. Well, it doesn't matter. Look, I could define the name of a monster called a wibbly wobbly that has 3 legs and 7 eyes. I've defined it. Therefore, that is true.
No, it's not true just because you define it.
It is true. No, it is. It is. I've defined that thing to be that. It is true now.
It is true that the monster has that name, even though the monster doesn't exist.
Yes, I didn't say the monster existed. I didn't say the monster existed. I say that that's my definition. I've assigned it. That it cannot be invalidated. I have defined
it's cool,
it to
man.
be that.
You will always end it failing trying to twist and contort refraction to make the stationary planar Earth a globe. So keep spinning your wheels; it'll never work.
You're a science denier, then. I mean, you just don't understand the science. You don't understand refraction. I mean, if you don't understand,
I'm saying you can spin and do formulas all day long. It's not going to make the Earth a globe. It's not going to convince. Science. It's not going to convince anyone it is either.
Well, it's going to convince anybody who believes in science.
Oh, we can make the same claim about every argument you guys make. I mean, none of them make the Earth flat.
They don't have an argument. They don't have a single argument.
The Earth just is what it is, and we're just
it's a sphere.
I can't.
And we can demonstrate that. You cannot demonstrate anything to the contrary whatsoever. You have no argument, no evidence, no reasoning that can suggest otherwise. Not a single piece of evidence or reasoning gives you a flat Earth. None. Every single piece of evidence that you draw upon confirms just simply basic from a sunset. That cannot happen on a flat Earth. The fact that boats go over the water can only happen on a spherical Earth.
That can under a personal dome, right? Like under a sky that is just a projection that is different for every single observer, that just basically show what you should see on the heliocentric model.
Hold on, but how are they not getting where the light from the sun that everybody else is seeing? I don't quite understand how they can have their personal dome, but other people are in that dome. I mean, so if you have your own personal dome and then someone that's on the edge of that dome, they're going to see something different to your seeing it. So that just doesn't work.
Well, it sounds like you guys are having a meeting of the Globe Earth Society and trying just to talk about fabricated straw man flat Earth things that you think are something.
Well, give us a piece of evidence.
Nobody ever said any of these things you're saying. You're just saying things that somebody cares.
I'm not saying that you guys said that. I'm saying what's the only thing that I heard from the flat Earth side that I think can work. That's the only thing I think can work. I'm not saying that's your position. That's only one here's position. That's my position on what can make flat Earth work with sky observation.
Okay, well, maybe you're at the beginning of this discussion. I'm not sure, because if that's your only understanding of how a sunset works, then I guess it's like you just joined yesterday. So maybe you're brand new to all of it.
No, that's not how my understanding of how it works, or my understanding how you guys think it works. That's my understanding of how the only way it could work on a flat Earth.
Okay. Well, I guess you're still really interested in the topic, so I guess keep working it out, right? I mean, I guess that you're going through your journey trying to figure it out, so we can help you out as you need. But otherwise, I don't know, maybe join a Globe Earth Society if that's
we know exactly how it works. You have yet to offer any single piece of evidence or reasoning or logic or anything as to why the flat Earth, evidence whatsoever for it.
The Globe Earth Society is just society, right?
Science, yeah.
Right. Well, you guys are here. I'm not in your Globe Earth Society.
News just in.
If there's something that we can help you with, let us know. Otherwise, you're on your journey, and I'm supportive of whatever you need to go through.
Well, you're the one who's on a journey. We've arrived. You're the one who's yet to learn about science and doesn't understand what density is. I mean, you're the one who seems to be sort of hundreds of years behind the rest of us. All of the evidence you can obtain from the real world shows and demonstrates a globe in every single respect. There's not a single piece of evidence to the contrary. Not a single bit. And people who've got some sort of religious or strange delusion that they want to believe in a flat Earth because, I don't know, makes them feel special or something, or enhances their ego, or they just want to fight against the orthodoxy.
Okay, do you have anything productive to offer? Because if you're just going to ridicule and just heckle people, I'll probably just mute you, because that's not what this platform's for.
Well, I asked you for any evidence. You've yet to offer any counter-argument to the points about...
Well, this isn't a platform that I'm required to do anything you asked me to do. This is a discussion platform. I don't have to do anything for you.
That's true.
That's not what this platform is. I don't have to. This is not a court. This is not a court with a judge that I have to do something or be scolded. That's not what this is.
Okay, don't do anything then. Okay, fine.
Yeah, it's a discussion platform. So if you want to discuss things, discuss things. I don't have to provide you with anything.
Then, when he was explaining how a dome could work, if you're not doing anything, why did you stop him from describing how a potential could work on a flat Earth? Why did you interfere with that and censor him?
No, because there was no censoring involved.
You did. You stopped him describing it, and you told him to go somewhere else.
That's
you said, discussing this. You said this is a private discussion about globers, and therefore don't do it. Do something else. And that the only thing you wanted to do was not put a counterpoint, but just to stop him describing that.
That's not what I said at all. What I said is that he said the only thing he could think was some fabricated thing that he said. And then he kept saying that he's so sure the Earth is a globe. And I said, okay, well, maybe you should join a Globe Earth Society, because this is a discussion platform. It's not a place to come and tell people, you don't understand, you're wrong, you're wrong. It's not what this is for. It's not what this is for.
You censor the discussion between him and I as to how...
It's not censoring anything, but I will mute you because you're constantly interrupting me. Let's move on with the discussion. Let's unmute Demak. You guys don't understand what this platform is. This is not a place to demand and force your opinion on others. It just isn't for that. If you think this Earth is a globe, that's fine. If you're going to force it on people, don't do it here. Go find somewhere else to do that. If you're conflicted about it, that's fine. You can be conflicted, but you can't be conflicted and then come in and just attack people all day long. That's pointless.
Good stuff, bro. He's useless.
The personal dome is pretty good explanation alternative to what we see.
He's also dumb.
Right.
Yeah, that was my point actually.
Yeah, it's pretty good. If you think about it, like if when you see the sun in the ocean, right? It's setting. To each, you can see a line of light in the water coming to you. If you think about it, each person sees that line coming to him. Each person in that beach, but you don't see a thousand lines drawn, right? So each person has a different. It has his own perspective.
Yeah, and wouldn't it be so easy National Geographic?
You're breaking up.
You're roboting, Denmark.
Kool-Aid.
Yeah, I think. I mean, if you have a stationary planar Earth surface and you have a light in the sky, the sun, what I would expect that to do is to set due to perspective and would converge to the horizon, the meeting point of the sky and ground as it moves away from you. It would cut off from the bottom up. All of that is precisely what I would expect to see. The idea of a personal atmospheric dome idea, that just sort of contextualizes it into a structure at which your field of view is limited on this huge planar surface. So you have that limited field of view. So that is why the sun will set for you when it sets, is because that's your field of view. So yes, that definitely explains it.
The mere fact that you can see that line of light coming to your feet, it's a testament that there's no curve. If there was a curvature and you only have sun showing, there should be no line coming to your feet on the water of light. You know, line of light coming to your feet. It will be cut like way farther than you can see it. But it comes down to your feet all the way. So there's no curvature.
But it starts your head before it reaches your feet, right?
But he's saying if light bends, why would it be a straight, direct angle, directly straight, all the way directly from directly? Straight.
Do you mean directly?
Straight.
No, he meant directly.
Well, actually, no, because if light is bending towards you, and you look to that direction, the light can be bending.
Begging the question at this point.
What?
Yes, it's begging.
You started by begging the question. Yeah.
It's begging
Why?
the question.
Staring at the light.
Because you're bending the line. You're bending the light already. Why are you doing that?
Oh my fucking god!
Why are
You're
you
saying
taking the
saying if light bends, we should see that. I'm saying if light bends, you have to consider it. You wouldn't see that. That I'm just explaining to you. I'm just helping to trying to help you picture out why you're wrong.
So now you're saying your curved light's going to do the thing to prove a globe, but unprove a globe now? What are you talking about?
If
I'm
you
talking about
it's
nothing
curved,
you just said.
hold on a second, Bacon. If you want to say it's curved light or not, something's happening to where we can't make straight lines from day to day to distant objects. So whatever's happening, we call it curved light, but something's definitely happening to where we can't make straight lines.
That what I'm saying is, if a light is bending towards you, if light that is reaching you is bent, if you look back into that direction, you are expect to see a straight line. You're only gonna see it bent from another. You're not gonna see it bent from your position. Your position is going to show a straight line because that's where the light is coming from.
They have your mind. They have stolen your mind, Bacon, with all this bullcrap, bro.
No, Silent. That's.
I'm sorry, my brother.
The bending shows how
they have stolen all your critical thinking, bro. It's
no,
it's
you're
ridiculous.
being incapable of seeing something that should be obvious.
All right, that's fine. I'm okay with you being happy with that.
You know what I think would be a lot more obvious? If we had a tape measure that was 24,901 miles and we strung it around the globe like National Geographic before they ever existed as a thing that they were, that's the first thing they should have done. Was said, we're going to become National Geographic, so we should actually prove that before we exist. But they never did. Isn't that weird?
Hey Gio, I have a question about the refraction thing. Have you seen those examples where they have the what is called the water, the fishing pool, like the fish pool?
Hold on, real quick. I'm sorry, Silent. The Rumpus used to agree. The Rumpus used to agree with me when it came to the refraction measurements. Until one night, I made him accidentally debunk the main surveyor's plumb lines aren't parallel thing, because Rumpus was like, yeah, you need temperature, pressure, and humidity all throughout, above and below the optical corridor. Absolutely. Otherwise, you're just guessing. And now he's switched his whole fucking tune since then. All right, my bad. Go ahead, though, Silent. I just wanted to...
It's all right. We know Rumpus
I
lies
exposed
all
him
the
on
time.
Brandon's show one night. He debunked the main surveyor on Brandon's show one night.
Have you talked to Brandon, Jeremy?
He messaged me like a week ago. It was the last time I talked to him. I messaged him. Yeah, he said he was good. I messaged him a few days ago, and then I just messaged him again this morning. I'm just waiting to hear something.
All right. So I was gonna say, maybe you, Jeremy, you can help me out to understand this, right? Well, I do understand it, but I want to see what they think. Have you seen those fish pool, like the fish bowl that they put water in it and then they shoot the laser and use the laser bending, right?
In the fish tank, the laser in the fish tank.
In the fish tank,
a whole bunch of them, yes.
All right.
Tons of them.
Are you telling me that because that light is bending, if you put yourself on the other side of the light where the light is being shot at, you're not gonna be able to see that light just because it's bending?
Well, you see it. You can turn around and see it hit the board below you, lower.
Yeah, but no.
They claim that it's going higher. They claim we're seeing it higher.
Jeremy.
Go ahead, my bad.
Yeah. I understand you're gonna see it at the bottom of the fish tank. What I'm asking you is, are you gonna be able to see it across the fish tank?
Yes, you're going to see it reaching the ground.
I think if you look at it with no medium in the fish tank, and then you put a gradient in it, I think that the thing in the background will rise up.
Well, okay, I don't care if it's rising up or no, Jeremy. I'm asking if you're gonna be able to see it.
To see where the beam's coming from, yeah.
So the light, that's the source of the light.
Yeah, the source. Yeah, you'll be able to see the source. I'm not sure if that'll, like I said.
So it doesn't matter if it's bending, right?
It does, because you're going to see it pointing downwards, even if it's pointing towards you.
You mean it'll be tilted?
How are you gonna see it pointing downward?
How are you gonna
because
see
because the light that is reaching you is coming from the top of that.
But you can see the
Because in order for the light to get to you, it has to pass through that tank, and we know that tank curves light down. So the light you're seeing is coming from a higher. Yeah,
hold on,
but every light
the line is curving. It's not going to your eyes. What are you talking about? It's hitting the hold on. It's hitting the floor of the fish tank.
Yeah, the laser.
And you're standing on the other side.
I'm not talking about the laser, Silent. I'm talking about the light of the object that is sending the laser.
Mark is calling me.
Well, anyway, I mean, you don't see just the laser. You see everything around it as well. And the light from that part of the object is also going through the tank, so it's also bending downwards. So the angle you're seeing is actually higher than it is.
If you were a person on the other side of the tank, the light wouldn't even reach you.
Of course it would, otherwise you wouldn't see anything through it. It's just coming from a different direction. And yes, you see it higher, not lower. You see lower from the outside if you look from the side, but if you look through it, you see it lower. I mean, you see higher.
If it goes from the left of the tank and doesn't actually hit the right side, it just goes to the bottom of the tank from the left and makes a slight straight line, and then arcs down to the bottom of the tank. No, it doesn't go all the way across.
You see, light it can't cross the tank.
I'm saying, can you see what's happening with the light, the green light, and they put the sugar water and it goes from the point and it goes down to the bottom of the tank. Well, if you're a guy on that water straight across, the light went down to the bottom of the tank. It didn't even go to you.
Yeah, you would see it on the floor in front of you.
Yeah.
But I'm not talking about that green light. I'm talking about the object.
In front of you, you'd see the light bend down and go into the water. So how come your guys' like boats and stuff don't go down into the water in front of us? Your visions, your view of the boat.
The light is reaching is reaching everything.
Then how can we ever see it?
Because some of them is reaching your eye.
If it's arcing down into the surface face of the water, flat down into it, and then going to the bottom of the ocean, how would we ever see the boat? If that image
because it depends. It depends on the direction. When you shine light at the object, it reflects in all directions. The one that left the object horizontally is going to reach the ground, but that's not the one that is reaching your eye. The one that is reaching your eye is actually has actually been reflected in a higher angle. So it bent down and reached your eyes.
They're using a focused laser in a tank.
Yeah, but I'm not talking about the laser. I'm talking about the things you're seeing.
Oh, now you're talking about sunlight?
No, you were referring to boats. The light the boat is reflecting is not a single
you're saying
line of laser.
Right. You're showing us, hold on a minute. You're showing us this light goes from left to right, but doesn't get all the way over to the right. And this light bends totally down and makes like a rainbow. Now the boat that's around the curve, like the thing should be rainbowing to the ocean in front of us and not to us. It should go arced and just go down, and we shouldn't see that.
Yes, it should, because when an object reflects light, it reflects in all directions.
So the bent rainbow image, what type of portion of the boat should we see? The top, bottom of the boat, like we're looking down at it from a bird's eye view, because it's bent rainbow coming to us. So which way should we see this bent rainbow boat?
Higher than it is. That's how you can see it.
So which way should we see the bent rainbow boat? If I gave you a little picture cutout of a boat, how would you put that coming to you in the air in the vision from a bent vision? How would that look to you? Can you show me that? I know it's hard to get. It doesn't exist. Listen. So the bent.
Didn't get the words instead.
Of course,
the boat is supposed to be shooting at me with light and then bending around an arc and then coming to me, right? But in the salt, in the sugar water, it's not bending around an arc of a globe. It's going straight through the medium and bending where it wants and doing exactly what it wants to do. It doesn't have anything to do with anything else. It's doing it at the distance that it's normally going to do it. So this thing that it bends, the light source that's supposed to be bending.
I think you should draw it out.
Kool-Aid. Remember?
Yes, sir.
When there was a discussion about S waves and P waves.
Yeah.
I'll draw it.
As I understood, like S waves are I mean, the S is from the shear, like that's the stretching of the medium, right? So for example, if you have a fabric and you twist it very fast, the twisting doesn't propagate instantly. It takes time to propagate.
Right.
That'll be the S wave. So when Sinclair was talking about the pressure would be with P waves, right? So I'm not sure if you can relate pressure to S waves, but I don't think you guys made that distinction. I thought maybe that could clarify it, but I mean, it was some days ago. I'm not sure if it's going to be useful to talk about it now.
No, I appreciate it. If I got it wrong, let me double check. I might have had it wrong on this.
Yeah, the difference that I remember you mentioning was that the S wave was much smaller than the P waves. But Sinclair server was trying to make asking for the pressure involved in the S waves. but I'm not sure how you would measure pressure if because in the S waves, the medium is moving perpendicular to the direction of the propagation, unlike a P wave, which is parallel.
Exactly. But it still has an intensity and a velocity, which is a pressure, right?
That's a good question. That I was trying to. I mean, when I picture it, I see like that there's some pull. If you break down things in layers around the emission, they are sliding in each other, right? With an S wave. I'm not sure if that can be called pressure. I don't know.
Other than magnitude, what would you call it, though?
I don't know. I just looked briefly into it, and I thought.
Yeah. No, you're completely correct. And if I was wrong, I stand corrected. I guess I just don't know the correct verbiage for that.
Yeah, me neither. But I mean, it's very different from P waves. I mean, P waves clearly creates pressure, right?
Right. They're compressing everything in one direction.
Exactly.
And then the S wave comes and moves it, like you said, perpendicular to the way it's moving. So, but it has to create pressure in the shearing forces. So something's creating pressure.
Yes. Yeah, I mean, the layer that moves first has to pull the next layer. I think that would be a negative pressure, maybe.
Good question. Let me look into it. Sorry, I've been geeking out about boats for the last couple of days. There's another race going on, and one of the race teams I follow has a brand new boat they're putting in it. So,
is it ether-based boat?
It is.
Oh, it's peat then. It's probably peat.
They're planning on putting this in the Antarctic yacht race, and in the Antarctic yacht race, it's probably going to smash the record by like 20 or 30 days. Absolutely crazy. All right, D-Muck, can you explain your drawing? Because I don't quite get it.
Well, there was about 3 more that come with it, but they're not loaded. Anyway, the way the sugar water shows you how, well, like the sugar water, you got the whole tank from left to right. The sugar water doesn't go straight across and hit the other side. It goes from the point where it starts from the side of the tank, the start of the tank. It goes across the water and then goes straight down to the bottom of the tank. Now, if that laser represented like a boat image, now the boat, instead of coming straight towards you, the boat image would do like the laser, go up, straight out at you and then go down to the bottom of the water. So the front of the boat would go to the bottom of the water, and the top of the boat, you would see the top deck from you're looking down at it up in the air.
But that's the problem. The image doesn't propagate as a laser. It goes to all directions. That laser would represent. I mean, that laser.
Hold on a minute. A mirrored image of an object mirroring from where it is, arcing over the curve is what you're explaining to come to my eye. Now, if the object in question is arcing in its reflection, then you should see the reflectant arc in the reflection itself too. You should never see something like you're looking straight at it if the reflection is coming at you with an arc bringing the object to you. What are you talking about? And it's supposed to be reflected like a mirage.
DMUC, looking at your drawing, if I was to put
really the one
boat,
that explains it. That was the little first part of the paper. I was trying to get it all.
Right. But if we're looking at that line that you have the laser, and we're saying that's the boat, where would the boat be in reality? Would it be on the surface of the Earth, or would that be flying?
The boat's supposed to be on the other side of the curve of the Earth, like where you can't see it. It's out of my vision.
Okay.
Now the light. Hold on. The light is supposed to bring it up back to me around the curve. So this light is supposed to be arcing the image back to me with an arc in the image itself, at an arc that followed the radius. So it should follow the image. Should have that same arc. The how much it should have that. I should see the same image that's bent, not the front of it, the top of it.
Okay. So go with me here. It's an arc, right? And that's what they're saying, is that it's obviously the boat is in the water. It's not flying.
Right. No, it's down in the water on the other side, supposedly, of curved water.
So it is then going to bend up and come back down to where we see it. But it's still the light that came from the boat on the surface of the water, not the boat flying up in the air.
Now we're on a
You're going to see the side of it that reflected that light, which is at the angle you're looking at it from.
I've never seen.
If you want to see the top of it, you would have to raise your elevation, and then you would be catching the light that bounced off the top of it. However, the light that bounced off the top of it is flying over your head.
No. You're acting like the light is going to come and just arc right to my eyeball, like you're saying. But as we saw, the light didn't arc to the observer's eyeball. It did what it wanted. It didn't follow an Earth curve. It didn't follow the water. It went straight from the point that it came from, the source, the laser pointer, and it went straight out. And then it just did its own thing on its own, like, application on what it actually does for itself, and it bent on its own degree of bending at its own distance. It didn't have to do with anything else. Now hold on a second. Now you're telling me, now since that thing couldn't even reach the other side of a tank, right? High power little laser couldn't even reach the other side of the tank with sugar water. Now the light, you're going to tell me it's reaching me from thousands of miles or hundreds of miles?
No. That's where it stops. The light that bends, in this case, the laser beam that we're looking at, when it hits the bottom, that's where you could see it. You can't see it from standing at the end of the tank. That light has stopped. It's no longer the same light. You're now going to get a different bounce and different color and whatnot.
Are you saying that you cannot see it on the other end of the tank?
You can't see it directly on. You see the reflection of
it. You're telling me that you cannot see the light, the source light, on the other side, on the other end of the tank.
You can't see where it impacts. You can only see the reflection of it because you're not at the impact point. You're not receiving that light directly.
You're not answering the question.
It's literally bouncing.
Can you see it or not?
See what exactly?
Light. The source of the light.
I mean, the object the person is holding that is sending the laser.
No. The source of the light. The source.
Isn't that the source of the light? So, yeah, the pointer. That's what I mean. The pointer.
I'm not talking about the pointer. My God, that's shit. It's so hard to communicate with you, man. The source light. What is the point where the light is coming out?
So, in the example of seeing the boat, that would be the boat itself.
No, the fish tank.
In the fish tank example, it would be the laser pointer, and you do not receive the light directly from its point of impact. You only receive the reflection of it.
How can
the light bend? But you can't actually receive it directly.
How can you see it?
Because silent. When objects reflect light to all directions,
right.
The laser represents a particular direction of light that is not reaching your eye. It doesn't mean that other things other light rays are also taking that direction. The light that is being reflected, the ambient light that is being reflected by the pointer goes to all directions.
That. You're calling it that because you have the idea in your head that the light travels in one manner, which to me it doesn't make sense when I'm asking you this. If the light is travel in such manner, then we should not be able to see not even the light source because it's moving down, right? You should be able to see only the bottom, the light from the bottom of the tank, which is where the laser is hitting, not across the tank.
We use a laser because it diffuses and we can see.
So that's why I understand. That's why you guys have to call it refraction, like a reflection, right? It makes sense. But that's my example I'm putting. I'm sorry if you're not understanding me.
Can you draw it? I mean, if you, I mean that would
I'm
help.
driving. I cannot draw it.
Oh, right. Because I really think we might not be understanding each other. If I understand, I mean, when you said the source of light, are you talking about the pointer?
Holy shit, bacon.
Or are you talking about the tip of the pointer?
I don't know. The source light to me is where the light is coming from.
So that hole in the tip of the pointer, right?
Yeah.
A bulb, you can call it if you want to.
No, I mean the hole. There is like a hole in the tip of the pointer, right? In which the laser comes from.
I think we're getting confused because we have too many analogies going on at one time. So let's just talk about the fish tank.
Mm-hmm.
So we're talking about where on the laser pointer the light begins its path, if you want to call it that, or
the light. The end of the laser, right? At the end of the apparatus, right. It's where the light is coming from, right?
And
that part of the light is what I'm asking you. If you're not able to see from across the tank,
you're not.
But you do, right?
No.
In reality, you do.
But you don't.
Yes, you do. Kool-Aid. No, yes, you do.
What you see
Kool-Aid,
is the light.
Kool-Aid. Listen to the words. Yes, you do.
I understand. What you are actually seeing is the light that is being scattered by the medium as it goes out. That's why on the laser we can see the entire path of the laser is because the light is being scattered.
I mean, you can make that claim if you want. I can say it's just a unicorn's bringing the light to my eye, right?
Okay, we can make a different analogy. I think by clarify what Kool-Aid saying. When you point a laser, the laser is going to the direction you're pointing it, right? I mean, you forget about the fish tank. Just you're pointing the laser in air, like in your room. You can see the laser, right? In the air. You can see that green light, right? Silent?
Yes.
Yeah, how are you seeing it if the light is going in that direction?
Oh, because it's hitting particles in the air?
Exactly, that's what Kool-Aid's talking. That's what you're seeing inside the fish tank. Is what's being reflected in the medium of the fish tank. So that's the only thing you can see.
Wrong.
That's what he means.
Wrong. You're seeing reflection on those particles because the light is there. It's actually there. Which in the fish tank, that light is going down to the bottom of the tank. It's not reflecting through the whole tank. You see my point?
Why not?
What do you mean why not? Because you can see it going down.
Yes, and the reason why you can see, I mean, if it wasn't being reflected, you wouldn't even see it.
No. You're missing my. Okay. You're missing my point. If the light is going down, is refracting down that laser, right? We already explained. You give the perfect example. The reason why we can see it on shooting on the sky, whatever, is because it's hitting other particles. That is bouncing out of those particles. So in the fish tank, we can see it go down, bending down, right? There's no reason why you should be able to see it across the tank from where it's shooting, because the light is not as we can see, the light is not bouncing straight across the tank.
Every time you say "as we can see," you're proving that it's refracting off little things and particles, letting us see.
All right. Well, you're just gonna make a claim there, and
if it wasn't hitting things, you wouldn't be able to see it.
I'm not sure, but that's what he's saying.
This is where your dogma comes in. That's your dogma talking, right? You have this dogma that the light has to travel in a certain way, otherwise it doesn't make sense to you, right? That's why you cannot, like your mind is stuck in this is stuck in this war view of seeing things that when you hear a different idea, it doesn't make any sense to you, and that's not my problem, right? And with all these conversations, we follow the same thing, Kool-Aid, right? The problem is the information that you have and the lens through what you're seeing things doesn't allow you to hear or visualize or imagine new perspectives, new ways of seeing the world. That's a problem.
You're going to say,
no. You gotta remember, Bacon. I was a Glover.
Can I try?
I had your lens already. I have your lens already, bro. Okay, so I was a Glover. I wasn't a flat earther before this.
Okay.
So no, I already know your worldview.
Who's hot mic?
So Silent, I don't even think you're posing something different there. I just think we're picturing things slightly different.
Sure, Bacon,
Silent,
you win.
Have you ever gone into a room that hasn't been cleaned in a while and there's a bunch of dust all over the place? And first thing you do is you open the window and you let some sunlight in, right? And then you get out the duster and you start dusting and you kick all of those particulates up into the air. And then you look over the window and you can see the sunlight streaming through. Well, there was already sunlight there because you let it in to open up the room, but you couldn't see it because there wasn't any particulates in the air to reflect it to you. I don't know. Right.
I don't think he's that interested in the discussion anymore.
Yeah, I cannot argue with Dogma though. It's hard to
I don't
communicate
think
with people who won't open their minds.
I don't think we even disagreed actually.
Silent.
Silent. I mean, you're driving. I don't think it's very easy to communicate what we're trying to picture here. I don't think where we're disagreeing is anything related to our beliefs on the shape of the Earth or anything like that. I just think we're having trouble communicating the whole.
No, but I disagree on the way you say that light travels. Right?
I mean, where exactly do you disagree?
I already explained, Bacon. I'm sorry.
Yeah,
bro.
and I didn't understand.
I don't have the brain to explain to you all, over and over and over the same shit.
Well, right. I mean, it's fine if you're not interested in clarifying things, but while you're driving, I can't ask for much.
Plus, let me tell you this, Bacon. In that fish example, the light is going from a non how you say, dense medium to a dense medium. When you're talking about boats, you and the boat are on the same layer of density.
The light's not.
So I don't know how it's refracting that way. Well, okay. Well, that you're about to make a claim which, listen, you cannot provide evidence that nobody has taken into account.
I didn't even make the claim.
Go ahead.
You're claiming
not
that
really.
the density.
I apologize. You say not really.
You just claim the density is the same. Oh, it's all known, even for other flat earthers that.
Same layer of density. You are on the ground level. The boat is also on the ground level, right? You and the boat are on the same. If let's say you draw around a sphere, right, like a circle, and then you put yourself there, and you put the little boat, and then you're gonna draw a parallel line across the circle, making it a dense layer. You and the boat are gonna be on the dense layer, the same one. It doesn't change unless.
Yeah, that's actually a great point. Yeah,
Unless you're gonna tell me you take it into account, then I would like to see who did that shit. Because on 6 years, nobody has ever bring any single piece of evidence about that.
I get your point, and that's actually a good point. That there is a, I mean, even if there is a gradient index of refraction, there is some height above the surface in which, I mean, if we keep the height, then the index of refraction isn't changing, right? Throughout the whole path.
How do you quantify that, Bacon?
That what?
How was it quantified?
I just claimed what you just claimed. I never added anything on what you said.
Then why you are using different words?
Because I was starting a point. So that's the thing. You started answering before I even make the point. Now you call me dogmatic.
Well, you are.
No,
but go
right.
ahead.
I mean,
Finish
you
your
started
point
the
that you were
answer
making.
without the point was made.
Then what? Okay, hold on. Why are you repeating my point? Just go on with your point.
Yeah,
if you have
I was.
a refute to
Yeah,
that.
I was just phrasing it in a way to give context to the point I was going to. I was about to make. So yeah, unfortunately, gradients of index don't work like that. If as you go up, the index of refraction changes, or as you go down, it changes. Then it doesn't matter if there's a layer in which it's constant. If it right above it and right below it, it already start changing, then it is going to bend. And you can see that in the fish water tank.
About, right? That's not what we're talking about. No, I'm sorry. I'm sorry. At this point, you have inserted a new variable, which is altitude, which we're not talking about that. We're talking about the two
you mentioned
things
layers
being on the same layer. There's no reason why it should bend. Okay?
I was just explaining why there is. Just interrupted me to claim the thing again. So you can verify that you can verify that with the fish tank.
I'm getting angry now, Bacon. Listen.
I know you all get angry all the time.
Yeah. Because you are moving away from the example. The example is the two objects are on the same layer. Why are you? How do I say politely?
How thin do you think a layer is?
Like want to bring another variable. Why is that?
What variable?
Altitude.
Because it matters.
In your dogma, yes, I agree.
All right. How
the
thin?
Reason why you need.
Silent.
Let me explain to you. Bacon,
how thin is a layer? How thin
Hold
is a
on,
layer?
Bacon. Hold on, Bacon. The reason why you let me explain to you. The reason why you need to bring altitude is because otherwise it doesn't make sense, right?
No.
In your model, in what you have in your head. So you need to bring altitude so that it makes sense to you.
No, I was just explaining to you.
Then let's leave altitude out of it, right? We have the same layer.
Why? If it's relevant, you're making a question. We're making a question.
Yeah, you and the boat are in the same layer. Why is that the boat bending over the same layer of density?
How thin is the layer?
Huh?
How thin do you think the layer is? What's the width of the layer?
Great question. How the fuck did you guys quantify it to make claims about it?
Simon, can we maybe dial it back a little? It's getting a bit intense at the moment.
All right, I'll go on mute.
No, you don't have to mute. It's just like aggressive sounding.
No, yeah, I'm actually a little bit triggered because he's listening to the example. He wants to go to other things and.
Yes, because I want to explain you. If you want an explanation, you have to allow me to say other words than the one you want me to
if
use.
You want to go outside of the fucking example that I'm giving you.
Of course, because the answer to your question relates to concepts that you're not taking into account. So I have to explain them, of course.
Concepts he doesn't take into account. You're showing us a sugar water tank that bends a laser from left to down. You're not showing us any stuff bending up around. So when you can show the laser and the sugar water bend up around the ball, then we'll be talking.
Let me ask you, Bacon. Do you think the laser is gonna bend? Do you think the laser is gonna bend if you put the laser inside of the water?
Of course.
Of course.
Yeah, the index of refraction is changing.
Are you sure what you're saying?
Yes, because the index of refraction changes there as well.
In the water. in the same density.
And the sugar, I mean, the example of the sugar water tank?
Well, yeah, it's inside of the water.
Yeah, it would, because when the light is not bending just when it reaches.
Can
Silent,
you show?
silent.
Can you show an example of this happening?
Someone that puts the laser inside water?
Yes.
I don't know.
I'd also like
Then
to.
why?
Maybe you could look it up.
Oh,
Well, here's the thing, Silent. Here's the thing. When the light enters the fish tank, it has a particular angle. It doesn't keep that angle. The bending doesn't happen when it enters only when it enters the fish tank. Otherwise, it would make a straight line. The reason why it
okay,
makes a
Bacon. Let me
curve-
ask you something. Are you playing dumb right now? I'm asking
course
you.
not.
The laser, you're gonna shoot it from inside the water.
Yeah, I was explaining why that's obvious. But if you don't want to listen to that, it's fine.
You were explaining the laser going again from outside the water to inside. That's not what we're doing in the example. I don't know why you keep bringing my examples outside of what I'm
Well,
talking
you asked
about.
it why was that obvious. I was explaining why that's obvious. But if you don't want to listen to that, fine.
Oh, wait.
Then just
Is
don't
it
ask it.
obvious because what?
Because the light that is once it enters the fish tank, it keeps bending. It doesn't.
What do you
It
mean
doesn't make a
enters
straight
the
line.
fish tank? Somebody explain to him what I'm talking about. The fish, the laser is inside the water. It's not entering the. Yeah.
You don't understand what I'm saying. What I'm saying is, I said that it's obvious that that's going to happen. You're asking how it's obvious, and I'm explaining why it's obvious, even without doing the experiment. If you want, if the only thing you want to know is if I see an experiment that does exactly what you asked it for, I already answered no. But I think it's safe to say that it's pretty obvious that that's going to happen. And if you want to understand why I think that's obvious, of course I'm going to use the example of the fish tank with the laser outside of it, because that's what I'm claiming that makes it obvious. Of course, that's what I'm going to refer to.
Do the lasers bend like that and show an arc and bend, or just widen in like hydrogen and oxygen and heat? The air we're breathing right now, does that laser bend all crazy when we shoot it at objects? That when it goes straight, does it bend in like that?
If bend when it what?
The laser, when we shoot it at an object, not in water, in the atmosphere that we live in, when we shoot it at something. When we shoot it at something, doesn't it hit the target?
Yeah.
When you shoot a laser pointer at the target, why is it not bending everywhere? You're claiming it's bending and all these lights bend and all this light's bending. One more thing. If the sun is directly above my head and shining straight down on me, how can it then shine me that way if it's shining in a different direction, in a different angle, in a different format?
You're breaking up a little bit, but the answer for the first question is, well, if you're seeing the target, then there's a path of light from the target to your eyes. If you point the laser to that direction, that's going to reach the target because it's going to make the same path, but in the other direction. There's nothing wrong with that. It doesn't matter if it's bending or not.
And then there's all this bending going, and that light can carry an object and bend it around a curve. But in this atmosphere, when you shoot all these lasers and lights, they're not bending like you claim. It never happens.
How do you know?
Well, where's it happen? You got to have sugar water, apparently.
No, you got to have a gradient index of refraction. That's what you need.
We have the gradient. We live in the gradient. We're talking in it right now.
So it happens, yeah. You don't need sugar water.
So exactly. So everywhere you shoot a light, you should see this bending crazy magic, but you don't.
Of course not.
Right?
No.
And if
the reason. Wait.
Hold on.
So the reason why you see the laser making a curve is that you're outside of the fish tank. If you're inside of the fish tank and the laser was sent to your eye, was reaching your eyes on the bottom of the tank, if you look to the source, you would see a straight line to the source. You wouldn't see making a curve.
Well, that's great if we lived in a fish tank, but we live on an Earth with a gradient of air and no sugar water, no fish tank.
Yeah, sugar isn't anything special there. It's just there to create
So
any
what's the
gradient.
point of this demonstration?
To show what a
it's
gradient
not really
does.
demonstrating.
It demonstrates what a gradient does.
No, it doesn't. Not at all.
So Bacon,
Right.
So Bacon, is what you think happening? Do you think that all these lasers that we can shoot across the Earth that hit the targets, etc., many of them visually can be seen to be straight, but nonetheless, I mean, I think it'd be cool to test it along the laser. There's ways that it could be done, even more advanced ways of being able to, you know, test it, like measure it along the path. Nonetheless, is what you think is happening? Do you think that this laser through the atmosphere is bending and warping precisely to the 3959 radius to bend around the curve in order to hit the targets? Is that what you think is happening?
No, not of course not precisely the radius. So the bending changes all the time, but the thing is, the direction you see things is the direction in which light is reaching your eyes. So if you point a laser to that direction, it's going to reach what you're seeing, regardless of its bending or not.
Okay, we're talking. If the sun is above us. That was such an obtuse answer.
Go ahead.
Wow. No, you can go ahead. No, I mean, all right. If you've got a target 10 feet above the ground and you have a laser 10 feet above the ground and you have a distance at which on a geometrically curving Earth, it should never be able to hit that target because it would hit the bump of the Earth. It would hit the hump. The fact that the laser hits these targets every time. What I'm asking you is that, do you think what's happening is that the laser is bending and warping around the curve? You didn't really answer that.
Yeah. Because, well, you give a more precise scenario. In that scenario, yeah, I would agree.
So you think it's bending every time, it's bending, the refraction every single time is bending and warping it in order to curve around the globe to...
Yeah, Gio.
No, it doesn't have to be perfect.
If you shoot the bullet from to that same shit, it's gonna hit the bump of the Earth, I guess. Some
it
shit
doesn't
like
have to be perfect. I mean, if the hump is to say it's also 10 meters, then the slight refraction is going to make the laser pass through the hump. So above the hump, I mean. But if the hump is higher and higher than that, then of course you're going to need more refraction. But because you're saying that it happens all the time, then yes, I would say it's always bending, yeah. But not precisely with the curve of the Earth. No. Otherwise, if you looked straight, you would see like.
It has to. If this is what you think is happening, it has to bend perfectly to the 8 inches per mile squared.
No, actually not. I mean, for more than one reason. One is that 2 inches per mile square is a parabola. It's not a circle, so it will get wrong. It doesn't. It's not going to work at some point.
Again, Gio, in your example, the laser is not changing from one layer of density to another. Therefore, there's no reason why it has to bend. Do you see the problem that they have? If that laser in the fish tank, yes, it's understandable, right? It goes from one medium that is not dense to another medium which is denser. In your example, Gio, right? The laser and the person, the target, are on the same layer of density. There's no reason why the laser has to start bending.
Yeah, I do see what you're saying there. But Bacon, the one I just posted, like, so, you know, you would agree that on a globe Earth, like, I mean, that's just a very basic little drawing, but it wouldn't hit the target, right? So what you have to claim is happening is that this laser is bending and warping at perfectly 8 inches per mile squared to hit these targets every time.
It doesn't have to be perfect. Let me just send a counterexample. So in that example, it's covering less than the surface, and it's still reaching the target, right? So it would have to be perfect if you were saying the person like at the same height as you, perfectly horizontal.
He said that. He said that.
No, he said that they're the same height, not that they're saying them perfectly horizontally. If you are seeing them perfectly horizontally, then yes, you'll have to follow the curvature of the Earth. But if you have to look just a bit higher or lower, then it's not perfectly with the curvature of the Earth.
Okay, So I get that you think this is happening. What is your reason to think so? Because of sugar water? Because you can put sugar in water and get that a laser to bend? That's your reasoning?
No, it's because less dense air is lighter than denser air. It goes up, and denser air goes down.
Okay,
so we end up with a gradient.
All right, let's forego the explanations. How could you test this? Could you put a brainstorm together? Maybe you could do a GoFundMe or something. How would you be able to test this?
Well, actually, Rumpus has an equipment that does exactly that, right? It measures the temperature, pressure, and humidity of air every 50 centimeters across how many meters?
I have a question for on your drawing, Bacon.
Mm-hmm.
Why are the lines pointing down to the ground?
That's their vertical.
Straight. Huh?
Because that's their verticals.
So if you think that when I'm extending my hand out, I'm pointing to the ground, is that what you think I'm doing? If I have a laser standing outside, straight from me, do you think I'm pointing down to the ground?
Oh, I get what you say, because it's not pointed like perfectly horizontally, right? It's tilted downwards a little bit. Well, no, yeah, that would be exaggerated. Yeah, the light can be emitted a bit more horizontally. I can change that curve to match better what you expect to see there, but I think I'll have to do it manually. 1 sec.
So if you do it, then yes, it's following the curve, right? And let's say you put you draw a layer of density over that circle, right? Parallel, which means it has to be equal on all the way around the circle. Can you tell me why is the line gonna start to bend?
Yeah, because it's in a gradient index of refraction. So it's light
How
as a
you
wave was
quantify
going
that
to
gradient so that you can make that claim?
well, not personally, but it's.
But you're gonna make the claim, right?
Oh,
and expect me to just follow.
Well, you disagree. For example, one of them is very obvious. The pressure. The pressure is obvious, right? As you get higher pressure.
I thought Rumpus, half-hour Rumpus said that pressure is meaningless. So I don't know what he's talking about.
All right. Well, I'm just giving you one example.
Well, don't give me that, right? Rumpus said it is meaningless. So why should you give me that example?
Okay, so temperature then, right? So
temperature.
Yeah, if you make air hotter, it becomes less dense, right? That's how balloons work. Hot air balloons work.
Now, when the formula was done, can you cite who quantified this?
I'm not giving you a quantification. I'm just giving you a relation.
So you're just gonna say things, right, and expect people to just follow them.
No, I'm
without any evidence or any.
I'm just asking.
Like clarification.
I mean, if I disagree with that as well, then yeah, I don't have a lot to say. But
there's nothing Bacon. There's nothing to agree with, right? You haven't present absolutely nothing. You're just saying things.
Yes, there is something to agree. What I asked you, I asked if hotter air becomes less dense than cold air. That's what I asked you. If you agree with that. Yeah.
Yeah, but yes.
Yeah. So hot air rises and cold air sinks.
Yeah,
so,
but hold on, if you are, let's say, 6 feet right tall, and the boat is gonna be 6 feet tall, you're gonna be on the same layer of the 6 feet of cold, unless you're gonna tell me that on those let's say that you're looking through 2 miles of distance. Unless you're gonna tell me that over those 2 miles of distance, there's like a wall of cold air and hot air. Because
no, of course not.
You know, as you know, cold air and hot air doesn't make walls, right? It is
sure.
All right. So you are
exactly.
still you're in the same density gradient. why is it gonna start curving?
Because the denser gradient.
But you're not in a denser
it is a
gradient,
gradient.
right?
It is a gradient because it changes with altitude, right?
Can somebody explain him better if somebody understand me what I'm saying? Because it seems like I try so many times and he doesn't get it, and I get frustrated. So yeah.
Oh, you don't wait until the whole answer. You just wait until the first three words, and if you already heard them, you don't listen to anything else that comes after them.
Yeah, it's a bit of a brick wall.
Here, I think I'll translate for silent.
No offense to you, Bacon, but yeah, every time I try to speak with you, it just seems like it doesn't go anywhere. It's like an unproductive deal. But I think what he was saying, yeah,
I'm trying.
If you're at the same altitude, if you're at 10 feet off the ground and the laser target is 10 feet off the ground, then why would you be at some dramatically different, denser gradient? Of course, there's going to be some changes throughout the distance, but you would still be in the same layer.
Sure. Yeah. I get that's a good point. So if you're looking perfectly horizontally, and the surface is flat and the gradient goes from bottom up, then yes, the index of refraction is not going to be changing, right?
Well, yeah. If you think about it, Bacon. Right now when I'm looking straight, and when I'm looking out into the horizon, if you think about it and you draw a line, I'm looking into the space, right, in your model. And the other thing is looking into the space also, the laser. So if we're in the same gradient, why is the laser gonna bend?
The same layer, you mean, right?
Yes, I'm looking into the space. There's no reason why the laser has to embrace the globe.
Sure.
Because the laser and me are on the same layer of density.
Right. Agree. But because I know you already heard those words and you'll be triggered, but I don't know other way to explain it. You know that just above the layer, right above the layer, if as soon as we move up, the gradient is going, the index is going to change, right?
Yes, I agree. But
Sure.
we're not, right? In this example, we're not, right?
Yeah, we're not going. Yeah, I'm just saying that above and below that,
Yes, I agree.
Sure.
Has nothing to do with my example. Yeah, sure. Keep going.
It has. Because
no, in my example, you and the object are on the same layer. You want to bring it up and down? Sure, I agree. There's no disagreement. It's gonna change, right?
It's not what I'm
Listen,
saying,
Bacon.
Silent. That's not what I'm saying, Silent.
If
You're not listening to what I'm saying. I haven't made the point yet. All
right.
So the same way in the water, the sugar water fish tank, right? If you shoot the laser horizontally, right? It should keep on the same layer, right? So it's not changing the index of refraction, so it wouldn't bend upwards and downwards, right? And yet it does, because that's not how it works. It does. When we're talking about refraction, we're talking about Snell's law. Light is not working as a particle; it's working as a wave. So you can't isolate a single layer, because whatever is right above it and right on top of it interferes on how that light's traveling. That's why it doesn't matter if you shoot at a particular layer. If the above and below layer have a different index, that's going to affect the path of light. And we can actually see that in the sugar water tank. Because even though you shoot the laser horizontally, it doesn't keep on that same layer. It bends downwards. So it doesn't work.
Is that
it's
your
a good point.
explanation?
It's a good action. Yeah, it's a good question. Why it goes below if the index isn't changing? Well, because it interacts with the lower layer, and then it bends lower. It bends down. Actually, that was one of my questions about refraction. I mean, a couple of months ago, I had the same question. Then I looked it up,
and somebody just explained it to you this way, and voila, right?
And also matches the observation of the sugar water tank, because
all right, if that was one of your questions, you heard this explanation that you're giving me to me. Do you care to ask the person who was explaining you what I'm asking of you? I guess not, right? Since you cannot bring it to, you cannot put it
that was my
to the
question.
table, right? Who
I think that was
quantified
my
it?
question. Oh,
Who quantified the gradient? How did it quantify it? By which methods did they quantify it?
Quantified the radio, the index, or
Yeah, the skews that
the
you're
bending.
giving me. Yes, the skews that you're giving me. How
The
was it
bending-
quantified?
The bending comes from deriving Snell's law. I mean, the way we quantify how light
Fair
should
enough,
bend in the
Bacon.
gradient.
Fair enough. Yeah.
Yeah, I mean, the way we quantify how light should bend in the gradient come from a derived formula from Snell's law.
Doesn't Snell's law use two different mediums, like a fish tank?
Exactly. That's why I have to derive a different one to use to apply to a gradient.
I don't
But
know.
Of course,
You keep bringing different mediums when it's the same medium in the example.
Yeah, but the index is changing.
To me, it only makes sense that you're able to see the object if you are on the same layer on a flat surface. Otherwise, you gotta bring all this magical thing about light doing. I don't know, bro. It's
Silent.
Hang on,
man.
The fish water tank refutes that idea.
Can you keep saying sugar water? Can you prove this without sugar water?
Prove what?
What you're saying is correct. Without sugar water. You keep saying sugar water.
Sure,
There's
because
no
that's
sugar water in the
that's
atmosphere, so let's be real
because
about that.
but I'm not talking about the atmosphere. I'm talking about how light bends in gradients. That's independent from the
Bacon.
atmosphere.
This is what is analogous to what we're talking about. If you put the laser inside the sugar water and then you shoot it, you're not gonna see it bend. You claim to.
Why not?
I'm not gonna make that claim. Why not?
Oh,
Because it's in the same density gradient. But you claim it does.
What?
It is in the same density gradient. The laser.
Do you know why it's called a gradient?
You're gonna stick.
Why do you think it's
my
called a
God.
gradient?
Bacon. You're gonna grab the laser, stick your hand inside the fish tank, right? And you're gonna turn on the laser on that water, right? There's no reason why the laser has to freaking deviate. It's in the same gradient. It's not outside. It's not going through the mirror. It's not going through the mirror. It's not going through. All right.
Okay,
So
all right, let me explain why that
in
claim
the
is wrong.
same manner. All right. Explain. And
Right.
present evidence.
Sure.
Something.
The gradient is called a gradient because something is changing, right? As you move from bottom up, something is changing. The gradient that we're referring to is a gradient of index of refraction. It's a refractive gradient, which means that
There's
the
a
index.
gradient. Let me stop you there.
That's what it means.
There's a gradient. There's a gradient if it's going from something different than what is ending up, right? So if you start, just to put numbers, if you start in a gradient of 10 or 1, which is in the air, and then you're hitting the target in a gradient of 10, which is the water with sugar, yes, you're going to see an effect. But if you're going from a 10, your hand inside the water with the laser, and you're shooting it inside of that 10, there's no reason why it's going to deviate.
Yeah, but then it's no longer a gradient, right?
Okay, Bacon. That's fine. I appreciate the conversation, though.
Well, just Google refractive index. That's exactly what we're talking about.
No. Just present something in the same gradient and the same gradient bending. Same gradient. Do you understand what that word means? Same. The 10,
Yes.
the number
So
10. Okay. No different ones.
Silent. Do you think once the light leaves the glass of the tank, it's no longer bending, or it keeps bending?
I don't know. You are the expert here.
Can't you see
I
that?
don't know. That's what I'm
That's
asking
visible.
you. Do you see it in the air?
I was talking about the fish tank. We're talking about the observation that we both share, which is the water. The fish
I
tank.
haven't seen the laser put inside of the fish tank. Neither do you. And
I'm
if
not
you
talking
have,
about that.
I appreciate to see that what will happen. I would like to see that. If somebody has that example, that would be awesome to see what the light does inside. Then we can argue. But at this point, I think we have come
What would
to
be your conclusion?
Hold on, Bacon. Let me finish. Yeah. At this point, I think we have come to an end where neither you or I have seen what the light does in the same gradient, which is the water with sugar, so that we can be making claims. So yeah, maybe either you or me, we can do this test, right? I don't think it's too expensive.
Right. If we do this test and it does bend, even if the laser is inside the sugar tank, the fish tank.
And if it
what
doesn't, what would be
your conclusion?
Let me repeat your words just for you. Yeah, what would be the conclusion if it doesn't?
Yeah, our whole understanding of refraction is wrong. That would be my conclusion if it doesn't.
Okay, well then let me get doing that shit.
Yeah, what would be yours? Are you willing to make that same bet?
That it bends, yes, that it bends. Sure, why not? If I see it bend, why? Hold on. If I see it bend, why am I not gonna admit that it bends? Yeah,
I'm not saying that.
My idea. Hold on, Bacon. Here's the beautiful thing. My idea is not the one in question. It's your claim, right? If something else is shown, all your maths and everything is wrong, which you have admitted. Now, at this point, I cannot make any further claims because I haven't done it. I haven't seen it. If somebody has seen it or done it, I would appreciate if they can post a video. Otherwise, we're in an impasse right now.
Well, but
what's the claim?
The claim, you know, that those examples of when you have sugar dissolved from the bottom of a tank, so it creates a gradient index of refraction, and then you shoot a laser, and then it bends downwards. You know.
Again, brother, you keep trying to argue.
I'm explaining
about
Roof.
something.
No. Roof is asking for it.
Yeah, I'm asking for the claim. That's all.
Yeah. So he asked what would happen if the laser was inside the sugar tank, because he's saying if it's in the same gradient, then it's not going to have any bending. And I'm saying it doesn't matter if it comes from outside of within the tank. It's going to bend.
Of course, I'll take that bet all day. Of course.
Yeah, that's what I'm saying.
Bacon.
I mean, it should be obvious because.
Bacon. Is there sugar water happening between point A and point B in reality?
I don't know.
I'm sorry, are you saying
I'm not talking about
atmosphere sugar water?
Yeah, we were talking specifically about the sugar water tank. We're not talking about how that.
All right, whoever said he calls, of course he bends. Who was that?
Me.
Yeah,
all
also
right,
me.
Present your evidence of that happening.
Of putting a laser inside.
Yeah. You heard the example. Don't repeat it. You heard the example. Don't repeat it. Present evidence of that. Yes.
No. Let's make a bet.
No. I don't care about. Yeah, how much you want to bet? $100?
Fucking whatever you want.
I'm on it. I'm on it.
Yeah.
You are you gonna do the test?
Yeah, it depends what the cost is. If you put $1,000 on it, I'll do it.
No, I'm not gonna put $1,000.
Okay.
Why do you need to make a bet to present evidence? If you're claiming it to be true, it's because you already seen it, right?
What flat earthers do is just deny shit and never put them.
You already seen it, right? Present it. No, the only one claiming shit right now is you, buddy, without any evidence.
I did not say that I have seen it. I said that will happen, and I will bet that it will happen.
How do you know it will happen if you haven't seen it happen?
Right, because I understand refraction. I understand it, and I bet that my understanding is correct.
Now I'm more interested on that shit.
And Silent's reasoning on why it shouldn't work doesn't make any sense, because if we would assume that he's right, his reasoning is that it only happens when you change mediums, right? So
which is obviously wrong.
That's what a gradient is. That's what a gradient is, right?
Yes, but the gradient. All right, Silent.
Idiot.
Silent.
That's semantics, I think. A gradient is a gradient a change in medium? I'd say no, but it's definitely a change in refractive index.
Exactly, which it actually would be a different. I mean, in the context of refraction, a different index it's like a different medium, right? Even though it's still air.
You can treat the atmosphere as discrete layers and apply Snell's law to it. That works.
Exactly. Well, my point was why it's obviously the Silence hypothesis or explanation on why it shouldn't bend doesn't work, because when, for example,
right, but what is he putting on the line? Like when we demonstrate.
Who cares about your explanation at this point, buddy? You haven't presented your evidence. Who cares?
When we show that you're wrong, what happens?
I'll admit it.
Wrong, what happens?
Plain.
I'm going to say it again. When we show that you are wrong, what happens to you?
I admit it. There's nothing.
Okay.
I admitted that the light bends inside the fish tank. Yes.
Okay, very good. What does that mean for the shape of the Earth to you?
Absolutely nothing.
Put something on the line. Put something on the line then. I can put $10 million on the line, right? And I have put $10 million.
Well, I don't have that money. Do you have those? Do you have that money though?
I do, and I'll put it on the line if people accept my challenge.
I don't.
That's fine, but it's a level playing field challenge where we present our evidence to a neutral third party, and that neutral third party decides.
Wait, you have $10 million, and you were saying how much is gonna cost you the fish tank?
Yeah, well, I want you to put something on the line.
Well, I was gonna put my $100. I mean, to me, that's a lot of fucking money.
Yeah, but it's not worth it to me.
What are you worth it? You have $10 million. What are you talking about worth?
Yeah, I'm not going to spend hours doing something for you unless there's something of benefit to me.
If you think about it, we're talking about money. There's nothing I can do that's going to be benefit for you. Not even me changing my mind is going to be a benefit to you.
If you $1,000 I see as something worthwhile for me to go and get a fish tank and demonstrate.
$1,000 is worthwhile when you have $10 million.
Yeah.
You clown.
If you saw $1,000 on the ground, would you pick it up?
If I had $10 million, I don't think I would.
Yeah, but the thing is, with that attitude, you don't get to have $10 million. You actually got to earn it.
I know.
Yeah.
So, Silent, would you at least agree that we understand refraction better than you if that's happened? Because we have different predictions on what something should do.
What? You haven't shown it. What are you talking about, Baker?
I'm talking about...
We haven't done it yet.
Yeah, I'm talking about what will happen if
you haven't shown it to happen.
Yeah, we understand that.
And
we understand that.
Yeah, but you haven't shown it to happen.
Yeah, but
so at this point it's all speculation. Hold on. At this point it's all speculation, right? Until you demonstrate it to be the case, then we can talk about it. How you guys had the right understanding. Otherwise, you don't have it.
Right.
I'm not asking you.
You're doing the right thing, Silent. You're making a prediction. This is what we want you to do.
We're not asking you to, right now, admit that we understand better than you. We're saying that if it turns out to match our prediction, would you then agree that we understand it better than you?
How many times did I say yes? I don't know how many times I have to say it. I told Ruben yes. I told you now 2 times already. How many times do you guys want a confirmation? I'm not afraid. Listen, I'm not afraid to be wrong. You guys are the ones afraid, right?
No, we're not.
I very much.
I'm not afraid at all. I changed my mind already once.
Flat earthers, wow. That is the definition of ego getting in the way.
Why are you guys all getting mad? I don't understand all that. It's just a conversation.
I'm in the car. I've got to yell a little bit, so I'm not mad.
Well, good.
And I've got to go in a sec anyway. Here's the park. Very good.
Does it matter the direction of the source of light? When we talk about light causing everything to bend, does it matter where the light's coming from?
No,
light's not causing. Light's not causing things to bend.
Hold on a minute. The source of light coming from the direction it comes from has nothing to do with which direction it's going to bend?
It has everything to do.
Everything to do. So if the sun is directly above, so if the sun is directly above my head and there's a boat forward in front of me on the horizon, how can the light refract when it's above my head?
What do you mean the light is above your head? You mean the sun is above your head? You know, it sends light in all directions, right? Not only in your head.
Above my head, coming down to me, not forward.
Not just to you, to everything.
My eye, if it's shining down from the source at me, and if the source is the thing that I'm looking at, it's shining down at it. How could you ever get a refraction for that?
Because once it reflects on the object you're seeing, and before it reaches your eyes, it has to go a more horizontal path, right?
Coming from the ceiling. So my light
coming from the object.
So the light, so my sun above my head, just like the light in my ceiling, is going to come down at me and down at the top of the object and down at the top of my head, and I'm going to look out, and it's going to make that hop up and do a McDonald's arch to me.
No, it's the reflection from the object that you're seeing.
The reflecting from the object is going to make a McDonald's arch.
No.
What are we talking?
Simple. When you look to an object, you're seeing the light that is being reflected by the object into your eyes. There's no refraction needed for that.
The light that I see, the light source is coming from the sun. It's not coming from the object.
Yes, and it's reaching the object before it reaches your eye.
It's going to the object and lighting it up.
Sure, but if it lights up and the light doesn't reach your eye, you're not going to see it.
I can see through the medium before the light bounces off the boat. You understand that, right? Before the boat ever gets there, I can still see what's there.
Before the light gets the boat, you can see the boat?
No, listen. Before the boat gets on the horizon, I can still see the horizon, the whole horizon. So that doesn't have anything to do with light hitting the boat. That's not the only reason I can see the light. I see the light anyway, before and after and during. The only thing the light is doing is lighting up the boat so I can see it. It's shining on the boat, and now I can see it.
Sure,
light reflect off the boat to your eye.
How do your eye knows when something's being...
From the sun, down directly at the boat, you tell me where that boat, where that's going to bend. How could that possibly bend to me and not just straight to the ground?
Hang on. Are you kind of assuming that the light... Sorry, first of all, does the light bounce off objects to your eye?
No.
No, okay.
So you're blind.
I have no interest in this discussion if we can't even get that far.
Yeah, I think Dimok's blind, maybe.
Yeah.
It doesn't have to bounce to your eye. All it has to do is light the object up, just like the ISS.
Right.
Light's not bouncing, it's bouncing from the ISS to my eye.
It's interesting.
Dimok, he already told you
knows.
if you don't jump into his model, there's no point on conversation.
Right, but he thinks the light from the ISS is bouncing down to our eyes or our hands.
Yeah, I know, but he already told you. If you don't believe that, there's no point on conversation. Because you're not gonna jump into his.
Are you in agreement
right?
with Dimok, son?
All he has.
Yeah, I don't think the light bounces out of things. I think they're illuminated, and then you're able to see them.
Right.
So I don't think light is bouncing out of to your eye.
Right. You know how a camera. You know how a camera works. Like cameras are man-made. Like, we know how they work because we made them, right? You know how cameras work.
Yeah, you think the light is coming to the camera or what?
Yeah.
It's the same concept. Is something is illuminated? That's it.
Yeah, but
do we know how the sensors work on cameras?
Yes.
Yes.
Yeah.
And it needs light to reach it, right?
See the object. They see the object illuminated, and voila.
What do you mean by they see the object illuminated? What does it mean when they see the object?
It doesn't mean that the light is traveling to you, right? It means the object is being hit by light.
Right.
No, the camera sensor has to be, not just the object.
How does the sensor know it?
Listen, you guys are both wrong. Listen, if the light, not silent.
Oh shit.
Silent, you're right. Both those two are wrong. Listen, if the light is supposedly hitting the ISS, right, and then bouncing from the ISS to the ground, we should see a spotlight. Go stand in it. Hurry up.
Sorry, what? You can see a
There's
spotlight.
the ISS spotlight that bounces to you.
Oh, Jesus. Are you saying you should see a light on the ground that you can make out?
You're the one telling us light reflects from the object to you.
Yeah.
The ISS is being hit by reflected light. Why? How can you see it with light hitting you?
Okay. Do you understand that everyone can see the ISS at the same time, right? People in different, people 100 kilometers apart can see the ISS, right?
Citation needed, Ruhif.
I've done this myself. Me and Wally have.
Yeah, you're one person. You're not everybody at the same time, buddy.
You did only say a couple hundred yards, though.
Yeah, me, Wally, and Wade's Underworld have seen the ISS at the same time, right? So do you understand now that the light is reflecting in all directions?
How do you know that it was at the same time if it has to be some delay, right? Remember?
We have a phone. We have a phone clock We can ring up the time. We synchronize our fucking clocks. There's a video on it. Where's Wally?
Yeah.
Hey, I'm all for simultaneous observations, measurements, what have you.
Yes. So me, Wally, and Wade's Underworld saw it at the same time, right? It's not a spotlight. It doesn't reflect on a single fucking point on the Earth. Otherwise, only one person could ever see it.
Yep.
That's the stupidest thing I've ever heard you say.
Uh-oh.
And here's the thing. The sensors that we have on cameras, they're light receptors. And the way they're, the position of the image that every sensor is going to produce a color is dependent on the angle that the light is entering the hole of the camera.
Correct.
That's why it has a hole, so it can separate light that is coming from different directions, just like your eyes.
Yeah, and here's another one, right? Here's another one. If you're in a room full of mirrors, right, and you point a laser pointer, right, at that mirror, you tell me that's not bouncing? Come on, get out of here. It's bouncing, all right? That's just going... all right?
Hey, I heard someone say somewhat recently that light does not directly go into your eye, like in a straight line. It's like at an angle or something.
You do have a lens in your eye, yes. Same as a camera. So it refracts.
Which help more
In fact,
light.
why do you guys fucking ignore refraction when that's what lenses fucking do? Like how?
Well,
how
I
do you
think they
feel that
only
one?
ignore ingredients.
Oh yeah, great. Okay, yeah. So deny that it happens through a gradient, and don't quite understand that a solid object, you know, the whole, when it comes down to like molecular level, it's still happening the same as a gas.
I bet some of them deny molecules.
Oh, again, like another topic I do not care. Once you get down towards brain and that kind of stuff, that's the spectrum I see. It's like what can I deny next? Basically, that's the flat earthers' modus operandi.
Oh.
How far down do I have to deny something?
Okay, are you talking about a small group of flat earthers, or what's going on here?
Pretty much all flat earthers. Pretty much
Are you
all flat
denying they
earthers.
do it?
Well,
If you do, then it's going to be a conundrum for you. I'm just saying, it's a joke, but it's kind of a catch-22. If you deny that they do it, then you're also denying. Never mind.
Yeah, good one.
I mean, just here to be an adversary or what? I mean,
but an honest conversation would be good though. If you guys were capable of honest conversations, you wouldn't be.
whoa! Oh man, you seem like on the defense. You should sit down, take off your shoes.
I am sitting down.
It's Ruhiv. It's Ruhiv. There's
offense.
nothing else you
That
can
was the
expect from this guy.
Fuck you, motherfucker.
Well, that's really sad. I'm not trying to patronize you either. I apologize.
I'm okay. I don't actually know you. What's your name? Who am I saying to?
So Ruhiv, when is the crosshair from Ranty's gonna be exposed?
I think you know the answer to that question, right? You've been told the answer to that question how many times?
No,
Yes,
no. I
What's the
remember
answer?
last time I give you my prediction, you say you were not gonna do it until Bev or some important guy from the Flat Earther was gonna give prediction. A couple of them have done it. Is it gonna happen or not?
Who's done it?
Huh?
I haven't heard Bev done it.
But who's he
Well,
talking
you
about?
say Ranty was gonna do it.
What are we talking about here?
No. Who gave the prediction for the angle?
Bev and well.
What was Bev's number? I haven't seen Bev's
What do you
prediction.
mean number?
His calculation for the angle that you would expect to measure.
Oh, I don't know. You ask him. I give you mine.
Have you seen my interactions with Bev? Me asking questions of him.
Well, yeah, he doesn't answer your bullcrap answer questions.
Right. Well,
yeah,
question
you
is
ask questions about things. You ask questions that are nonsensical. What do you want him to answer?
How is it
Explain why
nonsensical
they're
to ask for a
nonsensical.
number?
Were you asking a measurement of angles when the apparatus doesn't measure angles?
No, I've clarified that with him. I said if he won't accept, listen, if he won't accept an auto level, I will pay for a surveyor with a theodolite to go up there and measure an angle. He still won't provide an angle.
0.04. Oh.
Why? Well, why it has to be an angle? You just want the crosshairs, don't
That's
you?
what fucking theodolite. That's what theodolites measure.
Ah, but the initial thing wasn't a theodolite. Now you have changed it to a theodolite? Then I didn't know about that. I apologize. I did not know that.
I haven't changed. I accept that the image through an auto level, that's a prediction. Bev will reject any observation done with an auto level. That's why I said, if you're going to reject that, I'm quite happy to send someone up there with a theodolite, as long as you make a prediction for the angle. But he won't. So.
All right, I didn't know that.
Yeah. So I'm happy with the auto
It's
level.
only Bev, right? I guess the problem is only Bev. You cannot do it for
Bev,
other people.
Bev, Brandon, someone with, Lemon's the only person that's actually made a prediction, and he made the correct prediction for Flat Earth. But, Lemon doesn't really have much of a presence, someone with the channel, someone that's willing to, that basically has something.
I see what you're doing, so that you can show that they were wrong, and go on all the channels and talk shit about people, and I see. You
guys are terrified. You guys are terrified.
I'm not at all. I give you mine.
Well, he's saying he just wants.
Oh yeah, I mean you're right. I mean,
find him your Flat Earth champion and have the discussion. That's I think what he's asking.
Yeah, have a genuine discussion, like I said a minute ago. Flat Earthers are terrified of having an honest discussion.
Yeah. Not me.
They're scaredy cats.
I don't know. I'm a Flat Earther.
Then
I guess I don't count, right? Because I don't have a channel.
I reckon if Lemon did a bit of work and got some people behind him, such that it was a consensus prediction, we would go with that. Yeah, if we get a consensus of half a dozen of you guys on a number, we're going to do it.
And he's gonna be the crosshairs of the auto level with and he's gonna be level and everything, right?
Yeah. And where will Blackpool? Yeah. So I gave my prediction as an image, like I made a render, but obviously underneath that render is a prediction for an angle. All right. So I'm going to stand by mine. I've put it out there 100 times.
Is yours like Chaika or Ruhif? That is on top of like in the sky?
What? I don't know. Anyway, I put mine out there. Bev is supposedly some sort of geometry expert and owns an auto level. So, supposedly understands them as well.
Oh, he went and did the measurements already. He knows what it's going to look like. But I don't know why. I mean, I can argue for Bev, right?
Sure. He put out a photo the other day from a place called Tarbold Hill, I think, and I made a video. Oh, sorry, it's the one Ranty put out. Sorry, so Ranty basically published my video, which is pretty cool. I analysed that photo, and that is the same analysis that I would do for the Winter Hill one. So you can watch that as well. It's what was the fucking title? Hold on. It was. Math Genius. That's me. Math Genius debunks crazy flat earther a week ago.
Damn.
Yeah, so go and watch that. I'll be back in a few minutes.
Alrighty. In the meantime, I'll take care of these flat earthers. Nothing too hard. Cracking my knuckles. Okay. Anyway.
Hey Arma.
What's up?
Are you familiar with programming of some kind?
I mean, look, I'm gonna be honest. I'm not nearly as cool as a lot of you guys. I'm just like a basic game designer hobbyist. You know what I'm saying? So
basic.
Yeah.
I mean,
everyone else here is actually a professional. I'm just a hobbyist. But go on. I know a little bit.
No. I was just interested in that. I mean, I've seen you trying to every time you're on the subject, you try to make some sort of simulation out of it. And
yeah.
And
are
really helps
you studying or do you work, Bacon?
I was doing both until some weeks ago. Now I'm graduated, so I just work now.
Okay. Nice. Good shit, bro.
Yeah.
Hope you do good and with I guess you're working as the thing that you study, right?
Yeah. Actually, the company they work for was
the flattered company.
No, it was in Mexico for a while, some years ago.
Oh, I see.
Maybe you would heard of it. I don't know.
You're an
it was called-
engineer or something?
Computer scientist.
Computer science. What does that mean? What is that?
Well, computer science would mean like it's science of programming, right? So, for example,
Programming.
Yeah, everything from operational systems, AIs. I mean, there are many. It's a very big field. It involves many different things.
And you specialize in programming.
Yeah, he worked there at Mexico Soft.
Oh, hardly ever some computer scientists won't be dealing with programming. But yeah, there is some. For example,
to me, it's a vague term. I don't know what that means, to be honest.
Right.
Yeah. Computer science.
Well,
Yeah,
computer
reading
scientist
graphs.
is someone that combines the technical knowledge with the analytical knowledge. That's a simple way of looking at it.
But to do what in life? What is it like? What is it apply on?
It's to develop new systems, new methods. So you can think of things like back in the 70s and 80s, computer scientists were the ones responsible for, the advancement of things like production control system, telemetry system. So it's how we collect that data, how we interpret that data, and how we utilize that data. Then you have programmers that will write the bit in the middle, which is then sort of taking that data and displaying it in meaningful form.
But then why not call them programmers?
Because
I am a programmer because I work programming, but I'm all graduating computer science. They're not mutually exclusive. Like programmer is more like something like you do, and computer scientist is something that you are because you studied in.
I'm not. No
It's like when you have a full
faking. I'm a
mechanic,
mere
a full
truck
car
driver.
mechanic. You don't call him a tire changer.
Yeah,
Yeah,
but I'd say
mechanic
it's more than
doesn't-
that. It's more about the design
A
of the
mechanic
engine as
doesn't
well as
change
repairing
tires,
it.
buddy. So just so that you know.
Well, actually, some mechanics do.
Mechanics can change
the
tires,
mechanics
though.
at my bike shop change tires for me as well as doing
Yeah,
repairs.
go to Brake
I mean, they know
Masters.
how to do it, but usually they don't.
No, go to Brake Masters.
Even in the truck stops or whatever, you can see that there's one for the tires and there's a mechanic that does the mechanical thing. So there's a
Except at Brake
difference.
Masters. No, you're talking about specific situations, but no, I'm sorry, you're wrong.
No, mechanic in this case, mechanic involves everything that has to do with the.
Ask a mechanic if he doesn't change tires. Also,
Do you want to bet?
Do
you want me to record you?
Mechanic change my tires.
Do you
dude.
want me?
So
Do you want me to?
I just had my mechanic change my tires.
You a couple on the
just
TA
did that.
and the pilot
I
asking
do
them
that every few months.
if they can change my tires.
Dude, you're crazy. You're talking about some specific place, right? I'm talking about mechanics in general.
Yeah,
Mechanics in
I
general.
answer by saying yes, they do, but they don't usually do. They know how to do it. I never said they don't know how to do it. Well, that would be crazy.
My motorcycle dealership are the ones that change my tires, and it's the mechanics that change my tires.
Thank you. And you go to you go to Brake Masters, right? And you get some new brakes on. Your mechanics put the new brakes on, and then they rotate and change the tires for you.
Nah.
It's just part of the program. They do it every time. It's not something they don't do.
Yeah, mechanic has all that in that
Depending on
word.
the
You know
place
what a
you're at,
mechanic does.
Right. So the point remains that you don't just minimize the mechanic to a tire changer just because he changes tires. That's all I'm saying. Damn.
Well, programming is one thing
Fucking
that you
analogous.
can actually do without knowing anything
programming
else.
is one thing that you can do as a computer scientist. You're not.
I don't know
just
what a
programmer.
computer scientist is, bro.
Well, maybe there's where we have the problem. A computer scientist is someone who is more than just a programmer, who does programming, though
What else does
so
he do?
much more.
Design systems,
analysis, all kinds of interesting stuff.
Oh, yeah, I mean, for example,
yeah, develop.
I gave you two really good examples of production control systems and telemetry systems. That comes from computer science. And you then have programming that goes on top that takes that data and make it meaningful.
Let me give you I think a better example.
He talked over the whole thing.
Like, yeah, I mean, the architecture of computational systems don't involve programming, and it largely comes from computer scientists.
All right.
And that's yeah.
Why do you use the word architect?
Sorry.
You're building something.
Yeah,
Why
they
use the word architect?
You're roboting a lot. An architect is not a builder. That's a good analogy.
Yeah, I'm sorry.
Because you're drafting plans for the build, you know.
Yeah, an architect is not a builder in the same way as a computer programmer is not a system designer, but they're both computer scientists.
I specialize in security operations for IT, and Bacon's probably got some good fundamental understandings of some of the stuff I do, but not all of it. The same way as I have a very base idea of some of the stuff that he does, very little to be fair, but certainly not all of it, because I'm not a programmer. I know how to use the stuff that programmers make and apply it effectively.
I think another good example would be protocols. I mean, many computer scientists design protocols, and they don't necessarily have to deal with the programming behind them.
RFCs, I love RFCs.
I don't like RFCs.
Yeah, there you go.
That's a fucking reason.
RFC 1518.
That will be a protocol designer, no?
No.
Well, if you work just by doing that, maybe that would be your profession, but you would still, I mean, if you graduate in computer science, you would still be a computer scientist.
Yes.
And you would still know how to program, most likely.
Yeah, I mean, someone will have to implement that protocol using programming, but the protocol itself isn't an algorithm or something like that. For example, proving the complexity of problems is also something that is, I mean, it's, I would say, completely done by computer scientists. And what I'm talking about complexity is asymptotic complexity.
So how about Moyak's hey Moyak, video that you posted earlier about the refraction? Where did anybody go with that? Refraction in air, real, you know, not a different change in medium. Example, hypothesis, prediction, observation. Where'd it go in this room?
Hey, Moyak.
Moyak.
Is he there?
Maybe if he's not, maybe because I haven't heard from him in so long. I doubt he is.
He's not in the room.
Yeah.
Oh, he's not in the room. There you go.
He posted it. Yeah, he posted it earlier. Was anybody else here? How did that discussion go? Or did that get wrapped up?
Well, it came out the fact that we can make a single observation for about 1 kilometer. Therefore, we can now point to the fact that plumb lines aren't parallel.
Oh, I still don't understand that. How are you making that?
Because he basically said that, you know, you'd need one sort of weather balloon per mile. So that means at altitude, per kilometer. That means at reasonable altitude, we can make an observation which is good for 1 kilometer. That's 1,000 meters or 3,300 and something feet. And the observations done by people like the main surveyor were done over about 1,200 feet. So we're good to go. Ching.
Oh, okay. So it makes main surveyors. All right, it makes main surveyor's observation acceptable to them.
Yeah.
Right.
I call it the Jeremy criteria.
You see, if the light brings you the object, you should see 1,000 of the object on the way from the object with the light in the light.
I've never had light bring me anything apart from an image, to be fair.
You should see a 1,000-foot mirror, 1,000-foot deep mirror. It should be 1,000-foot deep boat from you to the boat because the reflection coming all the way to you, the picture of the boat the whole way.
Well, at least one person found that funny.
That's a long boat. My boat goes over the curve. My boat stretches very far to your eyeball.
And it makes a noise.
Times around the globe, up into your eyeball.
Ooh, someone farted.
When the sun is directly above my head, the boat is climbing forward around the curve from my horizon.
Oh God.
That's
You
funny.
really should name- you really should
That's
change
funny,
your
isn't
name
it?
to Demok the Straw
The
Man.
light source has to be behind the object for it to do what they say, but yet they claim it's always happening. That's impossible.
There's so much craziness and voices and shit coming out of your microphone, Dimok, when you speak. It's like poltergeist.
There we go. I'll be your avatar, Demok.
I wish somebody knew how light worked. I wish somebody knew that a shadow was light.
Huh? What was that?
I think it's weird that people
Don't
think
even bother.
the path of totality from the solar eclipse, how it was only like 70 miles wide. You know,
Yeah,
that
Dimok,
makes it smaller than the object casted the shadow upon. Pretty weird.
Fairly normal. We can
That's
certainly show that we can have
That's an
shadows
inverted
smaller than
reflection.
the object.
That's just inverted light. Just goes
Yeah,
the other way.
Dimok, light hits the object, right? And then it has the photons bouncing off the object, and then the photons see you looking at him, and he's, holy shit, I gotta go to his eye. Otherwise, he's not gonna be able to see me.
How can it go to your eye and my eye if I'm at a different angle and orientation and slightly to the left or
Because
right?
of what I said
Well,
a million times. It goes to all directions.
Hold on a
These are-
minute.
no, these are actual.
The photon says,
these are
holy
actually
shit, a million
questions that
people
they're
looking at me.
Yeah.
Let's turn into a million photons and
And
travel
then
to
bend
those
towards
eyes
each-
at the same
Yeah,
time.
because it's
Go
just
towards
a
each
million
observer's
photons, right?
eyeballs. Personally.
I mean, come on. Two humans make another human. How does this even happen?
That makes a lot of sense. The light doesn't.
Come on. Serious.
Yeah, seriously, two humans making a human, how we all got here, that
No,
makes
the
sense.
light
I mean,
thing. The light thing. The light thing.
No, it doesn't make any sense. Light doesn't work any way that you guys claim. Your spherical claims are light.
You don't think it bounces though? I mean, come on.
Light? No, listen to me. Listen to what I said. Light doesn't do anything that you claim for the globe.
Oh, well.
And most of
No
the
way
things we
whatsoever.
actually
It's
claim
like
about
I
light.
didn't explain to you my idea of what light does at all.
This is a word that deals with light.
It's a little specific, Demok, you know? I mean,
it's very
hold on.
interesting how he
So hold
created
on.
cameras.
I got
Can anybody hear the humor in this statement? There's no
got a riddle
way
for you.
whatsoever does light reflect reality.
I have a
So
riddle
every
for
time
you.
I look, like right now I'm driving, right? And I switch from one lamp to another, and the photons are traveling to my eye so fast.
It seems like the light is traveling to the object, not the other way around, not from the object to your eye.
Exactly.
So who said that light bounces from the object to your eye, bringing you the object?
It bounces
Every
to
scientist
the object
ever.
for
Well, why are they wrong?
That's the first
The
time
whole
I
body
hear
of
people
science, Demok.
Maybe we should, you and you go hold hands and start asking
Science is
one by
always wrong
one all of
90%
them.
of the time, and 90% of the time, it's a freak accident for everything they discover is a freak accident. If they know so fucking much and they're always right, why are they always wrong?
Because we're not.
Well, make up my mind, bro.
It's been a long time since I heard that one. The whole body of science, Demok. The whole body of science
is wrong. The whole body of
Yeah,
physics.
let's make the experiment.
We have
as I
no
was
globe
proposing,
physics.
See what's wrong. The body of
When have
science
you
or
ever
silent
seen
zero.
globe physics? Bacon, can you demonstrate global physics on a small scale in a classroom?
There's no global physics. There's just physics.
There's no global physics.
There's just physics.
Welcome to Flat Earth.
No, what you. Is that even. Listen, is global
I'm sorry
physics
to-
even.
Welcome to Leprechaun Farts.
I'm sorry to suspect Demok is just here for the purpose of entertaining us. There's no way he's being serious.
I mean, sometimes
quick.
I feel that way, but sometimes, I mean, I don't know. Yeah,
No, he actually believes the things he says. So, don't.
You can't say that. I mean, if he's a very good troll, that's what you think, right?
No, well, I mean, I know
He's a
Demok
Gemini.
for
He's half the time.
for
he's
what,
serious, so.
Demok? 5 years?
The thing
Probably,
with
yeah.
this light,
For 5.
The thing with this light, thing is, you could have people a mile around in a 360-degree sphere around an object, multiple objects, and they could see all the objects. You're telling me there's infinite light rays coming off every object, crossing through all the other infinite light. Hold on, my wife just walked in the room. She's looking at me like I'm crazy.
She figured
The
it
waves
out a
are
long
just
time ago. Who are you kidding?
how you're showing the spreading of the light. It's not that they travel as individual rays. We describe, first of all, we don't describe photons as like tiny balls. They're described as wave functions. So they aren't actually particles when they're traveling. That they're just a wave. So yeah, waves don't travel individual light paths. They, in some sense, they're the wave is just covering a whole area, right? It doesn't have holes or missing
So what makes
parts.
an image so sharp, man? How can we see things in such great detail?
Yeah, because once it enters your eye and interacts with your retina, then that wave function collapses, right? And while it's interacting with your retina, and that's how your brain knows what the light is getting to your eyes. Same way
And the
cameras
photon
work.
dies at that point, right, Bacon? The photon dies at that point. It doesn't bounce it anymore, right?
No, it's
What
converted.
happens to the photon? What
It's
happens to the
converted into a
photon when it
tiny
hits
little
your eye?
electron.
Hold on.
that's
What
one
happens?
thing-
What happens?
To the ones that was absorbed by your sensors in your retina?
Oh, they get absorbed.
Yeah, I mean they turn.
I get energy
I don't know
out
who
of
said
looking.
it, but they turn into electrons, right? That's how they interact with the. Yeah, I'm not
Holy
sure about the
shit.
subatomical reaction between photons and the sensor in your eyes, but if I'm not mistaken, yeah, the way they interact is as described in Feynman diagrams, right?
I should be getting fucking energy out of that shit, bro.
Yes, it's called solar panels.
They call light energy. There's a heat transference. Yeah. Come on, man.
Love it.
You know that. You're making it easy.
Well, hold on, silent. Don't get the wrong idea. If you look at the sun, it's not like you're gonna like recharge your battery or some shit. You know, like you're not gonna like.
I am. Why not? Why not? I'm absorbing the photons, bro. The energy. Why not?
It's not.
That's not how
That's not how it works. Holy shit! Oh, so it stopped at your eye, huh?
That's how
yeah, just like how
charged.
just like with the camera. I mean, it was absorbs it and it does shit with it. You know, I mean that's come on.
That does shit. Come on.
Yeah, it turns into electrical current.
Is that the best you got? It does shit. Come on.
Yeah, it does shit with it. I mean, what the hell? What am I supposed to say? Like I don't know. This is stupid.
I don't know, buddy. You're the expert
like
of
talking about
photons
the
coming
cones
to
and
your
the
eye.
lasers
I'm not an expert. I never said I was an expert. I just said that.
Yeah,
it
he's
does
trying
shit.
to embarrass you. He knows that you're not trying to make an argument.
Yeah, I
He's
know, but
just
he
taking you out
should
the route.
watch it though because I don't know, but he should.
I know. Easy does it, champ. We got you.
Yeah, no, I was just joking. Anyway,
Oh, Grim,
I know.
So Grim, you agree that the photon travels to your eye?
I don't believe in
Grim?
I don't believe in photons being massless particles, dude. So you're gonna climb up my tree.
I
you
don't
better get
either.
some grappling hooks.
I don't either.
You need to go somewhere, fly a kite. You know.
I was flying a kite the other day, dude. Stop that shit. Those are interesting things to do. Wasn't even my kite.
Yep.
And I'm like, can I hold that for a minute?
Yeah.
Sure.
But anyway,
Hold my
though.
dog. Trade you a dog for a kite for a minute.
Oh my goodness. Anyway, though, I don't get how flat earthers, or maybe not flat earthers in general, but the guys in this chat saying that light doesn't bounce. I mean, there's a lot of evidence for it. I mean, Silent, what would you say happens to a laser pointer when let's say you're in a room full of mirrors, okay, and you shine a laser at the mirror, all right?
Do you think that when you see yourself in the mirror, there's a second arm in the
when he
in
says
the mirror?
bounce, what do we mean by bounce? Because how do you bounce
that
a
what you-
massless particle? off of something.
Hold on, Silent.
Yeah, that's what I'm asking.
Hold
Do
on,
you
Silent,
think when you see the mirror, do you think you're seeing a second person there?
Where the hell did you get that from?
Well, you're saying it's bouncing. It means it's replicating, right? It's bouncing. It's something there.
No, no. Look, all right. You got a light bulb, all right. There's a bunch of. You know what?
It's a reflection.
I'm not gonna get into that actually because I'm not. No,
Yeah,
I'm not
a reflection.
about this.
A reflection.
It's so tricky.
A
I know.
reflection.
It is.
A reflection doesn't mean there's something bouncing out of it.
Wait, no,
it's
never
a
mind.
reflection.
Hold on. I'll get into this. I think I know enough for this. All right. So you have a light source, right? Like your light bulb. All right. That's usually roughly more or less white light. All right. Has a lot of the wavelengths in it and whatnot. Right. Okay. The light comes from that. Bam. It bounces off of you. Right. Now the stuff that you absorb. Right. Like for example, like I'm like a tan color. Right. So that's like orangish. Right. So my skin is absorbing the blue light, but it's bouncing the orange light. Right. Bam. All right. That bounces off of the mirror. Right. Bam. Into my eye. All right. I see, relatively orange. It's tan, but you get the point though. All right. And so, yeah. All right. It bounces. All right. And
it's emissivity and absorption. Yeah. You know what I mean.
Yeah. The light that didn't get reflected usually gets absorbed. Right?
Yes, but the cameras in our eyes, they usually absorb a lot more than they bounce though. So
absorbed by what?
Right? Just material, it absorbs stuff. Darker stuff absorbs more, and that's why solar panels are usually darker.
Like
I'd imagine,
dark stuff absorbs photons.
Everything do this,
everything.
but black things do it more because that's why they're black.
Because there's no such thing as a perfect reflector, so everything absorbs light at some
extent. Yeah.
Oh yeah, that's right. Yeah, it's black because there's no light bouncing. Yeah.
And
there you go.
For example,
forgot about that.
Glass is usually like greenish. It
that's a weird.
Absorbs green less than it does to other wavelengths, so you see it a little bit greenish if you see light going through a very.
You can see that effect. You can see that effect really well if you have two mirrors. Yeah, like if the two mirrors are facing each other, and then you see
that
it starts getting greener and greener, which is really weird.
Exactly.
Yeah.
Which is different from the sky, for example. The sky isn't blue because it absorbs the orange.
At this point, I don't know if you're trolling or you're being real.
No, that's well known. Silent. I'm not making this up.
How is he trolling, man? Silence. Stop, Silent. All right.
You don't know Grim, bro?
That's the only way I could rule out a glass dome because it wasn't green.
Oh shit.
The only way.
Isn't there a green shield where the ISS flies? Isn't there like a green amount of you can see?
Like they're trying to melt the glass right before they get to it?
No, I'm just saying.
Yeah.
A layer of green. When the ISS is supposedly flying, you can see a layer of green. Anytime they supposedly give you high altitude, very high altitude, there's like a layer or a shield or a field of green or something like emitted from the Earth.
Right. It's isn't that, what is that? Oxygen?
Is that the dome?
Ionized.
Wait,
what color is oxygen when it's ionized?
The dome?
You saying the ISS is a personal dome now?
Hold on. You're talking about the green color. I'm giving it to you. Now what?
Well, I've always told you guys that your firmament is the magnetosphere.
Well, I mean, I'm just saying, I'm giving you the green color there. We can actually, supposedly.
I think it's just what the ancients understood about there being some sort of
resistance in the mediums. Yeah, of course.
Yeah, or different effect out there that they didn't really understand, and they would call it a firmament or something.
Yes, sir. It makes sense to me. Because it's soft, yet it's hard, yet it's smooth, yet it can be.
And I bet at some points in history the firmament would light up like, how we have these Stevens, these little these auroras that come around. They're popping up all over the planet now. And I bet that at some point in history we had electromagnetic effects like that as well, where the ionosphere and stuff would light up, and we call it the magnetosphere, ionosphere, all that together. But it would light up in ways that would, probably just light the whole thing up in would look like, obviously, a dome from one hemisphere, like from one area, from coast to coast. Or not, it wouldn't even be coast to coast. It would just be from your horizon to horizon, whatever that would be. It could could definitely look like that.
Mm.
You know, the big old electric fucking green glowing oxygen and argon and shit
Super Aurora
all
Boreal.
above your head.
Yep.
Yeah.
Yeah, and the Aurora Borealis. Isn't that like,
No, Greaves. Those gases absorb less green. That's why you see
It
them
would be like
green.
how Mars took on a coma, you know, it'd be like the coma.
Yes, silent.
That's what I'm talking about.
He
The coma of
absorbs
a
less
comet.
red.
What?
Mars absorbs less red. That's why you see it red.
Right, it absorbs blue light. Yeah, he's got it. I'm just saying. High five.
Yeah, that's true about most things that have color. It absorbs.
That's what it does. Yes.
Yeah, but who expected him to actually use that
You
as
can
a good
you can
example and do
even
it?
you can even measure, for
Right.
example. I mean, Silent, you probably
No
realize that
offense.
black things get hotter in the sun more than clear things like white things, right?
Yeah, because black absorbs hot.
It's just racist.
Heat.
Yeah, it absorbs light, which turns into heat.
Heat. No, absorbs heat.
Are you serious? It only ever does
light
that when
converts
it's
to
light
heat.
outside. So where's
Why
the
in
heat
the
coming
shadow?
from?
The light converts to heat. That's the
Where's it
thing.
coming from? Where
Arma gets triggered.
What's
What's
heat?
wrong, Arma? Why are you
What's
so
heat?
triggered today, Arma? What's going on, buddy?
Nah, don't worry about it. Anyway, go on.
Iron hole.
All right, Bacon, go on.
Right. What do you think heat is, Silent?
It's light.
Okay.
Whoa.
So you.
No. What is it? No, I thought you were
infrared
gonna
light.
say that it's light.
No. Of course not. I didn't say it's light.
Oh. Well, heat to me, I don't know. Energy.
Heat is a collection of
I don't know what
energy.
you're asking. What are you asking?
Well, actually, that's a hard question to answer. I mean, temperature is an
stored
easier one.
as a capacitance. I know it is tough, isn't it?
Capacitance is that still heat?
Well, it's not really, but it seems like it, you know, if you could think of it that way, stored energy that's being slowly
Again, you
released.
think-
Obviously, if you know,
For
it has a
what do you think?
radiative
Why do your eyes don't get hot when with all this light that is going to your eyes?
They do.
Why is
They
there
do.
a strong
They do.
force?
Look at the sun for about 20 minutes.
Yeah, I mean, why do you
No,
think
James.
it
No,
burns
the
red?
photons, right? If light is heat, then
it turns into
why
heat.
Oh
doesn't?
yeah,
When things absorb light, they
intensity.
warm up. Yeah.
Yeah, it's about intensity. We're not measuring that kind of heat at absorb. You know, too much.
I mean,
Some light, like infrared light, we can feel it.
Exactly. That's how we measure temperature.
Y'all
That's
know
how we
it's about
measure.
them subatomic particles, bro. Sorry, we like.
So enough. No, you.
I mean, what's infrared light to Silent?
Radioactive.
What do you want from me, Bacon?
Radioactive.
What deals with decay or radiation? Is that the weak force?
No, it's electromagnetic. No,
Saying it's still space time doesn't solve any of this bullshit. Strong force, weak force. It's all matter and energy is the same thing. Period. Period.
I'm almost done with my shift. What do you want from me, Bacon? What was the question?
Yeah. Do you have any?
So yeah, what is
hypothesis on
infrared? Isn't
what
that the
infrared
question?
is?
Yeah,
Yeah,
it's
yeah.
a form of
Do I
light.
have any
right?
hypothesis of what?
On what do you
It's light.
think?
We
Of,
can't really see it with your eyes, but you can
yeah, well, infrared is.
feel it, or you
The
can measure
UV
it.
lights and all that stuff.
No, UV is different from infrared, but it's similar in respect. I mean,
Electromagnetic spectrum. Yeah,
exactly. I mean, UV is right.
it's still light.
Has a higher frequency than violet, which is the highest frequency we can see.
Which category involves more virtual particles?
I have no idea what that means.
Yeah.
And what the fuck does it have to do with the shape of the Earth, honestly?
Well,
I want to awaken because they're talking about the dome, brother.
Are we?
Well, DMOG was.
Oh,
telling
no.
you,
listen, you have a
Dimog's
million.
also talking about different things at the same time.
Listen.
All right, Jeremy's
you have
back,
a
guys. Let's listen to his example,
You
please.
have a million observers, 10 million observers. Let's say you got a planet, right? Where this is in your globe model. We have a planet, and there's a trillion observers all touching each other all around this whole planet in the middle. And there's other planets that people can see these other planets. There's like 3-4 planets, and there's a sphere of people all around them, all observing these planets.
Okay.
Now, everyone can see every planet, give or take. You have the light rays from one planet going in this infinite spectrum out. At some point, the light rays from both the planets have to like cross each other. How they getting by each other if it's like traveling?
Light Coriolis.
No, you don't understand what I'm saying.
That's a great question, Jeremy.
There has to be a point where there's
Because
two.
invisible
There has to be a point where there's
until
two. Hold on a second.
it
There has to
reaches
be a
an-
point. Hold on one second, Grim.
Sorry, man.
There has to be a point where there's two or more of these light rays that's sending an image to two different people in the same exact spot.
I'm not following you at all.
Each light ray actually does have to come from its own original spot to reach. If one is behind the other, you won't see the other one. So it's only a self-confusing question because it's that's not really what's happening.
There's some point in which their light is reaching the same point, right?
Yeah, reaching, but not coming from. No, all those separate lights have to come from their own original point.
I mean, they're coming to that point.
Right, and if one is behind the other.
So if you put a camera there, they're going to reach different parts of the camera sensor, and they're going to appear in different positions on the image that the camera produces. So, I mean, it's all fine. Everything's still fine.
Right. Each one has its own direct path to you, is what I'm saying. Nothing. If one is in front of the other, which would block your path, then it would also show that it's being blocked. You know, if I have two guys standing behind the other, and I'm standing and they're right exactly perpendicular where I'm looking straight at both of them, but I can only see one because one is behind the other. Right. That's just that would be normal. We could observe that.
I'm gonna have to draw this out in a diagram. You're not getting it.
Yeah,
diagram good.
That'll be useful. Everyone should do it. Once people are understanding, they should draw it.
What if if we're talking about near direct paths to you from each object, then I don't see this crossing of light paths that you're worried about.
Picture two people looking at two different objects, right? It forms a rectangle, let's say.
Okay.
Both the people can see both objects at the same time. They're at the same
elevation.
Diagonal? Yeah, they're looking diagonal. So the light there is a point where both of the light rays from different objects have to be taking up the same exact spot in space.
Yes.
That's what I'm trying to say.
Yeah, but what's your actual point though? Yeah.
That's in the middle, Jeremy.
What's the
point?
That's
happening?
You have two objects occupying the same space. You don't think that's a problem?
No. That's not how Jeremy.
Jeremy, what are interference patterns? Have you seen an interference pattern? What is that?
When peaks interact with peaks and troughs interact with troughs. And all that.
Yeah, and they meet at the board or whatever.
Yeah.
That's two photons interacting in the same spot.
There you go.
And cancel each other out.
I would like, if I could take 2 seconds to say to Jeremy, the thing from the two corners of the objects coming to the two corners to the people, those aren't going to cross on their way to the people. The spaces where they're like meeting is all in the middle and all that shit.
Yes, they have to. In the middle, somewhere in the middle, these two light rays meet, and they're occupying the same space now.
But nobody's looking at that.
They're both hitting you. Yes, both the people are looking at it.
That's fine. Well, again, interference pattern. What's wrong with an interference pattern?
So does interference pattern make it so you can't see the other objects?
If they cancel each other out, yeah, exactly what they do. That's what an interference
pattern.
Jeremy,
hold on. They're not looking to the middle to see these objects, Jeremy. If they were to do like a radiation scan on the middle area, there would be interference. Okay, well maybe I'm missing it.
If these interference patterns canceled each
He's
other out,
talking
you'd
about-
never be able to. If these interference,
He's talking about quantum
patterns
effects, and
cancel-
you're not, Jeremy.
Come on, Grim. I only got a couple seconds here. If these interference patterns cancel each other out, we would never see nothing because there would be constantly these light rays are going infinite directions from the sources.
Yeah.
They'd be constantly canceling each other out. We'd never see anything.
No, they're coming straight to you. Anytime an observer wants to observe, they become in the middle of the light rays. Anytime you observe, the light rays now coming straight to you. There's nothing in the middle anymore. You're going from the corner to the corner. They're not interfering. It's going around the border of the rectangle.
He's asking what happens when light rays interact.
I don't think he's asking.
They'll either. What are you asking, Jeremy? You seem to say that there's two photons occupying the same physical space. Yes. And? Did everyone stop talking or did I drop out?
No, everyone stop talking.
I was driving along. What the fuck happened?
If the light's behind
my best to understand what his
fucking
problem is.
Rayleigh criterion. Rayleigh criterion is two photons interacting in approximately the same space as well, where you can't resolve them.
Oh yeah, doesn't light aimed at light make matter?
To me, I think photons are matter. To me, and they hate when I say they think I'm the dumbest person in the world.
Yeah, it comes down to definitions again, which is semantic, and
The interference patterns don't always. Go ahead, Nemar.
Oh, you're good.
Yeah, I mean, if you look at E equals MC squared, then energy
Nemar
got
said I
matter.
was good, and then you go. Come on, Rohit.
Come on.
The interference. I know. Just hold on. I only got a couple seconds. The interference patterns, when they interact with each other, the light appears to bend, but doesn't actually bend. Do you know what happens when a peak meets a peak and a trough meets a trough?
When you say, are you talking about refraction now or two photons?
No, this is not refraction. So you don't. Once again, Ruhif, if you don't understand what you're talking about, you don't know about the interference pattern. Don, you don't know how does it measure? See, now he's going to jump in. You guys make it way more difficult than it needs to be.
You use the word bend. What do you mean by bending in relation to photons? It's not refraction.
How do you ever see two light bulbs at the same time?
Go again?
I wonder how you ever see two light bulbs at the same time.
Right, that's kind of the point. I'm like, aren't you in the middle of it? Like, Jeremy, what are you expecting to observe this middle area where they're meeting and mixing? That's what I'm missing. Yeah,
like
go ahead.
spider webs. Are you saying like the photons, like spider webs would interact with each other before getting to you?
No, listen, if you have a row of people, if you have two people and they're looking directly diagonal, you have a perfect square made. They're looking directly diagonal through each other's optical corridor. Okay? You guys with me so far?
Mm-hmm.
Sure.
Okay, so there's light coming from the one object diagonal to the one person, and there's light coming from the other object to the other person diagonal. There's a point in the middle where these meet. They don't cancel out because they can still both see the object. So that bullshit Ruhip said about interference patterns is fucking nonsense.
Okay, where are the objects, Jeremy? Are they in the other two corners of the rectangle?
Yes, Don, keep up.
Okay, okay. Well, I just want to triple make sure.
Okay.
When I say cancel out, they cancel out at the board, right? At the board. If you move the board further back, they'll cancel out at another point. It's at that point. So even in your example, maybe they do cancel out at that point, right? But they travel through each other.
Can you see one photon canceling out another photon with your naked eye anyway?
So you're saying they cancel out each other and we can see it or we can't see it?
Sorry, we can see it because even if they cancelled out, they would cancel out at that point only, and they would continue on.
Yeah, so they're going through each other, and because we can see them both. So they're not canceling out because we can see them.
No,
exactly.
listen to what I said again. They're canceling out at that point.
Okay, yeah,
All right?
yeah.
If you were to move that point, you would change where they cancel out at. They don't just disappear. They still exist.
So they cancel out at X distance.
They don't cancel out
and
because we
then
can still see them. They're still traveling through each other because we can still.
right, and they will cancel out again at X+1 and X+2. They'll cancel out many times. But in your example, they're only meeting at one point.
Listen,
So they only
first of all,
cancel
do
out at
not
one point.
listen. Guys, do not listen to Ruhif for what he's saying right now. He doesn't even know about the apparent bending of the light, not refraction. The fact he even mentioned refraction tells me he doesn't know nothing about this interference pattern and how it works and the canceling out or not canceling out of the light.
Absolutely do. How is it bending then? What do you call bending?
It's not actually bending. It's an apparent bend.
Okay, but I still have no idea what you're talking about. If
Because
it's not
you don't know
refraction.
what we're talking about. I know. I just made
Okay,
that.
then explain it. If you understand, then explain it. I'm asking you to explain it.
I don't understand. You know what, Ruhif? I know just enough to know that you don't understand it.
You can't even explain to me what you're talking about. You're talking about bending of light. The definition of refraction is bending of light. So what are you talking about if it's not refraction?
The light's not actually bending. It only appears to be bending.
Okay, in what way?
Talking about the
What do you mean?
Down, doesn't matter. It depends on which way the peak hits the trough or the trough, how it interacts.
So you're talking about interference.
Yes,
Constructive
the
or
apparent
destructive
bending.
interference.
And the
Right.
apparent bending of the light, not actual bending, apparent bending that you don't know
Okay,
anything
so that's-
about because you thought it was
So that's
refraction.
not.
Well, when is light like a force field? Is light a force field to light? I mean, that's what Ruben's trying to say, that the other one cancels the other one out like a force field, like stop here.
It doesn't cancel it out, Demok, because we can still see both the objects.
I know.
Nothing gets canceled out. The two people can still see both the objects when they're looking diagonal from each other. The light's still getting through, so nothing's getting canceled out.
I'm pointing out the stupidity in what he's saying because he's acting like it's a force field and it's not. Clearly, I know that.
First of all, you only get the interference patterns when it's happening in the same phase or wavelength or some shit. So, I mean, if this is happening on Earth with every object we see, they can only make this even happen with laser beams.
I'm not down with what he's saying. I'm just saying he's saying something goofy, like he's got some force field light that stops all light, which is impossible. He said a laser cancels out another. That can't. I mean, or the light cancels. It's not canceling it out. Clearly, it can't be. It's an interference. It's not a cancellation at all, ever.
Listen, there has to be a point in the middle where this light is sending an image back to you. Okay? And there's another light sending another image back to another person. This happens nonstop. This happens nonstop. And both the people can see diagonally through each other's optical corridor in the same exact spot. You could have lines of people all over the place doing this, everywhere. And nothing gets canceled out. They can both see the object. So there's a spot in where the X meets where there's the light is being, the image is being portrayed back to the person, and it has to be in the same spot at the same exact time. This is happening everywhere on Earth with this bullshit light ray theory. It's fucking nonsense.
Yeah, it is. Isn't it funny how the light's actually hitting the back of the object that they tell you has been? Okay, so if we're on the other side of a curve of the planet, and this boat is sitting on the other side of a curve, and the first source that hits the light is the other side of the boat, shouldn't that be the source that's brought to us? You see what I'm saying? It's a mirrored image, like left, right. It's inverted. It's seeing the other side of the boat. We're seeing the front of the boat. The light's shining at the back of the boat towards us. So how the fuck is it bringing the front towards us when it's only hitting the back of the boat? You get what I'm saying, right? If they're saying light hits the front of an object and brings that to you, this light's not hitting the front. It's not going around the boat hitting the front.
Where'd Ruhif go? Did I scare him off?
Maybe.
He doesn't know what he's talking about anyways. It's nonsense.
Right.
The fact he mentioned refraction with this interference pattern. Tells me he doesn't know. He never heard anything about this apparent bending of the light.
And that other thing they said about betting money or getting a level playing field, there's no such thing. And the laser thing wouldn't work because you know what these guys would do, Jeremy? They would just shine a laser through the water and be like, "Oh, there's our calculation. Oh, yeah, it's a globe that we did it off of." That's all they would do. That's it. I mean, I'm like, what the hell? I mean, and they say they have evidence. They don't have any evidence because the only evidence they have is making stuff up and saying you're on a globe now, and everything we measure is from a globe. When
If that thing was happening, that interference pattern, like Ruhib just said, everywhere on Earth all the time, light would be appearing to bend, not actually bending. It would be appearing to bend all over the place. Crazy, because that's what you get when you have this you get an apparent bending of light, not actual, not refraction, not actual bending of light, apparent bending of light.
Right.
The thing that he didn't know nothing about. These people are not, listen, these motherfuckers got us gassed up. They do not know what they're talking about. I don't know shit about this interference pattern and the when a peak hits a trough and a trough hits a peak. I know just enough to know that he doesn't know what he's talking about, though. You don't even need to know a lot. I'm not a smart guy. I'm not a fucking genius wizard.
Jeremy, I'm missing where
all
you
night.
observe it. Where are you observing the mix?
All night, Jeremy. Baseless assertions all night long, bro.
Bro, they be making this shit up. They make this shit up, dude. These guys in here, these anti-flat earthers, they're just making shit up.
Now listen, Jeremy, Ruhib told me it doesn't matter where the light shines from. So if the light's behind me, he said it doesn't matter where the light is coming from to like shine off the object or curve around the earth to give you that. And then the other one said yes, it does, and actually truthfully told the truth. So like clearly, you know. Like Bacon or one of them was like, yeah, it does matter where the light's at every time. Which is true. If I got the light source behind me and they're telling us everything at the horizon, a light is hitting that. Where's it hitting it from? If the light source is the sun behind me or up in the air, or it's the left or to the right, the light has to be behind that at the time that they're saying light is hitting it and coming to me. It's idiotic. So it should clearly be impossible if the sun is anywhere but on the other side of the boat. If the sun is above my head, I should never see anything going around any curves or any light bouncing anything anywhere.
Literally, if you're in a room, wherever you are, look around right now. There's an infinite amount of fucking light rays all interact, because there could be observers anywhere you're in or the area you're in or anything. So there is an infinite amount of these light rays that are having an interference pattern all over the place. Nothing's fucking canceling out. All the lights getting through. We can see the whole. Everyone would be able to see every part of the room they had a line of sight on.
Jeremy, I thought you were going to talk about maybe like sparks in the air or something, but the thing is any point where you start observing, you're blocking them interacting with each other now. They're now coming straight into your eyes, right? And you're saying there should be other shit mixing with them. I get that, but it's like think about like a billion, like think about trillions of bullets spraying at each other in all directions. Like, sure, some of them are going to crash, but some are going to get through.
No, listen. If it hits the target, if the bullet hits the target, okay, the boat's the target. Okay, you're a guy going to shoot the boat on the other side of the boat. I'm on the other side of the boat. The boat's in the middle of us. We're on a curved planet. You get what I'm saying? The boat's in the middle of us.
No,
you're going to shoot it. Well, draw a circle. Okay, draw a circle on a piece of paper. Put you on one side, him on the other side, and a boat in between you guys. Your bullet represents the light. I'm going to shoot my light at the boat. Now, how's that boat, the bullet, going to get to you when it hit the boat?
I don't know what the fuck you're saying. The point is, there's an infinite.
The light going to hit you if it's being blocked by the object it's hitting. If light hits a building, I'm going to see darkness around that area where it's hitting coming to me. The building's blocking the light.
I don't know.
Jeremy, he's saying, Jeremy, yeah. He's saying if the sun is hitting the boat from the back, like you're looking at the boat. The sun is hitting the back of the boat from your perspective. How is that light bouncing from the front of the boat to you?
I don't know. I thought of a new way to
No?
put this in I thought of a new way to put this in perspective, though. Listen.
Oh my gosh.
Pretend you have an infinite amount of observers. There's just observers stacked as close as the eyeballs can get. 100 feet, or say a mile above the Earth, just layered. There would have to be so many fucking light rays interfering with each other, no one would ever see anything. They're not interfering with each other. Everyone can still see everything crystal clear wherever they look. It doesn't matter how many observers are there. There's points where these light rays have to be in the same spot at the same time. That's my problem with this. You have a photon, what is supposed to be a physical object to these guys, in the same spot at the same time. This is like some kind of law of nature that two objects can't occupy the same space at the same time or some shit. You guys ever heard anything like that?
I like where you're going, Jeremy, but
that's why I'm telling you the light can't hit the object and come to you too, because it hit the boat, the front of the boat. You're on the back of the boat looking at the back of the boat.
They have concepts that
Dimok, your example is different than what Jeremy is talking about, bro.
Oh no,
Just
I
so that
know.
you know.
I know that, but I just want him to understand what I'm saying. I don't get how he doesn't understand it.
But you're right, Jeremy. It doesn't make any sense.
Right. But Jeremy, do you understand if you shine a flashlight at the wall and somebody's on the other side, they don't see the flashlight, buddy?
Yeah, no shit.
Yeah, so shit, if the fucking sun is on the other side of the boat and it hits the boat, how the fuck are you seeing it when it's shining on the back of the boat, not the front? You comprehend? Same thing, same example. The sun is on the other side of the wall. It's the flashlight. It's hitting the wall. You're supposed to be looking at the wall. They're telling you that light is hitting that somehow, the front of it, and coming back to your eye. How's that possible? The only way it can't be possible. Light can only be behind it and hit the back of it. It can never hit the front of it. The only way light can hit the front of it is that the sun's behind you, shining at the front of the object, and then shining it back at you. If the light is in any other position, you'll never see what they're talking about. It'll always be blocked. You get it, right?
You can't see light if it's behind a wall, yeah.
Exactly. So if the sun is up in the air at high noon and the boat's out in front of you on the horizon, how is the light source behind it to do anything, to bend anything, to bring you anything? It's not coming from that area. So how would that work?
Listen, something's bending because we're not getting straight lines out
I was
there.
gonna say that, Jeremy. The light is bending. You know,
I'm not saying the light's bending. Listen, I'm not saying the light's bending, but that's what we call it. But the fact we can't make consistent straight lines to objects in the distance if you don't change your observer height and if the thing you're looking at is static, the fact that we can't make straight lines to the same straight line to it every day, every day, every week, every month, we have to make a new straight line. That means we're not seeing in straight lines. Facts.
How do you shoot?
This shit is not a debate. That's not even a debate. We're not seeing in straight lines. Period. It's demonstrable. It's objective. It's definitive.
I don't even know what you're talking about.
I'm telling you, we don't see in straight lines, Demok.
Straight line, how come you don't see any tilts?
Demok, if we did see in a straight line, you would be able to make the same straight. Hold on, bud. If we were, I'm all fired up. I don't know why. If we did see in straight lines, we would be able to make the same straight line to the same object in the distance. If neither things are moving, day after day after day, hour after hour. That's not the case. We have to make new straight lines because things are apparently moving, even though we know they're both static. They're apparently moving.
What about my response, Jeremy?
You mean the medium is different?
Whatever's happening in between you and the object, we're not seeing in straight lines because we can't. If we were seeing in straight lines every day, every minute, every hour, we'd be able to make the same straight line to the same static object nonstop.
What's your response?
Every day, every minute, every hour. The only thing that changes is the atmosphere and the temperature.
Dimok, Crux wants to say something, bro.
All right, Jeremy, I gave you the response of like bullets flying in all directions. Like, you know that you could have crisscross traffic. Like, we could be firing in an X bullets, and if the timing is right, they're never going to smash into each other. One will go through when the other one has a gap.
And the thing is these photons.
Billion trillion vectors.
Hold on, Dimok.
Oh, go ahead.
The thing is these bullets, Don, they're not bullets. They're solid steel beams, and there's going to be a point where they're in the same spot at the same time. You can't have an object occupy the same spot at the same. That's got to be like. I'm gonna have to Google that. You guys didn't Google that
I
yet?
like that, but the solid
hold on,
steel beam is
Crux.
probably where the misconception is going to come.
Are
in.
you
What's
saying
up?
that each bullet contains all the information necessary to resolve what the object is?
I'm pretty sure.
All right.
I could be wrong, but I'm pretty sure.
Do you know what I'm saying, though, Don? Like, these aren't bullets, and they're just barely missing each other. This is a constant stream of bullets. Think of a rail gun or a solid steel pipe or something.
And Silence making like, I get it. He's like, yo, you're only going to get one piece from each bullet, so you need the whole, like, all angles coming in to see the whole image, like the whole object in the background. And how is all this crisscross happening? But Jeremy, I don't know why you're calling them steel beams. That is a throw off.
Because the image, Don, the image never stops. It's not like the images are flickering at us. We can see it nonstop.
It's because it's so fast, we can't resolve it. You know what? That they'll tell you that our brain, if we could process faster, that you would see flashing photons.
Well, what's the best camera we got? What's the shit for that? The numbers for that? Saying it's faster than that. So
you
it
wouldn't
is.
even need a camera. You would need a photon detector.
I don't know, bro. This whole light thing's bullshit. We're never going to get anywhere with it unless we show that there is magnification in the atmosphere.
Right.
This light shit ain't going to do nothing for us.
Well, I love your idea, but the thing is, Jeremy, it is a a level 1 idea, so I'm sure that they've worked on it, and I'm curious if like they only are solving this with quantum, or if they have like a crude concept for how this is solved. Which I don't know. It's kind of a cool question, but they have to have thought about it, right? It's not that deep of a question. But it is good. I mean, it's deeper
Don,
than
what question? What question?
Your question about the particles running into each other. It's cool.
It's fucking impossible. You can't have two objects occupying the same space at the same time.
Mm-hmm.
I don't know if that's an actual law or something. It sounds good, though. If you could show me that happening in reality, it's like not something that happens.
Like they could all be like, it could be like a photon soup out there, and they could all be like exchanging the information and by energy, by.
Well, brother, at this point, it's all speculation, right, Crux?
I don't know. No, man, I think that they're speculating. I'm not going to do it. I think that they're speculating, though, but they're able to use certain instruments to at least see some patterns of photons with different.
I think what they see it's effects, and they create stories. And since the reason why we are arguing about this because they cannot actually demonstrate the photon, right?
That's what they do. It's silent. You hit the nail right on the fucking head. They see effects, right? They see effects, and that's it. Then they just they got some wild speculation and ideas about what's going on with the effects, the causes of them.
I'm with you guys there.
These motherfuckers.
Y'all know I see on there, man. This fucking double slit fucking bullshit, dude. Only works at a specific ratio and all. I mean, kiss my ass.
Listen, Silent. How do you feel if we were to do a test? I have a test that I'm pretty sure could prove if the atmosphere is magnifying things or not. Ranty came up with it. This is actually Ranty's idea, but I liked it and I stole it, and it's my idea now. Now what? Anyways, listen, here's what you do. You get two cameras, same setting, same model, everything, same lenses, all that shit, all the same stats, nothing's different.
And then you switch them.
And then you switch them?
Just to make sure. I'm just kidding, Jerry.
All right, so we got these two cameras. They're the same shit, every settings, everything. We put one on a high altitude balloon, right? Before you even send that one up, you use that one to take a picture of the moon with, and you take a picture of the moon with the other one at the same exact moment. Then you send one of them up on this high altitude balloon, right? And you get an image of the moon. You go up 100,000 feet. You get an image of the moon. The shit comes back down. The whole time you're taking pictures or video or whatever with the other camera, so that we know we have clock sync. We know that we're at the same moment. You know what I mean? When it gets to 100,000 feet, we know that the picture from Earth and the picture up there is at the same moment. So there's no dispute. So the shit comes back down. You get the fucking camera, and you see if the moon, in their model, the moon should be at the same moment when the thing reached 100,000 feet. The moon should be bigger for the one that went up in the high altitude balloon. Not by a lot, but it should be bigger. If it's not bigger, if it got smaller at all, forget about it. That's magnification proof right there. It's over.
It does get smaller. Let me tell you.
Yep.
Why? When I'm driving, sometimes I got the moon on the horizon, and I can see it bigger. Jeremy.
Yeah, but they swear that's just an illusion, though. And if you actually took the camera, like I said,
no.
Did you ever take a camera and do it though?
No, because it's noticeable.
Yes, that's what illusions do.
It's noticeable.
That's what illusions do. It makes you notice things incorrectly.
Take a camera. Listen, take a camera next time it happens. Get a camera. Take a picture of it when it's, on the horizon, and then take a picture of it, later or the next night or something when it's up in the sky. And you know. Are you saying that the moon won't
during
be
the
big
same
in the
night?
picture?
Yeah, during the same night. You didn't let me finish. I see it in the horizon. It's bigger. As it goes up, it starts getting smaller and smaller.
Yeah, so you take a picture, take a picture of it a couple times in its path until it gets at 90 degrees, and we can sync it up and see if it's actually, don't change the settings or the zoom or nothing, and we'll see if it got bigger or not. They claim. I'm not claiming that it does. I'm not claiming that it does or doesn't. I'm telling you, the Glober claim is this is an illusion, and it's actually the same size when you do this. So I know that our eyes can be fooled. Our eyes can be fooled. Fair enough.
It's not even your eyes. It's just it's your perception. I mean, even your eyes aren't being fooled. Actually, it's just how you interpret what you're seeing.
Mic check.
Sorry, go on.
We hear you. Go ahead.
It's working.
Pardon me. I didn't mean to interrupt.
No, you're fine. You're fine.
Is
Go
the
ahead.
Globy claim that a picture of the moon on the horizon will not be enlarged like you see it with your own eyes? Is that the claim?
The claim is when you take if you take a picture of it, measure its angular size somehow, that it's not going to change throughout that one night. From on the horizon to 90 degrees.
Right, and they'll say because it's really far away, and therefore it's not changing much distance percentage, so therefore it's not changing much angular size or whatever. But Jeremy's kind of being like, well, what if it is going up a higher percentage portion farther, like, rotating above us, whatever the pizza, whatever. We know the thing. Closer, moving farther away by percent. No, this thing was magnifying it and making it look like it was staying the same size. Is that kind of what you're saying, Jeremy?
No, this thing is all about if the atmosphere is magnifying things. If we go up,
but why?
Like this isn't gonna end the flat Earth, globe Earth argument. If anyone can think of something definitive to do that, I'd love to know. This would be a huge leap for us, though, if we could prove atmospheric magnification.
Yeah, but I thought they admitted that. Like, I guess I was just applying this to the example you were saying about the moon on the horizon or whatever. Like, I guess you're trying to.
I'm just trying to figure out how to prove if the atmosphere is magnifying. We could also do perspective tests inside a vacuum. I've never seen anything like that. That'd be something. That'd be even better than this moon thing, honestly. If we had a long vacuum that we could do perspective tests in, because there's a certain formula for how big something's angular size is going to be, depending on how far you get away from it. So I'm thinking that don't match up in a vacuum. I think the magnification, the amount of magnification is built directly into the perspective math, and that's why we don't notice it or whatever. I don't know.
If anyone has any ideas to do something, let me know. We're trying to think of something so we could do like a, raise a few bucks.
This isn't a case where they've taken a real world phenomenon and then built the formula off of it. They just can do math and geometry on paper to talk about angular size and distance and all perspective. It's not, misderived from the real world.
Oh, but it's very easy to compare two pictures, for example. So you go to the paper, you, for example, change how bigger or smaller an object is, given how farther it gets. And then you take the pictures in both distances and you compare the pictures. It's that easy. Like it's something so trivial.
My favorite shape for that is just a triangle. Is pretty much what I'm sure they use usually.
Well, I mean, it's very hard to make basic geometry without using triangles at some point.
Bacon, you have anything that would definitively prove something? Any ideas on what we could do to actually objectively, definitively prove something that has anything to do with anything in this whole arena of shit we talk about?
I don't know.
Anyone? Does anyone have any ideas of anything we could possibly do?
Yeah, the water.
Yeah. You force the tilt, force a 4-degree tilt, and pull that bitch away from you until it's level. And if it can't do that, then you're not on the fucking globe.
Weather balloon with a camera that doesn't have a fisheye lens. That would do it for me.
Yep, weather balloons, yeah, because hot air balloons, when you get in them, you're not surrounded by glass. You're looking with your eyeballs. That's another thing.
Yeah, I'd be fine. Give me some oxygen and a weather balloon. I'll volunteer. I'll do it right now.
You can have thousands of weather balloons, thousands of miles apart, though, and none of them tilt. Like, you can take a picture and see that they all. Come on, man, it's got.
Did you hear us, Democ? Did you hear us talking about the tilt after I muted you earlier?
About the what?
Did you hear us talking about the tilt after I muted you?
Yeah, I heard you guys.
Yeah, they're trying to say you'd never be able to see it, but if you had two objects, remember two poles in the distance and you could see them, they would be tilting away from each other, so they'd have to be tilting to the side.
Right, they have to be. You can put a straight.
If you had an orthographic view on it, yeah.
Yeah, you could.
You know how do you do it?
Tilted. Go ahead,
Jeremy. You grab two air balloons, hot air balloons, and you put a string with the, connecting both. And somehow you make the air balloons to go straight up. As they go up, that line has to start stretching. Because, each one is following the...
Oh, yeah, but with all the wind and shit, bro.
That's the problem, yeah. But yeah, you could...
If you could do it with a heavy enough chain, even a chain or even like a thick chain would still be breezing in the wind. And the amount of distance you need to measure from the bottom to the top is insane.
It's insane.
This wouldn't be the be-all, end-all, but if we got the majority of the populace to understand that you cannot see curvature until at least about 120,000 feet, according to the globe model, that would cause two things to happen. A bunch of people would have to basically recant on claims that even me in my own home, there's a picture that was given to a family member of mine as a gift that claims to be Earth curvature at 47,000 feet. And I just fucking roll my eyes. The second thing that would happen is you'd have to have all these videos on YouTube of people claiming to have pictures of curvature at less than 120 and they'd have to take it all back. That to me that would be like step one. Getting people to understand you can't see the curve for a very long time or a very long distance.
Mathematically, there should be a formula that would tell you how high up you have to be before you can see curvature. And I mean, on the globe, it should be 0 feet. You should need to be 1 inch and see curve. So.
Oh, Jeremy, today Mitch from Australia, he had a great show, man. He was using Glover versus Glover. They contradicted each other, right? And this thing about the curvature came up. Neil deGrasse Tyson saying, that you're not able to see curvature at some distance, and then you got the anti-flat earthers saying you see the curvature at this distance. So it's contradictions after contradiction.
I mean, what's his face? Only claims to have a picture of it, Earth curve from 10 stories, 20 stories. He was in a hotel somewhere. That's definitely not whatever 1,000 feet Neil deGrasse said.
There's a difference between horizontal, left to right curvature and along your line of sight curvature.
We know.
And you can actually see
Robert.
left to right curvature from very low height, as has been photographed by that guy.
How many feet?
700 feet.
How many feet high you got to be to see left to right?
Well, actually, if you're prepared to take a good photograph of it, you can do it without little more than just head normal height, just a head height. But,
see, there you go.
But Neil deGrasse Tyson didn't bother to do the calculations when he had that performance on that stage when he was saying, "Oh, you're only a millimeter or something above the model." He was showing if he'd done it, but he was saying whether you see that visually, whether your human could detect that curve. I mean, the pictures that the guy from Mallorca did.
Well,
left to right.
Somehow he's on TV and you're not.
Nearly there. The left to right curve did with the camera, whereas I think Neil deGrasse Tyson was talking about with your eyes. Go ahead.
So
somehow he's on TV, not you.
So Neil deGrasse Tyson, the most famous astrophysicist, all this guy does is math. You're telling me he didn't do the math for this?
Yeah,
this guy's just talking shit.
Yeah, personally, I'm not terribly impressed with him, I'm afraid. But
yeah, of course, you're an anti-flat earther. He's pitching the actual globe model. We know.
I'm a believer.
No, he's a glober. He's a glober. He's pitching the globe model.
Yeah, well, he just didn't. Even scientists are not perfect. I mean, although I'm right every time of what I say, he's not.
Yeah, we know.
And he just did that on the stage with a quick and he was referring to what you can see with your eyes, I think, in which case he's correct. With your eyes, you couldn't detect the curvature, whereas I'm talking about with a photograph.
Rumpus, the difference between him is he's pitching the globe model. You're just an anti-flat earther going against everything we say.
Well, you just made.
And the camera works just like your eyeballs.
He and I are both pro science. You can decide to distinguish between because you don't like the idea of being anti-science, although you are. I'm afraid that's your position.
I love science. There's nothing about what he does as science. He's a theoretical physicist. He doesn't deal with cause and effect relationships.
Of course,
he deals with theoretics.
Of course they do. That's how they. For instance,
let's hear. All right.
Einstein, for instance, he came up with the idea of special relativity from theory, and then we did with the experiment. We established that was correct. Same with general relativity.
That was not an experiment. Are you talking about the Eddington?
Yeah, that's general relativity, but special relativity as well.
That's not an experiment, Rumpus.
Yes, it is.
Jesus
Yes,
H. Christ.
Sorry? What?
That is not an experiment. I'm trying to change my ways and not call people names. You're making it very hard.
Well, you're wrong. It was an experiment. Okay.
All right, what was it?
Well, some parts
it was independent variable.
I mean, some parts. Well, you could argue. Well, it did change over. So you the angle you chose to look at it, and the observed change would change depending on which angle you happen to have. But fundamentally,
when that was a cause, then
well,
what was the independent variable
by the sun?
Yeah,
and you can.
You're saying space-time was independent variable.
Angular dependent. So, for instance, we saw the angle of the effect on the star depended on how close it got to the sun. So,
Rumpus, what's the IV, bro? Rumpus, focus. What's the IV?
The position the observer had.
So, observer position causes this star to appear in different spots. That has nothing to do with space-time bending or anything. You need space-time to be your independent variable, dude. I don't know if you realize. You don't know. I'm biting my tongue, Rumpus.
Oh, I do know. I know all about it. I know you don't understand that science is all about observation as well. the angle that you get.
Oh, Rumpus.
Listen. The angle of the bending of the light from the distant star is dependent on your position and the position of the sun. So there are two variables there, and the mass of the sun as well, of course. So you can change where you are with respect to the sun and the angle the light has to get to you. So you're changing that, and then you're getting how far the sun, the distant star, moves with respect to the star. So like everything, like most flatties, you don't understand that almost every effect you ever come across involves more than one variable. So for instance, if you want to determine how, for instance, the damage done to a garage if you were to run into it, it would depend on the mass of the car, the velocity of the car if you run your car into it. Almost every single effect you ever come up with, almost all of them have more than one independent variable.
Yes, and when we're doing hold on. When we're doing a scientific experiment, we control the other ones, and then we have the one we're going to manipulate, the independent variable we're actually going to manipulate, so we know that it is the cause of the effect. That's only one independent variable. The rest of them are controlled.
We don't have to be able to change all of them. You can in an experiment, as you just said, you only need to be able to change one of the independent variables to make it an experiment. The other variables can be controlled and fixed. And so in the case of observing the refraction of the star in the Eddington case, the fixed one is the mass of the star, but you can change your position and determine what the change in the angle of the star is from your observation position.
The thing is with this, the only independent variable you can do is your position, which doesn't prove any of the other shit that you're claiming.
No, in an experiment, you only have to change one. The other one can be controlled. So the other one,
all you have.
Yeah, but it doesn't matter. An experiment consists of one independent variable and many other controlled variables that do not change. So you can have the sun, the sun being a controlled variable that doesn't change, and then you can change your position. That makes you. Similarly, with the effect of the Coriolis effect.
I'm not engaged you anymore. You ramble on for too long. I can't engage you, Rumpus. I just want to make my final statement on this, and then we're done after this. All you have is, if all you can do is manipulate your position, you're not proving none of the other. You would need more experiments with these other things that you're claiming are causes for them to be the IV in that experiment and then manipulate them. You don't have that. You can't do it. It's bullshit. You don't know what you're talking about. You're making shit up.
What I'm talking about. Yes, there's the abuse. Right, so you don't understand what you're talking about at all. You don't understand an experiment just consists of one independent variable you're manipulating, and you have lots of other controlled ones. And you, like most flat earthers, I don't think you realise there are these other variables involved. Similarly with the Foucault's pendulum, you get confused about what's the independent variable. Your latitude is the variable, and the other one, the rotation of the Earth, is another controlled variable. You don't have to be able to change the rotation of the Earth to have an experiment in which you check that theory. And for instance, and we know just from the maths and physics that we expect things like Foucault's pendulum to be that effect to exist as a necessary consequence of the spinning of the Earth. You don't have to be able to change the spinning of the Earth to get the effect to do the experiment. And this is where your fundamental problem lies.
Listen, stop. I'm going to hop out of this so I can stop you from monologuing. Okay, go ahead, continue with somebody else. I'm going to put the timer on you motherfuckers. You got 45 seconds. You're going on for minutes. It feels like minutes.
Just telling his beliefs. It's fine.
Well, no, I'm basing on evidence and science. It's quite simple. I mean, I can justify all these points. And the fact that you don't understand that science is also part of observation, you also have things called natural experiments, where you do not need to be manipulating the independent variable. You can let nature do it. So, for instance, if you wanted to find out what the orbital period of the various planets were, you don't need to be able to pick up a planet and put it in different places. You can use the existing position of planets and then say, look, therefore, I effectively got an experiment. I can change the radius of a planet, and what does its period do? That is a natural experiment. You do not need to have an experimenter manipulating an independent variable. You can just have nature do it. And that's something else you don't understand, something else that QE doesn't understand that you like parroting.
10 seconds.
Experiments exist. And why you think 45 seconds, just because you can't speak for more than 45 seconds, doesn't mean to say the rest of us can't. And some of us have got complicated points to make just because you're...
Time's up.
That doesn't make everybody... Well, why do you think you've got the right to determine...
There's nothing you have to say that should take more than 40...
you can only speak for 30 seconds...
your time with the mic's up. I'm putting a timer on you, bro.
Why do you think you've got the right to dictate...
Where's your fucking name in the list, bro? I don't even see... Oh, there you are. Yeah, somebody already muted you, fucker. That's why I had to get out of the conversation, bro. We're not having you monologue every fucking time you speak. So we said 2 words, and then you monologue for another 45 seconds, bro. Fuck that. And what you're saying is wrong, anyways.
Jeremy, he deafened himself, so I just kicked him from the chat.
What he's saying is inherently wrong. He's saying part of what he's saying is right. You can have an experiment. You have one independent variable that you manipulate. The other ones you don't. You don't fuck with them. Now, you're supposed to be able to control them. They can't do that. They're not controlling space-time or the mass of the sun or whatever bullshit he was talking about. Okay, and you'd also need another experiment where you now control your position and you manipulate the other things. And you control this mass of the sun and manipulate a different thing. They don't have none of that. They just made the other shit up. They have this one thing where you change your position and you see a star in a different spot on an eclipse or some shit. What you need to have is you need to be able to manipulate the shit you're actually claiming. Does something. They can't do that. They don't do that.
Yeah, basically what it's saying is witness nature, and that's an experiment.
It's fucking bullshit. I'm so fed up. I got to jump out of here, man. I'm about to fucking blow a gasket in here. These guys got me all fired up tonight, from Ruhit to Rumpus.
Just citing his
hard.
religion.
I'm about to go into gems and slay them all.
Again, Jeremy, it's because they are looking things through their dogma. They cannot think outside of this. It's man. And my perspective, I'm trying to help them to see the worldview from a different perspective, so they understand where we're coming from. Like, but they won't move not 1 inch.
Bro, you ever see Game of Thrones where the guy got captured, they cut his dick off? Theon Greyjoy or some shit?
No, I didn't watch it. No, I didn't watch it, but
there's some people you just can't help, bro.
Yeah. It's like, remember that guy, Mr. Sensible or whatever? He said the worst thing you did is just change the radius of the Earth. And I'm like, bro, you don't realize what that means? Like, your whole paradigm changes. That's why, Jeremy, they cannot give you anything. Because if something is wrong in their model, the whole thing crumbles.
What do you got, B-Ball? What do you got for us?
Oh, no, nothing, man. I'm just listening.
I just ran through Ruhif and Rumpus. You want it or what?
I'm sure you did. I bet you did.
All right.
By the way, your mic is a little bad right now, though. I don't know why.
Oh, me or B-Ball? Is it me?
No, silence lagging.
What's up? Am I lagging?
I don't. No, I guess it was me, Jeremy, the one lagging.
No, because now Demok sounds like he's lagging to me. Is it me?
No, he was lagging.
Come on, fix your fucking internet, guys. We're killing them so bad. This is like some CIA operative shit. They're slagging all our internets or something.
Yeah. You can tell he's dogma, right? Because Bacon, he was arguing about this refraction thing without ever seeing it or whatever. He's still arguing.
About things we just saw
Ruhip
in the fish tank.
Ruhip did the same. I don't want to engage on the same theme again.
Oh, you're talking about me.
Bacon.
And what do you think I said? And I'm just saying that's not what I said. Is it lagging for anyone else, or is it me?
Yeah, I'm getting some lag and shit here.
Because neither you or I have seen it happen or what happens, and you just kept going, asserting what you believe. Actually, that's all you got.
I
didn't
believe.
Talking that whole time.
No, go ahead.
I didn't
Were you
keep
talking
going.
that whole time? I think you lagged out for like most of what you were saying, Silent.
Well,
did you hear?
Yeah, I mean,
you hear?
The ending of what he said connected to the beginning.
Yeah.
So. Yeah,
The middle's missing, but okay, go ahead.
Oh, but he ended with a very
go ahead,
clear
then.
sentence, right?
I don't know. I don't remember what he said. Go ahead.
Oh, okay. I lost track of what I was going to say.
Can you guys hear me now?
Uh-huh.
Yeah.
I said that I conceded and said that we are at a impasse. Neither you or I have seen what happens when the laser is inside the fish tank with the water and sugar. Neither you or I have experienced this. We don't know what happens. Rufif hasn't done it or seen it either. Right? Me, personally, I consider and say, until we further check this, I can make assertions. On the other hand, you and Rufif keep making the same assertion without ever witnessing.
Actually, we're betting at the point, not asserting that.
Yeah, he bet $10 million.
And you actually asserted once. I mean, you started by asserting that. Then I challenged that, and that's how we got that discussion.
Remember I asserted, and then I realized that I shouldn't be doing that because I haven't seen it. And then I told you, I concede, bro.
Sure.
Neither you or I have seen it, but you kept going on the same thing. So
No,
I'm sorry, but
we're
you're
just
wrong.
betting. We weren't talking about that anymore. We're just betting, trying to see what the other would concede if.
But
the
that
experiment
tells
was-
you a lot of your mindset, Bacon. Bacon, I'm not here to win over you, bro. I don't know you. You don't know me, like, personally.
Sure, but the thing is,
there's nothing to win. Like, do you think I win anything by winning an argument here? No, bro. I'm trying to learn and discover things as they actually are without any dogma. And when I come here and listen, and you're not able to concede that. All right, give me a second. Work is calling me. Fuck.
I find it obnoxious that you guys are involved in these arguments and you don't even know about the shit you're arguing about.
Well, we don't know about.
Not only do you not know, but you're asserting the exact opposite of some things. Like Rumpus was now with the science. That was ridiculous.
Well, I don't care whether or not it fits on your label of science. I mean, if you have an experiment that can tell, can falsify a hypothesis or confirm it.
Okay, you
then
can't.
That's good evidence.
The Rumpus's hypothesis with the Eddington thing, you can't falsify it. You also can't prove it because you don't. He doesn't have a valid. He has one valid experiment that you can do that changes your location as an independent variable.
That's
all the
why I
rest of
say-
them with space-time bending and the mass of the sun, those are all independent variables that you can't do nothing with.
It doesn't matter if you're how you're labeling it.
First of all, in order to even have an independent variable in an experiment, you have to know that it's real. You can't use space-time bending as an independent variable in an experiment. Where's the thing that proved it was real in the first place?
Thing that's not the point. The point is they had this new hypothesis. Yeah, they had this new hypothesis on how the universe works, and one way to test if that's the case is to make predictions. So if that's the case,
listen, it's not a valid hypothesis.
Why
it's
not?
not valid.
Making predictions on nothing of a prediction on nothing that you don't have. Thing. It's
what is
just
an
a prediction
invalid
on nothing.
hypothesis?
It's
What
an
does it mean to
invalid
say-
hypothesis is one. Go ahead.
Go ahead. No,
I want to
Jeremy,
know
go
that.
ahead.
What do you mean by it being invalid?
If he says something
hypothesis?
different, I'll give you the other answer. All right, no one's talking, so I'll just say it. You can't have a valid hypothesis without an observation, since no one has ever observed the Earth curving. It's all bullshit. No one's ever fucking seen
hypothesis
a nebula. Actually,
what
a
you're
hypothesis
saying,
comes after an observation.
but that doesn't make sense to call the hypothesis after you already know what's going on.
Oh my god. All right, well.
I mean, if
there
you
go.
know what's going on, why you
listen.
hypothesize about what's going on?
Your hypothesis.
Jeremy,
silent. You're lagging.
let me just say this. Do you guys hear me?
You're roboting a little.
No, you're roboting pretty badly.
Do you guys hear me? Fuck.
Try to back out and come back in.
Listen, an invalid hypothesis is would be one where you have an independent variable that you can't manipulate.
hypothesis don't have to do with
also
variables.
another invalid hypothesis would be one where you have an independent variable and you don't know if it's real or not. That's also an invalid hypothesis.
No,
because
I think
you have to be able to manipulate your IV. If you don't know the thing's real or not, how are
you're
you
not
going to
talking about
manipulate?
hypothesis.
Yeah, I am. I'm talking about the
variables.
independent variable inside your. A hypothesis consists of a dependent and an independent variable. You know this, right?
No, that's not.
You don't know how science works. I'm sorry, but that's how it works.
No, I think you're trying
Yeah.
to describe what a scientific experiment is, not a hypothesis.
No, I'm describing a hypothesis. A hypothesis is an experiment test.
No, I'm talking about hypothesis alone. Forget about
the
the experiment.
hypothesis. It has your independent and dependent variable, cause and effect.
Can you quote
Dude,
that?
you
Can you
don't know.
cite that? Where hypothesis mean you have variables? Because I can hypothesize about anything I want. It doesn't require to have specific variables.
Stop.
Oh. Go ahead. Oh, you're roboting too now. Is it me? Am I lagging?
No, he's lagging.
You're lagging, bro. Why is everyone lagging tonight?
Probably there's some instability with Discord.
Hey, bud,
or some
go
of
ahead
the,
and
of
type
some of its
into
servers.
Google how to be so.
You're lagging out.
I know.
Platypus.
I know how to form a hypothesis. These guys don't. This is the shit I'm talking about. I just said this before I had started this conversation with this guy that they're talking about shit that they don't know anything about.
Mic check.
You can hypothesize everything you want. If you go to the doctor and he says, "Well, I think you might have cancer," he's not sure about it. He has to test it.
That is not a
hypothesis. We're talking about a scientific hypothesis.
Oh, you said invalid. Science. Yeah, you said
not some bullshit
hypothesis.
gypsy palm. Not some bullshit gypsy palm reader. Not some bullshit gypsy palm reader. Psychic idea, theory, hypothesis. This is an actual scientific thing. It has an independent and a dependent variable inside of it that has to.
No, you're describing the experiment, not the hypothesis itself.
No, dude. What do you think you're testing in the experiment? You're doing a hypothesis test.
I'm not even talking about experiments yet. When you're mentioning variables, you're talking about experiments, not about a hypothesis.
Outside of an experiment. Do you understand?
I'm talking about a hypothesis. The hypothesis. Do you understand that a hypothesis is an experiment? Is a Hold on, I didn't finish. I didn't even finish. Your experiment is a hypothesis test. Okay, do you understand that?
Okay, yeah.
You agree?
Yeah.
Okay, and inside you're testing for. We're talking about natural science. You're testing for cause and effect relationships. Inside your hypothesis, you have to have the cause and the effect because this is what you're going to be testing. You understand that part?
Actually, no, I'm not sure if I agree with that part. Because the thing is, a hypothesis doesn't describe an experiment. I can give you a hypothesis, and 10 people experiments to try to validate them. And from those 10 people, 3 of them might do it right, and the other 7 do it wrong. 7 of them might come up with an invalid scientific experiment. That tells nothing about the validity of the hypothesis. Those are separate things. The hypothesis isn't proposing necessarily an experiment. It's just a hypothesis.
I'm disengaging with you. You don't know what you're talking about. So there's no point in even going on.
Can you hear me? Yeah. Mic check.
Yeah, I think you're good now.
Okay. This can just be solved. Who was speaking? Sorry. The other guy? Bacon. Sorry, yeah. Just Google how to form a hypothesis. End of discussion. It's all good. That's all I was trying to get out.
My AirPod died. What'd you say?
I said just Google how to form a hypothesis, and it's all about how to explain your observation. Okay, so in order for any experiment to be talked about in regards to flat Earth, at least for my standards, I want to hear what the initial observation was. Does that track with everybody?
Oh, that's step one, of course. You have to have your observation is your dependent variable. You can't proceed to the next step without having this. That's like the most crucial.
Exactamundo.
That's the most crucial part of it.
Actual scientists or anybody would.
B-ball, your robot and or lagging or whatever too. Why do all you guys connections? Like, am I tripping or what? I mean, I am pretty blazed right now, but
Jeremy, do you think any scientists or theoretical physicists would agree with you?
no, because they want to masquerade as actual science when in
Oh,
fact they're
okay.
doing
So they would know more since they've studied it more, then, right?
study
you
what? Their
haven't.
pseudoscience? They study their pseudoscience more.
What are they observing, and then what are they doing experiments off of?
Well,
Name
B-ball's whole
one
things.
observation
They
that
don't just sit in
an
Discord and
astrophysicist
claim that
did.
scientists don't know what the hell they're talking.
One, just name one.
They
Name
don't. They
fucking
don't.
one.
They don't
No,
sit in Discord and think they know
hold on.
everything.
I'm not asking for 2 or 3 or 4. I'm asking for 1. All right, who the fuck just said that?
Yeah, they don't sit in
'Cause
Discord and
I couldn't have been
know
more
more
explicit.
than all the other.
Not 2, not 3, not 4. Just one observation that an astrophysicist makes.
Well, just like you just explained before, you can go ahead.
Great. Someone.
Oh, he barely started speaking.
Is
Why is
someone
he muted
literally
already?
trying to mute this guy at the same time as me, or no?
Yo, you guys are both lagging very badly. It's probably a bad idea
For the
for you
same
to both
reason
have a
I've
conversation
thought
right
about
now.
muting you.
Yo, whoever that was, you're lagging super bad, bro. B-ball, your shit sucks too. I wouldn't even get home or something, maybe.
Just change the server.
Oh,
I just changed it to US Central. It was on US East. We'll see if Central's any better, but it might just be their individual connections.
we good now? Say something. Who was that? Platypus?
Hello.
Oh, you sound good. All right, here we go.
Oh,
Let's
that was
go.
me, Silent Zero, Jeremy.
I know. I said you sound good.
Oh, who asked me to
mic check?
This is how to form a hypothesis.
No, everybody here except for you knows how to form a hypothesis.
No, I asked it. Who asked me to Google that?
That was me.
Right, just did.
Who are you?
First result has 0 mentions of the word variable. Right.
Yeah, I
And
never said
it has a paragraph.
variable. I said
Right,
observation.
Sure.
Yeah.
And the first paragraph, just say for you to imagine how an explanation can relate to anything you have observed. Try to imagine possible solutions. If they're testable, then you have formed the hypothesis. That's all it says.
Yeah, but if you don't have any observations, you can't imagine any sort of test. Are you serious?
I'm not saying that.
Oh my god.
Wait, you
What are you
did say
talking
that,
about, man? I
Bacon. You
didn't
said
even
you
say
could.
anything.
You said you can hypothesize anything, pretty much that you want. So
Yeah, I think this guy has got the word hypothesis.
That's giving. I mean, that's saying how you can form a hypothesis. Right.
Bro,
yeah, I can
listen.
concede. I can concede that. Okay, you can. I'm only going to hypothesize on things that I have some observation about. That has nothing to do with what you're arguing for before.
Sorry, the reason
It has nothing
I've
to do with
literally heard
dependent
this
and independent variables.
conversation. Is my mic working or am I
You're
just shot?
lagging. You're still lagging, bro. Wait till you're done traveling. I'm sorry. I'd love to hear from you because I don't think I've ever heard your voice. Maybe a while ago or something, but I haven't heard you recently. I'd love to have you involved in this, but your mic is just terrible. I'm sorry. Maybe if you get closer, try us again in a minute or so. But I mean, listen, natural science hypothesis. You have to have a dependent and independent variable.
Where did you get that from?
That's your if-then statement.
Where did you get that
University of California. Pick any university. Here we go. You ready?
Yeah.
A hypothesis is usually written in the form of an if-then statement according to the University of California. Statement gives a possibility of and explains what may happen because of the possibility then. The statement could also include may. Here we go. This is from Khan Academy. Scientific method. Make an observation. Okay, Daddy's gotcha. This is from Khan Academy.
Oh,
Make an observation.
where does any of this back up what you said? That a hypothesis need dependent and an independent variable.
That's your if and then. Your cause and effect.
How does that back up what you said?
He just
The
told you,
if-then.
Bacon. Are you listening?
Yeah, I am.
Thing is your cause and
Then
effect.
what?
No, he
Yeah,
said
your if and then.
specifically. No. He
Your
said
if and then
specifically.
is the cause and effect.
First of all, that's saying how you can describe a hypothesis. It's not defining a hypothesis. And second, that's not mentioning dependent and independent variables, as you said, are needed for a hypothesis to be valid. You just want to fit what you believe into what you're reading there, but it's not backing up what you say.
I got you. Hold on, I'll find a better one. That was just a real quick off the cuff one. Here we go. Ready?
Yep.
This is from Lumen Learning. The one variable that is different between what?
Oh, I just said I don't know what that is, but go on.
Well, all right. Let me get you. You want one from a university or something? I mean, there's
No,
a million.
go on
of
with
these.
that. Let me hear what it says.
Okay. Hold on, let me find it. I don't know. I fucking lost it. Son of a bitch. Dude, this. You've heard QE's videos, bro. You need to start watching QE. He has like 100 citations of this. He's got 20 videos on the natural science and the scientific method. He goes over this again and again. He has hundreds of citations. This is not like we didn't make this shit up, bro. This isn't our thing. This isn't a flat.
I'm not
Earth
saying
thing.
you made this
We
up.
didn't
I'm
make
pretty
it
sure
up.
you heard it.
We heard it from every college and university in America.
I think you heard it from QE.
Yeah, and QE has the citations from every college and university across America, practically.
All right. Yeah, I don't deny that it takes citations from sources that are actually reliable. But I mean, just it's not every time you show citation that it actually backs up what you're saying.
Mic check.
Yeah,
am I better now?
Damn. Very blowy. Windy. I don't know.
Windy City.
Yeah, we could hear you, Platypus, but there's just a lot of wind noise. But
Great. Awesome. We've been trying to explain to Bacon for the last 30 minutes that you need an observation to come up with a hypothesis if you wanted to perform an experiment.
Sure.
I think we can get past that. I think there's a reason that no other Globers are...
I'm not denying that.
No, here, don't talk.
Right.
I think there's a reason no other Globers are rushing to your aid right now. I'd like to hear it.
My bad.
No, it's cool.
My bad. Go ahead.
One question. I just want to ask one question. One observation that an astrophysicist made, and then the experiment that followed.
Mm-hmm.
Did you have a response to that, or do you want to hear the citation?
Oh, was that a question?
Oh, I don't know.
Platypus, are you saying any actual scientific experiment that an astrophysicist has done in general? Is that what you're...
Yeah. Somebody else was talking about astrophysics. I think I tried to mute him because he said they do experiments and they don't sit on Discord all day, which is not an answer to the question. You know what I'm saying? Because I know where this conversation goes. Like, if my instincts are correct, Bacon is literally just taking all of us on a ruse cruise right now. Like,
yeah, let me rip these citations off real quick. I got a whole bunch of good ones right here before I lose them.
Yeah, let's just not devolve until we're like actually trying to define observation, because then I can't help you.
Right now, he doesn't think you need to have this independent and dependent variable in your hypothesis, right?
Yeah.
So a hypothesis leads to one or more predictions that can be tested by experimenting. Predictions should include, now your prediction is your hypothesis. You're predicting what's going to happen.
No. The prediction
should
is
include
no.
both
Prediction
independent-
isn't the hypothesis.
Yes, it is.
No, the prediction is made by the hypothesis.
Okay, here's another one. You don't like that wording? A hypothesis is an idea or proposition that can be tested by observations or experiments about the natural world. In order to be considered scientific hypothesis, why are you guys talking through me? In order to be considered
observations,
scientific hypothesis, Rumpus. Is that Rumpus?
It is.
Just hold on a second. I'm almost done. In order to be considered scientific hypothesis, in order to be considered scientific, hypotheses are subject to scientific evaluation and must be falsifiable, which means that they are worded in such a way. Shit, that wasn't the right one. The hypothesis must be worded so that it can be tested in an experiment, and it must include both independent and dependent variables. That's from static.nsta.org. I mean, dude, there's tons of these.
That's first referring to the experiment that it immediately had mentioned, right? Not the hypothesis itself.
You realize you have to have the independent and dependent variable in your hypothesis.
In the test. No, in the test.
No, in your hypothesis. Your hypothesis tells you what
Give
you're
me
going
an
to test.
example of hypothesis.
Your hypothesis tells you what you're going to... Where do you think you get an experiment from?
From the hypothesis.
Exactly. That the hypothesis tells you what you're going to test in your experiment.
Doesn't tell me how. That I have to come up with myself.
It doesn't tell you how you're going to do it, but it tells you what you're checking for. You're checking for a cause and effect. The independent variable is the cause. The dependent variable is the effect. Dude, I can't believe we're going over this. This is like sixth grade shit, bro.
Jeremy. No one disputes that.
He's disputing it right now.
No, he's not
Rumpus. Set your
disputing
voice
that
straight.
cause and effect by independent and dependent variable. No one does.
All right, Rumpus. Do you need to have a dependent and independent variable in a hypothesis?
Not to do science, you don't. For instance, if I want to measure the size of a proton, if I want to measure the size of a proton, which is a scientific endeavor, I don't need any hypothesis at all. Or if I wanted to work out what your DNA was,
You're taking a measurement. Can I just
finish the point? If I wanted to take your DNA and find out what the DNA in Jeremy is, that would be a scientific endeavor. I don't need to have a hypothesis. And I could then really find out what your DNA is and find out what your particular characteristics are. None of that requires a hypothesis. Measuring the size of a proton doesn't require a hypothesis. Measuring the mass of an electron doesn't require a hypothesis. Measuring the size of the universe doesn't require a hypothesis.
Okay, we're not doing a scientific endeavor. We're doing an experiment.
Yes, but Jeremy would claim those aren't scientific endeavors.
No, there are no buts. There are no buts. You described measurements. We're talking about an experiment.
Which is scientific.
I don't care. You can call it whatever you want. It's not an experiment.
I'm not claiming it is. I'm not claiming it is. That's the point.
You're telling me every time I pull out a tape measure and I measure something, I'm doing an experiment?
No, I didn't. No, that's an observation.
Exactly.
You don't even understand what an observation is.
Yeah, we know exactly what an observation is. We've been arguing about it.
Do you regard that science? Do you regard measuring the mass of a proton as science? Yes or no?
So you interrupt.
What'd you say, Rumpus?
Do you regard the measurement of the mass of a proton as science?
The measurement of anything, sure, why not? It's
great. Okay, that's fine. Brilliant. Okay, we're in agreement then. Observation is part of science, but QE and Jeremy don't think so.
It's not an experiment.
No one's saying it is.
Well, then you changed the subject.
Yeah, okay, now that Rumpus is back, Rumpus, can you name one observation that was made by an astrophysicist before he made an experiment?
Well, they perform natural experiments. So, for instance, what you might do is say, where is star formation? Where does that happen? And then you go and say, well, I've got this theory now. I bet it's something to do with dust or gas, or it's only going to happen in very young systems. And then you go around effectively, which is your independent variable. Okay, where there is young, dense gas, there are stars, could be your hypothesis. And then you go around looking around the universe, doing a natural experiment because you have all these independent variables of where there's dense gas or variations in the gas. And you then go and look. Oh, look there. Every time I see some dense gas of a certain characteristic, and young. Oh, look, there are stars. So then someone publishes that paper and saying, look, wherever you see in the universe, there's going to be dense gas. They're going to see the star formation. And so you allow natural experiments, i.e. not one in which you do the manipulation, but you let the universe or nature do it. And then you come up with a theory. And then you find then you can make predictions with that theory. You could even say, well, this particular age of dust or this particular density leads to these sort of stars or those sort of stars, depending on the density. And you can do an experiment, in effect, by what's called a natural experiment, where you let nature do the work of being the independent variable. Finished.
Show me somebody identifying a star formation.
That's not a scientific experiment. That's not
It
some
is a
other shit.
scientific
That's a
experiment. It's
quasi.
natural.
Hold on, Rumpus. We let you go on for 45
Sorry.
seconds.
Okay,
Hang
Jeremy,
on.
I interrupted you. Sorry.
All right. That's called a quasi experiment, as in not real.
It
That's
is real.
pseudoscience.
Perfectly real.
Listen,
Perfectly real.
that's
It's not pseudoscience.
that's pseudoscience. You're not manipulating any. It's not a natural.
It's a natural experiment.
It's not a scientific experiment in
Yes,
natural
it is.
science. You're doing something else.
If you
I don't know
look up the
what you're
definition of
doing.
experiment, you'll often find that it does not require an experimenter to be the person change or thing that's changing the independent variable. A number of quotes that QE comes up with from little children do say that. But if you go and look in the proper literature, and often in the literature that QE quotes, it actually says that the independent variable does not have to be manipulated by an experimenter, provided you've got a natural way of it being manipulated. It's no different to an experimenter manipulating.
Listen, that's an ad hom against QE or some shit. Or
no, it's a point.
You got that? Hold on, I'm not done, Rumpus.
You ignored the point I made, didn't you? You ignored the point I made, didn't you? You're covering. You're diverting.
You're gonna funny mute me. The little kids one. Where that little kids one got it from? The University of Arizona or Texas or some shit. That wasn't some shit little kids made up, dummy.
Okay,
which one? My bad.
Okay,
my bad. I shouldn't be calling names. My bad.
Give me that quote then. Show me the Arizona one. I'll bet you.
The Science Buddies. What was it? Science Buddies or Granny?
Here we go. Here, the Granny. Yeah, you were going to refer to science.
That
Grannies.
came from the
not
University
Arizona
of
University, is it? That's for
that's
kiddies.
Where do you think they got it from?
Well, he often quotes Science Granny or things for teenagers.
Science Granny gets their shit from.
Sorry?
They get their stuff from. Do you think they make it up?
They simplify it for kiddies.
And they get it from colleges.
For instance, universities.
Verbatim from colleges.
Have you not seen that university textbooks tend to be much more detailed and specific? So, for instance, things like experiments, they'll not make the error. And, of course, it's written by teachers rather than the teachers don't necessarily get it right from the scientific institutions. Anybody who's come into contact with high school teachers, no, they do not have the same grip on the subject as universities and educational establishments. And so they make mistakes, and they would do things like cut out the fact that they'll include the things like the experimenter, and also they might be for experiments in the lab. They'll often be talking about laboratory experiments. Well, obviously it's an experimenter changing the independent variable, but if you go and look at the proper philosophical literature or from a proper university, they'll be explicit. And indeed, half the quotes that QE has got about manipulation of the independent variable, it doesn't mention the experimenter. It says the independent variable is varied, and it makes a point of not saying an experimenter.
Rumpus, hey, just give me 1 sec. Jeremy, please also give me 1 second. Forget about, let's stop bringing up QE. If you guys want to bring up something that he said, sure, but it's really like it tends to take the conversation away from what we were originally at. And I originally asked you, Rumpus, to name an observation that an astrophysicist made, and you went on this crazy rant about natural experiments. I just want to know about a regular experiment that was done by an astrophysicist. And what
experiment? Well, the only parts of an experiment are to determine cause and effect. And to do that, you need an independent variable, which, of course, by the way, requires a quantified variable. Any relationship between two variables is a mathematical relationship. So you have to come up with a mathematical relationship between two variables to do that for your independent and dependent variable. And as I say, you can get the universe to do this for you. So, for instance, I was giving an example earlier about.
No, hold on. No, I don't need a different example.
You're not going to let me give the example then.
No, you interrupted me literally, and then I just let it go.
You asked me a question, and then you wanted me to answer it.
You actually interrupted me while I was asking the question. So unfortunately, I had to mute you for the next 10 seconds so I can finish what I'm saying without being interrupted. I just want an observation made by an astrophysicist that led to a hypothesis and experiment. Okay, go.
Right. So, for instance, Kepler.
He doesn't have that.
Made an observation of the period of the of the planets, and then he said, well, what's that dependent on? And then he, instead of being able to put a planet into place, he then said, well, I'll tell you what, I'll look at the 9 planets that we've got and then see, I've got a theory. And effectively, by picking on different planets, he's changing his independent variable. What is the period of a planet if I change the radius of its orbit? And he doesn't have to get out there and manipulate the orbit of a particular planet. He can use the ones that are there, and that's a natural experiment. There is an independent variable, the radius of the orbit, and the period. So just by making an observation and therefore effectively doing a natural experiment in this case, you've got the independent variable of the radius, and you've got the dependent variable of the period of the orbit.
Rumpus, hold on.
So that's a natural
Hold on,
experiment.
Rumpus. He's asking you for a natural.
I did. I just gave you a natural experiment. One in which the independent variable is the period and the independent variable is the radius. Jesus Christ!
I misspoke.
Do I have to go through that again?
Hold on, I misspoke. He's asking you for a scientific experiment.
That is a scientific experiment.
No, that's a natural experiment.
That is a scientific
We want a
experiment.
scientific.
That is scientific. That is
yell.
scientific. It's absolutely qualifies as a scientific experiment. You've got an independent variable, a dependent variable. You've got a hypothesis as a particular relationship between the two, and you can go and test it. And then it makes predictions. The resultant theory that you end up with, or law, then makes predictions that you can go and test in other circumstances.
Okay, but here's my issue.
Experiment in every single regard.
Adam, we'll let you finish. You done?
You're finished, yeah.
Thank you. My issue is that I've asked the question 5 times now, and the first time I asked it, you tried to tell me that a measurement. You went off about measuring something, and what did you call it? A scientific expedition.
You measure the dependent variable.
And I said no. I'm not looking for a scientific expedition. I'm looking for an experiment. Then you went off.
I gave you one.
And then you went off and defined something called a natural experiment.
Yeah, exactly. Well, that's a experiment. I explained. I thought I made this absolutely clear. A natural experiment is just one in which, instead of an experimenter manipulating the independent variable, nature does it. And I thought I gave a pretty comprehensive example with the planets, where the independent variable is the radius, and instead of someone having to get out there and move a planet, you use the ones that are in different positions with different radiuses. That's your independent variable. That's the cause. The dependent variable is the period of the planet, and you can test this. And you can use it to make predictions about other planets and other situations. And then you come up with this hypothesis, which you said there's this relationship between radius and period, and you can test it in any way, like any other experiment. So it's
but the problem was you started talking.
You don't seem to understand that
rambling on about the radius of an
experimenter didn't manipulate it. You seem to think that makes it a non-experiment. Go ahead.
Yeah, but here's the thing: you fail to answer the question, and then you further go and describe the radius of an orbit.
Yes.
All orbits are elliptical, and any ellipsis has 2 radii. You don't know what you're talking about.
Yes,
so
I do
just
know
keep
that.
it simple.
You know what you're talking about. You seem to miss the point I'm making. There is no difference between the experiment I described, and just because orbits are elliptical, they're not all elliptical, by the way. But the relation. But who said anything about them being circular? I never said they were all circular. You just made that up. The theory for the period is dependent on the radius. Okay, and there's an extra factor of the eccentricity. Okay, fine. We'll add that in as another variable, and that also is done in nature. So you can test this. So I don't know why you think you've got a point here. Or didn't you understand? Just because there's no difference in what I described as an experimental laboratory, except that nature has done the varying.
We just stumbled onto something. Let's put the observation on the back burner for 1 second. Do you think that orbits are perfectly circular, or do you understand that they're all elliptical?
Oh my God! I said about 30 seconds ago that they can be circular, but they can also be elliptical. And I talked about eccentricity. If you knew anything about orbits and
name one orbit that's not elliptical. Because now I'm learning something.
There is one that's very close to being circular. I can't remember what it is.
Okay, so that's not circular.
Not circular.
That's not circular. That's an ellipsis.
Very close.
2 radii.
Hold on. So in other words, let me get this right. If you think it varies by 1 inch in the period of a year or whatever orbit it is, that makes it non-circular. Is that what you're saying?
If it's not circular, if it's an ellipsis...
How close does it have to be circular in your
So an ellipsis
language?
is an elongated circle.
How long does it have to be to cease to be a circle in your mind? 1 inch?
And any amount of measurement off, sure.
Right. So if it's 1 micron off a circle, then it's not a circular orbit to you.
It's not a circular orbit to math because you're going to have two radii.
So
you understand?
Okay. So you
There's going to be a longer and a
circular
shorter,
orbit
a
is
semi-major
one
axis
thing that
and
will
a
be
semi-minor
1
axis.
nanometer off being circular. What
If
you
it's
don't
got
seem
a
to understand
major
is
and
science
minor,
works.
if it's got a
Science works to a degree of margin or whatever
All right.
accuracy you're interested in. And
That's fine.
I'm
Show
not
us one
saying.
that's 1 inch off of circular.
No, I don't think there is. I think they would all be elliptical if they
How
were
about
1
a
inch
foot?
off. I
They
don't think
are
it's
all elliptical.
Go by the diameter of the body itself. Hey, Rumpus, two things. Okay, one, give me proof that Venus is not plasma, and then prove to me
Hold on,
the size of Venus. I want him to
Hold on,
prove
this
the
guy's right in
size
the
of
middle
Venus.
of it with him. We don't hear from this guy a lot. Hold on. Are you done? Are you done,
Right.
Platypus? Or
No, go ahead. The floor is anyone's.
all right, go ahead, Brian. My bad. I cut you off for no reason. I'm so sorry, bro.
Yeah, prove to me that Venus is not plasma, and prove to me the size of Venus.
Well, we've actually been to Venus. We've sent a satellite around it, so we know what its mass is. We also can probe it with radar and establish that it's solid and doesn't behave like a plasma, it behaves like a solid.
We haven't been to Venus.
So your proof is we've been. Your proof is we've been to Venus.
We've also bounced radio beams off Venus from Earth as well as from satellites.
Let's see it.
See what?
Show me where they bounce a radar off Venus, please. Let's see it.
You want to see a radar map of Venus done by the satellite that went round it?
I've been hearing this horse shit for 4 years. I want to see.
You want the radar map? Okay, well I don't have it. You didn't give me any preparation for that. Let's see if I can go and find a radar map of Venus.
I don't want to see no map. I want to see somebody bouncing the radar off of Venus.
You want to see? Well, the satellite.
That's a pretty big request for an on-the-spot thing.
You want a picture of someone hovering over a VDU, looking at a radar output. Is that correct? Or standing next to a radar station?
Yeah, and I want the software too.
You want the software as well. So you want the entire software, you want the hardware, you want a picture of the guy next to the satellite.
I don't want the hardware. I don't want the hardware.
And you want that. Oh, you want a
blowjob while you're at.
You want a picture of the hardware, of course. There's no point in me just telling you. I could show you a picture of any radar.
I don't even want you to ever mention hardware again.
Right, so I would to collect all that information together would take a week or more.
Quit claiming it until you do then.
I'm afraid you see what the thing is, Brian, I have trust in people and institutions that have
I don't.
I know you don't, and that's what makes you a science denier. Because there are science people.
No, I want proof. I want proof, Rumpus.
Yeah, but there's no proof of anything. You can't prove anything in this world. So what the thing is, we live in a world with computers and aeroplanes, etc. that have been created by technology, and we know this stuff works. We know that science works. We know that hundreds of thousands of institutions, or the 80 institutions, space agencies, all agree that Venus is a planet. Many of them have sent. Well,
a consensus fallacy.
The Russians and the Americans have sent probes over there. And they all agree. If there was some dispute about it, if it was not correct, this other institution that's also got access to all this information would then come out and they would get Nobel Prizes running amok, saying, "Oh look, we've shown that all these other people got the wrong end of the stick." But the thing is, we know that these people are authoritative and correct because they do stuff that works. Go ahead.
Okay, that's an appeal to authority, but let's just leave it. I like where Brian's
working authority. That's right. We do. I believe in science books because they work. They produce technology that works.
Okay, well, hey, look, we like science too. So let's riddle me this, because I actually like where Brian was going with the Venus. You just said that we've sent probes to Venus, right?
Yeah.
Right. Do you know what those probes did on Venus?
Well, radar mapped it for one. And some of them landed probes down there that got destroyed in moments. I think the Russians, tried to get about 4 on there in the 70s.
Yeah, and you know what the claim is? That they floated some balloons with a probe on it. Do you know what the temperature on Venus is?
400 degrees C.
Yeah, 900 Fahrenheit, 475 Celsius.
Yeah.
So you're telling me we had balloons that were floating around in an oven.
What kind of balloons? What was that material
they made? And they designed things to give them what they needed, to be able to descend. Because the atmosphere is very dense on Venus, it means you don't.
Rumpus, what material can survive that heat?
Well, they only lasted for a minute. For instance, the initial Russian probes, they melted immediately they went in the atmosphere. But they gradually got one that lasted 2 minutes. It's difficult. And I can't remember what the Americans did, but they managed to get one there that lasts about an hour. It is problematic. But they managed to get it to work for about an hour. I think the Americans did.
This shit's make believe fairy tale.
Well,
Shit,
just,
that's what
yeah,
that
but
is.
it's from the authorities that brings you things like aeroplanes and computers and stuff, and then you just wish to
The
reject
authorities
them.
didn't bring us airplanes, bro.
They did. The scientific institutions, they put you.
We can all make airplanes, Rumpus. We can all make airplanes.
Aeroplane. You can't. No, you can't make an aeroplane.
Okay,
It's
we're
the
not going to
result
go.
of
We're not going
understanding
to
physics
argue over
and
who
engineering.
can and can't make an airplane because that's ridiculous. The one thing that we're all beholden to is the math. Okay, which could also be described as the science behind it. All right, the way that we're describing and quantifying these natural observations. Now, if you want to go ahead and figure out how they got a balloon onto Venus and it didn't melt immediately, and they were able to get some sort of data.
Balloon. It's obviously not made out of plastic balloons we deal with in.
Yeah, I'm not suggesting that.
Well, good.
I'm not suggesting that. I would hope that they aren't
then.
suggesting that either.
Well, there. If you want, I can go away
So,
and
let me
research
ask you
that
this.
tomorrow and come
Let me
back with
ask
the
you
answer
this.
to what material they
So let's-
used as
hold
a
on.
balloon.
I'll
They
give
called
you
it a
this.
balloon to explain to people like you, but it's obviously not just a piece of plastic.
Okay,
that we're
just
familiar with.
calm down. Calm down. I know it's not just a piece of plastic.
Good.
So let's give them that. Let's say they had some super Teflon shit, right? And they're like, all right, we need this because it's 900 degrees Fahrenheit on Venus. How did they know? How did they know the temperature before they ever launched a probe?
Because you can do that with spectroscopy and all sorts of things. We knew that it was really hot just from looking at the atmosphere, and also the satellites that revolved around it can make sort of temperature measurements of how.
When did they first record the temperatures on Venus?
I don't know the date off the top of my head, but they sent things around Venus before they dropped things onto it. And from that, when you're right next to something, you can make. I mean, radiative bodies give out a particular spectrum. For instance, we know the temperature of the sun.
I can fool them with a fucking grow light, Rumpus.
Brian, please. We can.
I can fool your spectrometer with a grow light, bro. You're not in the lab.
Brian, you're next.
Can I just
Brian,
finish
you're
my
next.
sentence?
Hold on a second.
So, for instance, we can measure the temperature of the surface of the sun simply by looking at the color of it. Finished.
Okay, I could fool your spectrometer with a fucking grow light, dude. You're not in the lab using spectrometry. This is nothing the same. It's all speculation. It's a mathematical model, just like their orbits and all the other shit is. If their original assumption of Venus was off when they said this is before they radar mapped the son of a bitch, it just happened to be correct. Venus, after further speculation and after building the whole damn model, we have now radar mapped it, and it turns out we were right. Venus was the same size because now we've radar mapped it. Rumpus, you can't prove any of this shit. It's a story. It's a mathematical model, bud.
You're just denying reality. You're denying all the evidence of the observations we made. I mean, you can
show me the evidence. No, I'm not denying it. I'm asking to see it.
Hold on, Brian. Let him.
Don't put words on my mouth.
Brian, there myself and seen it. But
if he lies, hold on a second, Rumpus. Let him respond, and then you can deal with his bullshit after, please.
Right. So
no bias.
Who's talking now? Who's supposed to be talking?
Well, don't tell me I'm denying it, Rumpus. I want to see it. Is that denying it?
Okay. So we need to take.
Yeah,
so
my
you're
bad,
not going
Jeremy.
to accept it. So you're not going to accept it until we take you around Venus. And unfortunately, that's the position that flatties have. Unless they've seen it in their bedroom, they don't believe it. Well, I'm afraid you're not going to be able to see that. You've got to believe that authorities who make predictions, who give you the world around us that works, and they are checked by one another. Hundreds of thousands of institutions are always checking one another. Millions of people are checking each other's work. And if they were to be sort of perpetrating some lie, they would be caught out. And they're not. But that's because they're telling you the truth. Finish.
Okay, so...
Okay, now, until you can prove it, let me respond real quick. Until you can prove these claims, don't say I'm denying it. I'm only asking to see it myself. Okay, and there's nothing wrong with that. That's what a real scientist would do, is want to verify. Okay, just because you don't need to verify it doesn't mean I do. So I don't need to fly around Venus. Hold on, I don't need to not be able to build an airplane. I don't need to fly around Venus. I want to see the software. Okay, and I want to see the radar map. Okay, I don't want to just take your word for it.
Okay, well, okay. Perhaps I'll go tomorrow and try and get hold of all this information for you, the radar map and everything. But you'll just say this has been made up, this is a lie, it's a conspiracy theory, even when it's presented to you. And you'll say,
well, the people,
they'll have a picture,
listen.
they'll have a photograph of the guy not quite at the right angle over the keyboard, or he's not quite looking at the right data, or they won't have a picture of quite the right angle on the radar thing they used.
No, hold on, Rumpus. Hold on now. Behind the keyboard. Hold on, Rumpus.
I mean, how do you believe in Australia? I mean, Brian, presumably you haven't been to Australia. Do you believe in
Hold on,
Australia?
hold on, Rumpus.
Do you
Them
believe
guys
in
behind the
Australia?
keyboard. Hold on, Rumpus. Them guys behind the keyboard, okay, for Apollo mission said they didn't know the difference between the real thing and a simulation. They did it so many times. So go on with your horse shit, Rumpus.
Yeah, exactly. Well, of course, that's the ideal thing. You simulate it so
Oh,
well.
with your
that it
Australian
looks
bullshit,
like
Rumpus.
it
You got
looks
no
well
proof.
enough. What else do you expect
Time
them to
out.
say?
Time out.
That
Time
means
out.
that means the simulation.
Rumpus, do you hear me? Just time out. One sec.
Why are you interrupting me in the answering Brian? Why do you think you can?
Because
interrupt
I'm
my
trying to moderate. I'm just trying to moderate.
Well, why are you
If we-
interrupting my answer to Brian?
You'll
I was
be
just
able
trying to
to
give Brian
answer
a quick answer. He asked me made a
Lord.
statement. I'd like to respond to him. Then you can have a go.
Yeah, Rumpus, I'm trying to moderate. Everybody's going to be able to talk and say everything that they want to say. Even I got a little heated. We just need to bring it down a little bit because the people listening won't be able to hear what we're saying when we're screaming it at each other over each other. All right, go ahead and respond to Brian. You're unmuted. Oh, he's deafened himself. Okay.
Oh, bro, you can't mute Rumpus. If he can't monologue nonstop and like interrupt a little bit here and there, he'll just go on deafen. He has no interest in honestly engaging us.
That's fair. I understand, but I'll continue to moderate and just do the best that I can.
Yeah, sorry. It is hard not to get heated with him when he's saying we did this, we did that, and we asked to see it, and he can't show it, and he
You're a
starts talking
beast,
about
Brian.
the authorities.
Brian, you're totally unreasonable. That was a joke, but the first thing you said was wild. You were like,
that was a joke.
But the first thing you said was unreasonable, though. You're like, I want a map of Venus, the software they used. Like all the shit you were ripping off at the beginning. I was like, whoa, there's a lot of stuff for just an on-the-spot demand.
Yeah, and I'd like to ask.
Well, they've been claiming it for years and years. You know what I'm saying? They've been claiming all these radar bounces and all this stuff, but that same radar will curve around the Earth. If you know, it's just a big bunch of horseshit. They never back up.
We got Hurricane Kosho in the crib. You guys are like fucking doing quick shifts tonight, or what? Rumpus got muted. Kosho pops up. Kosho will leave. Fucking Ruben. What's up?
I was here when he got muted.
Yeah, you knew it. You knew it was coming to an end, so you had to come in here and take over his shift.
No, I was in gyms all day while I was working on the yard work.
Bro, I was in gyms earlier. It's a straight shit show over there. Like, obnoxious. I can't believe I was in that for a long time.
We were having a fun conversation.
I went to Jose's. It was not too bad today, man. Wasn't flooded.
Jose keeps it clean, bro. He's fucking on point with the moderation and shit. I gotta give it to him.
I'll give him that. He'll
Clean
shut them
fight
up.
there.
When I go to talk, he'll shut them right up. I'll give him that. They'll hear you out. Nothing else.
We should be hearing each other out. That shouldn't even be like a thing where it's like, oh, he does such a good job. Everyone's hearing what everyone has to say. Like, that should just be the thing that we do. Jesus. It does get intense with some of these guys, though. I've been hot all night, Kosho. I'm telling you, you don't want it right now, bro. You don't want this beef.
The way I see this thing, though, is they had the model with Kepler, right? Way before radar or any of this other shit, their computer models and all that. But my point would be, is if they guessed it all started with the size of Venus being similar to Earth. Okay, so let's just say, hypothetically, that the size of Venus turns out to be 1 mile, you know? So we can see it going in front of the sun, whatever. It's 1 mile, which means it's way closer. That means everything in our solar system, or that they call it, you know, is even if it is what they say it is, everything is 8,000 times smaller, and all the distances are getting exponentially shorter, and it just compounds from a solar system to a galaxy to a, you know, it's just a compound. It'd be a compounding error that instead of a light year, you wind up with a couple thousand miles, or if even that. It's just by the time you get out past the galaxy, it's just it's a computer model, and nothing more, man. It's a mathematical construct, and they've made it work mathematically until you get outside and see the galaxies and see the star rotations and all that. See the outside stars of the galaxy rotating at the same speed as the stars of the inside, and then they start realizing their math is off by numbers we've never even named, like 10 to the 120th power and shit.
What's funny is that they'll always appeal to authority and claim that we think everybody's lying about the maps. And I honestly want to know, when did they think that they stopped lying about the maps? You know what I mean? It's maybe when they discovered Antarctica, and that's as far as we can go. That's as far as we have. But even then, they've been lying about maps the whole time. Our maps right now are a lie. They are a fabrication.
It's like any of the data that would help us make a map, we can't get. You know, the flight path, the planning of the flight path and stuff. It's all I mean, it's information that's unobtainable. It's closely guarded.
Forget making a map. Forget the map thing. We need to do some kind of test or measurement or something that's going to be like a definitive thing to prove something. If anyone has any ideas, let me know. I know you got something, Brian, Kosho. You got, but don't, Kosho, if you fucking say GPS, I don't want to hear a GPS thing. We're going to let you do that if we ever make a straight line somewhere, but
you're going to let me do that.
Yes.
Listen, dude, my girlfriend just gave me $300 last night because she was drunk. And
and then what?
And today she kicked his ass 300 times.
I'm gonna walk away from my girlfriend for a second. Anyways, she gave me $300 last night, and I'm gonna use that to get the GPS RTK. So it's ready in the works, dude.
That's fine. It'll be one of the straight line. Listen, you never prove it definitively with one straight line. There's going to need to be multiple different methods of making a straight line. So yours will be one of the ones. We'll invite you to wherever we're making a straight lines at, and your method. We'll get your little RTK thing out, and we'll do it up. We'll probably have another GPS guy there beside you. I don't want you guys getting your signals crossed or anything, but we're going to have as many ways of making a straight line as humanly fucking possible. All right.
Yeah, sure.
You're in.
I mean,
you're in, bro.
Apparently, it'll be the first one for some time, maybe the only one, because so far you haven't had another method that's even by your standards adequate.
Tell me what you think about this, y'all. So we take in an auto level and we lay out. I mean, that's what bothers me when we talk about this. An auto level will show you it's not curving, but whatever. We might be curving our way around Earth. Okay, I'll give you that. So let's take an auto level and let's lay out straight right next to, like, say, a canal. Let's lay out 3 miles of markers. We'll just mark them all like 5 foot above the water.
Right.
Yeah.
Hold on. The only way I would even accept this is if you did this thing where you have your auto level. Like, say you're at the beginning of the middle of the canal.
Wait, you ain't heard me yet. It ain't really got nothing to do with that. That was just a precursor.
All
right.
Well,
so we lay out a straight line. They say it's curving. We say it's straight. Okay. So then we on top of that we lay out a reverse
Hold on.
straight line. In other words, we make the line. What?
Hold on 1 second. Or go ahead. I like what you're about to say. Go ahead. I'll go after. Go ahead. My bad.
Yeah, so then we lay out another 3 mile track on the same stakes. We make marks and we make it curve up. We force the curve at either end. What's 3 foot? That'd be 6 foot of drop. So we have 6 foot from beginning to end.
Basically make a tangent.
We force the curve, and then we force the curve above it. Yeah, and then we force the curve underneath it. Right.
You could use their math of how much it's curving and just make your marks according to that. So according to them, that should be a straight line.
Well, if we force a curve underneath it, and if we force a curve above it, if the line is straight, they should match. If it's not, we should be able, they shouldn't match. You know, if you got a
Wait,
two
what don't
parallel
match?
arc lines, basically, you know.
Hold on, what's going to match?
The curve at the end of the one we forced upwards 6 foot over the 3 miles, and the one we
What's it gonna
forced
match
downward.
again?
They should mirror each other, right?
No, one of them's going to be curved. One of them's going to be straight, no matter what it is.
No. If the middle line, if our baseline, the one we initially lay out, is straight, in fact, and we
The
force
other one will
6
be
foot of,
curved.
and no, we force a curve on the one above it.
Yeah.
It curves up 6 foot at the end, and then we go below it and we force a downward curve 6 foot. If the baseline is flat, a straight line, then they should mirror each other. But if they're not,
Oh, I
then
see
they
what you're
shouldn't mirror.
saying. How come I never heard this before? We talked this to death. You
Wait,
missed
what do
a
you
bunch
say?
of meetings. You missed a bunch of
It's
flat
just
earth meetings,
symmetry.
right?
Just using symmetry to prove it or disprove it.
You know how you would do it? At nights with lights. You'd put lights on the line you made, the straight line and the curved lines, and then you would take a picture from an orthographic view, 90 degrees, or a side view.
How are you going to take an orthographic view of a light?
No, you have a string of lights.
A string of lights. Yeah, string of lights. Good idea.
You have three
Yeah, this is what,
lines.
dude, me and Lichwink came up with this a long time ago. Except for Lichwink was saying, like you have laser pointers, and you basically set it up to where you have a series of them, but each section is lasers pointing back and forth, so that you make sure that it's straight between those two lasers.
But you'd have to make them equal distant from you, or perspective would curve the ends down. So, but yeah, I see what you're saying. We've all thought of that.
I like this, Brian. I don't see how. All right, so let's say. So you're saying if the middle one is straight, then the other ones will be symmetrical. If the middle one's not straight, the top and the bottom one won't be symmetrical.
Right, they won't mirror. We can go back 100 foot and measure top to bottom, and they won't mirror. It won't be.
How long do you got to go with this line? How long do you got to go?
I mean, the longer the better. But I mean, I could go a few miles in a day.
Minimum? What's the minimum?
Man,
shit gets
minimum if you
expensive real
want.
quick.
I mean, God, minimum. I mean, a mile. I don't know, man. I'd have to go at least 3 myself, man. But that's achievable, man.
You wouldn't
and
be able to see
surveying,
the
that's
8
not
inches?
that far, Jeremy.
You wouldn't be able to see the 8 inches on each side?
I don't think you'd be able to back up 100 feet or whatever and see the dissimilarities or the similarities.
All right, let me back
just 8
this whole
inches.
thing up. I like that idea. We're gonna put that on the table. That's one of the better ones, especially if you go out 3-4 miles. I see what you're saying with the distance. I like that. I like where this is going. We're gonna keep that. Let me back up a little bit to when you first even laid these posts. Right, you used your auto level to make these posts. When you make the post, when you move your auto, like you have your auto level, then in front of you, you put a stake out, right? But then past that one on your line you're gonna make, you put another stake. So you do one 25 feet or 25 meters, 50 meters, and 75 meters. You now have 3 stakes in front of you, right?
Yeah, that almost proves the straight line itself if you do that, though, Jeremy.
No, here's
We've
what
done
you do
that.
though. Here's what you do. You move your auto level forward. You disregard the fucking level feature on it, right? Don't even worry about if it's level or not. All you do is you make sure that these points line up on the rods. You see what I'm saying?
Yeah, I see exactly what you're saying. That's a good idea.
So that way we're not. They can't say, "Oh, you moved the auto level. You changed your level. Levels aren't." That doesn't matter anymore. We're not even using that. You just use that to start, right? And then you can go both ways off it or whatever, or just one way. It doesn't matter. Just go one way. But once you do that, you could just keep leapfrogging it, not using the level feature on the auto level, which sounds crazy, but I mean, this thing's going to make a straight line within range, regardless if it's level or not, right? Is that how it works? I don't know.
Yeah, I mean, pretty much, man. Look, double rodding or triple rodding. I mean, look, I don't think there's any contention that we could lay out a 3 mile level line within an inch or so.
You heard, Coach? That's one of the ways we use when you do your GPS bullshit. That's one of the methods we use. We got ways, bro, to make straight lines. Don't get it twisted. You don't have the only.
I don't think people appreciate the conversation we had, Jeremy. You know, and what it actually takes to prove or disprove a straight from a gradually curved line like that. I mean, we've been through so much, man. And there's
Because of Jeremy, though, of course. But regardless, yeah, in that observation, how do you get rid of the issue of optics causing a problem? Because that doesn't. I mean, isn't it still a visual test? Like when you're looking at the auto level, like isn't refraction
but I think
going to be a problem?
here's what this triple riding or double riding thing would do. It would I believe that this optical effect is an exponential thing. Like you say, the drop is 8 inches per mile square. I think that's happening just optically. So like if you only go 75 feet each time, you're going to eliminate the exponent part of it. You know what I mean?
Yeah, the refraction, and
But
all right.
Let me put it like this: if you're flying on a plane, you only have to drop 8 inches for every mile you travel. You don't have to drop like thousands of feet that the Earth's curve would demand over that distance because you're going with it. So if you go with it, like in the plane, you only have to drop 8 inches per mile. So if you're going with this thing, you're not going to you might get a little bit of the optical effect, but I don't think you're going to get the whole.
Yeah, but you're thinking about it backwards, man. Because you're right. There's less and a shorter distance, but that less doesn't. That means that's more. That's more that you have to be able to eliminate from your air, because if you're at a closer range, then there's only less. There's only a less amount of air that's going to false positive.
You can only use, I don't know. I have a bunch of different ways to make straight lines. That's just one of them. All right. I got another thing with laser levels. You know, those lasers that spin really fast? You might be able to do something with those. Beach says he could write a computer program to do this. I don't know how much confidence I have in this guy. I don't know what, if he even went to a good college or not. So,
Jesus Christ, he went to Stanford.
Yeah, I don't know. I heard this. What's the peasant Stanford?
Jesus Christ.
No, but Veed says he could write a computer program for this. I actually think that's a very good idea.
I remember that conversation, man, and I remember thinking that, what is the hell is he talking about?
I'm talking about this.
I was going to write a computer program to do it.
You have a camera on the line, right? You make a line. I told him this is doable in a small scale. Like if you have a wall and you just have your lines be like a centimeter or millimeter segments. Like you could do this this is doable in a small scale to see if it would even work. And then you would know if it worked because you'd be able to see like, oh, okay, it was only off by this little tiny bit or something over this amount, and you would scale it. Anyways, this is just, I don't know what he had in mind. This is what I envision though. I envision a camera on a computer. You got a camera on a computer. The camera can see where the last part of the straight line was and the new part of the straight line is, where it's going to make a new straight line. And then it could just like keep it going. It would like point a laser or something and be like, all right, this is where you want, this is where you put your line. It'll keep it straight. I don't know.
It's not a question of a computer program. It's a question of optics. And again, like the precision of the tools. You know what the lady at LIGO, what she did, one of the scientists, she actually wrote a PhD on this, but she had the mirrors. They needed to get them perfectly aligned, like not even like any bit of air at all, or they had a certain bit of air they were allowed to allow, but they had to get it to that exact parallel, these two mirrors. And she would shine like the light back and forth on it, and she did this weird thing where, like, if it wasn't perfect, there would be like this. It would create this weird like flare thing, and so they would use those flares to get it perfect, basically. So she used like the position of the flares, like where they were showing up, in order to reposition it and get them perfect. And so, eventually when they were done, she's like verifying that they're perfectly facing each other. I mean, that's why you guys should probably just use LIGO, dude.
I heard
LIGO
flares.
is already.
I heard flares. This lady had some flares and she lined them up or something.
Yeah, dude. Yes, she had flares. Anyways, dude, you should just use LIGO because for a fact
Well,
that it's in a straight
Listen,
line.
A, I don't know that for a fact. Or B, they need to let us go into LIGO with something. A water level, a plumb line. Oh, we wouldn't even need a water level. All you need is a plumb line.
Yeah, but all we need is
you can measure
all we
the,
need is a couple cheap-ass lasers, and a water level would be better to have one.
Yo, if they let
than
me
not.
go
But
near
yeah,
that
it
laser,
wouldn't take that long, bro.
if they let me go near that laser beam with a string and a weight on it, like a plumb bob, I'd be able to find out in fucking like 10 minutes if that shit was level or
They
if
would
that shit was.
let you. Yeah.
Or no, wait, you would need a water level. Actually, you would need a water level.
No, but you know what Zanuck said about Slack? He said that whenever you go there, and I was looking for the video where they do that because they give tours at Slack, and he said what they do is they present that to you, that the ends at Slack are not level with the center. Like it doesn't make like it's not. I think he said they put a plumb bob at each end or something like that, or water level or something like that.
Well, if the line's straight, then the plumb bob would be off at the ends.
Well, you could always look at the Bethesda line, which is a known curve.
So you would just need a plumb bob, and you wouldn't need an actual water level.
Yeah, well, yeah, you just need a plumb bob at the center or where it's level at, and a plumb bob at either end or whatever.
You need
And
something
see
else
that.
too to measure the angle. You would need something to measure the angle, but that's
Then
because
bring
it's not
bring a right
Right.
fucking angle thing, dude. Bring a
You
straight
might need
edge.
something better than that, but you're not gonna bring a carpenter square or something for this.
You'd have to bring something that can measure 1/32nd of a degree. I don't think that's feasible. It'd be as easy as this, guys. Look, just bring a laser, right? And set it up. You'd only need to clear 3 spots. Okay. And this would be the first phase. Clear 3 spots, one at the beginning, one in the middle, one at the end. Okay. If their survey is correct, okay, then and you measured the height above at the beginning, the height above at the middle, and the height above at the end. So you compare it to the water that you know is connecting in one height. And so if it is literally higher in the middle, or if it's literally lower in the middle, then it would be easy to find out. It wouldn't even take that long. I could do it easily within a day.
You got to convince them to let you go there. Where do you live, by the way, Brian? State do you?
I'm about 8 hours from there. I
Don't
could
dox
do it,
yourself.
man.
I'm about 8 hours from there too, man, but probably in a different direction.
I used to live there, man. I've been over Pontchartrain Bridge. I don't even know how many times.
You guys should meet at LIGO and touch tips.
Shut the fuck up. This is fucking dude. The guy who fucking does nothing wants to set up some gay fucking meetup. You fucking sick fuck. Anyways,
I tied down until about June. I could do it anytime after June. I'm gonna start pressing them because they don't want to let me on to do this shit.
But
But I'm gonna start
you
pressing.
couldn't do it till June.
Yeah, I'm tied down, man. I can't go to. I'm in contract until June.
I got you. Well, I was gonna say because my girlfriend's from Louisiana, and I told her that she's gonna help me with this straight line bullshit with the GPS RTK. So maybe I'll tell her we'll go to fucking LIGO.
Let me say this. So, Coach, if I was to make a set of plans for a straight line, and I was to draw up the surveys and all that, that's exactly how I would draw them to get a straight line. If you used globe GPS and stuff like that, you'd have to draw it like that. It still doesn't prove that it's curved or flat. It just shows that, if I'm going to use the GPS software or GPS equipment that is saying that the line's curving, then I've got to draw it up like that and follow that. Or else it's
GPS.
not
Okay,
gonna
so
match.
let me just tell you. There's no software involved. There's no
I meant to say
interpretation
equipment,
involved.
man. I meant to say
I know,
equipment.
but all the equipment is doing is getting the exact raw data from the satellites.
Hold on. Is the satellite curving, or is the satellite going in a straight line? Now, if the satellite
doesn't matter.
curving,
That doesn't matter, man. That's not even part of the measurement.
it's
The
a
satellites-
two-dimensional. Listen, Coach Joe. It's a two-dimensional system. Okay, and they can
not.
make it into three-dimensional, but initially
not a two-dimensional system.
it's built off. Its baseline is two-dimensional, though.
No, it's not.
Okay,
In
so
no
the
way.
surface of a sphere is not two-dimensional, right?
its baseline has nothing to do with the surface of a sphere. It gives you its information using a 3D coordinate system, an XYZ
Right,
Cartesian coordinate system.
sea level, right? Cartesian. So sea level is 2-dimensional on a sphere, right?
Yeah, but it does nothing to do with sea level. Has nothing to do with curvature. Nothing to do with the globe Earth. It gives you XYZ Cartesian coordinates, and it's up to your computer, your cell phone, or whatever system it's passing through before it gets to your cell phone, to interpret it and translate those 3D coordinates into spherical coordinates, longitude and latitude.
Yo, hold on one second. Hold on.
You don't. It doesn't come from the satellites in with spherical coordinates in mind.
Okay, so how much range does each satellite have?
I would assume infinite. What do you mean?
What's the radius? What's the range? Give me an idea of the radius of each satellite's range.
Well, they're about 22,000 miles above the surface, right? So depends on what angle you're receiving at. If it was directly above you, I would say 22,000 miles, and if it was somewhere else, I don't know, further. I don't think it has a range. There's no maximum range. Just if it's above the horizon, then it's able to send you a signal. But anyhow, yeah.
I mean, I would think. Listen, I would think they wouldn't break about 80 degrees to so they don't involve refraction. They would want to use equipment that's, if it's overhead, like you say, why would they want to extend out in the distance? Then they'd start involving refraction, all this other shit.
Refraction doesn't become a problem at 80 degrees. It doesn't become a problem until like 20 degrees, or maybe less. I mean, or maybe more, like 30 degrees or something like that. But definitely doesn't become a problem at 80 degrees.
Well, with the accuracies you're talking about, then yeah, it could be a problem.
The accuracy doesn't come from. So first of all, like the measurement that it's taken. Okay, so the accuracy comes from using a base station. So there's your rover, like the one on your cell phone or RTK rover, and then there's a base station that it communicates with, like their known positions. Like the surveyors have these known positions that are already marked and known. So what they do is they just compare. They compare. Well, why would you want to stop me?
No, I wanted to throw this point in real quick so you could expand on it and add it into what you're saying. That you say 22,000 feet. That's the Lagrange point.
No,
That's
22,000 miles.
That's only over that's over the equator, though, man. The geostationary
There's no
satellites.
way a Lagrange point.
Okay, good.
Yeah, Lagrange point. I mean, one of them is 1,000,000 miles away. I don't know how far the other ones are, but 22,000 feet.
Are these GPS satellites? Are they orbiting? I mean, are they circling around? Or are they geostationary? Are they using satellites that are in motion, or are they using geostationary satellites?
All satellites, including geostationary ones, are in motion. But yeah, the ones that are GPS, they orbit about twice a day. So they might be lower than 22,000.
Okay, so if what
20,000.
Yeah, they're exactly. That's my point. They're definitely not 22,000, man. That's the geostationary satellites that I know of. They're 22,000.
They're
claimed to be 22,000 miles away.
Yeah, they're 20,000 kilometers. So about 12,000 miles.
I just have a hard time even believing that.
Yeah, sure. Of course. I mean,
Why would they want to use? Why would they want to use satellites that are hauling ass? Going freaking Mach 11 or whatever, however fast they got to go, faster than that. Yeah, going 20,000 miles an hour for GPS. It doesn't that seem kind of, non-intuitive?
But the speed doesn't really matter. I mean, because it's going to send a signal. Let's say it's moving at 0 miles per hour or 1,000 miles per hour. It's going to send a signal from wherever it was, and the signal it sends you tells you wherever it was whenever it sent that signal. So, and the time.
Sure.
So everything is acting as if the thing was stationary.
So you could
I mean,
use the
'cause
math to make the adjustments. In other words, I see what you're saying.
well,
You could
no,
use
you
the
don't. You
math.
wouldn't have to make any adjustments. The whole point is it's sending you a
But
signal telling you where exactly where it is, exactly what time it is, and at that specific moment, that's going to be true. By the time it's moved, it's not going to be true anymore. So, but it's true for that exact moment, and that's the moment that it sends you the information. So,
But it seems like, man, with all the directions that we're moving, and being that we're moving over 1,000,000 miles an hour, just a portion of a second we'd have traveled so far, unless the light conserves momentum. I mean, I don't know.
first of all, it's moving with us. The satellite is, and second of all, light. It's relative. I mean, the speed of light is constant. I mean, from every reference frame. So, but it takes into account time dilation. But either
So
way,
if I'm sitting here with a laser, and I want to bounce it off a moving object that's moving. No, let's say I'm moving 1,000,000 miles an hour, and the other thing is so it matters what the other thing is doing for it to bounce back. In other words, it's going to conserve the momentum of the moving bodies. It's not going to fire a straight line. You're saying that the photons that come out of the laser are going to conserve momentum with the moving
truck, and you shine a laser. The light from our reference frame being on the truck too, since you're bouncing the light from where you are onto the truck and back to you. Yeah, it's all moving at the speed of light, and from our reference frame, speed of light's the same speed that it always is. So, yeah, it's not gonna make a difference. The only thing that makes a difference is, like I said, that the clocks on the satellites are going to be ticking a little bit differently, but they adjust for that. But the light itself,
so we could treat it like we're stationary then, basically.
Yeah, exactly. Yeah, but I mean, it's like if you're on a truck, you're moving with the truck, and the satellites are moving with the Earth, even though they're orbiting around the Earth. They're still moving with the Earth.
If you're in a truck, that's the same thing as the interferometer. It'll show you that you moved. It won't conserve momentum. Yeah. If you have a
that's interferometer.
What?
An interferometer will show that.
Yeah, because the light doesn't conserve momentum. It will show the movement.
Well, no, an interferometer is not just one single light. It's two lights opposing each other, and
no, it's split.
It'll show you. It won't show you constant motion. It'll show you change in motion, or specifically change in rotation. Or not change in rotation. It'll show you rotation or change in motion or change in speed. But again,
Don't it make more sense that we have GPS and towers all around us and above us, and on balloons? We've seen these satellites crash down. We've never really seen the ones in orbit. We've seen versions of them and all that. We see rockets, but they were in contention. They curved down and shit. But don't it seem more rational that we just send up these balloons with the GPS, satellites attached to them, and we just replace them every now and then? I mean, it just seems so much more rational, man.
It really doesn't, but regardless, I can give you that just for the sake of moving past whether or not those are in the sky or not. The question for like these measurements specifically is it giving you accurate information? And so we can pretend that they're in balloons or they're in towers, and still use them and still trust that the positions that they're telling us are the positions that they're telling us. And we do that, and because it does give us correct positions and the RTK just allows it to give you more exact, precise positions. So using
But they
precise
had all this
position.
stuff. They had all this stuff with Moran, you know.
Yeah, sure. So that's what I'm saying is, yeah. I mean, we can move past it and say, yeah, maybe it is possibly just towers. Try and conduct tests like this, where you're just using the positions it gives you, and taking those points that it's giving you, and constructing straight lines from them. Because with Cartesian, with spherical coordinates like longitude and latitude, it's kind of difficult to do that. Give you actual real straight lines. But with Cartesian coordinates, it's very simple to do that. If you have 2 points in 3D Cartesian space, making a straight line is, between 2 points is pretty trivial.
Not if you don't know if the satellite's curving or going straight. That's the whole point. But wait, that wasn't my point. My point is man, if you take a look into this old Loran, and that brings Earth curve into contention, man. Maybe it's not a solid proof, but it damn near. I mean, the distances these things claim to have worked from towers that weren't that high, working a few hundred miles out at sea, man, is brings Earth curve into contention right away. If you really look into this, the old Loran, the military ship.
I've seen Loran, and definitely it was, GPS is based on the same sort of trilateralization, but regardless, I don't think the ranges were that far. I don't think, like you said, 100 miles or so. Not sure they were that far. I think to get 100 miles, you have to be 20,000 feet off the ground. Do you remember what the range was for Loran?
I'm going off memory. I thought they said, that it could stretch out a few hundred miles, but I guess I could be wrong.
Hold on. It's long range. I'd love to see it.
Point I was trying to make is that basically with GPS is gonna, you've got to put a map on. I understand that it works in 3D space, but you've got to apply it to a map. You've got to apply it to coordinates. You've got to fit them, and you got to model it. So that's why.
Well, no, that's how people use it commercially, or how your cell phone uses it. But the way that, like I said, for this test, it would be used is it would not be fit with any map or any model. It'd be fit with the exact Cartesian coordinates, the raw data that gives you, and you would use that to construct a straight line and all the points on that straight line, and then you can then if you wanted to, you could take those points and map them onto the curve of the Earth. I mean, not curve of the Earth, on the surface of the Earth, and see where they matched up. Or if you took like 2 points and create a straight line, and then took at one point in between those 2 points at the center of that line, and see where it's at. If you did all of this over water, you know, you would see how that straight line, how it corresponded with the actual surface of the Earth. Like if it was, you know, matching it, like if it was level the whole time, or as I would predict, it would, you know, the center of that line would probably be several feet, depending on how far the line was. You know, it would be relatively lower than the surface of the water, depending on how big that line was. Like if obviously if it was 1 mile, but it would be 4 inches.
Yeah, it wouldn't be shit. A couple inches, yeah. I see what you're saying, man. I just feel like they could easily. It to me, the baseline of it all starts off with a map that's 2-dimensional, and that's why y'all call the sphere 2-dimensional, because everything relies on the Cartesian. Before the topology is added, the baseline is all 2-dimensional, and that's why y'all call a globe a 2-dimensional surface to make all this shit work for you. I disagree with that. But
All
I don't know, maybe
surfaces,
not.
all surfaces are 2-dimensional. The coordinates that GPS gives you are 3D Cartesian coordinates, X, Y, Z, not 2-dimensional, and it translates them to spherical coordinates, which, if you don't have a constant radius, is a 2D surface. But if you don't have a constant radius, then it has to use a third coordinate. It uses the radial distance, so it'll give you longitude, latitude, and altitude, and elevation.
This is what I was talking about though. So let's just say the not the receivers, but the what you call it, the other end of the GPS. Okay, the satellites. Let's say we had them in airplanes and they were just doing circles. I mean, just going straight overhead. So if you were to map it 3D, you know, and so you could give elevations and exact pinpoints of where you're at, I would say that, you know, you'd claim, look, it's showing it curving around. And I would say, no, it's not. The airplane's going straight overhead. So I would claim that airplane is not following a curve. It's only going straight. So that's straight. But the way y'all made it where y'all could argue that the airplane's curving, showing that the ground is curving. So you'd use that as proof that the ground is curving, assuming that the airplane is curving.
I'm not sure what kind of test you would do with that, but yeah, I mean, it's true. If the ground was straight, then the airplane would be flying straight. If it's curved, it'd be curving around the Earth. And,
That's my point. I could easily map that.
Thing.
I could easily map that on a curved surface. If it's going straight, as long as I keep it equidistant and make level curved, I could easily map it onto a ball. Is my whole, my point.
Yeah, that's what I'm saying. That's what I'm saying. So yeah, it'd be experiencing the same thing in either case. So it's not really something you can make. You can see the distinction in.
I mean, it is a hell of a thing trying to get true proof, tangible proof, like all these tests we're trying to come up with. You know, GPS. You know, I'm just bringing in all the points of contention that one might raise. You know, but it's harder than people think. People think it's just a dumbass argument that we have pictures, but when you put the pictures in contention and the rockets in contention, then it becomes a fair debate, man. People act like flat earthers are so stupid. I don't think that's the case at all. Might be some stupid flat earthers, but in general, it's a fair debate, man.
It says Lorraine can get up to 1,500 miles.
Yeah, see, that's that.
I think it's because it uses radio waves.
Oh, right.
Like low range radio waves, or low frequency radio waves. I mean.
Say, did you do that thing with the tornado?
No, man, it's gonna be a minute. But when I do it, I'm gonna try and implement a little system there. It's so. I mean, the way I was doing it, simple shit. That kind of gets it a little bit intricate, but it's a good idea though, man.
Yeah, start from the small, from the source, and then make it get wider to the, as you go further away, and that's what'll cool it.
But let me bring up one more point to kosher, like when they do, so you're talking about the radio waves, and so let me bring up sonar. Like they detect, you could do mapping with sonar, because they show, all the acoustic shadows, all the areas that the sonar don't reach are shadowed. So you can map the bottom of the ocean with sonar. And now they say the whales can hear each other's calls up to 4,000 miles. Now, being that the sonar is showing every little nook and bend and bump on the ocean floor, maybe not everyone, but enough to map it. How are you claiming that that's able to map the ocean floor and curve around the ocean floor at the same time? To me, that's slam dunk proof that it's not a globe.
Oh shit, I was on mute, man. Yeah, give me a minute. I'm about to run.
Well, they got to fuck. Sure, they say the same thing about us. Like I said, the sonar, you can map the ocean bottom with the sonar. So it can't be mapping and curving around.
A good answer for what? Was Kosho answering you?
No, he had to run right when I asked him. He ran off, but I've never got a good answer from any glober as how we could use sonar to map the bottom of the ocean because of the acoustic shadows. Shows all the shadows. It shows where the sonar doesn't come back from, and how can it do that and curve around the Earth at the same time? Because that's what it would have to do to be able to detect sonar from 4,000 miles away.
No, they do it with these super amazing submarines that go all the way down, close enough to actually get a ping off the ocean floor.
Yeah, you got to be close enough.
They basically do it like, like they suppose it's a flat, motionless Earth when they're doing their local measurements, their local, sonar detections.
Yeah, because the sonar goes out from the point and widens like a sphere.
Or like light. Anything that,
Yes,
has
sir.
the inverse square law. But really what they're doing is they're assuming Euclidean geometry. It's science.
Yeah, they can make a cell phone and an airplane. Therefore, sonar proves the globe. I hate when they use that argument. Like, look, these are the same people. I mean, no, they ain't the same people. These people, there's people making different components of cell phones, and then you got the people who put it all together. None of them know the whole fucking method, in my opinion. You got the people who make all the transistors. You got the people who make all the speakers, and then you got everybody making their own little components. Some of them make a few of them. Then you got the people who put it together can't make individual components.
Yeah, it's called component artilization. I need to work on
They
that.
don't.
I see what you did there.
It wasn't as smooth as I'd like.
Hey, I wanted to get an answer on that. How are they using the sonar to map the floor because it shows acoustic shadows? In other words, they bounce back, show the places where the shadows where the sonar doesn't reach. How can you show all the contours of the ocean floor, and also the radar be detected or the sonar be detected from 4,000 miles away? If the Earth is curving, it would map that. There would be a acoustic
They say
shadow.
whales can do that. I've never even heard that. But the sonar.
Moisture,
I'm sorry.
like too much of it, like that'll like not help it as much.
Somebody's low.
Like if you have a scab, you put a Band-Aid on it so it keeps all the shit away from you. I don't want it to get.
I got a hot mic, man. But my point is you can the signals can't bounce back and keep going forward at the same damn time.
So you're saying there's an interference pattern with the thing itself?
Not really. I mean that. So you're saying there's a chance? That's funny.
Well, I mean, if it goes one way and hits something, for example, and it's bouncing back through itself also, right?
Well, no, I mean, they definitely can hit something and bounce back and also curve around something too. I mean, even when light's refracting, the people who are, like, if you see Chicago skyline because it's refracted, you could also just be in Chicago looking at those same buildings because the light is not just going in one direction. You know what I mean?
How come we never see refracted? How come we never see refracted light source? Like when you look at a flash, look at the sun, it shines from the source outward perfectly. There's no S wave of light. There's no fucking refracted. How come we've never seen this anywhere and any real light shining anywhere? I mean, unless you got sugar water, I guess. I mean, we've never seen this refraction of light. Like a source like the sun doesn't refract. It doesn't go and do what you're saying. Not at all. I don't see the sun rays going out and bending around, going up and down and over and around and under.
Well, how good are your eyes?
They do widen from the source. They do widen, but they do not bend. And where would you have to be in that tank of sugar water as a little bit as the laser being a giant source and refracting around like something would be being that small? You understand you point of like where it would have to shine from, you reflect all the way around it. I mean, to show you nothing from Australia all the way around to fucking almost the North Pole.
I'm gonna be honest, Mark. You sound like you were like on point there, but we didn't catch any of it because you were roboting like a motherfucker. But just like my intuition tells me that you're correct.
The light, how the sugar tank works, and the light goes out for its certain amount of distance, right? Just imagine you're a little guy, and that certain distance is the globe. That light source is shining all the way underneath, down and around, like it's like basically like in almost Australia. Now, if there's a boat in Australia, and we can see it up around almost North Pole, then I'm with you on this bendy light shit. But I mean, it just doesn't make any sense. Like if you put a globe in that tank, and the light source went and did what it did, it would shine straight past the globe, come back, and then go back around, and it like, I mean, from a super distance away, so it'd go straight for half the
I don't even.
distance.
That's a good point, man. I don't even know if it would bend. If with an obstruction right there, would it even bend?
Well, plus look at this. They tell you that light is coming and refracting around the curve, right? But the light has to hit something. So how is the light hitting the object like a wall, a boat blocking the light? But then that same light supposedly going through the boat and carrying the front of the boat image to me, but the light's only touching the back of the boat. The light never touched the front of the boat if the sun's behind the boat. How could the light hit the front of the boat and bring me that image if the light's never touching that? Ever. Unless the light's behind me. Yeah. Think about that one. So if I put a big wall there and had the sun behind it and then backed up and the wall's at my horizon, the wall should be a shadow, not lit the fuck up. It's going to block the light that's coming to me. So I don't get what they're talking about.
I think the extent of their bendy light is distortion at its best. You know, I don't think.
Right.
Yeah, no way do I think it's going around a curve.
Right, but think about it. If that in that tank, put the globe in that tank, in that fish tank, where they have the sugar water, and just imagine a globe being there. Where would you now have to be where that light's bending to see your shit around the horizon? You would have to be at the source where the light bends and comes almost to like the bottom of the tank or close to that, right? That's where you would be. And then the source of light is shining straight around way down the bottom of the globe, past the bottom of it, you know, supposedly in space, from space, shining straight past the globe a little bit and then bending around to you. So that means literally if there's a boat.
You cut out right after you said literally. If there's a boat.
If there's a boat on the bottom of the ball, just like the laser, the boat's image should carry up straight and then curve to us like Superman, like just automatic, like make that curve, baby. Like from the bottom of the ball, not from just the horizon. We should be seeing shit from around the globe everywhere, thousands of miles away, 12,000, 6,000, 8,000. Because the laser goes straight for half the tank, and then all of a sudden it stops right there like a force field's there, and then it goes and curves around. If the front source of the light's what we see, like looking through a straw, right? And the source of light coming to us is like a light beam, and we're seeing through the straw. The straw is going to represent our light. Now the boat would have to be like the straw hitting the boat, right? And then we see the boat through the straw, like the straw being the light carrying the boat to us. That's supposedly what they tell you.
percentage are you there?
It seems like we could disprove the refraction just by putting something at a angle, like in the water, halfway between the Chicago skyline and the observer. Because for that to happen, for the rays to bend the way they're saying, they'd have to come straight and and bend around the ball. So they'd have to. We'd be seeing the light rays that are initially heading up over our heads. So if we could show that we're blocking that angle, but still seeing the Chicago skyline, then their little theory about these rays bending around would be debunked.
If anyone knows if there's like some kind of law or rule about two objects occupying the same space at the same time, speak now or forever hold your peace.
That'd be quantum mechanics, right?
I don't know. Is there a rule that says two objects can or can't occupy the same space at the same time?
Yeah, I think he's being sarcastic. Yeah, they can't.
No.
I'm not being sarcastic. We got into this shit earlier.
There is, Jeremy.
With
I don't
the
think
light.
Not the same exact space. I mean, not two objects. No, not that I know of.
Oh, they got a particle as the photon is supposed to be a particle to these people.
Oh, okay, I see. So how can it be? Yeah, I got you. A photon.
And they got particles. They have particles taking up the same space at the same time.
Right. That's a conundrum. Now, supposedly in quantum mechanics, what it is you can have two things in separate, like apart from each other, that are supposed to be the same thing. It's like one thing multiplied, duplicity, supposedly, but it's not the other way like you're thinking. It's not two things occupying the same exact space. It's, space being occupied by the same thing twice, side by side somewhere. Supposedly. Yeah, no, I don't understand how unless you jump inside the thing, and then that's still, they'd have to be inside each other for that to, like something in my belly can take up the same space I'm taking up in a way. Other than that, you can't. I guess liquid could. Liquid can take up the same spot in the same space as an empty container. Does that make sense? That's the only way my mind can think about it. So you have liquid filling an empty jar, and they're both occupying that space. I don't know. I'm just little old D-Monk. So if like a photon could fit inside a particle or a wave or whatever the little source of light is, a photon and a particle can fit inside each other, I don't know. But it's kind of like they act like a garden hose is the light. And if the garden hose touches the surface, then you just string the other side of the garden hose back to the observer and be like, look through your garden hose. That surface right there that you're looking through is your surface of light that's supposed to bring you what you're seeing. That way, kind of like looking through a straw. You know what I mean? It's a hollow thing, like you're the light. But if the light is hitting the back and the top of an object, like the top of the boat and the back of the boat, Why would we ever see the front being brought back to us in a bent image? If the image is bent in an arc, the thing in the image should arc also like the boat. So it should have an exponentially greater tilt with the arc of light that's carrying it on an arced path. So the arced boat should be carried to us on the arced light, and we should see it as an arc, and we should see the top of the boat. Ever the front. If light bends, we should never see the front of the boat, just the top. Literally, we should look in the sky and see like a deck of a boat floating at the horizon. I swear. Like a sideways floating jet, boat, you know, like a jet on its side, flying past, and you see the cock, you see the, you know, the pilot and the wings. Oh, but Brian, spin your actual source, and then have the tube be a spiral. I'm thinking if you spin the thing that you got the electricity going through and the liquid in with little electrolytes, you actually spin that. See if that has an extra little effect, like a slight effect. Not gravity, goddamn it, vacuum. I'm sorry. I'm so sorry. I should never said that G word. A centrifugal vacuum.
Yeah, we got Branch in the house.
Branching out. What do you think, Coach?
I was talking to my girlfriend. What were you saying?
You know the Mythbusters, how they supposedly had the thing to make HHO?
HHO. What's HHO?
Brown's gas, but they didn't add salt to their shit, dude. So they barely got any bubbles at all. It was a joke,
So,
dude.
did you ask me what HHO is?
Yeah, what is it?
Oh my God. It's hydrogen, man. Hydrogen gas from water.
Oh, I've made that.
Okay, well, my idea is to spin it while you're doing it.
Okay. No, that's how I made my hydrogen. I mixed pipe cleaner or like this, like I forget what it's called.
Or not
Sodium
hydrochloric.
You know,
Yeah,
one of the byproducts is helium, right?
No, but it's hydrogen. And
No, it's hydrium. It's
helium doesn't react with anything, so it's not going to be the reaction from anything except for fusion.
No. It's the byproduct of. What do you mean? I didn't say it's going to react with it. I said it's going to come from it. A byproduct
No,
of.
that's what I'm saying though. If it doesn't react with anything, then you shouldn't expect it from anything.
Then how do you get it? How is it a byproduct of natural gas? What are you talking about?
Because it's a reaction. It's a fission reaction.
Well, HHO is a natural gas, and it's also a fission reaction. When you spin it and you get the electricity and it acts like a vacuum, yes. Just trust me and do what I'm saying.
Okay.
Why argue with science?
Hey, that's a good question. Why argue? The truth is, though, there's a difference between chemical reaction and nuclear reaction.
I'm not talking
fission and fusion are nuclear reactions, and I'm saying that you're not going to find it as a byproduct in a chemical reaction. So I think that it does. I think that it does. Yeah, sorry, go ahead.
I don't care what reaction or how. The thing is, I care about the outcome. So, and it works. Then forget all the other dog shit. It works.
But you're talking about a chemical reaction.
Listen,
I'm talking about cookies, coconuts, and Scooby Doo caramel and ice cream. Doesn't fucking matter. So if I put this shit
Caramel.
in there and centrifuge it, and the result I get is what I want, then does it matter what I'm talking about?
Guess not.
Okay. So now when you want to make HHO, what you should do is spin it. Don't just sit a container there and have two electrode things going on. Spin that motherfucker.
Okay.
And after you
It's actually
spin it,
not a bad idea because that
I'm telling you.
it'll separate it, but it separates it, and you got to have two different tubes for each of them to go in each tube or whatever. But yeah, I guess if you spun it, the hydrogen would be buoyant in comparison to the oxygen. So
Yes, sir. The same way they separate your blood and your motherfucking plasma. But so you're also going to get a charge, right? You're also going to get a vacuum effect right in the center. You're also when you do that, when you put it out to your tube has to spiral from small to big, like a tornado effect. Also,
your spiral.
yes,
Where do you get a spiral from?
a tornado design.
Oh, you're talking about like
From the
because
bottom
it's
up, the
centrifuge.
tube.
Yeah.
Yes, after you do the centrifugal, the tube that releases it outward, you have like a P trap, and then it goes up into a spiral, small to big, and it's going to control the temperature that you need also. And
See,
it's
that's how
also
they.
going to separate them.
Yeah, because the helium that they get from natural gas, like I said, it usually comes from a fission reaction, but that's how they separate them by temperature. They just
I'm telling you,
administer different temperatures. Yeah.
in my mind, this shit is all. I'm telling you, man, we've already had all the free energy is just there.
Well, like I said, when I did my hydrogen, I got it from doing the hydrochloric acid. No, not hydrochloric acid.
Sodium hydroxide.
Yeah, thank you. Sodium
Right, you did
hydroxide.
the
That's right.
chemical.
I don't know
You
why.
did the chemical process instead of the electrolysis, right?
Well, those are both chemical processes.
Well,
But
yeah, do both. Yeah, of course.
regardless, yeah, I did. Yeah, I mixed the sodium hydroxide with aluminum and with water.
Aluminum, yeah.
Yeah. Actually, this a lot.
Uric acid's a little.
Hold
Yeah, a
on,
lot of
hold
people
on. Let him say what he
they make
did.
bombs. Well, no, that's exactly that's what it is. You mix it together, and it creates like I had a whole apparatus, man, and I had tubes come out of it, and the hydrogen would immediately just go straight to balloons and fill them up. But this is what people use these chemical reactions to make fucking simple bombs. Because if you made one of these in a glass bottle, like I actually did it in a glass bottle, but I had tubes coming out of it. But if you did it in a glass bottle and you closed the top, it would explode and create like a fucking glass grenade. Actually, this is what people do. People make simple bombs.
Yeah. Bacon is glycerin, right? And then a little bit of nitrogen, nitroglycerin. I mean, that's beside the point, but yeah, you do both. You do the centrifugal thing. You do a little bit of electricity. You do a little bit of the chemical. And remember, you can always separate by temperature. The tornado effect is going to like compress or decompress. That's how you can do the temperature thing. You can spread it out or you can compress it. Compressing it, you send it from a wider loop down to a small loop. Decompressing it, you send it from a small source and it gets wider and wider, and it does the centrifugal thing backwards and decompresses itself.
I wonder what gas you get if you do electrolysis on like gasoline or different types of liquids. Alcohol.
Probably helium and hydrogen and nitrogen. I mean, depending on what the fuck it is.
That's what I was thinking.
And why would you expect to get it for electrolysis to work like that?
Because they don't talk about it, and all they talk about is doing electrolysis with water. But that's
Right.
not the only fluid out there.
Pee? Why not human pee? What do you have in the desert but a lot of pee?
Well, if you're in the desert, you're not gonna have that much pee.
You're not going to have a lot of water.
That's true. Exactly. That's what I'm saying. So you're gonna have a lot of water. You're gonna have a lot of pee.
So what would you have electrical liquid would you have at your disposal that you don't want to get? You don't want to lay on it. You don't want to fucking sleep in it. You don't want to be around it. You put it in containers and use it for batteries. You piss.
Well, look, urea is supposedly get way more hydrogen in electrolysis from
Well,
piss
that's
than
what
you
I'm
do
telling
water.
you. Yeah, so if you piss in your container and then do exactly what the same thing that you're doing with the water or the salt, you can do it with grape juice. Mix half grape, or actually third. Do it in thirds. A third grape juice, a third piss, and a third water and salt. Throw it in there and see what happens.
They say you need way less volts to get the reaction. I don't know if it's more, but for the energy, yeah, it's more. Consider the energy output. You need way less volts. So
Now
in
listen.
return, it also controls the heat. But
Do
I've
you know
never
if you
tried it.
put, do you know if you put helium in there and just add some helium in there also? Actually, so fuck, do it force. Add a little helium in there, right? And when you compress the helium by centrifugal the spin, you're automatically going to get a charge out of that too. It automatically puts a charge into it. The more you try to compress or display, it gives you a charge. Helium. Pretty much same with hydrogen also, I guess, right? And nitrogen. So when you mix these certain things together and you compress them all, what would be the outcome? See, because the centrifugal effect's like a vacuum.
Motherfucker.
It's like a vacuum, but backwards. It's a vacuum.
I'm reading about electrolysis right now.
Yeah, I'm sorry. It's a vacuum towards like the inside. So if you spin something, the liquid stays towards the outside, not towards the inside. Like it'll leave like a gap. So what it's doing is compressing towards the container. So if the container is the thing that's, you have your little electrodes connected to, I'm just saying. The container itself can be a certain material too, Cocho, not just glass. Think about this shit. Do it right. Be a man. Do the right thing.
The way he did it, he don't want to use glass because that lye will melt right or fucking melt that glass.
Yeah, you want to use
Oh
copper.
no, I used glass actually, but it didn't melt through it. It just like I said, I had tubes coming out of it. It did tubes melted a little bit.
That shit's hot as fuck when it comes out. It's so hot.
Yeah, it is very hot, and the I use like what did I use? What's that stuff called? Like the glue shit. What's that? Epoxy. Yeah, I use epoxy to seal the tubes and everything, and it melted through everything. So there was nothing that I could use that. Well, actually, yeah, but it worked better when I used the one that did have bleach in it.
Listen to this, man. That begs the question, man. If it might just be the heat making the fucking balloons rise, because I did the same thing. I've used all three methods, but when I used the lye, it was so fucking hot, dude, and it made the balloons float, but they didn't float for very long. Okay, so I've made a real long hose, so it wasn't so fucking hot by the time it came out the end of the hose, and then balloons didn't float, man.
You're making
a
small percentage of helium
It was
also.
different aluminum. It was different aluminum, but still, it was aluminum. It reacted. It filled up the balloon, but it wasn't near as hot at the end of that long hose, and it didn't float for shit.
Dude, let me tell you what I did, dude. I had the bottle where the reaction was taking place, and that went into that hose went out of there into a big jug of water, or a big jug of water and ice that it went through at the bottom, and so it would go through. It would go through the bottom, and then come up out of the water, and it would cool. So it would cool the hydrogen, or so when by the time the gas got, and so yeah, on the top of that, I had like cotton balls or screens and stuff like that. So by the time it got out of that jug, it was as much just pure hydrogen as I get, and then of course it wasn't exactly pure, but it wasn't hot at that point anymore. And yeah, they floated for a long time actually.
So how about this one? I tried to make torches, right? One of them little tiny little micro torches with a like a needle, to see if it cut through the way I've seen the videos, and I didn't have an arrestor, right? And I'm gonna tell you right now, I mean, I have the stuff to make the arrestor. I haven't got around to it, but and I tried making an arrestor, and my little tip, I just had like a pin. It wasn't a needle. I don't know why I even said that. That's what was in the video. But I had like a little pin. It looked like a pin, like an empty pin, but it was a real, narrow point at the end where the gas could stream out. And I took some like Brillo and tried to make just stuffing that in the pin for the arrestor, thinking that would work, and I had the jar going, and it was making all the gas and shit. I let it build up a little bit, and and then I had it going through the bubbler. I tried doing it without the fucking bubbler, man. So I don't know what would happen if I did it with the bubbler. But I went to light the motherfucker the second. I mean the very second I put the flame to the end of that the pin that was attached to the hose. That pickle jar said boom, so fucking loud, dude. It woke up my wife and the whole other side of the house and shit. And
holy shit.
But I went and I looked at it, I ran away for a second. I got my breath. I mean, it was loud, dude. But it wound up just blowing the top off. It didn't even break the pickle jar. It just blew the lid off of that thing.
That's good.
But
yeah, you're lucky then, dude, because that's what you're not really supposed to close those, because exactly the pressure that it creates is immense. And if it was obviously the top was weak enough for it to do that. Otherwise, the glass would have just busted up and a whole bunch of pieces, and that would not have been good.
Yeah. So the next thing I did was so I got an old storage tank. The little tanks that you fill up for mobile use, like you could fill it up with the air and then take it somewhere. In other words, there's no compressor on the tank. It fills up with air, and then you take it to wherever your truck or car is, and you pump, enough to pump up like one tire. Just a portable air tank, basically. So I hooked that to. I took the thing off. I took the nozzle off, and I tilted it to where the aluminum didn't mix right in with the hydrochloric acid. Well, I just call it muriatic acid. That's what we always call it. It's the same shit. But so I took the aluminum, a bunch of pieces, and I put them in the tank, and I had the tank sitting on an angle. So then I turned the tank the other angle, like I shook the aluminum to one side of it. So when I poured the muriatic acid in there, it didn't immediately hit the aluminum. You see what I'm saying? I had to, level it out. In other words, I just had it sitting on a couple bricks. One side sitting on bricks with the aluminum balanced up, and the aluminum balanced in the top piece. So I pour the muriatic acid in there, and then I hurry up and screw the hose back on, basically. The attachment that attaches to the hose. I screw that back on real quick before it gets hot and before I start wasting shit. And but I was wondering, because I didn't add I could have added way more aluminum, way more muriatic acid, but I didn't want to overdo the pressure, because I know them tanks are rated at about 110 psi, and I only got it up to about 50 psi. But by doing that, I could I used my attachment, one of my attachments, my compressor attachments, and I was just blowing up the balloons and shit, and they were lighting them on fire. But basically,
But don't you gotta add water to that?
No, I didn't add no water. No, you're talking about lye. You're talking about the powder shit.
Yeah.
I'm talking about the shit. I'm talking about the shit you buy at Home Depot. This like skips the middleman. This is basically hydrochloric acid. It's called muriatic acid in Home Depot.
Metals are you using again?
Yeah, so it's mixed together.
What
It's
metal
the
are
shit
you
we
using?
use to clean driveways with,
Yeah.
What metal were you guys using?
Aluminum.
Just
aluminum. Yeah, you can just use aluminum, like aluminum foil. Be careful, Demok. If you fuck around with this shit, be careful, man, because it really is. If you're not careful, it can be dangerous, and especially depending on what kind of lye you use. But don't do what he did the first time. Don't close. If you make this shit, just don't close it. Like don't put it in a bottle that you close.
Right,
Like,
let it
make sure
breathe.
the
Let it
gas has an
breathe.
outlet. Yeah, make sure. Like mine was going into hoses that went into a balloon. So like the pressure was filling up the balloon. But if you don't have anywhere for the pressure to go, then yeah, it's gonna make a nasty explosion.
And if you try to light it on fire and you don't have an arrestor, a good one, it will backfire. I don't know if it would still do that going through a bubbler, because that bubbler, that's one of the plus sides for a bubbler is
Hold on.
to stop
No, it
backfiring.
definitely will.
And, I guess it could still backfire to a certain extent even with the bubbler, but it would have to stop at the water. But I guess you could still get a backfire. But my dumbass tried lighting it just straight coming out of the jar. I just got impatient one night and it boom, bitch exploded.
No, it definitely will. I don't know about backfire, but yeah, hydrogen's extremely flammable. So definitely don't have any lighters or candles or just not even cigarettes, smoking a blunt nearby, any of that kind of stuff, because yeah, it's also a nasty explosion. I was originally going to do this. I don't know if you guys remember Soda. She lives here in Texas, Central Texas. We were actually going to do the experiment that I'm still going to do with these balloons. That's why I was making this hydrogen, but I decided not to use hydrogen. I ended up just buying helium. So I have 2 tanks of helium.
I think you cut
It's
out.
not that dangerous, Coach. When you go to light the bombs, when you go to, I'm real quick. When you go to light the balloons, you got to hold that lighter there for a couple seconds before you get it to react. It's got to melt through.
Dude,
But yeah, it is a little dangerous.
you weren't
but
using.
it
You weren't
ain't
using. You weren't using. Yeah, the hydrogen you got then wasn't. You said yours wasn't floating either. Like yeah, it wasn't pure hydrogen.
That's
then,
when
man.
I used the lye. That's when I used the lye and ran it through a big long hose. It could be that there was a
Hydrogen is
lot of air
extremely
already in that hose.
Sounds like you were
It could
creating
be
that
that there was
heavy gas,
already
Ryan.
air in the hose, and I blew it up the regular air,
You were creating heavy gas if it was like staying down, it wasn't going up.
I'm looking back, dude. It probably was all the air already in the hose. Maybe if I'd have kept doing it,
blocking it, and yeah.
Hydrogen is not the only. It's not the only reaction that you get. It's not the only thing that comes out of the reaction.
Anyway, when I use muriatic acid, it floats every time, dude. But and when I use the HHO, my pickle jar thing, it works. But tell me about your experiment, and I'll tell you about mine.
Well, no, the experiment that we're doing like a Alberuni test. So
oh, okay. Looking over.
She wanted to take a balloon up and just see the curve of the Earth, but I was like, okay, well that'll be part of the test, I guess. I wasn't even worried about that. I was just worried about doing a Alberuni test.
I bought 2 weather balloons, and I used my HHO generator thing, in the pickle jar, but it was floating. It was filling up this big ass fucking weather balloon, the size of fucking bigger than the hood of a car. But it was filling up, but it was so slow. I wasn't just gonna sit there and watch it. So I had a water hose running on the battery and running on the not the battery, but the leads to the pickle jar because the shit gets hot. So I just had water going on it, and I had it sitting in some water too, and going through the bubbler and all that. But I left and came back, and it was starting to fill up real slow. But it's a big ass lot of gas, but it was filling up.
Yeah,
go back and look a half an hour later. It done melted a fucking hole. It done melted a hole in the weather balloon.
That was always my problem. I did it so many times. Sorry, Mark. I just very quick. I did it so many times, and there was always issues with the apparatus. Not fucking it up. But eventually, I got it right. But it still takes so many. It takes so much work just to get a couple of balloons. So that's why I'm like, I'm just gonna fucking just do helium, just because it's.
Hey, listen, bro. Not with the fucking Muriatic. The Muriatic, all you just take you a fucking a plastic fucking bottle, a 2 liter even, and just hook you on a spout or you could really just put the balloon right over the fucking end of the 2 liter. It's hot, so you just wear some gloves. But I've done that. The first time I done it is I had an old plastic vodka bottle, and I put some aluminum at the bottom and poured on some muriatic acid. And just filled up a couple balloons just right there, just right.
Have you ever tried to use liquid nitrogen? Have you ever used liquid nitrogen to be like a medium, like a cork, like have like a container and a P-trap? In the P-trap, have like a section full with liquid, like so much liquid nitrogen, and then the heat has to travel through that. Would that help or no?
I mean, it would help. That's what I'm saying. But it would kind of contaminate your the hydrogen. But that's what I did basically. That's what I'm saying. I had the bottle go into a second chamber, and in that second chamber, it had to pass through ice water to leave. Yeah, and it leaves the top of that container, and it goes through a filter, and then into a hose, and then into the balloon.
Yeah, I was gonna say just take like a big cube of ice and actually have a cube of ice, pre-freeze your tube in a cube, and then connect your tube. It'll be in a cube of ice solid. That'll probably help.
Yeah, my problem that I kept coming up with is because mine was so complicated, and there was like different points where it was connecting. I had leaks. Even though I did so much to seal up all the pipes and everything, all the tubes, there was still always some leak somewhere. Like, any place where there could be a leak, it would always
there will be.
Yeah, and it like increases and like builds through it, and the shit will tear through it. The chemicals are just nasty.
You're almost making helium. I mean, once you get to a certain compression and a pressure, like 800, whatever, like that's like the byproduct. Like that's what it is. You know, they do it through so much compression and they cool it and they take the heavier shit and everything that's the top shit. It keeps getting pushed out, and that becomes the helium.
You say so, man. I'm telling you, in my understanding, the only two ways I know to make helium is the fission reaction, like where uranium is decaying, or a fusion reaction where two hydrogen atoms are fusing together. But I don't think you can get it from a chemical reaction.
That's what you're supposed to be doing with the HHO.
That'd be cool if you had a fusion reaction engine in your car, your exhaust would be helium.
That's what I'm telling you to spin it for, and you can use different things. You can probably use a magnet, maybe different liquids, different gases. What are those magnets that cool each other? Weren't there some magnets that cooled each other?
Magnets cool each other? I'm not sure.
Yeah, some like permanent magnets or some magnets that put off coldness. You never heard about that?
Peter, hey, Pete, real quick before we get off the subject, Peter and Pete told me to run my hydrogen through some nanocarbons or nanofibers, like carbon nanofibers, and you get helium. Or they said try it. Maybe I thought they said I'd get helium if I ran it through a bunch of carbon nanofibers.
If you did what? Say it again.
If I filtered the helium or the hydrogen that I got, if I filtered it through a bunch of nanopart, like carbon nanofibers or whatever you call them, carbon microfibers or some shit, like basically through carbon, like charcoal but they said carbon nanotubes or nanofilters or some shit, nanocarbons, carbon nanofibers.
And he told you to get what?
To run the hydrogen through the.
I don't know, but what do you say? What do you say the result would be?
I get helium. I get helium.
That's what I'm telling you.
Or unflammable hydrogen, if you will.
That's what I'm trying to fucking tell you.
I don't think that's true at all.
Any byproduct.
I don't have any of that what they're saying anyway, so I didn't never try it. But I'm not sure if they said it would work. They might have just been telling me to try it, like Devros or is what's your name again, bro?
Democ.
Democ. Yeah, like I'm saying it might have just been an idea, but I thought they were saying that's how you do it. Like telling me how to do it. But I don't want to stand firm on that. I want to give them a little out just in case they were saying to try it.
I wonder why that would even be. Why would that even? Why they would expect that to be happening?
I think any inert gas that rises is helium. Anything you can't light and it rises is helium.
That's kind of. Well, it's not really true. That's not absolutely true. But yeah, that helium is definitely an inert gas that rises. Yeah.
Your breath, helium.
No, dude.
In the wintertime, when it rises.
Yeah, your breath's not helium. It's just hot air. It's just warm air.
What's radiant energy do? Radiant energy from the source does what? Rises, and you can't light it.
Radiates?
radiant energy from anything, a cord, a plug-in, a Xbox. You can't light that on fire, but it's rising from the source at all times. Radiant energy is helium. The byproduct of anything that's inert and rises is helium. It's just certain amounts. It's certain amounts, like even your cigarette, that smoke that starts to go up before it curls open. It's a certain percentage of helium in that shit being offset. It's just so small of an amount because what you got to do to produce the byproduct of solid, a good amount of helium, like a certain percentage. Like say you want 1%, you're going to do this and see this effect. If you have 99%, which is pure helium, the actual all helium gas or what you call that, then yeah, it's going to do better.
So here's the process of how you get helium from natural gas.
I already know, man. They put it through a process of like 52 fucking things. They cool it,
No.
whatever.
Oh yeah, that's once the helium's already there. But I'm saying before the helium even exists, the uranium exists because it's an unstable element. It decays into that's the decay process right there.
I bump in for 1 second.
Byproduct of natural gas.
So what?
Helium
I
is
bump in for 1 second.
byproduct
Sorry.
of natural gas. What are you talking about, Coach?
Yeah, go for it, Ruhiv. Can you guys hear Ruhiv?
I heard him trying to say something again.
I was going to ask if Brian Leakey's there. He's in the voice chat.
Yeah, I'm here. I'm here.
Hey, you've seen both my videos?
I've seen one of them.
Oh, there's two.
And I agree. I agree with the. I looked at the Blackpool Tower and all that stuff, and I agree. I agree that your measurement is. I think yours is off a little bit, but maybe not. It's mine is not going all the way to the bottom because there's like a building that it runs into or blocking it. So that would take that measurement off. But I'll give you that. I'll give you that.
Okay.
But I told you that. I thought I told you that. But anyway,
No.
I would.
Can you redo yours?
I do want to. Yeah, I do want an explanation about the second part. My second point.
Yeah, that's
of
my second video. Anyway, we're interrupting a conversation. You can DM me on Discord and we'll sort it out.
Oh, you guys.
But you
guys
made a
are
video.
fine.
Okay, you made a video
I can't.
addressing.
I've locked myself in my bathroom. So,
Oh, my bad. Okay.
yeah, just DM me, Brian, and we'll sort it out. All right, see you guys.
All right, I'll do that.
We were done anyways, Demai. I mean, I was just. You said you already know because I was agreeing with you, Democ. Because natural gas is basically like a cocktail of gases that just happen to be down there. So they find a pocket of gases, and there's methane and fucking whatever else, helium. It's all in there, and then you're right. They cool them at different temperatures, which isolate each specific compound, into, just that. It isolates them so they can collect it and sell it and stuff like that. But I'm saying that's how the helium gets down there, because helium is, one of the lightest elements. So, you wouldn't really expect to find it on Earth, right? Because if it was on Earth, it would just go to the upper atmosphere. You wouldn't really find it down here,
Oh, that's why.
the lower
though.
atmosphere.
So,
Yeah,
right.
this is what I'm saying. That's why it exists
It
down there.
never
It's from the
stops.
radioactive decay.
Well, hold on. It never stops its rate of rise. So that's why you got to get it before it starts to go, because once it starts, you know what I mean? You can't catch it. So the radioactive decay of the lithium, uranium, what'd you say?
Uranium, yeah, for example.
The uranium, yeah. That just reminds me of radiant energy. That is inert. Sorry. It's an offset energy you can't light, but it's an energy that can still be used. It has potential. It's like the negative spent energy, the lightest amount, the one that's going to go away really quick.
It's funny you said lightest amount, because the three main types of radiation, the three main types would be the alpha decay, which is this helium nuclei, beta decay, which is an electron, which is a little bit lighter, and then gamma rays, which is light. But really, any light would be radiation as well, and
Right.
neutrons could be a product of the radiation. So it's just that's why stuff like uranium can be pretty nasty, because if you get shot with neutrons, they're going to destroy all the atoms in your body. But anyhow, I don't remember what we were talking about, but regardless, yeah, that's yeah. Helium's a cool shit, man. But
what about the cold? What do you think
What
they're
about
gonna mine? I mean, what do you think they're mining in like Antarctica, like in the coldest part that
Oh.
like barely go? Like, do you think there's solid helium there?
Solid helium. No, but I do think that they say on Jupiter might have metallic hydrogen. I'm wondering
That's
if
what I was getting at.
they would expect.
Metallic helium. That's my whole premise for this whole shit.
It'd be hard. I wonder, like something like a gas giant, if there's any shit like uranium there, like if there are pockets of solid uranium, like anything that would decay into helium. Because if there's nothing like that there, then you wouldn't even expect really any helium there.
Well, they say the moon is supposed to be helium-3 or 4. I mean, have you ever heard
Yeah,
that?
helium-3. Yeah, that's true.
So
That's
that
true.
would be
I don't really understand that. I don't
I don't
understand
either.
how
It'd be a solid helium we're looking at then. But I'm like,
is it
literally.
solid?
Well, I
That's a good
mean,
point.
I'm just saying, like in my mind, if helium is clear and you can't see it, and then you say, okay, that's helium, and then there's another source that's one up, like helium 1, 2, 3, whatever, right? You got helium-3. It just means a denser form of helium. Once you see helium-4, that's the actual.
I think helium-3 would be less. Well, it weighs less.
Yeah,
That's why
it'd be
than
like colder.
helium-4.
It'd be colder.
Oh, it wouldn't weigh less.
Colder, denser.
Yeah, it weighs less. Yeah.
No. It would have more material, but the more material has more of a potential buildup too. So
I'm saying it has less materials. What I'm saying. Helium-3 is less
I agree
material
with
than.
that. I think it'd be colder and denser, man. Like they cool down the helium-3. That's the shit they made that superfluid out of, and not just like a fucking nanoparticle of it, a whole bowl of it. And when they got it down to almost absolute zero,
they cooled it.
helium-3 turned
They
into.
cooled it though.
Yeah. They super cooled that shit, man. But it's super cold up there. No matter what model we're on, we agree it's cold as fuck up there. By the moon.
But when you looked at the helium and it was super cooled, it didn't look any gray. It didn't look like any moon. It didn't look like dirt. It didn't look like any solid substance, like solid, right?
Yeah, it's a lighter. It's a lighter isotope.
Right. So water, right, doesn't look like a solid, right? But once you freeze
But then it turned from a liquid. It turned from liquid to a crazy like substance. It wasn't even a gas. It would like drip through like a thick. It was
like a jelly.
The shit
Like
like in your
jelly.
propane tank, like it's gas, but you shake it around and it feels like liquid. It's almost like that, man.
Like a helium jelly.
Air.
Oh yeah, you're talking about superfluids, but that's just because they cooled it down.
Well, in space, the idea is that it would be that super fluid. It would become that. So if it's on the moon, is it like something clear we can't see on the outside of the moon? Is it the moon's atmosphere? Or would it be actually what we're looking at and the moon is this said thing called helium-4 or 3?
That's probably what made the lunar wave. That's probably what caused the lunar wave was the superfluid.
I don't think space is cold enough for superfluid helium. What I'm saying.
Bullshit. The Go Fast rockets had gauges, real gauges, not ones you see, not the cheap ones they're sending up on the balloons that break down and fuck up at about -70, and then they start doing bullshit. I'm talking about they had real gauges on the Go Fast rockets. I mean on the Soundly rockets from Germany, and they showed it fucking once you got up to about 60 miles, 70 miles, it was negative fucking. It's like right there, almost at absolute zero. Like just a degree
That's what
over.
I'm asking. If it can get to absolute zero, anything you put up there with any energy, it's going to get pulled from that object direct, like automatically.
It can't get to absolute zero. It gets to like -3. It gets about -3. I'm sorry. It gets to about 2.7 above absolute zero, and I think it says superfluid helium. It has to get as cold as almost 2 degrees after above absolute zero. So it's slightly colder than our space.
Is a theoretical
So
number,
if
bro.
it's colder than
There's
what
no
you
such
need
thing as
for
absolute
helium.
zero.
Well, if it's colder than what you need for helium, then hydrogen, helium, and nitrogen must be up there, and a little bit of argon.
I did a
Why
whole
says
video
there's
on that. I did a whole video on that, like how hydrogen and helium rise, and I showed the temperature that gauges on the rockets show them at -472 or -272 Celsius, and I showed how the ripples were created from some of the fucking SpaceX rockets, and they're like skipping off something. It looked like they're skipping off, trying to get into some kind of layer, and they're skipping off of it. I think it's called something about ether. So I made it a while back, but I showed all that stuff, man. I've got a lot of it from the Spanish guy from Globebusters.
Ripple of sound. They're using sound. When you
Why do you say
when
absolute?
I was just gonna say, when you play a certain sound that's like supersonic or whatever you want to call it at a distance in the air, you might just see some waves or ripples. Think about it.
Could be, man, but I was thinking along the lines of I was thinking even if they could get into that stuff, instead of skipping off of it and shit and creating that fucking light plume looking thing, that super glowing looking plume, if they could get into that stuff, and they just heat up the end of you wouldn't even need rockets to thrust. If they were in the superfluid, it'd be like putting water on a hot fire hot frying pan, how it just spit off like and the water shoots off. If you heated up something, it'd blast you fucking through. You could probably reach some crazy high speeds with very little energy.
And this HHO shit gets super, super hot.
But I'm just kind of going off in the realms of speculation with a little bit of evidence. Like I said, we do know helium is what's up there, and hydrogen and shit, and we've seen the gauges showing how cold it is. We see what happens to helium when it hits that temperature, and then we've seen the fucking ripples created by them rockets in a few different videos.
I don't see anything keeping its heat up there. I don't understand how it could.
So I was looking into the helium-3 on the moon. So supposedly, it's because it is kind of. First of all, it's useful because it would create cleaner fusion than even using like the what do you call it, like tritium or deuterium or whatever. But on the moon, it gets there supposedly by solar winds. So it's like cosmic.
So you're telling me I've been screaming about hydrium and helium, and nobody's been using helium with a centrifuge or hydrogen mixed with helium to a certain percentage. We need to do
What are you even saying, man? When you say solar wind, what the fuck is solar wind in a heliocentric model? You don't got
radiant
wind.
energy.
Okay?
Radiant energy that you can resist.
It's material from the sun. No, the sun obviously gives us electromagnetic radiation.
Exactly.
But also the sun can it doesn't just radiate just electromagnetic radiation. Some of it's material from the sun itself, like in the form of, I guess, helium-3, electrons, plasma, that kind of stuff. And also it can shoot this shit at us. Like that's what a solar flare basically is. It's like a solar flare is not just electromagnetic
Get up
radiation.
closer to the sun, it don't get hotter, bud. I'm just telling you in reality. I'm trying to pull you out of your model. The higher you get, the colder it gets, and you're not going to get any heat from the sun like that. It's a focal point. You're going to get it's going to be the hottest below sea level. Like what's Death Valley is the hottest temperature ever recorded. It's like way below fucking sea level. It's a focal point, bro. It's not what they're telling you it is, man.
But that's just on Earth. Like that's because we have gases. If you were in a I don't know, like a perfectly sealed greenhouse, that was you know, it'd have to be a really sunny day, I guess, because the coldness of the outside is gonna. So it'd have to be perfectly sealed. But regardless, if it were perfectly sealed, the sunlight would be able to heat the gases inside of your greenhouse, and only the gases in there are going to be warm. And when you leave the greenhouse, it'll be cold again because it's cold. But that's like with the atmospheres. The atmosphere is just basically a greenhouse that retains the heat from the sun. But there's nothing like that.
Yeah,
When
you ever
you
thought
leave
it's funny that look, kosher, the closer you get to the sun, you know, in reality, the higher you go, the colder it gets. And we've seen instrumentation that shows this. There might be a couple exceptions, but in general, the higher we go, the colder we're going to get. And then the further away from the sun you go, start digging in the ground, and it says in the heliocentric model, you get hotter. So you go away from the sun, you get hotter. You go toward the sun, you get colder. Everything about the fucking model seems backwards, dude. Just
you're
against intuition.
you're talking about going into space, and you're talking about convective heat, which can only be felt whenever you're measuring the temperature. You're not measuring the temperature from this, like here on Earth. You're not measuring the temperature of the energy coming from the sun. You're measuring the temperature of the air around you. If there's no air around you, you got nothing to measure. You gotta
So
measure.
the heat's got to transfer. Yeah. So the heat's got to transfer. So if the core of the Earth is hotter than the sun, where is all that heat going? It's got to go up
It's not
through the
hotter than the
ground
sun.
to dissipate. It's
You can
got
still
to go
be. You're
somewhere.
gonna get if you have a tank of water, and you have that tank of water inside of a vacuum. Let's just say, so you have two tanks, I guess, for some fucking reason. Anyway, and you have that here on Earth. You also do the same tank of water somewhere close as you get closer to the sun. That tank of water is going to be receiving more energy as you get closer. So it's not going to, and you'd be able to measure this. It's not hotter because we're further from the sun. It's just because we're in the atmosphere. We're retaining the heat.
Right, which leads me to tell you, like, how is there a heat in space? It has to be cold.
Because convective heat is not the only type of heat that you can receive. You can receive radiative heat, which is the heat that the atmosphere receives from the sun. So the radiative heat travels from the sun into the atmosphere and then heats up the atmosphere, which then transfers that heat convectively with everything it comes in contact with.
So you get your cake and you get to eat it too. In other words,
I mean, there's, I guess.
look at
I mean,
them
those are
super
two different.
thermoses they
Those
make,
are
man.
those.
They put a little vacuum, little air-filled vacuum layer on them super thermoses, man, and they keep shit cold forever, dude. Just from that little tiny vacuum wall, you know. And
That's what I'm
but
saying. It's not cooling anything. It's just keeping things cool because the heat doesn't have anywhere to escape to. Or
yeah, it's keeping the heat. It's keeping the heat from getting in there.
Yeah.
The vacuum is preventing the heat from heating up your shit inside of it. So that vacuum, you're talking about all this radiative shit, and then they tell you they tell you so much bullshit. They tell you the coldest place in the universe is fucking like on Mercury during the shadow. They tell you it's fucking crap, dude.
Actually, the coldest place in the universe was created here on Earth. I think with the laser cooling. This laser cooling thing. They said it was the coldest place in the universe, assumptively. But regardless, you're saying, yeah, the thermos that you're talking about. That's what I'm talking about. If you have a thermos here on Earth, and the only type of heat that you're able to transfer to it is convective, then it's not going to receive that heat because if there's a vacuum in between the inside and outside of the thermos, there's no way to introduce that heat unless you had radiative heat, which it could transfer into that thermos. But usually you're not dealing with radiative heat. The sun light does radiative heat. microwaves, things like that. But the air is, you're not going to heat it up just by being in a hot place.
Did they tell you like 60 miles up? There's a fucking where they combine the lasers. They got to go up real high. They try to combine the lasers down lower. Don't work. You know, they got to combine these fucking industrial lasers at like 60 miles because there's a sodium layer. Well, how the fuck is there a layer of sodium 60 miles up, dude? It's just a bunch of fucking horse shit, dude. There might be something up there, but it ain't fucking salt.
Sodium's not salt, not by itself at least. But
I'm just saying, man. You know what I'm saying?
I've never heard this
being
before.
a smart ass.
But there's a sodium layer. I never heard of this before.
The artificial stars, man. They fucking they shoot them and they combine them. They cross the paths at a sodium layer that's 60. I mean, they say there's a fucking. I think of all their claims. They claim there's a ionosphere. What the fuck is an ion? How do you have a place up there where an ion is still a charged particle from something, man? So you're just telling me that there's charged nothing up there? There's got to be a charged fucking vacuum. I mean, all the shit they say is just for your mind, bro. It's to keep your
charge
fucking
these
mind
nuts. Listen,
down there. You ain't
charge
discovering
these nuts.
shit yourself.
Charge these nuts. They got the ISS out there in this fucking make-believe fantasy land where it's beyond the melting point of the materials that it's made out of. Okay? I don't want to hear bullshit about radiative heat. Listen, I leave for 5 minutes. You're letting Kosho ramble about nonsense. Come on, guys. Get it together.
Well, Jeremy, you gotta learn the difference between heat and temperature, because at temperature, that's something's melting point. Some metal exists at. If it's only receiving energy, radio. What I say?
Yeah, did we say it was 2,500 or 4,000 degrees up there? Well, we didn't mean it was 4,000 degrees heat. We meant that it's 4,000 degrees fucking not heat. Dude, it's just one of their fucking excuses when they get called out when technology catches up to them and people can get up that high and prove their fucking crap wrong, dude. They come up with horse shit fucking answers.
Check this out, man. Let's say I'm gonna use a number that I'm not 100% sure is the actual number, but it's just because I don't have time to look it up. But let's just say a cubic centimeter of air has 1 trillion particles in it. Okay, down here at sea level, and let's say up where you're talking about in the ionosphere, a cubic centimeter has exactly 1 particle of whatever gas is up there. The temperature of each of those, the average temperature for each of those are going to behave completely different, because the average temperature, if the average temperature at sea level of a cubic centimeter of air is, I don't know, 90 degrees, then that's the average temperature of all those gases. If the average temperature of all those gases added together, so if the average temperature of some one gas molecule is whatever they say, like 4,000 degrees at in the ionosphere, that's that one molecule. So if you come in contact with that one molecule, the amount of energy that it's going to transfer to you is not going to do anything compared to the trillions of particles that all have an average temperature of 90 degrees. You know what I mean? That means that you add all those together. You add all that together, that's the energy that it can transfer to you.
In my opinion, air stretches. I don't believe in that gas particle theory shit, man. I believe air stretches. I believe air compresses and stretches. It doesn't necessarily have to be individual particles. I believe it's like a fabric. It's a fucking medium. It's but I don't know, man. It's still, to me, it's them saying it's hot.
It's the fabric of gas time.
Yeah, not a fabric. That was a stupid fucking example, but it's like a material.
Wait.
Just fucking,
then how do you think electrolysis works then?
Hold on, Coach. Let me ask you this: Can two objects occupy the same space at the same time?
No, it's a Pauli exclusion principle.
So there's like some rule where that says that can't happen, right?
Well, the Pauli exclusion principle says 2 quantum particles can't share the same quantum property, and position would be one of those properties. Yeah.
Or is there anything that mentions two objects sharing the same space at the same time? I don't know what you're saying with this fucking
You're
quantum.
saying not allowing to, or
Either way, can
because
two
Pauli's
objects?
principle says not allowed to.
So this thing says that two objects can't share the same space at the same time.
Yes.
Okay. Light. We got a real fucking problem with this light thing. All right.
Particle wave.
Light's not a material, man.
They don't classify light as a particle that has mass.
It's not a material. It does not have mass.
Waves, particles.
So this thing that has no mass can influence things. No, bro, it has to have mass. It's considered a particle.
Yeah, no, I know. But the light is light is the energy transfer between electrons. So when a light enters an object, or when it's absorbed by an object, it's really being absorbed by the electron, and that's present in the fact that the electron has more energy now.
Yeah, they call them massless particles. They call them photons massless particles.
Yeah, but it's rest mass.
It's another trick.
Yeah,
It's another trick. It's
if
another
you have
trick
electricity,
for them to call it a particle, make it follow fucking particle laws and shit, but not be a fucking particle. It's just another trick.
Is a light a particle, Kosho, that has mass or what?
I think somebody had said at one point it has relativistic mass, but I would say no, it doesn't have mass. But I'd say it is a particle. Photon is a particle, or it's got properties.
With no mass.
It's got properties of a particle and no mass. Yeah.
it burns you. It burns you. It's electrical continuity. It can be focused. What do you mean?
It's energy.
Right. And if you can focus something, it has to be a mass of something. If you can do stuff with it and have a design with it.
So light can't occupy the same space at the same time, you're saying? Coach?
The light can occupy the same space at the same time?
Yep, two light particles, whatever. When we're looking at something, okay, listen, picture this. There's a rectangle. Perfect rectangle. I'm looking at an object diagonal from me. You're in one corner looking at another object diagonal. We're on the same side. The objects are on the other side. In the middle, our eye lines are going to cross. Like there's light coming off the object I'm looking at coming to me, and then there's light coming off your object going to you. In the middle, right there's going to be an X, right? You could draw X in the middle of this.
I see what you're getting at. Yeah.
There's going to be a place where there needs to be your light particle sending your information going to you, and my particle coming to me, and they need to occupy the same space at the same time.
If y'all both looked at it at the same time, it'd make a hole in the universe.
Exactly. I mean, whenever like I'm imagining it like with sound waves, because they propagate in a wave like nature, and the way that sound propagates, if that was happening, or even like a water, if we're in a pool in two corners. Yeah, I don't know. I mean,
they wouldn't take up the same space. They'd interfere.
Yeah,
sound, light, and water can be all traveling through at the same time. You can have light and sound traveling through water at the same time, like directed towards each other.
I don't know, Jeremy. I'm not exactly clear what how that works.
Yeah,
if they're talking about the particle thing, if it just can't do it in the quantum space of particle, I don't know. I mean, that's just imaginary shit. I mean, you can fill a glass, right? A glass is taking up a space in reality on my table. It's empty, and I can fill it with liquid and then shine a light in that. So that's 3 objects in one space.
To be honest with you, I'm not 100% sure on the Pauli exclusion principle how it works with light. I think it works the same way, but when I think about photons, I don't really think about them. They don't travel through space like particles. They propagate. The energy's propagating like a wave. So, I just don't know really.
Then I could sprinkle salt in the water.
Then I
So
can
according
bubble a
to
little weed smoke up through that water and make it a bong. We can actually find the same place for the
according to
live stream.
quantum theory, like if there was light crossing, but Kosho wasn't looking at his light, you were looking at yours. Kosho's light that was coming that he was supposed to look at but didn't would still be a wave, and then the light you're looking at from the other corner would be particles. I mean, who believes that horse shit?
Nah, that
That's
particle
not
light.
that's not how it works, man.
Listen, that double slit is just dog shit. It's just miscomprehension, just like everything else they have for a globe that doesn't exist.
Yeah. Anytime I do it in real life with pencil leads or razor blades and little hand lasers, you get interference patterns. I don't know what, and I'm observing it, and it's still a fucking interference pattern. I don't know what they're talking about with the two lines that it's supposed to create when you observe it or know which slit it went through. I guess I'm not knowing what slit it went through, but to me that's all theoretical mathematical shit.
The double slit experiment with the light was showing that it propagates like a wave. Like you get the interference power because it's wave-like property. I think you're thinking about the
No.
double
It's either
slit experiment with
either the
electrons.
quantum eraser or the double slit. No, look, listen, Coach. If you know what slit the supposed photon went through, then it acted like a particle. So they're saying that it's a particle. So you could fire one photon at a time, and observe which slit it went through, and it'll wind up making just two lines through the two slits, right? But if you don't know, like if I'm just shining my laser through the pencil leads, and you don't know which slit it went through in between the pencil leads or the razor blades, then you get an interference pattern showing a wave. But I don't believe they could fire one fucking photon at a time. And also, I don't believe. I think it's all mathematical, man.
Light always. I think you're thinking about the one with the electron, because the light always propagates like a wave. It's never. Yeah, it's never gonna. You're not gonna be able to fire one photon and let it hit on the other side like a. They can't do that. But
there's a story they tell us. Here's the implication.
Yeah,
The
but I think
implications
you're mixing up with the electron story, because the electrons, you would expect them to be a particle, and so it would hit, wherever, depending on which one it came out of. But yeah, they're saying when they didn't have detectors, or when they didn't have something, basically it's not interacting with anything before it hits the other side. There's no what am I trying to say? So if it interacts, the least interactions it has, so if it doesn't, then it'll keep its like a wave-like uncertainty, and can interfere with each other and all that kind of stuff. But because you have to actually interact with it to even see it, like you have to point a light at it or whatever kind of mechanism you're using to determine how it's going through which slit that interacts with it, and when you do that, it immediately starts behaving like a particle. Like it immediately, the wave function collapses, how they call it. But as for a photon, I'm pretty sure it's always understood. It's always traveling like a wave. I don't think it ever travels like a particle.
To the quantum eraser, in the double slit, they when you observe, if you observe the particles, if you observe which path it took, they basically forced the path of the quantum eraser, and by knowing which path it went, it made one spot. There's no interference, there's no diffraction pattern. By not knowing which path it took, then it had the possibility of taking either fucking path. So it had a wave like, but I think that's mathematical, because the implications of that are that light not observed is fucking, it's almost like telling us we're in a simulation, like light not observed can be whatever. And as soon as you observe it, then it's something definite. But the fact of the matter is in both the experience, they have to be able to fire individual photons. Okay, the electrons are like thousands of times magnification bigger than photons. They're supposed to be even like small, even super fucking small. And so what do they do? They're basically just making a tiny little flash of light, calling it one fucking photon. I mean, it's just think
I
about
don't
it.
think
I think
they,
we're giving them too
don't.
much
I
credit.
don't
We're
think
giving
they
too
do
much credit for
anything.
point.
I don't think they do. I don't think they do anything at all where they say they have a one photon.
Well, they claim that. They claim that they're at the universities. These fucking machines, they could fire a fucking photon. You know, that's what the claim I've heard over and over. Never
I'm
seen it.
driving right
It's
now, so
university.
will you check for me? I'm pretty sure the delay choice quantum eraser was with an electron, but I'm trying to see. Hold on.
Yeah, no, buckyball. They did it with as big as a fucking buckyball. That's still theoretical shit. I mean, show me a fucking electron. I mean, it's not a thing. It's a fucking model. You know, it's not an actual thing. I don't think. I don't. You know, you can't show me a fucking electron.
Okay, hold on 1 second. I'm about to be pulling off the road, so I can take a look.
And you'll be looking for days. I look for hours, dude, trying to find an example
No,
of
I'm
it.
just trying to
And
see. I'm just trying to see if it's if they did that with photons or electrons or whatever you
yeah, they've supposedly done it with something as big as a buckyball. I think a buckyball is detectable. Like it's not on the realms of theoretical fucking shit with like photons and I think buckyball they did it and they're like orders of magnitude something we can actually but that's as big as they've done anything with. But that's still way magnitude bigger than photons or electrons. But so that's all you're gonna find when you pull over, just so you know.
I think actually the late choice I think was with photons, but that's what I'm trying to read. So hold on, give me a second.
It's all a mathematical construct, man. It's all that shit is, man. And it come in handy, you know, the electron come in super handy and all that. You know, that's how they pretty much get your voltmeter from the concept and the model of the electron. Yeah. But it's not 100% accurate, man. And then they'll just come up with a variable to try and explain it. But as far as all that, it's not all scalable, it's not all accurate. There are a lot of things they don't understand. You know, people give them too much credit. It's just you know, just effects. Certain things they do, they can replicate. If they do it the same exact way, they get the same exact result over and over without fail. So they can use these concepts to you know to in technology to make shit. You know, and then but they invent the shit first, then they make up the models and the theories, and then they start toning in the variables and modifying the model. But it all comes from real life first, inventions, shit that actually happens, man. They act like they're figuring all this stuff out from like even the latest MRI where a dude improved it, saved tens of thousands of lives. Who says we need to apply the same concept to the sun to prove that it's not a gas. You can't get full spectrum, continuous spectrum from any gas, much less fucking hydrogen and hydrogen fusion. You know, he's showing that if anything, it could be graphite or a liquid. Trying to figure out what the sun actually is. It's some kind of transformer. And but but basically just giving these people too much credit. You know, so he supposedly broke the physics. Physics said that the amount of X-rays it put off would kill a motherfucker, and he showed them flat out. Their math is fucking wrong. Their physics is wrong, and he made the shit, invented it. It saved hundreds of thousands of lives, and now they just rewrite the math. They add a variable, rewrite the math. You know, but that's how the real world works. It's not motherfuckers sitting down in offices with paper and saying, "Hey, this math checks out the fucking that we could build this." That's not how it works. They can modify shit, make shit better that they've already fucking made, and make shit more efficient and all that. But it's not real world. They're giving these pencil pushers, these mathematicians, too much credit. You know, they get the credit for making shit efficient. But they're not the ones inventing nothing. No inventions come from pencil and paper. The only one I've heard that come from pencil and paper is, hey, we did the math, and according to fucking Kepler's fucking there. You know, there should be something right here making this thing wobble. And they open their eyes and look, hey, there's fucking Neptune. Look, there was a planet there. We just never opened our eyes. As soon as we did the math told us to open our eyes and we'd see it. Stupid shit, dude. What kind of fucking story? Who would believe that? Who
We all
would
believe
fucking
it.
write
Times.
down
That
believe that?
happened three times actually.
It happens every day, Kosho.
Well, no, I mean, it
I got a
happened.
bridge to show you, bro. People are so fucking naive. It's sickening, bro.
Just hold on 1 second. No, I'm saying it happened with Newton's law. They used and they saw perturbation or some wobbling, or whatever, and sure enough, they ended up finding something they didn't know was there based only on Newton's law and that wobble. But that's happened 2 other times where.
Prove
Go
it,
ahead.
Kosho. Prove any of them stories.
Prove it.
to
That's
me.
how Neptune was found.
Yeah, just
I mean,
prove that Neptune's even anything at all. Prove it ain't plasma. Prove the size of it. You're gonna have to say they.
Even if it was
Tell me
plasma, it
stories,
would still
bro.
be an object.
It could be ionized fucking gas turning into
could be.
plasma. It's a star in a jar. It's got its own light. You know, it's not reflecting the fucking sun. Look at Jupiter. Look at Saturn. Saturn's so bright it looks artificial. Doesn't look like
That's the point,
they
though.
show us. I just seen it last night through my P1000, and it's bright as fuck, dude. You're not telling me that sunlight's
That's
reflecting off them rings just as
Dude,
the
you're making
exact
way
same
too many
bright.
points at once, dude,
Hold
and
up.
it's in the middle of me
Let
trying to
him
finish my
respond.
point.
Yeah, let him respond.
Yeah,
You're making like 5,000 points. I can't respond to all of them, dude. But fuck. Right. So the point is though that when you can find an object that you didn't know was there, based on this law of gravitation, you know, if it wasn't true, then you wouldn't have been able to find that object or find that. It doesn't matter if it's plasma, star in a jar, or whatever it is. The fact that you're able to know that it's going to be there based only on an error in you know, some other orbit somewhere else. So you say, well, there's either an error in this equation or there's got to be an object up there, and they found an object up there. So, you know, it shows you that
That's how they're telling us there's new planets, bro. They're telling people there's new planets around this star because we've seen a certain twinkle or wobble in the fucking star. So that's how we know there's a planet, and it's a little bit different than this other twinkle in this other star. So we know there's planets. They're not seeing these planets, bro. It's an illusion. It's people believing in crap, dude. Even when you talk to the astrophysics, what you call it, wakey, pin one down, and asked her about all that stuff, and she's saying, you know, that's just theoretical stuff. You know, she admitted to him, and she didn't know she was being recorded, and she's a pretty famous astrophysicist, and she admitted right there, it's just
You're not being specific, man.
Images they get back are splotches on paper.
Yeah, first of all, I know what how they find that specific way to find exoplanets is different than what Chronic does. But what are you saying? She said it was theoretical. She says it's theoretical.
All of it.
She used that
All
word.
of it. Yeah.
No, it's all. What do you mean
There's
all
no,
of it?
There's no way to prove any of that shit.
I know, but you're not being specific. Are you talking about the
He asked
exoplanets?
her.
Or what
He
did
asked
she say
her
was theoretical?
if they had images of these like galaxy stuff like that, and before that, and he was talking about the artist, you know, how they touch them up and everything, and say how they think it looks. She said yes, it's all splotches on fucking, you know, the images they get back are just splotches of light. She said it's all theoretical shit. She just kind of laughed and agreed with him that it's just a fucking story, basically. That's my words. But
You are being
it's all
specific, but
theoretical.
you're talking about the artist renditions of those exoplanets. Like they show us pictures of planets, and it's like all this like looks like, you know, fantasy type planets or whatever. But in reality, the only evidence of these planets are the light and the frequency that the light is dimming and that kind of stuff. That's true. Those are theoretical. You weren't being clear. What you're saying was theoretical. Yeah, those artist renditions, those drawings are completely theoretical. They're not really based on. I wouldn't even call them theoretical. They're you know, there's assumptive, I guess. But it's not an assumption that those are planets. Like they
tell these stories like it's fact, Kosho.
They tell these
That's what I'm saying.
stories in the
I'm saying
magazine.
that's not the assumption. The assumption is what they look like. But the fact that they're, the masses and the fact that they're planets orbiting these stars, that's not really an assumption, because that's why they don't just make those
It is,
claims.
dude. The
based on a
assumption
hunch.
that Venus is the same side of Earth is a bullshit assumption. Venus is not the same size as Earth, and they based their whole system around that fact. Before they had radar, before they had fucking spectrometry, all this other shit, before they had rockets, and then after they had the whole model already constructed of the solar system and working throughout the galaxies and all that, and done figured out, trying to figure out the retrogrades, then they come up with the technology. They're like, oh look, Venus is the same size. So if Venus was only 1 mile wide, then that means everything that they're looking at scale wise is 8,000 times smaller, and then every distance in between them working its way out is exponentially smaller, and then that means we don't know what fucking galaxies are or any of these other shit, much less claiming we live inside one. It's all theoretical, because you can't prove
You have
that
to
Venus
understand.
is not ionized gas.
You keep cutting me off to say these points, but then you make long points, man. But the Venus thing. So the thing is, they understood the ratios of all the planets and the sun and all that stuff. They just didn't know the exact. They knew the relationship between them. They just didn't know what the astronomical unit was. So it's like they have all the distances from each other. I mean, all the ratios of the distances from each other, but not really the exact distances from each other. Not until they have the astronomical unit, which they got from assuming the size of Venus. But even just knowing the ratio of the distances of all these objects, you still have an idea based on, how far they're moving around, like, how far Venus's orbit has to be and how far
It's a mathematical
Mercury's.
construct. It's a mathematical
Well, no,
construct.
but I mean, they still are able to get a pretty close estimate. And plus, they already had an estimate for the distance. They already had an estimate for the astronomical unit at that time. So,
Right, it's a mathematical model all based on inverse square law and the relationships, the corresponding distances between them and all that. It's all a mathematical model. And then if something doesn't fit, then they give it a variable. They say, oh well, this is actually retrograde or some shit like. I mean, it's a mathematical model that's built on core assumptions that we will never be able to prove. You could say they have that, but you'll never be able to show me any of that or prove it. It's just
but
a story, man.
what four assumptions are you talking about?
The assumption that they know what planets are, the assumption that they know the distances. They don't even know what they are, man. They're a mystery. They can claim all the shit they want, that comes out of their model. It's nothing more than a model. Promise you.
Those assumptions that you just said wouldn't really be assumptions if we sent craft to all of those planets. I'm not sure if you sent anything to Mercury, but
You said we. Show me the footage of that craft.
human
No
beings,
craft.
me,
Okay,
you, and
go
the
look
rest
at
of
a
the humans.
rocket. Go look at a rocket. They go up about, I'll give you 15 miles. I'll give you 20 miles. They probably go up about 10, 12 miles. Okay. They hook over real quick. And some of them come up the coast right here where I'm at, about 100, a little over 100 miles
Have
north
you
of Kennedy.
Have you ever
They're
observed
not.
the exhaust coming out of a rocket?
Yeah. Have you ever seen the exhaust coming out of an airplane? It's fucking phenomenal, dude. Out of a jet plane. Same
Yeah,
shit.
the exhaust coming out of a rocket, because it's raising altitude, it starts to dissipate more and more and more and more in a wider volume of space behind it, because the atmosphere is getting thinner and thinner and thinner. So if the exhaust is dissipating more and more and more the entire time you see it, doing an arc, whatever you claim it's doing, that tells you that it's raising altitude that entire time.
If I'm looking at it from exactly a side angle and it's not going up and it's not going higher. So in other words, it's getting closer to me. I'm looking at it come from the south, going up the coast, and I'm a little bit actually northeast. So that's the same path it's taken as the northeast passed. Okay. up the coast, and off into the Atlantic. Okay, so I got an orthographic view of that rocket, and I filmed it twice. And so when it gets closer to me, it's got to cross my path. It should be coming up to the point that it gets as close as to me that it can. And then as it starts to go away from me, it should start going down. But as it's getting closest point to me, it's already leveled off. It's not getting any higher. It's not really getting
How
any
do you know?
lower at that point, but it's not getting
Did you
any
check
higher
the
either.
exhaust? Did you check the exhaust as it was doing that?
I seen the exhaust, man, and I mean, you zoom in and shit. It's booking, dude. It's booking. But then I looked at the exhaust of a jet, and it's doing the same thing. But I agree, it could be higher. Like I said, I'll give you 20 miles. It could be higher than the planes are going, but it certainly doesn't appear to be. But it's possible.
The exhaust,
Up there in
the,
thin air,
the exhaust
I don't
actually
doubt
does
that.
the same thing. Yeah, the exhaust
What
coming out of
was
the
that?
jet.
I lost you.
I said the exhaust in
It's
a jet
booking.
doesn't do the same thing.
It's booking, bro. The exhaust coming out of a jet's booking, but it's a little
Yeah, it's
different
booking.
in the air. I agree with you there, and I will say, man, it's spectacular seeing it's a light show, man. It's crazy cool to look at and film. There's something
Man,
up there. It's getting it, but it's
I
just
gotta
not
run,
moving
man.
across the
But
sky. And you pass it with a
I'm
plane
telling
because
you,
it's not. It's got to move across the
I gotta
sky,
go.
and it's just not going much faster than an airplane.
Yeah, it doesn't matter how fast it's going. I'm telling you, the exhaust is widening. It starts off in a thin column, and that column gets wider and wider and wider to the point to where it's coming out of it. It's not even coming out in a column anymore. It's coming out in a wall almost. And that's only happening because it's going in thinner and thinner atmosphere. But
Okay, go look at a couple of options again. Look at some different ones, and it doesn't change
I
really
have
until it changes stage. Once the stage changes, that thing falls down, and then it cuts it back on, and then you got the big plume. It's not like it just gradually goes from small to big. It changes stage and goes immediately from small plume to big ass giant plume. If my memory serves me right, anyway. But like I said, it's crossing the sky. It's going from the same way I see planes. It could even be going a little faster. It doesn't seem to be. It's coming up the coast. By the time it gets here, it should be going pretty fast. I need to time it though before I make any more claims. I need to time it from exactly when it launches. I've never corresponded the launch from TV and then timed it, because then I could tell you. I could look exactly east, and I could tell you exactly how far it's basically traveled and how long it took to get there. It seems like it was about 10 minutes, which is getting it. But that's not much faster than a plane. But I don't want to make any definite claims until I actually time it.
I think it should be funny too if they took some. I mean, not on that point, but if they took some like objects and acted like the object was the light bending, and like took like a boat or a car or anything, and just like made like a design of an arc with it and like brought it to you. Like, look, light's bending this to you. Here's your little boat coming to you in an arc.
Dude, that's funny. I was gonna make a little meme with I got a P1000, and the fucking scope thing, it zooms out. It pops out of the camera and it sticks out pretty fucking far. I was gonna take a little tube at the end of that and extend the scope just for visual, and bend it downward and take a picture of me, and my wife is in my arms, and we both got the camera. We're looking out in front of us, and we're seeing the back of our own asses. And you look at the zoom, and the zoom's curving down because of the way they said that you'd be able to see your own ass to a telescope if it was strong enough and the atmosphere was clear enough. I was gonna show a meme saying, "Yeah, here's your own ass to a telescope." Where we're looking out in front of us with a curved ass fucking zoom telescope looking zoom, like on Pirates of the Caribbean when he stuck out that eyepiece, and Jack Sparrow got the longer one, and the bitch was so long it was bending and shit. I was gonna make a meme with my camera and show we'll be looking through the visual part of the camera, the display, and seeing the back of our own asses. Bendy light.
Jeremy, you still here?
What's
Just
up,
saying,
Don?
which part? I don't think he's here yet for a minute. Which
I'm
I
here.
part?
think I heard him. I
Oh,
think
there
I
he
heard
is.
you. What's up?
Am
What
I
did you ever get the mainstream conclusion on the steel rods of light or whatever? The cross, the everywhere interference. What did
That
they
wouldn't
ever
work.
settle on that, man?
So
Want my
there would be
opinion? That wouldn't
interference.
work.
Listen, oh my bad. Go ahead, Demon.
Oh,
You're
my
in a rush.
opinion is it wouldn't work. I'm not trying to be goofy or nothing, but I think
Yeah.
what they would do, if I was a glober, what I would do is take any source you guys wanted to do, put it underwater, and be like, look, there you go. That's how it's going to react. There's my calculation. There you go, globe. See what I'm saying? They're
Yeah.
just going
Yeah.
to do
Good point. Good point. I don't even know what you just said. Don. Fuck. What did you ask again? I forgot. That was a good.
Remember about the interference patterns? What did Ruhif
Yeah.
say you were gonna?
Listen, Rohit doesn't know what he's talking about. If these interference patterns were happening, they'd be happening all over the fucking place. Constantly, there's infinite light rays bouncing off of everything. Don, do you know how many fucking angles you got light coming at each other in infinite ways and shit? Like this ray of light thing is bullshit.
But the thing is, I can't recall this episode of PBS Space Time. But it's like I know there's one where they have like a fucking specific, like they've talked about this specific thing, right? About them all hitting each other and all that. They fucking talked about it. So I didn't know if like Kosho came in with it or somebody in here figured out the official narrative. Because you're right. I mean, it's a cool point that you're bringing up. I never thought about it like the steel rods. Like I see a laser beam looking like a rod, but I just thought it was very quickly shot particles with
That's the only way they can even.
tiny spaces.
Yeah, that's the only way they can even make and when they get a heavy interference pattern, they can make it so that this laser beam will apparently bend. It's not actually bending, but it looks like it's bending optically.
Right.
So, and they can only do this in a laser beam. That's the only way they can even make anything happen with this. So, like for Ruhif to say there's interference happening over and it's canceling, that's fucking ridiculous. That's not even. I don't know where these guys get this shit from. Listen, Ruhif's just. I don't want to. He's not here. I'm not going to slander him. So I'm not slander him. It's facts that just shit. He was absolutely. They've been telling us for years. They know how refraction works. None of them can give me Ruhif's calculation. He doesn't know what the formula is. The whole fucking thing is based on this formula. He also doesn't know what measurements he needs to take. He thinks he can get weather balloon data, and that's fine. If he has 2 weather balloons in the area, like, bro, you need to measure your optical corridor. If you don't measure above, below, and through your optical corridor, you have no idea what's going on because light's bending towards the denser medium. So you have to know if the denser medium's on top or on the bottom, or is it still staying in the middle? You understand what I'm saying?
Yeah, I
So
feel
if you
you
don't
on
have
that.
these measurements, of which one's a denser medium, you're just playing guessing games on which way the light's moving in between you and the object you're looking at. Fucking ridiculous.
Yeah, and
man.
see that's the weird thing is like I see plenty of skeptics will respect their best guess, their best hypothesis, their best assumption guessing game. But then it's like when it's time to turn around and be like, all right, but let's like look at the other guesses. There's a big group of these clowns that are just like, no, we already know definitely. You're just like, no, you don't, bro. Like, what is you even talking about, man? Like, you ain't measured none of this. You guessing. I mean, it depends on what topic we're talking about. They're gonna have different degrees of confidence, but like the points you bring up are interesting, man. And there's gonna be a lot of people that, to them, they were told on PBS Space Time that the theory is this, and so that's just what it is. Period. No questions asked.
Well, I mean, I beat a guy. I went on Jose's once and just beat. I don't even know who the guy was, but we were having an argument about the light bending and shit. I'm like, dude, The light might not even be bending. I'm like, do you know about interference patterns and shit? Like these guys, he didn't know. He didn't know about it. He looked it up real quick, tried to come up with something like, dude, you don't know what the light's doing. Just plain and simple, just fucking admit it. I'm not saying I do know. I'm telling you, you have no way to prove that what you're saying is happening is actually happening. And it's obnoxious.
Right.
Yeah, the rays is theoretical, man. There's no, even Andrew Thomas Young will tell you, there's no light rays. There's no, like, the way they describe them. It's a model, you know. And so, like I said, if what they're saying is true, then the light from the skyline of Chicago is the light that otherwise would have went over our head. Okay, so we're seeing a bulge of Earth curve. Okay, we'd have to look down a little, and the Earth would be getting in the way normally. But this is their story, not mine. But the light that would have otherwise went over our head is bending around and hitting us in the eye, making us see it on the horizon. So in other words, all we'd have to do, literally, is put up an obstacle from the height. You know, if I'm 10 feet above sea level, I need to put up a fucking some cardboard at 11 foot halfway in between us, because there's no way that it could get to me. If it's otherwise would have went over my head, bending down into my eye, then it would have to go through that cardboard. You see what I'm saying? And it wouldn't be that expensive. It takes some light material and a big ass piece of cardboard, but it wouldn't be impossible to prove that. You know, they already went. You know, God rest in peace, Rob Skevens. So, but they went just to call bullshit. They went and drove across Lake Michigan just to show, look, it's right here. Works the whole time. It ain't a mirage, you know, which was stupid, but it was showing them how stupid of a claim that they're making with the refraction. Like, we're looking. I personally agree with Travis saying that the stuff we see that's distorted and inferior mirages, you know, the reason we're seeing it is because it's there. It might be distorted some, and it might wiggle around a little bit, move up and down a little bit, but off of the distance, like we're seeing, you know, light can block it, but we're seeing shit because it's there. But we've seen Pebbles on the Pond, Sky Free, do their little, you know, with the different temperatures, opening the garage door and watching lights disappear right in front of our eyes. We got line of sight to light. Next, you know, he lets the cold air in. But then when it shows back up, we're seeing it because it's there. You know, the light, you know, hid it, obstructed it for temporarily. But so there's some funny things going on. But it's you know, what they're claiming is probably one of the most extreme claims of all, in my opinion, which we could prove wrong. Like I said, with some obstruction in the middle of our observation in our eyes. You know, proving the light ain't bending downward. Or they could prove it, and we could disprove it, or they could prove it, doing that very thing. Because if they took a piece of cardboard halfway in between the Chicago skyline, like at 11 foot, and to a 10-foot observer, they held the cardboard up 11 foot, and then all of a sudden we couldn't see the Chicago skyline, that would prove that it is light that would have otherwise went over our head and is bending down, hitting us in the eye. But I don't believe that.
Well, supposedly on the globe, the light's hitting the object and coming up around the globe, not down. But that's like the total opposite of what they're trying to tell. But look in the back chat. I got like 2 diagrams. One diagram is just like showing you the sun source, you know, where it's at. Like, say it's the other way, you know, down, you know, around the horizon, beyond the horizon, right? It's that direction. Okay. And you have a boat. The next picture is the boat and where the light actually hits the boat. The light hits the boat on the top of the boat and the back of the boat, never the front. So for the light to reflect the way they say off the back and the top of the boat and go up and around the curve, the only image you should ever see is a floating top and a floating back of a boat. Like you're looking down on the, like literally like you're flying above it in a helicopter and looking down into the deck at it. That's the only thing you should ever see on a globe. You should never see the front of an object, ever. Bending around shit. It's impossible.
Wouldn't say it's impossible.
I would, and I just did.
Why? Why though?
Because I
What's
just did.
impossible?
Because you don't understand anything. I don't know how to explain anything to you. Everything I say to you, you don't get. No point for me to talk to you, Jeremy. I like you, but I mean, I don't know what to tell you, buddy.
I just don't understand what you're saying. Since you say
You don't
something
even understand the
15 times,
drawing
sometimes-
diagram. I don't know what to tell you, buddy.
Welcome to the
find it,
conversation
man.
with D-Mock.
Wait, I
Well,
can't find it. I want
I'm
to see
being
it, but
nice. I'm being nice, man. I'm just being nice. You can't understand the diagram. I don't know what else to tell you, buddy. I can break out crayons and draw.
and don't that sound stupid though, D-Mock? Don't that sound stupid? Like in their world, I'm gonna put up a piece of cardboard, 11 foot off the water, and block, and then all of a sudden, the Chicago skyline that's underneath that piece of cardboard is just gonna disappear. So, in other words, you put up something above my eyes, and it's blocking the light that's coming from the skyline bending down to my eyes. So you put something up 11 foot, and it's going to block what's underneath it. I mean, it's so counterintuitive. It's almost comical to even to explain it. Do y'all see what I'm saying?
Yeah, it's counterintuitive to say that the light is going to hit the back of the fucking city and show you the front of it. Also, I wouldn't know how that would work. Show me how you're going to shine a light on the back of my house and then show me the front of it from the fucking light hitting the back. Show me that anytime. I'm ready. I'd love to see that refraction. If you're on the other side of my house and my house is directly at the horizon and the sun's behind my house, the sun's not shining on the front of my house. Clearly, I don't understand how no one would get this.
I get it. I know what you're saying.
Say it again, my
It's
man.
like they claim there's gajillions of fucking photons scrambling around everywhere. I understand what you're saying, D-Mock.
He's talking about the scatter, about how light wraps around things.
Well,
And
actually, what it's doing in the example I think I heard you talking about is light is reflecting off of things.
The
Like
back
you're
of
gonna
the
shine your
object.
light. Well, no, it's not. It's not reflecting off the back of the object. It's reflecting
If the light,
ground and everything that's behind the house that lights the back of the house up.
yeah, so it's shining on the back of the house. Now, at what point in time does this big flashlight shine on the front of the house?
I'm saying.
I mean,
It's shining. The light is coming on from the front of your house, but it's reflecting on things that are behind your house, and that light that's reflecting from those things is coming back and lighting up the back of your house.
the main source of light's only touching the back or the roof. It's never touching the front.
Basically,
That's reflected.
D-Mock, all the light that goes to the other area on the other side, you have the shadow, right? You have the shadow, and then you have all the other area that's not the shadow, where the light isn't blocked by the house and it's making it. All that fucking not shadow area is bouncing shit back. That's all he's saying. I mean, now let's talk about how stupid that is.
No, no.
Oh, he is. He is.
Hold on a minute, man. If the light,
I promise that's what I'm
listen
saying.
to me, man. Listen to me clearly. If you guys have a garage and you shine a big spotlight on the back of the garage, right? And you think that this light is going to bend, right? And then go around and make an arc to the observer. And the only thing this big spotlight is hitting is the back of the garage. What do you think the observer in front of the garage is going to see with his bent light?
Oh, well, that's different. That's total
No,
darkness.
that's what the globe, that's how the globe works.
Well,
the sun is behind the horizon in my example.
It has
the
the
object
moon.
Is on the no, not the moon. I said the sun is beyond the horizon.
The sun has a reflector on the other
Hey,
side.
listen, you give your own example. I'm giving mine. What are you talking about right now? What the hell? Listen,
Well, you
the sun is
here's
beyond
the deal.
the
Here's the
horizon.
deal.
and I
You
got a
got
bow.
in your first example, Democ, the
there.
flashlight is smaller than the object, so it's blocked by the whole object.
I'm
the whole
giving you
back
the
of
sun now, and you keep talking
The
over
sun
me.
is bigger, supposedly. They say it's bigger than the whole object.
What's your point? Shut up for a minute.
Well, it's a different analogy.
If you then what? I haven't finished my sentence.
You said the flashlight is blocked by the whole garage.
Yeah.
Well, in the example of the sun, it's not blocked by
So
the
my
whole
question
garage.
to you was still, you didn't answer my question, did you?
Okay.
So in that
Okay, my bad,
example, what portion of light and what are you going to see reflected to your eye? Are you going to see the front in your spotlight portion? Or are you going to see the back of the garage, the only thing where the light hits? Answer the question.
No, see, Democ, the sun's got arms, bendy arms that scoop raisins and shit, man.
Yeah, that's what
And
they're saying. Yeah, that's what they think. So listen to
Saw
me.
that commercial too.
So if I have a sun that's behind, I'm giving you the whole sun now. Wait till I'm done. The sun is behind the barn. The barn is on the horizon, 5 miles, 10, whatever your horizon is. It's there. The sun is behind it. Now, what am I supposed to see when the direct source of the main power of light is hitting the back of the fucking garage, not the front? I understand your little weak light coming around at whatever angle, doing its goopy stuff late and late and light, not bright enough, not the main source, reflected dog crap, right? That ain't doing nothing. Now, what should I see?
Now we got to talk about angular size, I guess, guys. If someone better than me can help, he's got.
I don't think you have to talk about angular size.
I'm not talking about it. Dude, where's your brain?
Hold on, guys. You
Hold
don't
on,
have the
man, hold
words.
on.
Let me just make the connection. So, Coach, he's got a cool example here of how, any object on the horizon or in your landscape could block out the whole tiny sun, I guess, in theory, right? Like it could.
Yeah.
Right?
Doesn't matter what size object that you're on. If there's a source coming from one direction, then the opposite side of that object is not going to be receiving direct sunlight. But that's only an issue. That's why in outer space, that's why on Earth there's a nighttime, because in outer space we don't have objects behind the Earth other than the moon to reflect sunlight off of and give us light. If we had a bunch of objects back there, then that sunlight, even though it's nighttime for us, it'd be reflecting off of those objects and reflecting back onto Earth, and we'd have enough ambient light or reflective light even.
No. Gravity is supposed to be bending the light. Gravity is supposed to be.
This is my point. Hold on, this is my point though.
Be bending the light through the atmosphere around the planet.
Okay.
So at night, hold on. So at nighttime, if you got half the dark planet and half the light planet, half of the light planet should be shown through the air, bending around the curve on the horizon to the dark part.
I'm just getting to my point though, man. I'm just saying that's what's happening when you're on Earth and there's a garage or a house or something, and the sun is hitting the front of the house, and you're in the backyard, facing the other direction, or looking at anything. Say you're writing notes on a piece of paper, and the house is blocking the sun from you. The sun is still bouncing off everything else that's behind your house. So the light that you're getting is going to be ambient light or this reflective light.
Yeah, I think
you're telling me.
I think it would be a false assumption to say that the sun is the only thing that's emitting light. To me, it seems like the sun activates the actual sky itself, the blueness of the sky, and that's what's giving off a lot of the light that we observe.
That's weak light. You guys are talking about weak light that doesn't matter. That's why shadow exists. Because the shadow is blocked light. It's the weaker source. It's the source being blocked off. So listen. Hold on a minute, man. They're trying to tell me, Coach was trying to tell me that the weaker source of light's coming through and going through all the main source, the main power light that hits the main back of the object, and that part is supposed to come to me with the power of the reflecting of the sun while it's curving with that source of the sunlight. Now the other light.
I'm not agreeing. I'm definitely not agreeing with them. But I wanted to ask you a question. Have you seen Dan Dimensions?
No, I don't.
If you haven't, he's agreeing exactly with what you're saying, bro. He's showing how the sun comes around and the sun might emit light, but it's not what causes daylight. It's a cascading ionizing atmosphere that causes the daylight, and it follows the sun around. You know, it's like the same thing, the same electromagnetic,
Oh yeah.
whatever, and it causes the sun is the same thing that causes light to. It's just, and he proves it by showing different layers in the atmosphere. Like he shows that the nitrogen and oxygen show like a clear, and water glows. It ionizes like a clear, whitish, bluish,
And so does
just like
argon.
daylight. Yeah, and then he shows
Argon
how
glows after the
up
sun.
higher the gases that are up there, how the neons, the red, and he shows how it's always the same order. You got the clear daylight to the red, all the way up to the blue, and so I put a couple of his videos. I mirrored them on my channel, Flat Earth Test, but it's called Dan Dimensions, and he's got a laboratory, and he's got all these gases separated and ionized, and it's pretty
Well,
fucking
it's
neat,
kinda
dude. It's backing up what you're saying.
And also another thing I'm saying, it's kind of like having a big light source, like a big spotlight to work with, like a construction light, and then having a candle. What's the you think the candle's going to outdo and outshine and outbring to your light a different, better source? No. The greater source, the actual source of the light, the main thing that hits the first part of the object, that hits the first object to the source of light, would be the part that should come to you first, not the other stuff that's like coming from around something after, slower, less. You know what I mean? It doesn't make any sense. And if something's on the other side of a globe and you don't see it, like I can see the barn, right? Now take this barn and move it further. Now the barn's supposedly past the horizon. I can't see it. Now the sun, in theory, would be hitting the top of the barn, right? And the bottom, the back and the top, not the front still. Now, how come if the light bends to me and it's not seeing the front, it's only seeing the top, the roof, and the back, the reflectant thing to me should be floating in the air is the roof and the back of the garage, never the front. So if we're on a globe and the image is wrapping around.
Been with this for about 3 hours saying the same thing. Can we move
Yeah,
on
but D-Mock.
to a new topic?
Yeah, D-Mock. Hey,
What's your
D-Mock, I
point?
just posted.
This is
Wait,
just getting
D-Mock, I
really
just
repetitive.
posted. Let me say something
You
to
know,
him real
Mike,
quick.
the idea that I'm
D-Mock, I just
broken.
posted. D-Mock, I just posted sunlight versus daylight video in the live stream one text or whatever. It's fucking, dude. It's about 9 minutes long. It's exactly what you're saying, dude. It's badass, dude. You gotta fucking watch it
I
when you
don't
get a
get
minute.
how I'm being shunned for disproving the globe right now. And everything about refraction, every bit of it, right now. Here live. Okay.
Got some Twilight.
Change the subject, I guess. Let's talk about something we can't even refute about space. Let's talk about space.
Well, no, before we go to space, let me ask Kosher this question. Kosher, I don't know if I got an answer out of you. So if you believe that the light's, curving around the globe, okay, fair enough. It's, not a hell of a fucking curve, but it's a gradual curve. Okay, so the Chicago skyline, right, is light that otherwise would have went over our heads, but is bending down to our eyes, making it appear on the horizon. So shouldn't you be able to, so if I took a piece of cardboard, if I was a 10-foot high observer, okay, above the water across Lake Michigan, and halfway I took a piece of cardboard and blocked off the right above the skyline at 11 foot. I put the piece of cardboard 11 foot high, a big ass piece of cardboard blocking the rays of light 11 foot off the water. Would in your model, wouldn't that have to block out the skyline because it's light that otherwise would have went over our head, but it's bending down. So I could hold up a piece of cardboard at 11 foot and block out the skyline that's below it.
I kind of see what you're saying. Yeah, I
You could
guess
prove
there'd
your
be a
globe.
place.
You could prove your globe
There'd
if
be
it
a place
works, but
where
it
you can
sounds
do that.
solid to me.
Yeah, but
like
I mean,
you should get.
you would have to be somewhere close to the person, right? Like you wouldn't be able to be too far away.
Well, just say halfway. You could start there, but you could prove the globe, man. If you held that fucking cardboard up directly between the skyline and the viewer, 11 foot high, and it
I don't
made
think
the
you could be halfway and do
skyline
that.
underneath to disappear, you could prove the globe, man.
I don't think you could be halfway and do that though. You could probably be somewhere close to the observer and do that. But
So you think the light bends? You think the light takes a sharper bend at the end, or is it a gradual
no,
bend?
No, I think that if you want to be a 10-foot observer and you want to, I mean, if you would be a person on the surface and or wherever you're standing, and you want to have a person who's only 10 feet off the surface obstruct stuff, he's gonna have to be pretty close to you. Otherwise, the thing that he's obstructing has to be lower. I don't know. You kind of have to do the math and see exactly where you'd have to be to do that.
Yeah,
I
since
don't
you
think
can do the
halfway though.
math, you can use a K-value and use Ropus's fucking ray diagram. Which, like I said, Andrew Thomas Young says it's there's not really sun rays. It's just fucking a construct. But still, it would still have to be the same principle. And I mean, really, I thought you was gonna just think about that and be like that's stupid. But technically, if the light is
Well, I mean, you're
bending
assuming
down,
halfway
it
is
has
the
to start
distance, but
off as
I
having
don't know
one
if
over our
halfway would
head,
be the
right?
distance.
I
You
got
have to
one
determine where the
suggestion.
distance is.
Should get a tank with a little bit of water in it and put an actual ball in the tank of water and have water just a little bit above the ball. That way you have a surface of water over a little bit of a ball. Put an object in there. Shine a big light on one side. Put whatever you think you need your atmosphere to be above that water in your aquarium, and then see what happens. I'm done.
I got to think about this one a little bit more, I guess, because it's kind of weird, but
Well, not really, man. Not really. Like I said, if you just start off at the observer, okay, and you've got a piece of cardboard 1 foot above my head, like a just blocking out every a big ass piece of cardboard. Let's just say like as much as we could actually hold between two people. Big ass piece of cardboard, like half the size of a billboard. But I can see underneath it, right? Because you're holding it 1 foot higher than me. Now they start going in the boat, holding it up. It's a calm day. They maintain 11 feet in height. I don't move. I maintain my observer height of 10 foot. And the whole way, as they start to go away, I'm just seeing the skyline underneath the piece of cardboard, But I'm looking at the skyline, but really what I'm looking at is Earth curve. I mean, a bulge of Earth. I'm having to, look out in the distance, but really there's Earth curve hiding it. So really the skyline ain't there. I mean, it's barely not there, but it's not there. So really what it's doing is it's curving down. I mean, it's angled up over our heads just a little bit, nothing extreme, but it's bending downward. So at some point, that boat would have to block that skyline. It is tricky to think about when I put it like that, but I don't know. It seems like we could prove something, because to prove the light's bending or it's not bending, I don't think it's fucking bending the way they say.
yeah, I'm looking at Mick West refraction simulator right now, just to kind of see where, but it's not, I don't know. This doesn't really have distances. Let me see.
It'd have to start disappearing from the top down, because the building is in my opinion, the building's way higher than me standing at 10 foot. But in your opinion, the building's not really there. So as you start working your way towards the building, it's not really.
It's
what?
It is there. The building's really there.
No, it ain't.
There it is.
No, it ain't. It's lower. It's got to
Well,
be
no,
dropping.
you're able to see further. Yeah. So you're able to see further, but now you can just see 60 miles away, where before you couldn't see 60 miles away. I know what you're saying. You're saying it's lower instead of being as high in your vision as it is. But
yeah, it's dropped down like 277 feet, but lower off in the distance because of the Earth curve. So the Earth is
but it's
actually
just as
blocking.
far. It's just as far as away. It's just as far away as it actually is, though.
I agree, but my point is that as the cardboard goes away, okay, then if it's so, you got to admit that the top of that building is always lower than that cardboard. So the closer you get, you should start seeing a shadow on the top of the buildings, or not a shadow, but it should start blocking, because the buildings are literally underneath the cardboard, lower. They're lower. In other words, the cardboard should never, ever block that building. But if it's standing on a flat earth, the cardboard's going to wind up at the bottom of that fucking building across Lake Michigan, and they're going to be holding it up against a building at 11 foot high. In my model, the cardboard's going to, if they keep going, they're going to hit the building at 11 foot high.
Well, you understand, regardless.
Your model, it should never block the building. That cardboard should never block the building, right?
Okay. The buildings are being blocked, though. You can't see all the buildings. You see like the top parts of the buildings.
Right. That's what I'm saying. So it should disappear from the top down. In other words, the first part coming into visibility would be the top of it. That's what's poking its head out. And so the cardboard should start as it works its way toward Lake Michigan. It should block the top. You know, it should never. I got to think about this.
I don't think it would block it from top down. Why would it block it from top down? The light doesn't come into you in a reverse order.
Yeah, I see what you're saying. It wouldn't necessarily have to be the top down, but it should block the buildings. It should block the light that's hitting your eye. But it'd have to be out a little ways, Kosho, because you can't just say the light's aiming over our head and then bending down at the last minute. But you see what I'm saying? In your model, the building's got to always be underneath that piece of cardboard. No matter how far you go, in reality, them buildings will always physically be underneath that 11-foot obstructing piece of cardboard. Would you agree with that?
I don't understand what you're saying. That they're always underneath it. Oh, you mean like in a straight line? You're saying in a straight line. Okay, I kind of see what you're saying. Yeah, if the geometric horizon, so you'd have to determine where the geometric horizon is first of all, and then you'd have to do your 8 inches per mile squared from wherever the geometric horizon is. And if the entire building is supposed to be cut off, given those numbers, then yeah, a straight line from you to those buildings would be cut off by that cardboard always. So yeah, if you have cardboard there and you're holding it up, I mean, I agree with you that if there is some place you could stand where you're going to be able to obstruct the light. I just don't know exactly where it is. I don't know if the 10 feet is going to be where that happens.
Yeah, I agree. I was just using that, as just a number, an arbitrary number, just something you could imagine. But so when you try and think of these things, it's the way we try to get some new globe earthers or like Terse or somebody who hadn't put much thought into it, who still think you should see Paris. When we're talking to you or George or Rumpet, at least we don't have to explain that we shouldn't see fucking Mount Everest from Florida on a flat earth. You ain't that retarded. But I ain't gonna say retarded, just no concept of what reality would be like on a level plane. Y'all thought it through, at least in most cases. But
Tony V said something interesting one time, because you're right, maybe you can't see Mount Everest, but you should be able to see Mount Everest from a silhouette from almost anywhere on Earth. I forgot what the distance was. It's pretty far, though.
No way, dude. No way.
I'm trying to remember.
Absolutely not. You would not be able to see. You're saying you'd be able to see Mount Everest, a silhouette of it, from anywhere on the Earth if the Earth was a plane?
Well, I think from half the places on Earth, but I'm trying to remember exactly how we came up with that. Oh yeah, right. Okay, yeah. So if the sun reaches down. Okay, no, that's right. You got to figure out what the angular size. So give me a second. I got to figure out the distance for the angular size. Let me see.
You can supposedly see your butt with a good telescope. So yeah, I get what he's saying.
Yeah, all the way around the globe.
Yep. So Mount Everest shouldn't be that far of a stretch if it's that huge.
I was trying to give him some common sense credit, you know, him and Rumpus, you know, and then he says some shit like that. Like, Jesus Christ, can't even fucking, like, are you kidding me, dude?
Let's see if I can
He's trying to give you,
validate it. Maybe I can validate it right now. And I think I can. I got to go in about 4.
Have you guys ever saw Mount Everest from anywhere you look?
Okay, here we go. Let me just validate it. We'll use the height of Mount Everest as, we'll use 29,000 feet because that is its height. Fucking hell. 29,000 feet. Yeah, so I'm driving at the same time.
you want me to do it real quick?
No, hold on. 29,000 feet. And then we'll use 0.02 as angular resolution of the eye. Okay, so that's
It's the same as the globe,
thing
man.
you can resolve. Hold on 1 second, sir. And then we'll use this is this. Where did I say?
You know, the atmosphere acts like a lens. They all say it. Some days, boats go off as far as they can. They never disappear. They just shrink into a fucking smudge. We've seen it. And then some days, the it looks like the atmosphere looks clear, but in blocking boats, but it's just like it's magnifying. And then, like Rob Skiba demonstrated that, you just take a lens. They say the atmosphere is acting like a lens. With a certain lens, it would do exactly that. It would make shit disappear into the ground with a certain lens. So certain day, that's what's causing different atmospheric phenomena, different refractions. Is a certain amount of moisture content creating a different type of lens, you know, so there's plenty of different combinations that I would guess. But that's how I justify it to myself of how I see shit disappearing bottom up every now and then, or sometimes when I go, and how the sun would set if it was being that it's as high as it is the triangulation's telling me. It wouldn't take much. It ain't a miracle. It's an actual decent fucking explanation. Easily demonstratable, you know. It's not a stretch. What is a stretch is like them saying that, you know, when the sun is setting, that it's, you know, it's already behind the horizon. It's really not there. Then they try and tell me to use a solar filter for my observations when I'm looking through a solar filter and seeing a sun that is not even there. And then if you look at the sun through a solar filter when it's like halfway on the horizon, it's smushed, you know, refracting like it always does when it's on the horizon. Halfway on the horizon, you know, it's smushy. Then you get a smushy ass looking. In other words, the solar filter it might block glare, but it doesn't block refracted light. You still get a disfigured sun, you know, and they fail to take this into consideration. It's incredible.
I don't know.
want Kosho to do the math for Antarctica. Two high altitude balloons, 120 Gs, 120K feet in the air on either side of Antarctica. Could we see the balloons from each other, or would they be blocked by Earth curve?
How high is it?
100
I
to
can do it.
100
I just double
to
checked his math. It was right. Go ahead.
Leaky, your math's shaky at best, bro. I don't know.
No, it ain't, dude.
Handle
It's just
this.
fucking. It's not. Man. I just had to brush up on it, dude. It's not, man. I just had to brush up on it, dude. When I was trying to do my model, it was confusing, man, because there's, I was every time I got pressed doing it live, dude, I fucking, I'd leave something out. But I got it down pat now, dude. I've double checked the whole thing. I just had to brush up on the shit. I ain't did the fucking, trig in so long, but it's not that difficult, dude. I've brushed up on it, and it don't matter, dude. I'll go to the triangle calculator. I don't even have to do the formulas myself. I understand it, so I just put it in the calculator. Simple shit. Like all Kojo did is go to triangle calculator, and for his angle theta, the angle you picture yourself viewing from, he put in 0.02, and then he went to side B, the opposite side, the one that represents the height of Mount Everest. So straight across from where you're looking, that side straight across, he put in 29,000 something feet. And all you need is two values, and then just hit calculate. It gives you the rest. So it gives you or that would be side A. So the bottom line, I think it calls side B. So then it calculates side B for you. You don't even have to do the fucking math. That's why when I'm giving example, I mean, I can do the math, but I did have to brush up on it. But that's why when I'm in my videos, I show the figures in the triangle calculator so people ain't like, because I know I've made some mistakes with the math, but I just, like I said, I had to brush up on it. So, I mean, who the fuck knows how to do that shit, dude? Like by heart. Math teachers. That's it, dude. Math teachers. Who the fuck sits around doing trigonometry every day of their fucking life, dude? I learned that
Lovers.
shit back. I learned that shit back in high school. And but it's been so long, I just had to brush up on it. It's not that fucking hard. I understand all that shit. I mean, I understand some calculus and shit. Like how he was that's calculus when he was talking about the radius with the ellipse with two radiuses. It's x equals x squared. You just you make the graph and all that. But I'd have to brush up on that too, really, and that shit gives me a headache. So it doesn't prove nothing.
Leaky, are you there? You go off
Yeah, I'm here.
rambling, bro. I zoned out. I zoned out on you. You go out. You monologue too much. Listen, I need to know if one high altitude balloon on one side of Antarctica could see another high altitude balloon on the other side of Antarctica if they're both at 100,000 feet at the same time. Let's say we can line that up. Say the 60th parallel. That's a huge chunk of fucking the globe right there. If it's if we can't see them, what are they going to say? Refraction? If anything, it should make them be their refraction should make it be higher. Yeah, if we can't see them, that hurts them. You're supposed to, don't count any refraction, just the geometry alone. Because refraction would go against them if we couldn't see it. I just put $200 in this thing that makes $2 a day. Let me know when you got those numbers, bro. I don't think you'd be able to see it at 100,000 feet. Antarctica, I think they're talking like it's 6,000 miles or some crazy shit.
Give me just a minute.
No rush, but I need it in like 2 minutes.
Hey, Jeremy, what were you saying about Antarctica?
100,000. Well, listen, we're on the edge of Antarctica. 60th parallel. No. We're at the 60th parallel. Opposite sides of Antarctica, right? Exact opposite sides. You put two balloons up 100,000 feet in the air.
Are you cleaning the toilet?
That's not me. I don't clean toilets somewhere. I mean, I clean my house toilet. It's Matrix.
Yeah, I hear that,
man. Matrix, Matrix. Hold on a second. Hold on. Everyone, hold on. We gotta. There we go. He fixed it. What were you gonna say now? Sorry.
No, I was waiting for you. You were saying
No,
something.
somebody jumped in. I know somebody jumped in right as I was trying to get control of the hot micer. Now, what was that person gonna say?
No, you're good. Go, keep going. Something
right.
about 100,000 feet.
Yes, we're at 100,000 feet. We're at the 60th parallel, opposite sides of your globe. We go 100,000 feet in the air with each balloon. Can they see each other? Just taking the geometry of Earth into account.
Wait. Before you answer that, opposite sides of the Earth, 60th parallel, like north 60th and south 60th, or what?
Bro, we're doing Antarctica. What do you think? Come on.
I didn't hear that part. Sorry, missed it.
All right, it's okay.
They're saying they're both at 60th parallel, opposite sides. So they're both at 60th parallel.
You missed
They're not going to be
Antarctica.
opposite sides.
Okay, I got it. To the horizon distance.
Opposite
Hold on,
sides. Basically, hold on. I'm trying
Hold
to
on, Leaky.
fix up, dude.
He gave me a 2-minute deadline.
I was joking. Go ahead, Kosho. Let Kosho finish up. You're next, Brian.
Opposite longitude, so like 180 degrees longitude away from that one, but both at the 60th southern parallel.
I got it. Yes, he clarified. You didn't need to do it. I understood that.
Oh no, I was actually clearing up to Jerry, making sure that I had it right. So you're saying right there, right there.
We're all on the
yes.
same page.
Yes. In Kosho's mind,
I got
he
horizon
has it wrong, but
like
the rest of us are on the right
387
page.
miles. And
It
would be blocked. It wouldn't be able to be seen, bro. It would be
it would totally block.
Hold on. Yeah, totally blocked.
No, dude, this was my point when I made that the Mount Conagu meme, and I used I found the horizon from each of the positions, and they were in between each other, that they'd be able to see each other. So as long as your horizon is at some point that when you add their horizon, it's greater than the distance that you are from each other, then you'd be able to see each other. Yeah, that's all you'd have to compute.
Jeremy, it'd be 315 miles of hidden height from or like 314 and change.
No,
you did both the balloons going up at 100,000 feet, or just one?
Yeah, but that's granted 2,000 miles distance.
No, they wouldn't be able to see each other. They wouldn't be able to see each other. But 100,000 feet, the distance is about 400 miles. So they would be able to see each other if they were within 800 miles of each other. But they're not within 800 miles of each
other. Okay. That's fine. Just curious, what if we were right at the edge? What if we got as far in? See, they'd never let us set balloons off, though, because they'd be like, oh, you can't get them and shit. Why can't we cross it like the little girl did? Some little 16-year-old girl crossed it. That would solve up this whole fucking thing for us, maybe. It would definitely end the debate on if Antarctica's the ring surrounding the flat Earth, or it's just a continent, or it's like what you guys say. I mean, it would definitely end the If you could cross it, it would definitely end the notion that it's a fucking circle around encompassing flat Earth. You know what I mean? Obviously, that's not the case if you can cross the shit and pop out on the other side. Like, why won't they just let some little 16-year-old girl did it? We're like grown men. We can't do this shit, or what? How pussy are we?
Yeah, I agree. All they really have to do is send some witnesses in 2 planes, one from South America to the base right there by the tip of South America. I think it's McMurdo, and then the other one to Scott off the base of Antarctica. Have them land, refuel, okay, and then just film it. Them planes should cross each other. They should only be about 4 hours apart from each other. If they both flew toward each other, they should cross. And it wouldn't be that, it wouldn't even take that long to get from one side of Antarctica to the next. It should, take about 6 hours. So in 3 hours, they should cross paths. And, that's not a great feat. It ain't nothing crazy expensive. I mean, I'm sure they fly down there all the time. But in my opinion, Antarctica base and the South America base are a world apart, They'd have to be on a flat Earth. So nobody'd even have to do nothing fucking magical, cross on foot or anything. But yeah, if it could be done, I believe millions of people would have did it. Not millions, but lots of people. It'd be more popular. It'd be something.
So to be clear, if the only reason to do something is just to satisfy the standard of evidence that flat earthers require for proof, and that's the only reason to do it, that's not going to be a reason that people will do it.
Isn't that what the moon landing was about?
In a few years, it will be. The more this shit grows, it will be. Because look how much they spent just to try and prove relativity. Fucking billions of dollars, and then their time ran out, and they never discovered fucking gravity particles. And then right before
they didn't do that to prove relativity, dude.
Yeah, they did it to get gravity waves. What are you talking about?
Yeah, not to prove it.
Really? Not to fucking prove fucking.
They would have shut it off. They would have shut it off once they saw the first one. They're using it
They
as
never
a
seen
as
one
a
until right
detector.
before it was time. They never even seen one. There's no such thing, dude, in my opinion. But look,
but
so what are they doing then?
They would have made it.
That's what they say they're doing anyway.
They're detecting gravity waves, but they're not. They didn't make it just to prove that gravity waves or that general relativity is correct.
And why?
They're using gravity waves as a detection device.
For what? What do you mean? I mean, that's what they claim. They're fucking trying to detect gravity waves. That's the whole goal. You tell me what they're claiming. What else they claim?
The goal is not to prove general relativity. The goal is to use the tool. Use it as a tool to measure gravitational
I
waves
didn't say
for the
general
purpose of
relativity.
detecting.
I said relativity. It's special.
Yeah, but it's not to prove it.
I once heard it described as, imagine that you only had the ability to see something your entire life. You were completely deaf, and you could only use your vision as your sense. And then all of a sudden imagine that you've got some sort of hearing aid, and now you can hear for the first time. That's what the gravity waves are. Basically another way to see into the universe.
That's exactly a perfect way of putting it. So that's
Bro,
exactly
right
perfect.
before their fucking contract ran out. I mean, not a month before their shit expired. I think it's more like a few days, but they magically discovered the shit and then got a fucking another grant. I mean, do you really fucking, are you that naive, dude? When they had a way to simulate it. Hold on, it just so happens they had a way to simulate it, and the guys could one guy could hit the button to supposedly keep his people in check to see if they're, if anything could slip by them. Yeah, sure, there's a button you can push to keep your people in check. And all of a sudden, right before your grant expires, you fucking found it. How naive are you, dude?
I thought that as soon as they turned it on, or soon after they turned it on, they detected the first one. They've been detecting them ever since.
some people say they haven't detected shit.
Yeah, I know, but that's what I'm saying. Don't they claim that they detected it, soon after it was operating?
No.
Soon after it started operating?
No, they had a couple of them, and come to find out that it was the simulation. It was a fucking exercise. Fucking like I just said, it was the guy hitting the fucking button. I mean, I'm saying it in my own words, but there was a guy who could simulate it in the program and to supposedly keep the people there on their toes, and it was a simulation. No, they didn't claim it until
remember
they
hearing that they got
discovered. It was
detection
big
soon
news,
after they
bro.
turned
When they remember, it was big news when they just made the claim with the fucking conjoining black holes. What the fuck is a black hole? All this shit's fantasy shit, in my opinion. They think they're God.
Oh, Kosho, besides your GPS bullshit, what are we going to do to definitively prove something here? What can we do? I don't care if it's a small piece or the whole puzzle.
For a straight line or for the flat Earth in general?
Just anything we talk about, bro. Is there anything we could prove?
Yeah, dude.
definitive?
Very simply. I mean, all you have to do is measure, like the other test that you were going to do, but the sun's speed during the equinoxes and the solstice.
The
That test
subsolar
right
point?
there. Yeah, exactly. The subsolar point. It
All that
definitively shows
does,
you one way or the other.
that shows you if then you have to have a map. You have to have a map and shit with this, and then,
Yeah,
and
if
then
you
that
want to
only
find,
shows
Kosho is saying, if you want to find out what the Earth is, you need to look at the sun.
Yeah. Well,
No, I
it's
didn't
a
say
spot
anything
on
about.
it.
I didn't say anything about looking at the sun. Actually,
You said subsolar point, right?
yeah, I did.
There you go.
You would be
What
looking at
direction
the
is the
ground for
subsolar point? Yeah, the subsolar point's on the ground.
Subsolar.
I was actually on this for a while. This was pretty good, but then all the flat Earth would say is that you don't know how the sky works. That we would be pushed back to a Pac-Man map, which is fucking insane. Anyways,
No, dude. Yeah, remember the pandemic hit, dude. People were restricted, like the people in Australia, fucking who didn't have access to even get to some of the spots and shit. I mean, I think we
okay,
can
Brian,
still do this. It's a great idea, bro.
do it. If we do it and then it comes out not our way, we could just say it's a Pac-Man map and continue on with business as usual. This
Even
is
a
still,
Pac-Man map would
even though we're
destroy the
looking
globe,
at,
bro.
even though we're looking at the ground, this has a lot to do with the sky. It's pretty much everything to do with the sky and how the sun's working and moving and shit.
It
so.
absolutely doesn't. Think about it like this, dude. No, think about it like this, dude. If the sun, if the ground that the sun is directly above changes at any given moment, there's never two places where the sun's directly over. Then that position makes a complete cycle in 24 hours. That position on Earth makes a complete cycle. Then all you're doing is measuring a position on the ground. If you measure it right now and then you measure it in 4 minutes, and it's made 1 degree of its cycle, in that 4 minutes, you can see the distance it traveled, and you can determine what 1/360th of that path is. And it doesn't matter that the sun is a hologram or whatever. It's
We're
the
not trying to
ground that you're
do
measuring.
1/360. We're trying to do straight line, something we can measure. But look, Jeremy, even if it is the Pac-Man map, then it'll be the same speed at the equator as it is at the Tropic of Capricorn. That'll still disprove a globe, and that's just as likely as it being going further in the south. I think the globe is the very least likely of all them outcomes. And it's a great idea, Jeremy. Kosher's in on it too, man. We could get the people to in on it, man. We just gonna have to
There's a lot.
be
There's a
after
lot
all
of.
the ideas.
You have no idea how much is involved with this. No idea. You have to have a map.
Not that much.
The sun's going. You have to have a map. The sun's going in a curving pattern. It has to be between known land distances. We fucking dispute every land distance.
Dude, why would you need why would you need a map where you can simply use, like, Gray Angelo, for instance, lives in Peru. If you measure the subsolar point 1 minute to the next minute, it should go a fourth of a degree. Right? So all you have to do is measure that distance on real land. Then it travels in 1 minute. Excuse me. You see the distance travels in 1 minute, and then you'll get, a quarter of a degree of that circumference of that path. And yeah, that's real information. That's just, you multiply that by 1440, and you'll get divide that by 24. I don't know why I said it like that, but yeah, multiply it by 60, and you get its speed miles per hour.
Listen, you're roboting. I just thought of something awesome with this light thing. How can I stand in a shadow, right? If all this light's coming at my eye and I can see all this shit everywhere, how can I stand in a shadow and still see light? Shouldn't the light be filling up my shadow?
Dude, you're where Democ was 30 minutes ago. We were talking about this fucking an hour ago, dude.
I am pretty high right now.
Yeah, I know, but no, Democ, I don't know if you were here, but Democ was asking about that. He said, like, a house. He said, like, if the sun's on the back of the house and you're on the front of the house, and the sunlight and this house is blocking the sun. He had a different point, but he was asking about how you're receiving light. Well, the light that you're seeing is reflected light. It's not direct. It's not direct sunlight. It's light that bounces off other objects.
Well, there's also a difference, like I was trying to say at that point. There's a difference between sunlight and, like, what Brian Leakey was saying, daylight. Like, what seems to me is occurring is that the sun, likely through an electrostatic type effect, is activating the ionic gases in the upper layers, which create the blue sky. So once that, sort of like a fluorescent light bulb, so once those gases are ignited, you get all that blue sky. And the blue sky is what's causing a lot of the daylight that we experience. The sun, of course, is part of that as well. But I do think there's a difference between daylight and sunlight. So the blue sky type of light is lighting up the entire environment in addition to the sun. So you're going to get that lighting from the sky, which is just lighting up the entire environment, or from the blue sky. That's going to be lighting it up all the time.
It would otherwise be a hell of a coincidence that water vapor ionizes as white light, and nitrogen and oxygen are a whitish bluish light. It would be a hell of a coincidence that what we have down here is just happens to be the color of the sky, and then neon gases just happen to glow the same color as the in the same order, basically, of density as the damn same colors we see in the in the sky, day in and day out at sunrise or at sunset. It's a hell of a coincidence. There's a lot of coincidences when we're in this debate, man. It's crazy.
When have you ever seen ionized water vapor?
Look at my video on Flat Earth Test, man. He's got ionized water vapor. It glows white. You think I made it up, dude?
Yeah, if it's
we're not like you
like
guys,
glows white.
Kosho, we're not like you guys. We don't just make shit up. Shot
Yeah,
fired.
okay. Ionized water vapor, you said it glows white? You mean heated water vapor? Why would ionized water vapor have a color? Water
And
vapor
did
is
you just
invisible.
make that up? Don't make me look bad, bro. I just like berated him for telling him we don't make
white light, man. White light. White light. Look it up.
All right. I'm looking it up. I have like 14 tabs open for all of the shit I looked up in this conversation. Let's see. Ionized water vapor. Google's gonna be like 0 searches. Dallas David would always do that. He'd like type in these 2 random words that don't fit together, and then say, "Tell me why there's only 8 results in Google." Like, dude, I see 25 million results, man. But
But have you ever looked? Have you ever looked into those results though? Coach, you need to look at the dead internet theory. There's a part 1 and a part 2 to it. It's fucking great, bro. There's not even nearly as many results. You get 5 million results back, you might get 30, 40 pages worth, maybe 50. Tons of them are dead links that don't even work anymore. The whole internet's dead almost. There's more broken links.
Hey, you want to hear something funny? When I wanted to look up, can you compress water? It kept giving me vague fucking answers. But when I went to put it in, I was wondering because one of the key questions that came up is, can you compress water? Yes or no? Like we can't get a straight answer out of the Globers. We can't even get a straight answer out of Google. You got to ask, can you compress water? Yes or fucking no, Google? That was one of the key searches. Yes or no.
Well, my water stick kills them for the you know that thought. Go ahead, Coach.
No, go ahead. Just said no, you can't. But go ahead.
You can't compress water. Okay. So you remember that thought experiment with the stick from the sun to Earth, with 2 people pushing or pulling on it? Yeah. So if you have a stick of water, water's filled in the stick, right? It can't compress. What's going to happen with the stick now?
Vibrating is not compressing, man.
Bro, 2 people are pushing the stick. What's going to happen? Are they going to feel it instantly? It's a stick filled with water. Or 2 people, the whole stick's water. There's just a little thin layer on the end to hold the water in, all around to hold the water in.
Yeah, I'm just imagining this fake thing. Yeah, gotcha.
Yeah, picture
Not only that, you
solid.
can't have water on a neutron star if a teaspoon weighs 10 billion tons and you can't even compress water. It's
There's
just a
not
big
water on
contradiction,
neutron
man.
stars, man. There's no water on a neutron star.
It's ionized water. I'm sure it's ionized.
The point is, you can't even compress half this shit, water, and they're talking about a teaspoon weighs. I would said that not so you could say there's no water on neutron stars. For you to think how
teaspoon of
ridiculous
neutron star.
this claim is, bro. There's no fucking neutron stars, dude. You're gullible. You're naive,
a
bro.
teaspoon of neutron star water.
Are there
Quantum
neutrons?
compression.
Bro, they were trying to come up with anything to give
I'm asking you, Brian, I'm asking you, are there neutrons? Are
When
there
they
neutrons?
say that
Brian,
hold on, when they say that what?
Go on a rant, dude. I'm trying to respond to what you just said. I said, are there neutrons? The neutrons exist.
There's a fucking, there's the model with electrons and fucking and positive neutrons. Yeah, it's a part of the model. It works
No, they're
good.
not
Yeah,
positive.
fine.
They're specifically called neutrons because they're not positive. They're actually neutral. Okay. So
Okay, as soon as they come in contact with an electron, then what are they?
still neutral. Yeah. So that's why protons and
I learned
electrons
something new.
they have some sort of interaction with each other, and that's why the electron stays around the nucleus of the atom, but the neutron doesn't have a reaction with them outside of like a gravitational reaction. That's why that's why
Suppose it
that's
gives
why
off the
neutron
electron
stars.
and becomes positive. That's what I thought.
Yeah,
I
that's
thought
why
I
neutron
thought
stars are. That's why neutron stars are so heavy. Is because they don't have all that empty space like atoms have. It's just a what do you call it? Dense. It's extremely
Bullshit.
dense material.
Yeah, but listen, Kosho, when they come up with and said that dark matter and dark energy are like 95% or 96 whatever percent of the universe, that's counting all the black holes. That's counting all the neutron stars. That's counting all the theoretical crap made up more matter than the planets that they claim that we see and all that. They had to, and even with all this fantastical fucking mega gravity, they still come up short fucking like 90 something percent. Bro, the model is busted. Gravity is not how that shit works up there. I'm sorry to tell you, bro. And I thought the fucking, like in batteries, the neutrons come in contact with the electrons, and the electrons shed, giving us electricity, and then the neutrons become positive, I thought. But maybe, I guess
That's a common misconception that almost nobody else has. But no, it's not how batteries work.
Nobody else has.
Or how neutrons.
So they're not saying that they're giving off the batteries, from the fucking breaking down of the cathode and shit, giving off
But
electrons.
that's a chemical reaction. That's a chemical reaction.
That's
Neutrons.
photovoltaic.
Yeah, that doesn't have to do with neutrons though. But Neutrons are unstable outside of the nucleus, so they decay into a proton and an electron. That's true. And it's also true that if you have enough mass, there's enough pressure to overcome the electrostatic force between the, not electrostatic, but electromagnetic force between the proton and the electron. And so it squeezes them together and basically fuses them into a neutron. Both those things are true. And the latter example I gave, that's what causes neutron stars, is the protons and electrons can't overcome the
that cold
repulsion
fusion.
or their,
Are you describing cold fusion?
their attraction. No, I'm not describing cold fusion.
Neutron stars.
Let me ask you a question.
Yeah, man.
Because I got a good question, Kosho, man. So on one of these super dense stars, okay, so let's say hypothetically we were to go to them. So with all this gravity, so if I went on it with whatever didn't melt or whatever, I mean, I wouldn't get crushed because I'd be super buoyant, wouldn't I? I mean, if there's all that super gravity, then there'd be super buoyancy, wouldn't there?
Wait, hold on. There's a baby around me. I have nothing to do. Say it again.
You're saying shit would weigh. You're saying shit would weigh fucking 80 million tons for a teaspoon, but that's not true because shit would be super fucking buoyant.
No, that's
if,
the contents. The contents of the planet would weigh that much. You would be crushed because you're the amount of gravitation.
Crypto thing.
I didn't talk about this fucking argument, dude, because you definitely did fuck up in the argument.
No,
I was like, yeah, you did.
I didn't fuck up in our. I wasn't even paying attention.
Yeah, apparently, Jeremy, you're not capable of dual tasking, so you might want to focus on one or the other.
Fucking bastard! What were we talking about? Oh, I know where you. I know where you detected them at. They do it way underground, in these little
pools,
way deep underground. They can have they get hits on what is it? Some kind of sensor thing?
Yeah.
What's the sensor they use?
I don't know. They're in pools, and I think they is it something like mesons or something like that? I don't know. I thought you said
Muon.
they get detected.
Muon.
I knew where they did it. I didn't know what they used it to detect them with.
Yeah, I forget. It's a byproduct of something else. But yeah, so yeah, you know they exist too. That's cool. Both know
Just
they
lost
exist.
$4.
Hey Jeremy,
$8.
give me $10 million. I'll detect anything you want, buddy.
I know, right? Yeah. Well, I mean, they got to be doing something. They got to be getting hits on something. I mean,
yeah, sure. I have a picture of the sun taken through the Earth from the neutron stars.
That's
from the neutrinos. I mean, from the neutrinos.
Can you track it the
They
whole?
use
Can you
neutrinos.
track? Can you track it the whole way around?
What does that mean?
I mean, you have a picture of it underneath the Earth, right? You're looking down, and you have a picture of the sun, right?
Yep.
Can you do so 180 or sorry, that's 180 degrees down. So can you do it at 270, 90, 0?
Yeah. I mean, if you were kind of cool, yes, yeah. I mean, I guess.
Well,
But it would be that
that'd really
spectacular.
be something, bro. That would prove that the sun's going on. What do you mean that wouldn't be spectacular? I don't know
Well,
what
I
you're
mean, if
taking
it
a picture of
can
now,
go,
but
if it can go all the way through the Earth, all the way through the entire planet, then it can go through any shorter distance through the planet.
The thing is, how do we know? If we don't have video, though, how do we know that what we're looking at is a picture of the sun and not just something else?
Because it's midnight and the sun is directly the direction this fucking object is coming from that looks like the sun.
Bro, it don't even make it to the bottom of the ocean, bro. It don't even.
So can they follow it through or what? Like they should have video of this following it through all the way around 360. That'd
He
fucking do it
believes
right
everything, Jeremy. He's fucking naive.
That doesn't
man.
even make sense, man.
there. Kosho, if we have the sun, hold on, Brian. Kosho, if we have the sun doing a 360 degree circle, and at one point it's underneath us. You don't think that would do anything for your guys' side? What are you
That's what I'm
nuts?
saying. You can easily, dude. When the sun is up at noon, it's right above you. At 6 o'clock at night into the morning, it's on the horizon, and then at midnight, it should be right below your feet. And when you use these detectors to look at what's right below your feet, it happens to be the sun. So yeah, you can do it 360 degrees.
No, but can you do this neutrino thing 360 degrees in video form? Is what I'm saying.
Basically, I think he wants like a little slideshow of the neutrino.
No, I want. No, hold on. I want a video of this. You can look down, take a picture. You can look to the left, take a picture. Right, take a picture. Just do the whole circle, and that'll wrap it up. We can all go home after that.
Yeah, the thing is, I think it's a collection of. It's not from a single day. I don't think. It's so that they have to do it over a period of time. But I'm guessing it could be done, but I don't know exactly how they the nature of how they collect how they collect all that data. I know that the picture I've seen, I thought it was from a single day, but it was from a long series of receiving these things. So
All right.
it might be the case that they have to point it in a specific direction.
So these neutrinos, they come from light, or like why is there more neutrinos coming from light than off my hand? Like, where's the neutrinos even coming from?
Coming off light? No, it doesn't come from light.
I don't know. Why can you see the sun through the thing, through Earth?
Because the sun is emitting. It's not just emitting light.
Emitting
So we're saying about
neutrinos.
cosmic rays. Yeah, it's emitting cosmic rays, particles,
Everything across the
electrons.
spectrum. All the spectrum. Gamma rays, X-rays, all of it. Infrared.
So neutrinos come from
And
everywhere? Bro, where's the fucking neutrino come from, bro?
Yeah, where's
Nuclear
neutrino on the
reactions,
on the,
because
on the
neutrinos
light?
actually can be generated in nuclear reactors too.
So neutrinos come from nuclear reactors and the sun, and what else? All light? I mean, do they come from a light bulb?
I said it's not from light. It's not that it comes from light. It comes from. I know that there's a specific, like decay. I think it might possibly come from. Like I forget which decay, but it comes from. There's
Come
different
from the
decays that
straw. I'm
neutrinos
sorry.
now
Come from
come.
the weak force. The weak force. Thank you.
It's just another way for them to make the ether into particles. Call them neutrinos.
Yeah, I think through fusion. I think fusion actually is another one of the products that the sun is doing fusion all the time. So if it's doing fusion, and energy is is part of the result, and I think also neutrinos are part of the result.
Yes.
And obviously, the new particle is part of the result. But there's other ways. It comes from it comes from a decay process as well. I forget which one, but all that stuff. But from the sun specifically, if it's doing fusion constantly, then then that's what you're going to receive is neutrinos, because that's what it's doing is fusion.
I just got on the Avalanche network. I'm about to get on Solana and the Harmony chain tomorrow.
You're about to get some salami.
The Solana chain and the Harmony chain.
I was thinking about getting Solana myself.
I got on Phantom and Avalanche. I'm spreading my wings out. All right, you got to branch out in this. You can't just stick to one thing and think that's going to work out good for you. You got to be diversified.
I bet you're doing pretty good on yours.
Bro, I cashed out today. I cash out every Friday. I cashed out $700 today.
Nice.
Just for my that's all passive profits. That's not like I didn't make no trades or nothing. Well, I mean, I sold the things. I didn't trade to get that money. Like that shit all ticked in passively, except for this one video game I played. It only takes a few minutes that I just fucked up on because I'm talking about Kosho about bullshit. Fucking
Hey,
neutrinos
asshole! What
and
was that?
shit.
What was that DM you sent me? It was all this fucking sloppy, fucking looked like he wrote it on crayon and then typed it out. I didn't understand what it was, man.
I put $188 into this thing, and one day I made $9 passively off it.
Wow, dude, you got $9 from only 188? That's crazy. A whole $9 from 188. That's insane.
Don't patronize me. And those
Yeah, I get it,
$9
though.
add up.
No, we're not
Drop-
doing that, Jeremy. We're not patronizing you at all. Don't worry.
Drops fill. I feel like that was patronized. Listen, all the drops fill the bucket, guys. You can't have a bucket of water without all the drops.
Yeah, you're right, man.
Entirely, a bucket of water is made up entirely of drops of water.
And once you have that bucket of water, man, you're made. Hey, but for real though, what's got me?
Made of neutrinos.
Listen, everyone's dripping. I'm trying to make me a puddle.
What Scott Beach was saying about a 2% daily. If you compound that, dude, that's actually a great deal of money. But you're not even compounding it, man.
No, I've been compounding. I've been compounding mine. I've been compounding it.
If I'm actually interested in that, I heard somebody talk about that. I don't know what that's about, but I would like to be on that.
Yeah, and if you do it the way Scott was saying it, you could do it if you spend the 30 minutes to pull it out and put it back in.
I don't think Veach.
You double up every 30 days.
I don't think Veach is accurate on how much he can get into and get out of that coin for. There's a tax on the coin itself. Now, he may be right and I could be wrong, or I'm right and he's wrong. But I'm pretty sure there's a tax on that coin, meaning every time you buy or sell that coin, they take like a little percentage. Like you're not going to get into it and out of it for $1 every time. I don't think it's going to be worth it.
Yeah, I know. He was saying it's like a convoluted mess, and he wouldn't believe it either if it wasn't true. And he was saying that it's so convoluted, that's probably why it's able to exist. And I mean, if he's saying this, I gotta look at what he's saying and check it out myself. But if he's right, dude, then you're crazy for not doing it correctly. Because like I said, you could be doubling up every 30 days. If it's 2%, if it's more than that, even more. But
well, I mean, I just keep it anyways. So
60 days.
I keep the coin anyways and compound it. So whatever. I mean,
yeah, but if you pull it out, put it back in, you do two things. You don't have any of the risk at all, and you also have you're compounding it, every time. And then you can pull it out at the end of those 30 days. Just pull out exactly half, or don't pull it out. And 60 days, you'll get 4 times. Another 30 days, and you'll get 8 times. It'll grow exponentially.
it's 10%, bro. I just asked him in the Telegram chat. The slippage is 10% every time you buy and sell. It's 10%. You're not getting out of that. So if you buy it, you're losing 10% of your money. If you sell it, you're losing 10. It's not worth it.
He said he found a way to get out of it.
Bro, he can get into the Binance chain for $1. He can get his money in and out of Binance for $1. He can't get in and out of this coin for $1. I'm telling you, bro. I just asked him in a Telegram chat. If he can, I mean, that's God bless him. But you're better off just holding the coin because there's a 10% tax every time you buy and sell. But who was that extremist that's asking about the?
Yes.
Yeah, DM me if you want the details on how to get in. I'll
Which
walk you
one is
through
it?
it. It's called Spaceport Universe.
Okay. Is that the game thing?
It's on the Binance Smart Chain. It's a game you play, and every day they let you earn up to 2% of the amount of coins you're holding. So I got like, I don't know, $400 worth. I get like $8 a day, which I just fucked up on today because of Kosho and his bullshit neutrinos.
Way to go, Kosho. Good job.
Yeah, thank you. I do my best, man, and I'd be doing even better too if I had full access of your accounts, Jeremy, I can make you lose even more on purpose.
Hell no.
No.
700
but
bucks today, bro.
that's what's up, man. I'm happy for you, dude. My girlfriend gave me $300 last night for no reason, and
Bro, I'll get you $3 a day off that right now, bro. I just
I
put
get more.
I just dropped $200 into Avalanche. I'm getting $2 a day off it.
I'm gonna talk to Scott Veach again, dude, because he's saying that this is compounded. I mean, he's saying that you can pull the whole thing out. If you can pull the whole thing out in one day and win everything that you're winning everything that you took out, right? Then you just
Listen,
put that in, you make more.
I'm telling you right now, if you buy or sell, every time you buy or sell, they charge you 10% tax, which means that shit's gone. So if you buy 1,000,
Under your feet, then right above you has to be 0.
has to be. Oh yeah. So what is it? 270?
No,
What's
it's
directly
180.
underneath it? Is it 180? Listen, it's not important. It's not important. The point is, the point.
Jesus, Jeremy.
The sun under. I don't care what the numbers are. Having the sun underneath us. I have to get my math guys on this. It's not crucial. The point is though, the sun underneath us. I mean, absolutely demolishes a flat Earth. I mean, I'd be befuddled at this.
Like I said, Jeremy, first make them show you a picture of the sun above them, a mile underneath the ocean. If they couldn't produce a picture of the sun from a mile deep in the ocean, which they can't, how the fuck are they going to claim of getting a picture of the sun at 270? Insanity.
They got it right there. I'm looking at it right now. I mean,
you almost never see the ground, especially in the distance. You see haze. Now,
yeah, it's a haze. They actually hold on real quick. When we go up high, we see the horizon. They say we would see on a flat Earth at just that haze line. Anyways,
right.
Go ahead. I didn't want to.
Yeah, which, by the way, haze is not ground. So a horizon is something, well, it's basically just what seems to be a line from something lower meeting something higher at a vanishing point. Or I guess maybe when you're on the ground, it would be where the limit of your vision of the ground meets the sky. I mean, I don't think that we see a horizon, so to speak, from high altitude. I think we see haze that is below us, right? That is conforming to perspective. And there is, they say that the horizon meets to eye level. Well, yeah, if you have something to look at, because the higher up you go, you're increasing that gap between you and the closest reflective object. So there's going to be a slight lowering of that supposed middle point of your eye. The horizon is going to be just a little bit.
The horizontal is from the heat Felix Baumgartner jump to be able to tell that the horizon's not 6 degrees below it.
Well, if you look at the fucking capsule's hanging like a pendulum from the ground, and just mark where the horizon is on the ground.
Swinging like a pendulum.
It's the same camera. It's no, it ain't swinging. It's more stable than you can
Yeah, it's
believe.
not swinging. It's steady.
Yeah, once you get up over the wind, it's steadier than you would think. Go look at the footage. I couldn't believe how fucking steady it was.
It's not steady enough for you to say that somewhere that you're looking out, like you'd be able to discern where the eye level is.
Well, let's say this: when he sits down in the fucking seat, and you could mark the horizon from the ground. They show the capsule level hanging from a pendulum. Okay, him sitting there, and then him sitting in the same exact spot. Opening the capsule basically at altitude. I mean, the same as him getting in and closing the capsule door. Then they show him opening it at 128,000 feet, and the horizon's in the same damn spot. So maybe you can say it's moving around
right there in the middle.
Yeah, but you're assuming that he's at, well, if let's say on the ground it was level, whether it was or not. You're saying where he was at that point that you're talking about, he was at exactly the same orientation.
Well, at the highest point, just before he's exiting the capsule, it's I mean, the camera, it's very steady, and the camera's plumb with the horizon. I mean, it's right there in the middle. It's really hard to refuse, man. To be honest, you need to go watch the footage again.
I mean, I would be impressed if you would have some sort of mechanism to see where the eye level was, but there isn't a mechanism to do that without some tool. You can't just tell
Yeah,
that.
look at you
if he
just
was
being a
if he was in the
contrarian
ground,
without actually looking
if he
into
was
it.
in the, if
Look
you
at
no,
you,
because I'm doing tests like
very
this. I have to
disingenuous.
say, think about these things. If you're on the
No,
ground,
we do think about it. You're
if
being very
you're on the ground,
disingenuous right now.
if you're on the ground, your orientation is going to be dictated by the bottom part of your craft, and wherever you are, wherever your camera is. If your camera's in the same position, but you're not on the ground anymore, and you're in a balloon hanging from a rope, the balloon hanging from the rope is going to have you oriented a different way. If it was perfectly steady, which is not going to be
on the
perfectly
ground.
steady.
Yeah, I'm losing some respect for you, Kosha, right now.
The capsule's hanging from a rope on the ground too. It's sitting there. The crane has got a rope hanging from it, and the capsule's at the bottom of the rope. So even on the ground, it's not on the ground. It's up about 10, 15 feet in the sky. It's hanging from a pendulum at the ground, and then when you get up in the sky, it's hanging from the string, fucking from the balloon. It's always hanging from the string. It's not sitting on the ground. So good, nice try though.
Yeah, and in both cases, you're saying that it's perfectly steady, even though it's obviously not.
It's 100% perfectly steady.
Yeah, but that's what I'm saying. It would have to be perfectly steady for you to be able to make this claim.
It
Yeah,
is
at the
perfectly
highest
steady,
at
bro.
the
Look
highest
at
point,
it.
it's just plumb sitting there.
Let's see. I'm gonna go to the Fizz Baumgartner's video right now and see if it's perfectly steady or if it's moving. But every balloon footage from any balloon ever is never steady. You can't get a steady shot for
Only when they get up above
more
the
than half a
atmosphere,
second.
when they get up into the black, they all get steady. That's the
And
part I
you
look forward to.
All
Is
right,
when
well,
they
I'm gonna go to his. I'm gonna go to that
And
specific
you know
video.
why? You know why it's not steady in balloon footage, Kosho? It's because the hardware is very light. They have to make everything very light in order to get a cheap balloon launch. But this was not a cheap balloon launch. They can have enough gas to take heavy objects up there, and so it was sitting up there plumb and steady because it was solid.
I'm going to the video right now. Hold on.
Actually, it was pretty good, Riggs. I can't believe you guys were debating when he jumped over Planet New Mexico. Nothing was accurate about that. That guy's been accused of being a fraud before. That Baumgartner guy faking things.
Before we move on too much, Riggs, while I appreciate your explanation, I remain unconvinced. I understand you have haze because the light's not there's an atmosphere to reflect the light, but wouldn't you expect that haze would just be a straight line, just like the horizon?
Well, sometimes the haze is. Well, you have to understand that light has extinction. So even if there was, even if it was right in front of you, you still might not be able to see it because it extincts after a certain distance.
Percentage. The reason I told you is why you would expect it to be curving, because as you come up off a circle, your circle of vision, that circle of vision would start to curve as you came up off it.
Why?
That's because that's what happens when you make a circle out of something. Get a hula hoop, put some Pepsi cans around you in a circle at whatever distance, and put the camera at the center point, at the radius, and then go up with the camera, and you'll be able to see that it's curving.
Yeah, but that's
It's
probably
soda
just
can.
due to circle of vision wouldn't really apply to that because, again, the horizon's an apparent phenomenon. It's it depends on your observation, and it's a horizontal circle of vision, right? It's always going to be horizontal from the observer. For
if you were on the ground,
curvature that you see, maybe it's barrel distortion, but you wouldn't expect it with just the circle of vision. I don't think.
Yeah, I would because listen, if you see in a circle of vision, it's a circle. You're seeing in a circle around you turn 360 degrees, you can see in a whole circle, right? As you come up off a circle, Like get a hula hoop.
No, but it's not a physical circle. It's the circle that ends on the observer. So if you as you come up, that circle of vision comes up.
The circle of vision gets wider. You can see more farther.
I don't
know.
know.
Yeah,
you're not
Maybe
you're not
a little bit
accounting
wider.
for light extinction, and you're also not accounting for the gap of empty space that you're creating there. Like if this were a video game and you could see forever, then yeah, it would probably jump up to the middle of your camera. But that's just not how shit works. You can only see so far.
I'm telling you, it would be curved just based on your circle of vision coming up off of that. That's my idea, anyways. Like I said, me and Brandon, we did it, and it did.
I mean, I don't know what to tell you. I think maybe it's like whatever you were using, you have barrel distortion or something like that, and maybe that becomes more apparent, or I don't know. But in terms of just like your horizon, you wouldn't expect that it would just start curving. Even in light extinction, like that, there's less atmosphere, right? So you should be able to see clearer, but because there's less atmosphere, there's less reflecting, so it's going to be blurrier, basically, right? But it does that shouldn't introduce
what I would like to
curvature.
see. What I would like to see is infrared at the same altitude.
That would be good.
Quite often. I'd love to see what it looks like in many different scenarios.
How come no one sent an infrared? How come no one sent an infrared camera up on a high altitude one yet?
There's this one guy who set up a few different cameras, but he didn't set up infrared.
Percent.
What?
What's up?
What shape would you see the horizon as, if not curved?
It's going to be horizontal, man. What do you mean?
That's what. See, in both models, I see it as possibly being horizontal, but you spin around and you see that same horizontal. You have to understand that it's slightly curving 360. But
no,
the horizon drop is a thing. Not that it might not be explainable by different variable on flat Earth, but the horizon drop is what they look for in the globe. I think they say it'd be a circle in both, though. Thank you.
When you said like you go around 360 degrees, you expect that there's like curvature. No, not at all, because that's not how the horizon works. Yeah, the horizon's
percentage.
360 degrees
I have a
around
question
you,
when you're done.
but it's an optical phenomenon. Go ahead.
I feel you.
Okay, so at the ground level, the ground basically let's assume that like 6 feet is nothing, right? So if you're looking out, the ground is going to come up to the middle of your vision, right? And then the sky is very, it's very tall. It's going to fill in the rest of the space, the other half of your vision, right?
Mm-hmm.
Okay. So when you're at 120,000 feet, and you're looking straight out, where are you going to put 120,000 feet compressed into the bottom part of your vision? How are you going to fit that in between the ground and your eyes?
Well, I don't think you would be seeing 120,000 feet's worth of like distance.
I agree with you. I agree with you. I think that what we see is light reflecting off of haze and clouds about 80,000 feet below you. Okay, so what are we going to do with that other 80,000 feet? Where's that going to fit in below the middle of your eye level? Where's that going to fit in?
It probably wouldn't be visible.
There you go. That's why the line drops.
No, but hold up. That doesn't mean that the clouds are now like that. There's curvature. I agree with you. The new horizon.
I'm not saying it's curvature. I'm saying that when you look down in all directions, you can carve out a circle of vision because there's nothing in front of you and everything you're looking at is below you.
I don't think so. I think the light would still reflect off of the atmosphere that you have, but basically the clouds would kind of like become kind of your ground,
Just think about it some more, man. Like you just agreed to everything I said, so I know you'll get there.
Hey, think about this one time. Take a look at that. Picture
good.
looking through an auto level, and you're 20 foot off the ground. So the crosshairs and way off in the distance are going to be showing 20 foot off the ground. It's going to be a little smaller, but so as you rise up, the horizon doesn't rise to eye level, but it does rise up with you. So when you get up to a mile and you're looking through an auto level, the crosshairs out in the distance are going to reflect 1 mile. The crosshairs are going to be 1 mile above the ground. It's going to get a little bigger. You will see a little further, but as the atmosphere starts to get hazier, you're not seeing as far, so it's going to drop some. It's so if you're 50 miles up and you're looking through an auto level, then out in the distance is you're going to have to see enough distance to compress that 50 miles, and it doesn't happen. You can't see through that much atmosphere. It catches up at about I don't know 60, 70,000 feet. It starts catching up, and I mean I don't know, man.
I don't think you guys have adequately explained why there would be a curvature from like the outline of the clouds or what have you.
No. It's not curvature. It's
It looks
literally
like curvature.
that
That's what you guys
everything.
said, right?
It would appear to be curvature because you're looking down and everything you're looking at is below you, and because your vision is a circle, you can only see a limit of the circle in vision around you below you.
You see the limit of because your horizon is still at your eye level. The only difference is instead of seeing sky, it's going to be black now.
But there's 80,000 feet of stuff that's not in front of you. So there's not going to be a horizon line. That's what I was saying. There's no such thing as a horizon at that altitude because you can't even see the ground.
I disagree, man. I think
and
you'd
you're
be above the
80,000
clouds.
feet from anything that would create something below you.
Yeah,
clouds
I
aren't
disagree.
always
I think
there,
you'd be
though.
above the clouds. The clouds would basically be part of your ground now, and
The clouds aren't always
you'd
there.
still have a
angles.
horizon where that mixes in with at the horizon point or the vanishing point, you'll have the black of the thin atmosphere or what have you, and there'll be like a haze in between. That's my opinion.
The clouds aren't
You guys have
always there, though.
visualization.
The
I'm with
clouds
you.
aren't
If the
always
clouds aren't there, then you're just going to see the sky, like the ground underneath. It's just going to be very blurry because of all
the
the
clouds
atmosphere.
aren't always there. And I would like to. I mean, I wish we knew more about these launches, man. There are a couple videos, I believe, that the clouds are not always there. But even then, I'm not sure they reach the same altitude, and I'm not sure they use the cameras that we would prefer. It's kind of hard to find exactly what you're looking for.
Yeah, but even if the clouds aren't there, you just see very washed out ground or water or whatever you're above, right? Like there is a ground per se, in terms of a horizon.
Yeah, absolutely. There is a ground somewhere. But if we're being honest, like the cloud layer, and the haze layer could be 50,000 feet up, and we're not looking at the ground. And the definition, if we're going to stick to the definition, then ground meeting sky is not. If we're in the sky medium, then it's kind of changes what you're looking at.
Hold on. Not only that. Hold on a second, guys. Not only that, you could be looking to the right of you, and the clouds could be 20,000 feet high or 30,000 feet high, and you could be looking to the left of you, and they could be 60,000 feet high. The clouds, you guys don't even know how high the highest clouds go. I'm just saying it could be off centered, and it might not even be an even cloud layer above the surface of the Earth.
Absolutely.
Yeah.
So the wording, I would agree isn't accurate. The wording
Bro,
should
you're
be
next.
instead of. Sorry, go ahead. I got some. It's busy here.
All right, go ahead.
Well,
Merle.
just when you're in the upper atmosphere looking down, you're not necessarily looking at the ground when you're looking at the cloud band. You're looking to the cloud band, right? So it's just a language thing. But you explained it well, Rick.
Yeah, I just want to say, in terms of the wording, I would say instead of using where the ground meets the sky, like in this instance, that that shows that wording is incorrect. It's better to say where what's below your eye level meets what's above your eye level. That's what the horizon.
Well, and then that's just not good enough for a definition. Then that's just perspective.
But that's what the horizon is. It's based off of perspective. It's based off of the observer. It's literally an optical phenomenon. It doesn't exist if you don't have eyes.
So what I'm saying is that the point of saying horizon is to indicate that there's a sharp distinction between what you can see on the ground and what merges from the sky. But in this scenario, especially when you're let's say you're a pilot, right? And I don't know if RC Meisty is still on the server, but or I always say she because I think I have my own conspiracies, but he he yeah. Anyways, this is why they have like horizon indicators. It's called an artificial horizon because they can't see anything. Let's say if you're flying a plane and you're literally flying in the clouds, there is no horizon. You see where I'm going with this?
Mm-hmm.
Yeah. So the idea of a that's no different than being in a high altitude balloon.
You cut out in the
'Cause you
middle
can't-
of that.
Yeah.
Oh.
So the idea of a horizon.
Yeah. So what I'm saying is that horizon's really only useful like if you're close to the ground at a sharp angle, but when you create that space, it kind of loses its definition, and that's why they have artificial horizons in planes, because if you're in a bunch of haze, you don't have a horizon. It's not useful. There's no such thing.
Yeah, but we're not talking about the usefulness or the applicability of it. We're just talking about whether or not
what's the point of calling it a
while.
horizon if it's not accurate and it doesn't serve any definition?
What do you mean? It's still accurate. Like, when you're in the
No,
clouds,
if you're
your
at a high
horizon is
altitude
obstructed by
where-
clouds. But there's still a horizon, there would be if it wasn't obstructed. But we're not talking about how useful it is when you're flying. We're talking about whether or not, as you go up,
What I'm
it
saying
curves.
is that when you're at a high altitude, the usefulness of calling something a horizon disappears. It doesn't meet the definition. So all you can really call it is perspective, which already has the definition.
Okay. I mean, I fail to see the relevance of that, but okay.
Like, it fits within the definition of perspective, but it doesn't fit within the definition of what a horizon should be.
Regardless of what you want to define it as, we're just talking about like whether or not this straight line on like the surface or close to the surface turns into a curved line as we're going up, right? That's what Jeremy was saying. It's like, that you would expect that it looks like a curved line, and I don't think it does. I haven't been convinced.
Let me ask you, if you're laying on the ground and you're looking straight up, where's your horizon?
You don't have one.
There you go. Thanks for playing.
What's the relevance of that?
It's never mind. I mean, I really believe in everything I said, but like just think about it some more, man, and then we can try again. Maybe I'll have something better to tell you.
All right.
I'm telling you right now, when we came up off of those circles of vision, like I said, we didn't expand the circles of vision as we went up to scale, which is what we should have done. But as you come up off a circle of vision, it starts to appear curved. You can set up some soda cans or a hula hoop, get a camera, put it in the middle, put it at the bottom in the middle. It'll look like a straight line, the horizon. As you come up off of it, though, the more you come up off it, the more it starts to curve.
Yeah, I mean, I'm not saying it's impossible, but the only thing that I can think of that would cause that would be like
Optical
some sort
phenomena.
of phenomenon. Yeah, some sort of phenomenon with all of the atmosphere somehow causing, this sort of effect. But
It's
I
a
don't
function
think
of distance, man. It's a function of distance, man. The atmosphere starts getting hazier. The higher you get, the further you'd be able to see if it wasn't for the atmosphere limiting your vision. So it starts dropping and looking around because your circle of sight.
No, what I meant was like some optical phenomenon that's somehow exaggerating barrel distortion, like exaggerating that effect in your lens or what have you, to make it seem like it's more curved. That's the only thing I can think of that,
Of horizons on airplanes, though, right?
I'm telling you right now, as we go up, as we get higher, you see exactly what I would expect to see on a flat Earth. The Globers even describe it like this, with the hazy line that fades out into a line of haze and not a crisp horizon. That's where we get that.
Of course there'd be a line of haze, absolutely, because that low atmosphere, which looks black basically, there's more and more atmosphere, and the atmosphere reflects the light, so it's gonna give you it's gonna be visible. But I don't think that line of haze is gonna be curving, unless it's like some sort of exaggerated barrel distortion.
It is, bro. We got footage from the balloons they send up. It's curving.
Hey, no, you're right.
lenses
You're
that have
right.
barrel
It's not
distortion.
curving. It's more of like a barrel property because you can't make a flat line look flat if it's below you.
Yeah, but I don't think. Again, I think the horizon rises to eye level, so maybe that's where the the differentiation is.
Just think about that. You cannot make a flat line look flat if it's below you, correct?
Let me think about that. I
Listen,
mean,
me
if
and
it's directly
Brandon did
below
this.
you, then you can.
I did
If
this.
you have a circle around you, like directly in the middle of your eye, and then you lower that hula hoop down to your hips, right? If it's at your eye, it looks flat. It looks flat all the way around. But if you lower that hula hoop, it looks like a circle, right? That's how your vision is.
But no, that's not how your vision is, because your vision isn't the
It
hula hoop. That's
absolutely
something
is.
physical. Your
You
vision,
no.
your horizon is
You're-
optical. It's
You have a
completely
limited
based on-
vision. You can only see so.
Listen, I was at work one night when Brandon was debating Mr. Sensible or whoever on the Mage 2 photo. And when I heard this going on and he was showing the horizon, how it was curving, I immediately thought of this, ran down to the break room, set a whole bunch of bottles up in a circle, and then did the thing with my camera where I took a picture at the bottom and then lifted it up, and you could tell that it was curving. And I sent it to him right away because it's just what you would expect to see. It would be your line of sight, your vision of sight curving down as you come up off a flat plane.
It depends on how high you are. So like if you're on a hula hoop, for example, and you can see it right in front of you, yeah, it'll be a straight line. And when it's down by your waist, yeah, you'll see the full half circle. But when you're as high as Felix Baumgartner, I think it's like 400 miles. So it's like a 2,000 mile circumference all around him
Did
is
you say
horizon.
400 miles?
A 400-mile radius, and so about a 2,500-mile circumference all the way around him, and his field of view.
But you have a
is
pre-model, right,
right-
Coach? You're talking
and
about
his
a
field of view-
pre-model that
hold
you.
on, sir. Hold on, man. And his field of view is probably I don't know, some small percentage that maybe even less than half. So he's not expected to see even. He's not
In
expected
this
to see even.
example, Coach, in this example, you already have a
Why would I,
size of
why
the
would I
earth,
respond
right?
to you if I can't even finish my first response?
Oh, you were not done? Holy shit! All right,
No, I was
sorry.
making my point. I was actually getting to what the point was.
Facts and figures.
Yeah, so the point is that you're only getting a small percentage of that hula hoop. You're not seeing a whole half of it as you would if it was at your waist. So there would probably be some curve, but it wouldn't be discernible, not without some measurement.
What?
Again,
What?
may I answer now? Again, on this example that you just gave, you have a pre-assumed size of the earth, right?
Yeah, that's what we're talking about here, man.
Well, why you have that?
We're talking about what you would expect to see on a ball the size of the Earth we think it is.
Not if it's bigger, right? You wouldn't see that.
You're right. If it was bigger, it would be much bigger, and you'd see some different things. But we're talking about the Earth that we live on, and we're using the globe model to find out what you would see.
I'm thinking about it.
All right.
Sorry, go ahead, Tyler.
No, it's okay. Go ahead.
I was gonna say, like, hold up.
Well, while we're waiting for percentage, I was going to say I was looking at the Felix Baumgartner footage, and yeah, it isn't steady. But go ahead, man.
Sorry about that. I got some noise here. But yeah, I'm thinking about it, and the more I think about it, like I think I understand what you guys are saying. I don't think it would be an effective barrel distortion. I think your horizon would still be rising to eye level, but because there's less atmosphere that is reflecting the light, basically what you think is the horizon, what you could actually see, will stay lower down, because basically the horizon would be somewhere above that haze, like where as you increase your altitude, it'll be like, more and more into the black of no atmosphere, right? But what you can actually see, what you think is the horizon, it wouldn't be the true horizon at that point, would be, where the ground is, or where all the haze is from the atmosphere, what's actually visible, right? And as you're going up, that's going to be in a circle, and it's gonna curve. Does that sound right to you guys?
Or you guys are looking way too in depth in this. I'm telling you, the circle of vision is going to curve as you go up off the floor. That's just how it works. It's a fact. I did it. Brandon did it.
Like I said, I think the horizon is still going to be at your eye level, the true horizon, right? But you're going to think the horizon's lower just because that light is going to be basically reflecting off of the stuff like below you more than it is above you. So it's going to be like an optical illusion wherein you think the horizon is lower, but it's actually a little bit higher.
It's if we could see forever, right? Which
Yeah,
we
Jeremy.
can't. What's up?
Well, no, I'll finish and then because I was gonna say something about what you said when you
Go
rise
ahead.
up how we see the curve. Well,
Yeah, go ahead.
yeah, at that point, if we're seeing curvature, that means that we're seeing the edge of what will be the Earth on this case.
No,
No,
you're
just the edge
seeing
of
the
your vision.
circle. Yeah, you're seeing
Mm.
the edge of your vision.
No, guys, you cannot see. No. Okay.
You can
All
only
right.
see
Let me
so
think
far,
about what
Sal.
you just said. Yes. Okay, I got it. You're saying you're gonna make a circle with your eye. Yes, your eye is gonna create the illusion of a circle, right?
Yeah.
Yep.
Even though your horizons are going to be it's going to be at your eye level, you won't actually see that actual, vanishing point of your horizon because
No, I'm saying
it's somewhere in the black of, or like in the haze of,
I'm saying this is an actual thing, and we're seeing it. It's not actually curving, but it's actually appearing to curve. Like
I'm with you.
All right.
Like I understand what you guys are, the explanation that you guys have. But I don't
Mine's
think
rock
it's your
solid.
actual
We
horizon.
checked it. My explanation is rock solid. There's no guesswork in it. We checked it. Me and Brandon did it. I did this while he was debating Mr. Sensible on the Mage 2 photo. So,
You're
and he
talking
did it
about.
that
Go ahead, man.
weekend. He did it later that weekend. He set up a giant one. I did it twice. He did it once with a giant one.
Yeah, but you're talking about. You said you did bottles around you, or bottles in a circle, right?
Yeah.
And how big was the circle?
Few feet.
Right, and how big was Brandon's?
Brandon did like a 25 or 50 foot. So he did some huge shit with string and stakes and shit.
Yeah, but like, what? So, what you say? 25 feet was that the radius or the circumference?
Bro, he did a huge circle. He went to the park, got some string, some stakes. He did
Yeah,
a
I know.
huge
But
one.
you got to compare the height above the circle with the circumference of the circle to see if you can compare the ratio to what you would expect with a.
Well, we don't know how far. Who cares? No, forget what we would expect. We don't know how far we're actually seeing, and you can never make out landmarks.
Yeah, but we do know how far the horizon is.
No, you don't, because we can't make out any landmarks to see where the horizon is.
Yeah, I know, but if you're trying to check what's going on in our model, you can just use the information our model already has to make determinations like that. So if you're
But
saying
we want to know
how
about
far-
reality.
Wrong.
if you're saying how far,
About
yeah, if you're
reality,
saying
though,
how far, if you're saying what the curve should be looking like, and you were wanting to use the distance to the horizon as the radius of the circumference of the horizon all the way around you, then you would use the information from our model to make that
Kosho, your distance to the horizon is never right. Black Swan. Booyah.
Yeah, you're not close to the water, nor are you near the surface. So you can use standard refraction.
No, your distance to the
probably
horizon
less
is
than
never right. Why would we use that shit? That shit don't even work.
It's almost always right when you're off the ground, man. You can show me any picture of anything off the ground, not over water, 100
If it
feet off
was
the ground or
always
far
right.
above, and it's always going to be correct.
If it was always right, why did Alberuni have to make an average and not get just an actual measurement?
Well, I mean, what does that have to do with anything? If he did an average,
You said it's always
and
right.
refraction would have made it wrong, then his average would have been always wrong. And it would have been wrong because of refraction.
No, if it's always right, then you don't. Then when you go up, you don't have an average anymore. You always have an actual position. That doesn't happen though. You still have an average.
Hey, you don't have an actual position. I'm saying you have you can use standard refraction. Is what I'm saying. He didn't have standard refraction.
Okay, if he used standard refraction every time, he still is not getting the same spot. There wouldn't be an
I
average.
mean, he didn't use standard refraction, but regardless,
Even if you were using the same formula every time with the same standard refraction numbers, it should be in the same spot.
yeah, once you're that high, the refraction tends to be pretty consistent.
show.
That's why they use standard refraction.
It's not though, because he still had an average.
Yeah, he didn't use standard refraction again, man, at
No,
all.
but even if he did, it wouldn't have mattered because those numbers of this don't change, and the position of the horizon does. You're not getting it, bro. Come on, catch up.
Well, I just challenged you and you didn't do the challenge, but I've challenged everybody.
Challenge me to what?
Oh yeah, Jeremy, you're running from a challenge, huh?
Challenge me to what?
Sorry, my internet just popped out. But
I
I
got disconnected.
yeah, no one's ever done the challenge, but I said take any picture from anything above, I don't know, I said 100 feet, but I'll just make it a couple hundred feet, and it's looking at the horizon, and I challenge you to find me one that is not going to be consistent with the curvature of the Earth plus standard refraction. The horizon's always going to be about where it's supposed to be, give or take a couple miles, but never, way out of range.
100 feet above sea level.
Yeah, not looking over the ocean, not looking over water either.
So over land, 100 feet up, not
At
looking
least.
over water. So what do we look at? Down a beach,
But
a coastline or something?
No, whatever you looking at a field. But you should know about what the elevation is. So, like, you could use an airplane, for example, because you would know that about what the elevation is. Yeah, but if you know about what the elevation is, you just do the curvature the equation for the geometric horizon and standard refraction. You're going to get roughly the correct answer. It's not going to be wildly inaccurate.
You're wildly inaccurate.
No, I mean I've done this with so many pictures. Even Felix Baumgartner's height. You look out, and of course you can't discern.
When he
exactly
jumped,
what
you're
looking
talking
at.
about Baumgartner when he jumped over Planet New Mexico.
Yeah, but I use that. Yeah, because even though you can't really see what there is, you can see that you can only see New Mexico, which is about that 400 miles that you're supposed to be able to see.
The sphere of New Mexico. You mean the sphere of New Mexico?
I mean, it's curving because he has like a fisheye lens or whatever, but regardless, the extent of the image.
So we're not seeing no Earth curve there.
I'm not saying anything about the curve of the Earth, man. I'm talking about what you can see, the distance of the horizon. And if all you can see is New Mexico, then it's consistent with that equation. Same thing with ISS and Planet Florida. There's a picture where you can see Florida and a little bit of I don't know, whatever's north of that, Alabama or whatever, Georgia. But yeah, it's consistent with the distance the horizon's supposed to be.
Hold on, man. Hold on. So the sun is half a degree, right? So at the height Felix Baumgartner was, the horizon's supposed to be downward angle 6 degrees, between 6 and 7, but I'll give you the benefit of the doubt, 6 degrees. So you should be able to fit 12 suns at half a degree each, 12 suns in that door of that capsule. Looking out, it had to be 12 suns lower. The horizon would be exactly 12 suns lower than it was at the ground. And it's exactly at the same place as it was at the ground, bro. You're desperate.
Yeah, I thought we already talked about this, man. Because I just said, well, I mean, it was in the middle of their conversation, but I say I was watching the videos, I was looking at it, and it's his thing is swaying when he's up there, so it's not steady. And then I'm trying to find the one where he's on the ground to see where it is in the frame, but it wouldn't matter. You're not able to discern where the where eye level is from the altitude, and then you're not able to tell if it's the same as what it was on the ground.
It's not swaying, bro. There's a good.
Well, it's not. I'm saying it's not steady. It's not steady.
When I took my footage, it was perfectly still. And maybe it starts swaying afterwards, but it's showing the horizon steady for like 15 seconds, bro. He's just sitting there, looking out. Same place it was on the ground, bro. It's not swaying the whole time.
Show me a still shot from the ground so I can see what I can see which one you're using. I'll show you the.
I'll
show you the
put my video. I'll post my video. It's pretty short.
Just watching this video. I gotta go back to it.
Misunderstanding of optics all day long, Kosho.
Right, I posted it. You see, it's not moving where I cut it out. You see, I drew a line on it and never moved the line. So you're gonna have to go through some of the video where the line just sitting on the screen. Because I put a line at the horizon when he's on the ground and I never moved it. I left that line for the whole video. So then when he opens that door, it's right in the same damn spot in the horizon and it's not moving, bro.
All right, I'm watching yours now.
I'm watching the video.
First of all, already at the beginning of the video where you drew the line, which is super thick, it's encompassing both the entire range of the swaying. That's what I'm saying. If that line wasn't there, you'd be able to see that the thing that when the dude's there is swaying. So I'm not sure where you decided the line to be at the beginning, but at the end it's not swaying as much as it was when the dude was in there, but it's also not steady. It's adjusting.
Well,
Like it's constantly going up and down. Let me see. Let me see.
Is that assertion based on something or just what you think is happening, Kosho?
Is that assertion based on something? I just said I was watching his video, so it's based on the fact I was watching his video. I just described exactly what was occurring, so it's probably based on the fact I was just watching his video and saw what he was showing me.
Think
And
about it
because,
like
I
this.
said, the bar is
Alright.
the bar is big enough to encompass the range of the swaying. You know, you can claim that it's not moving, but it is moving within that the range of that line, the thickness of that line.
Wait, are you saying that the red bar is big enough to account for what the drop on the horizon would be at that distance?
12 sun.
It's certainly big enough for you to not be able to discern the angle that it's where either it's steady or where it's changed.
Did you calculate this, or
can't make a
you're
price.
just saying it, Kosho?
Well, we can measure it right now. Let's go ahead and measure it.
No. Oh, so you haven't.
I can clearly see it moving. Okay, we can measure it, and we can see how much of the frame of the image that line is encompassing.
Think about it, Kosho. Could you hide a sun
Good job,
behind
Brian.
that line? Thank you, man. If you could hide a sun behind that line, then it would be 0.5 degrees, Kosho. You need 6 degrees of drop, bro. It's what your model dictates. So you're telling me, even if that line is enough to block the sun, which it isn't, you'd need 11 more of them, bro.
How would you be able to tell if that line can or can't block the sun?
Well, I'm judging the sun as 0.5 degrees. Okay, so that's 1/12.
Yeah, I know, but I'm saying in reference to that line, in that frame.
I'm just giving you something to judge it by. To me, it's probably taking up about a quarter of a degree, maybe. You know, I mean, I'd shit if it was enough to block the sun. I'd shit. That'd be me. It's taking up half a degree, but it still need to be 12 times bigger, bro.
You can't know that, not unless you know what the field of view of that camera is.
So you're not satisfied with.
There's no way to know what a half a degree is.
You're not
But you
satisfied
haven't done
when
the math, remember?
that pod was stationary.
No, there's no way to know unless you have the specs of the camera.
Oh, Kosho, but you haven't done the math either.
No, there's not math to do there. You don't know what the field of view or the zoom is on that camera. There's no way to tell what half a degree would be. We can tell how much it's taken up in the image, but you can't tell if it would be covering the sun or not.
Bro, you can't.
And how are you?
It's the same at the ground.
And how?
It's the same at the
Hold
ground,
on.
you know?
Let me ask him. Then how are you making assertions that line it would account for the missing drop?
No, I'm seeing how much of the actual image is taking up. That's what I was measuring. And I'm seeing how much of that jostling up and down the horizon's doing, because it's doing about the thickness of that line.
It's still jostling, dude. It's stationary, man. Quit bullshit.
I was gonna say that.
You're telling me at the beginning of the when he's going up and you just draw that line, you're telling me it's not moving at all.
Well, in the stationary, no, yeah. Hold on. Let me answer to him, Brian. In the ground, it wasn't moving, and when it's up there, there's no air to be rocking that thing. So I'm sorry, Kosho, but you're just wrong.
It's not air rocking it. First of all, there is air because it's floating. Second of all, it's not air rocking it. It's the fact that it's hanging from something, and it's moving upwards. It's constantly moving.
Yes.
Yes. When you're hanging on something and you're moving, you're not going to be steady. That's why if you were going to do a test like that, you would have to have something on your screen denoting like where eye level was, and then you could try to make a measure. And then you also have to know the field of view of your camera. And
Always excuses.
And then you can make a
like always.
You can make it. I mean, that's like I said. I'm doing a test exactly like this, in which I'm actually taking the steps to make sure that you know when it's level, and to make sure that you know whenever. I'm going to know the field of view of the camera and all that stuff. So I wouldn't do it without any of that information and then claim, it's either above or below, or above or matching the horizon. I would have to have measurements to show that.
As above, so below.
That's what he should name this video.
What we showed you, it's either a coincidence or dude, you're brainwashed, bro. I'm sorry, man. Still love you, but bro, there's no helping you, dude. No matter what we show you, right in front of your face, dude, you make up.
You drew the horizon with a thick line where it's clearly moving.
Bro, so if the line was thinner, you keep saying it's moving, dude. The most that capsule moves is when the crane first lets go of it. It nudges forward a fucking smidgen, bro. I couldn't believe how steady it was. I picked a spot where it was completely fucking steady. Okay, whether it's turning around in a circle, I've had to look back. I wasn't looking at that. I was looking out at the plumb. The vertical, the horizontal. Bro, you making desperate points. It's stationary as a motherfucker, dude. It's not tilting. You're acting like it's rocking, where it's tilting forward or tilting back. It's not. The horizon's steady.
Oh, I didn't say it was doing a super huge tilt. I said it's not steady. That's my point.
That horizon is not 6 degrees down, bro. I don't care. You could make excuses all you want. The horizon is not 6 degrees down. It's not 1 degree down. I'll give you 1 degree, but that's a stretch. It's not 6 degrees down.
That's what's crazy about what you're saying. is that it certainly is more than 3 degrees down, much more than 3 degrees down, and that's measurable
It's in the
by
same
everybody who
spot,
measures
dude.
anything from a third of that height. So there's no way to
In the
tell
same
how
spot
far
of the
down it
ground,
is.
bro.
There's no way to tell.
Maybe you can't tell how far down it is, but you can see that it's in the same damn spot as it was on the ground.
Let me see. I'm watching your video again. I'm trying to find.
Whoa.
I'm trying to find
Whoa.
I'm trying to find where you drew the horizon line.
You guys hear that? It's like bombs in the sky. Oof.
Who's shooting bombs?
I love how like trying to basically compete with the claims of the ball is treading the line of unverifiable like observations. It's like right at the line of not being able to discern, but apparently that's the best proof.
No, sir. Let's see if you were paying attention. I just said if you wanted to do this test and make this claim like he's making, or claim that it is lowering and, say how much is lowering, all you do is you take the steps to make sure you know where the eye level is, you know the field of view, and you know the zoom. This way you can tell actually where the horizon is in reference to eye level. Without any of that stuff, everything that is happening is just guesswork. So this is in lieu of having actual steps and making an actual measurement.
It would be a better
He
proof
just said
if
that
we
he said,
had an auto
he said
level
it
like
doesn't
the
even
Earth
look
is
like it's 1 degree below the eye level, and it's obviously
Hey, if we
much
had an
lower
auto
than 1
level
degree.
or a Godlight app, I agree, Trisha, it would be a better proof. But it's like this is just something y'all threw at us as glow proof. Everything y'all throw at us as glow proof, we shove it back down your throat with reality.
Who threw this at you as globe proof?
Dude, you see it all over the freaking news of Felix Baumgartner seeing a curvity Earth and all this shit. Oh, really? And then
Yeah.
we see, and then Jeff Bezos goes up, sees a curvity Earth, and we cram it all back down your throat with details. The devil's always in the details, bud. Remember that.
Us and me aren't the same people, man. So if the news says that, and then Neil deGrasse Tyson says you can't see it up there, it's flat. That's not you
Because of
saying that.
what
That's Neil
we
deGrasse
showed.
Tyson saying it. It wasn't
No,
me
he had to
showing
come
this
out with
to you.
that
That was
video.
the news.
Dude, that video was freaking when shit was more popular, and that was him smoothing shit over because we came out and showed that the horizon didn't change from the ground, so he had to say that. That was, what do you call it when you're smoothing something over, like housekeeping or whatever. He was housekeeping, man. He had to claim that because we proved that it wasn't curving.
Yeah, I think he was answering the question that I think a girl had asked him, some person in the audience. I don't think he was doing that just because the flat Earth claimed that. He was like answering people's questions, and somebody had said something about Felix Baumgartner.
Sure. I do think that he's prepared for these questions when he must know about these arguments though. They cannot let him go out there and speak without knowing the argument.
So if he's trying to,
yeah,
if he's trying to cover the Earth, cover the asses of NASA and people like that, and fight against flat Earth, why would he use the words that it's flat?
No, you missed the point. You missed the point. He had to say it that way because otherwise it will mean that they are wrong. So they have to say it that way. At that distance, the Earth looks flat. That covers their asses. But then again, we have people like you and other guys looking at bridges and claiming curvature, and I mean, it's ridiculous. It is ridiculous.
It's very ridiculous. It's ridiculous. I was giving a ride to a teenager earlier, sitting in the back, and I told him I was listening to these flat earthers and stuff. He said something about concave Earth, and then he said something about the simple proof. He's like, "Yeah, well, I know it's not flat because, even whenever it's like really early in the morning and the road's flat in front of you, there could be buildings or something, and you can only see half of them." I was like, "Yeah, that's true." He's like, "Yeah, as you get closer, you see all of them." Well, yeah, that's a good point, man. As a kid, saying this shit. So, say what you will, but
that's just misunderstanding how perspective compresses things bottom up.
Yeah, but it doesn't.
So it gives you the illusion that it's disappearing bottom up, and people who has no critical thinking just, oh, it's obstructed by something. It must be Earth.
Let's use your logic. If you're on a flat Earth, and there's buildings in front of you, and perspective, and the Earth is, and the road's flat too, so there's not hills or anything, and perspective is going to cause what you see. You're claiming that the bottom part of the building, the part of the building that you're closer to, is going to be compressed compared to the top of the building, which you're further away from.
Mm-hmm.
Are you kidding me? Are you kidding me? Look, this is what you're saying. What he's saying is that if you're 10 foot above Lake Michigan and you hold up an 11-foot piece of cardboard and you travel to 60 miles, then it'll never block the building. But on a flat Earth, you wind up at the bottom of the building.
I didn't say
with
that.
the cardboard pressed up against it at 11 foot high.
I didn't say that at all.
Cardboard would never block
halfway.
the buildings off the distance.
So,
I told you specifically. I said it would. I don't know where. That's what he told you.
See, the top part, like the sky, is not. You're not closer. Well, you're closer to the ground, right? So, as we know, the ground rises to your center of your eye level, and then the sky goes down, right? So, and they meet at the center. Okay.
Well, what's
Once
above your eye level?
Huh?
I said, yeah. What's above your eye level will compress to.
You don't see it compressed. That's what I was gonna explain to you.
I may converge, but I'm saying I'm agreeing with you, but I'm saying they converge at your eye level. So what's below your eye level goes up, and what's above your eye level goes down.
Yeah. But you see it converge on the horizon, but the ground level reaches your center at 1 mile, just by an example. Okay, don't. And the sky, since you have more room, is gonna take probably 100 miles to reach the center. You have a lot of space up there. So yeah, the things are not gonna compress from the top up, from the top down.
Right. So if there's a building in front of you,
yeah. So you walk away from the building, and to the point where the building reaches the horizon, right? Which is the limit of your angle. Okay, it reaches the center of your eye line. From that point on, as you move back, you're gonna start it's gonna start compressing. You're gonna start losing the bottom part because the angles on the bottom, like the bottom part, is not. You're not able to resolve that. It's too compressed.
I heard you, man. That's what I was responding to. Yeah, if the building's in front of you a mile, 3 miles, wherever the horizon is, and you're 6 feet tall, then the 6 feet of the building below you is gonna be appearing to move upwards to go to your eye level, and the entirety of the building above you is gonna be appearing to go downward to your eye level. So the point where they're converging at your eye level, the bottom part of the building, the 6 feet, is gonna be. I don't know why it would be more compressed than the entire building that is also converging, because the bottom part of your vision is converging upwards. Then the building doesn't have that. The bottom part of the building doesn't have all that. The rest of the building to compete with. You know what I mean? So it's like the 6 feet right below you and the 6 feet right above you. So let's say let's say the door of the building is 6 feet and you're 6 feet. It's a short door or something.
I don't know
right above the door is
talking about.
Right above the door is another door, and then there's the rest of the building. Those two doors, the one above your eye level and the one below your eye level, they shouldn't appear to be two different sizes. They should appear to be decreasing at the same rate in front of you. And so the bottom part of the building shouldn't be, the bottom door shouldn't be disappearing before that door right above it.
No,
there's no
but
reason
that's just wrong. It's like right now, right? Of course it's dark, but every sign on the road, right? I'm able to see the top part and not the bottom. Even at the distance, you can tell there's a sign, and you're not able to resolute the bottom part once it's in the horizon.
Now, that's not making a distinction of perspective. That if they're on the horizon, they're on the horizon. And on the globe, the horizon
well,
just means that
the problem that you guys
curve of
have,
the Earth.
Coach, is that you think that perspective only does one thing, which is shrinking things. No, it does a lot of things. And I guess that's your misunderstanding that you guys have with perspective.
That's what I'm asking you, guy. If
Have you
perspective,
seen?
a straight
Hold on.
perspective.
Oh, I see how you do it. I think
in front of you.
I can.
I'm trying to understand if I ask you a question, man.
Well, I can give you a better
Perspective in
example.
front of you.
Have you seen?
So that same building.
Have you?
If
Hold on,
perspective,
that same building.
I'm trying to ask a question, dude.
I know, but
I'm in
you
the
gotta
middle of a
answer this
question.
one.
No,
All right, go
I
ahead.
don't have to answer that one. Let me ask mine first, so you can ask yours. I'm saying if you're, with your perspective, you're looking straight at something a mile away, and you know there's some object directly at your eye level on the building, 6 feet on the building as well. The part right above it and the 6 feet below it, those two parts, they should be at equal angles and they should be at equal distances from you.
Yeah, if you
and
were
they
up in
are.
the air, if you were a half mile up in the air, then that's what would happen.
No, from where you are.
From
I'm
no,
talking about if
Coach.
the building was up
That's
in
the
the air.
problem
Hold
that
on.
you're
If the
having.
building was up in the air and you were up in the air level, in other words, if you just kept the same angle and rose up off the ground and so did the building, then it would shrink equally. But the ground is limiting your angle, bro. You know that.
Exactly.
Yeah, I'm talking about the angle of your eyes to the ground, and your
Let me
eyes
give you.
to the eye level point is the same level that you're at, and your eyes to the
Coach.
same distance that there is to the ground. Those two angles should be
Yeah,
exactly the same.
we explained it already. We explained to you already what's the problem there, right? Brian told you, I told you. You keep going to the same thing. I don't know why, but whatever. Let me give you a different example. Have you seen that example where they drag the coin back from a table and your eye level is at the table?
Yes, of course.
All right. So once the ground reaches the center of your eye level, right? It reaches that point. Right there at that point, you're looking pretty much like if you were looking the table, the coin in the table. That's what is happening. So the ground rises to your eye level, right? At that point, Kosho, pay attention to this. At that point, you're looking this example with the coin on the table. The horizon is the table at that point. You have no more angle of resolution. So therefore, you're gonna start. You see the coin on the top part, because I don't know if you know, but your eye is able to distinguish what is looking from the center down and the center up. Your eye is able to distinguish that. So once it reaches the horizon, the thing that is capturing the object is the top part of your eye, not the bottom one anymore. And you can do this with a camera. If you want, put like two different colors, like blue and red, let's say, and you put half and half, like the bottom part blue and the top part red, and then you have an object, and you start moving it backwards from that. You're gonna see that at one point, the object is gonna be only on the red side of the lens. It's not gonna be viewed by the blue side of the lens. That's why you see things compressing bottom up.
Yeah, the picture of the coin. You know, the table, the camera's not above the table.
I just explained that. I give up, bro.
No, yeah, you didn't just explain that. The camera is not above the table. That's why the table is obstructing the object. It's not above the table.
It's in the center, Kosho. The center of the surface of the table is at the center of the lenses. Don't say no. That's the truth.
I didn't say no. I'm making a picture. I'm trying to. All right, yeah. So here we go. So if
every observation like there's no ground.
Yeah, if the crux of this triangle here is where your eyes are, and the line in the middle is your eye level all the way to the object, and the ground is at the bottom of that object. At the top is where the angle on top. Those are the same angle, and that's exactly the same angle as you view it. So the same distance that's below your eye level and the same distance that's above your eye level is going to come to your eye at the same angle. There's no other way that there's no reason perspective would do anything different than that. That's what perspective does. Whatever shrinkage is happening at the bottom and at the top are going to be equal.
All your vision is up above the ground. Okay. And now, if things would work the way you're saying, like I said, if you raised the building and you raised up the same height. In other words, you have no limited angle. Think about the triangle calculator. When you look at your viewer, your theta, your little angle that you're measuring, look at the flat line at the bottom, B, and then look at the hypotenuse, how it goes up. Okay. So if you were to expand your vision, you can only expand it one way, up. You can't expand it down no more because the ground's in the way. Okay, so now we would see things the way you're describing is if everything was up off the ground. Then the building would disappear equally if it was up off the ground and we were also up off the ground. We'd have equal, and we were seeing from the middle of the building, and we have equal angle to the bottom and the top of the building, and it would shrink equally. But the fact of the matter is, we have a limited angle. If you pull a string from your eyeball to the bottom of the building, say the top of the doorway, and you pull a string from your eyeball to the top of the building, you have a better angle to the top of the building. Because that angle gets smaller and smaller. I think you know this, bro. You're
Ryan,
going back
did you see the picture? Did you see the picture that was posted?
I'll go look at them.
Yeah. It didn't address it, just said something different. But if you're 6 feet tall and that object that you're looking at in this image is 12 feet tall, and the middle part of that object is matching up to where your eyes are, then the top part of this object and the bottom part of this object on the ground, they would be coming at you from the same angle. And the top portion of this object and the bottom portion of this object would be shrinking. This is my whole point. This is what you guys are claiming doesn't happen.
Do you agree with that,
the top part, you're saying the bottom part gets compressed more than
No,
the top
I agree
part.
with what he's showing. He's only showing a 12-foot high object. We're talking about a building. Listen, you're going to get.
Well, I
I
don't agree with that, but I mean,
No,
you
it's
can
going to go further than what he's saying. When what the math showed, you're going to go further than that. It's not reality. That's not what we're seeing in reality. What you're showing and the way it disappears equally, you're still going to have a limited angle at the ground because it does, like he said, it reaches a point where the ground quits coming up. Where the ground quits coming up, then it can only go out. Okay, so then it's just a matter of angle.
If you want to try to understand visuals, you got to start representing as you see them in real life. Otherwise, you're not going to be able to.
No, let me tell him this. Coach,
no, you, Brian.
This is how you see things in real life, man.
No.
This is the only way perspective works, man.
Brian, give me a second. Where is the ground rising to the eye level of that a person? On your example, Coach.
This is the actual person that we're actually viewing.
Yeah. Where is the ground rising to the eye level?
The ground is going to be everything beneath them from their feet all the way to the object.
Represented
You ask
rising
me a
to the eye
question.
level.
Don't be an obnoxious person, dude. I'm trying to answer your question.
Answer the fucking question, then.
Don't shout over me.
Hold on,
don't
man.
shout over me to
Hold on,
answer the
Matrix.
question. I'm in the middle of answering.
Okay, Kosher, if you take that demonstration you showed me and take it and draw it over the ground, okay, now start backing it away and watch what happens. You're going to lose angle to the bottom first. Do what I said. Draw a ground in your picture and start
I'm
backing
trying
it
to answer
away.
his question. Okay. If you were to continue to make angles, not just these two angles, but a whole bunch more angles, then from your feet all the way to that object, that would encompass all of the ground, and all of that would have to be smushed into the bottom part of your view. Whereas the top part of your building, the sky, and you made all the angles on that side, you'd have more of the area of the sky and the building. There would be more room for it to take up. This is true, right? But that's not what I'm talking about. I'm talking about looking at something straight on and looking at the 6 feet below on that object that's right in front of you, or 20 miles in front of you. Doesn't matter how far in front of you it is. If you're talking about due to perspective, the 6 feet above your eye line and the 6 feet below your eye line are going to be behaving the exact same way, shrinking at the same rate.
No,
everything.
I disagree, but whatever. I guess. Yeah.
So just do what I said. Draw a line underneath that, representing the ground, and start backing it away. Okay, what you drew
Brian.
worked for a few hundred feet.
Brian, what part you don't understand? As long as that floor is is straight down there, it's not representing how we see in reality. You're not gonna get the effect that you want, Brian. Understand that.
What he's showing is deceiving. What he's showing is deceiving. He's showing it so close.
I know it's deceiving, and as long as they keep doing that shit, they're not gonna understand. And
Dude, it's not.
it's
not deceiving at all, dude. You guys just aren't understanding it. The bottom part of his feet.
I'm explaining you where the problem is, Kosho. For the 5th time, I have explained to you where the problem is, and you just ignore me. As long as you don't rise the ground, to the eye level, from the feet to the eye level, as we see in real life, you're gonna have a misrepresentation of the observations. I'm sorry, that's just a fact. Yeah.
Try to understand.
Great comeback.
Try to understand
Great comeback.
it instead of saying the same thing
No.
again.
You should try to understand it,
That's
bro.
fantastic.
You should try.
But yeah, as I told you, this line in front of you is 0 degrees. The lines above it and below it are 5 degrees each. Now, at the bottom line,
Don't care about your red,
all the ground on the red part is encompassing all the rest of the degrees for that half of your vision. So all of that is being compressed with that bottom part of the building into the bottom half of your vision. The top half of your vision, however, has a lot more range for objects to be like if this was a building and it was taller, you could see the rest of the building. You could see the clouds and fucking shit in the sky because that half of your vision is not being taken up by the ground, which is right below you. So that part's true. That the bottom part of your vision is going to be scrunched up because the ground is you're closer to the ground. But that doesn't change an object that is directly in front of you. That doesn't change an object that's directly in front of you at exactly the same distance above and below your eye level. It just doesn't.
Yeah, all misinterpretation of what you see. That's all you're doing, bro. I explained to you already. You say, "Nah, dogma," right? There you go. There's no fixing you, Kosho. I understand what you're saying.
You purposely didn't listen to it.
No. But I am okay. Hold on, Kosho. Hold on.
You didn't listen to it or respond to it, so it's all good.
I listened to you respond. I'm disagreeing and I'm explaining why I disagree and where the problem is with your example. And what was your answer? That's rhetoric. That was your answer.
Go ahead and explain. Go ahead and explain why my example.
Again. One more time, I'm gonna say it. Because your representation is not how we see in real life. How we see in real life, we see the ground going from our feet and rising up to your eye level. You have a ground that doesn't rise up. So therefore, you're going to have a misrepresentation. Every single time that you do that, you're going to have a misrepresentation of how we see in real life. That's it.
Yeah.
If you want to take it, okay. If not, I don't care, bro.
I heard it responded to by telling you it is being addressed in this image. When you realize that the bottom part of your image is everything that's below that straight line, which is
I don't see the ground rising to the center, bro. I don't see the ground rising to the. I don't see the ground rising to the center line.
Why
what are you talking about?
Why are you talking?
Because you're not. Are you being honest, Kosho?
My explanation.
Are you being honest right now?
Are you drunk?
I'm driving. How am I going to be drunk?
Well, then just be quiet for a second, dude. I'm in the middle of following up on what you just said.
Are you going to explain the same shit over and over again?
And you just end up asking me questions in the middle of what I'm saying. Right. I addressed what you said. I addressed what you said about...
no, you don't.
This is what I'm saying. Okay, I'm good, dude.
Yeah. Don't be lying.
People
don't
like
talk
you,
shit,
people like you, you're just not...
Yes, people like
you don't want to hear the answer. You don't want to hear the answer.
No. What do you mean? You're saying you addressed my point. No, you haven't. No, you haven't.
I
Don't
did,
stop.
man.
Don't say
Several
that shit,
times.
bro.
You're afraid.
No,
You're
you
afraid to
don't.
hear it.
I'm telling
You're
you,
afraid to hear it, so you talk over me every time I try to say something.
I'm telling you, you haven't addressed my point. You're saying you did. No, you didn't. How many times
Yes, I
I have to
did.
tell you?
Well, let's find out. Don't be a coward. Just listen to what I have to say, and
What
let's
is
see
my
what's going
point?
on.
What is my point? What is my
Yeah,
point?
you're saying, don't speak until I'm done, okay? Your point is that it's not showing what you see in reality because in reality, the ground is rising up and taking up more of your vision than the top part of your view. I addressed all of that and told you that that's what you're supposed to be picturing when you see the straight line and the 5 degrees above and the 5 degrees below the straight line are in the image. And you can see that below that angle, all of that is going to be.
You need to
stop. Hold on, dude. Hold on. All of that is going to be the ground that's right beneath it. All the other angles that you have are all going to be just ground, all scrunched up into the whole bottom part of your image. Whereas the top part of your image, you get a much bigger space. But that 5 degrees above and the 5 degrees below are not going to change. They're not going to be different. They're going to be compressing at different rates. There's no reason for that to happen.
Now, can you tell me on your drawing where is that line on the ground going to the eye level represented?
Yeah, I'm showing you the angles.
I don't care about the angles. I want to see the line, the bottom line, going to your rising to your eye level.
Yeah, I can draw all the rest of the angles if you'd like, but I think it's pretty clear to see that everything below 5 degrees, everything below that 5 degree line, all the other degrees for the bottom half of your vision are all going to be the ground.
You're not being honest.
All those degrees will be the ground. Everything
You know
above
what I'm
that
saying?
is going to be all the other objects in the world.
All right. Okay. I mean, you know what I'm saying. You're just ignoring it. It's fine.
No, yeah, I know what you're saying, but you're clearly not able to perceive exactly like 'cause what you're saying is true, but it's in the image. I mean,
The point here is, Kosho, as long as you draw that line, you don't draw it rising to your eye level, you're always going to have a misrepresentation. You're not going to be able to understand where you're wrong. That's period. I'm sorry.
I don't know if you know. I don't know if you know what field of view is, but if you have a field of view of a vertical field of view of let's say 60 degrees, that means that your eye level straight ahead of you is going to be exactly half of that field of a vertical field of view. And if there's an object that's directly in front of you 10 miles, and if there's no hills or anything, then the same height that you are should be exactly so if you're 6 feet, then 6 feet on that object should be exactly at half of your field of view, and your field of view is going to decrease equally on both sides.
In real life, that's not going to happen over distance. I'm sorry, but it's not. Just like things don't get smaller. I mean, in reality, they don't get smaller, but we see them smaller as they go. So you know what I'm saying. You just don't want to apply it to your drawing because then to you it doesn't make sense. Which is my point. You end up in the same spot, right? I explain to you. You refuse to understand. There's no helping you. It's pure dogma.
Kind of explain it to them in reality a way like with the brick. You take one brick, just say a 1 foot tall block, okay, and it's 12. You're 6 foot high, and the building is 12 blocks high. But now you just take the one block, the 12-inch 1 foot block, and you keep pulling it away from you. Pull it away, pull it away. Kosho's example worked up a short distance, but as you pull it away, the ground starts limiting the bottom angle. Okay, so
That is
in
correct.
demonstration, I'd say so the brick after a couple miles, you would not be able to see that 1 foot brick on the ground anymore. But if you stack the 11 on top of it, you see the 12-foot building he's presenting. But you
That
still
is
ain't gonna be
correct.
able to see that damn 1 brick at the bottom. He don't understand reality. He only understands it through math. And it's hard to talk to somebody who can't get their head out of the math book. When you're trying to describe reality, he don't see reality. He sees math, and it's crazy, dude. It's insane.
That is correct. All you said is perfectly explained, and we see that's reality right there. It will happen every single time in reality. And
So
the
what he
problem is
doesn't
when they start making these drawings, right? When they do these drawings in their head, and that this is what they got in their head. That's why they're not able to see what we're trying to explain to them.
Right, an orthographic view, that's all fine and dandy for a few hundred feet. But as you keep pulling that building away, that bottom line angle is going to get smaller and smaller. When you're going to have a viewing angle to the top of the building, but you're going to lose the angle to the bottom because of the ground. And that's what I was telling him. If you pulled the building, that 12-foot building up in the air, that's how he's drawing it. He's drawing it up in the air basically by drawing it so close. So if you pulled it 100 foot up in the air and you went 100 foot up in the air, so you had the same angle up in the air as you did on the ground, then yeah, you could pull it away, and then his theory would be closer to matching reality, and it would disappear equally. But the fact of the matter is, the ground is the limiting angle in this scenario, and it cuts off at the bottom before it cuts off at the top. So
You know where the problem is, Brian? I don't know if they know, but your eye is able to capture with different section of your eye is able to capture different things, right? Like I said, that's why when they say, well, if you're 6 feet and an object at the distance is at 6 feet, it doesn't matter how far you move away from it. It's gonna be at your eye level. What they don't understand is that object at one point is gonna be captured by the bottom part of your eye, the section of the bottom, and then it's gonna move to the top part, and that's gonna make a difference. Each part has its own angles. I'm telling you this because my wife, again, had a problem with her eyes. We went to a doctor. They did this fucking test where they show her like every single angle on her eye, and they detect the problem, right? So most of the people think that we see our eye is just like captures one like the image, and it's one point of entrance. No, it has several points of entrance, and your eye can distinguish from the center to the top and the bottom. I need to draw this because I've been having this in my head for so long, and I need to explain to you guys because most of the people don't know this, right? It's not something that, I mean, why would we know?
Yeah, the day that you said that, I actually made you a picture so that you could explain it to Brendan because he wasn't understanding what you were saying. So that is an obvious misunderstanding, but regardless, yeah, sorry, I was getting some food, so I didn't mean to.
That's okay, Kosha.
Step away for a second, but while I was
enjoy
the 12-foot building. The 12-foot building.
Enjoy your food, Kosha. Enjoy your food, bro.
Well, thank you, sir. While I was
But
gone,
listen real
though,
quick. You didn't hear me
while I
though,
was
man.
gone, I also
I said all that for
hold
nothing,
on,
bro.
Brian, just wait a second, man. I was saying while I was gone, I also made this picture, or added to this picture. I mean, just clearly show what I'm talking about. So pretty obvious, but I'm just gonna make this okay. So just let me post this very quickly because it is showing exactly
How you did all that. This is real simple. You take a 12-foot building, like you're saying, and you break it down into 12 1-foot blocks. So you got 12 1-foot blocks. So if you back away from it, okay. Now if you take just the 1 block on the ground and you back away a couple miles, it's going to converge with the ground. Okay, you're going to lose vision of it because you're going to lose the angle. Okay, but if you add the 11 bricks, you're going to see it again. But you're still not going to see that bottom brick, bro. What you're describing is orthographic mathematical view. You're not describing reality. In reality, we're losing our vision from the bottom because the ground is the limiting angle, bro. The ground is the only limiting angle in this scenario.
Brian, that's why I made this picture, man. You said to understand it before. The line, that straight line from that position, is the same height as the observer, and the whole building is that blue building. The whole building is blue, right? This portion, that green portion, is 5 degrees above your line of sight of your eye level, and 5 degrees above it. Okay, and the reason why the ground is encompassing all those other angles, so that it's 5 degrees, and then there's going to be 25, then 35, 45 degrees, and same thing going above it. I just added 10 degrees each time. And so, yeah, it's correct that the ground, below the building is going to compress at the same rate as the part above the building. And so since the ground since you're so much closer to the ground, that amount of those angles that are as they get bigger, as they get wider below the 5 degrees, they're going to be shorter and shorter because you're so close to the ground that they're going to be shortened. Okay, and the ones above the building, you're going to have more of a range to see because there's not a ceiling or whatever shortening those angles, shortening those lines, so you can see much more. But the 5 degrees above your eye level and the 5 degrees below it, the same height as your eye level to the ground. If you were to take the mirror image of that and go upwards, there's no reason why those behave any differently. They behave the exact same way, no matter how far as you move farther back. If you're only doing perspective, that those same rates or those same parts of the building decrease at the same rate. And same thing with those bricks.
You're standing up against a building. You're right up against a building, and all you can see is the bottom. You look up at the top, you can barely see the top because you're so close to the building. The building's real tall, right? As you start backing away from the building, you're going to get a better view of the bottom. When you're 100 foot away, and you're still, the top will be a little bit, but as you keep backing up, Kosho, then it's going to hit a point out about a mile or whatever where it's equal, where you can see the bottom and the top equally. But if you keep going, then you're going to start losing the angle to the bottom of the building, and you're going to be able to see the top bigger. Okay, what you just showed, you're showing the perspective, the lines going into the ground. The ground is the limiting factor here, bro. Just I don't see how you can't understand this reality. I understand the math you're saying, but the reality of it.
Shorter, dude. That's why I made those lines. They get cut off. Those lines at the bottom, they get cut off, and they're much shorter than those lines on top. I agree. That's what I've said the whole time. I agree with it. That's what I'm telling to you. I'm telling you to focus on the 5 degrees that's directly above and directly below the eye level.
Is that the top of the green or the middle of the green? Is the top of the green 5
No, in the
feet
whole
or the
green
middle of the
line.
green?
That's the whole green line. The whole green line is the 0, which is right in front of you, and 5 degrees above it is the top part of the green, and 5 degrees below it, which is the ground, the bottom part of the green. Everything below that,
green, bro. It's cut off.
everything. Yeah, it's cut. Yeah, just imagine it's bottom. I moved it over a little bit, but regardless, everything below that, those lines get shortened, and that's exactly what you're saying. Those lines get shortened, and so they compress at a different rate than those lines above it because you can see further. There's no ceiling. I agree. I'm agreeing with that 100%. I'm telling you though that the part that the angle from your eyes to the ground part of the building, whatever amount of building that is, the same length of building above your eye level is going to behave the same way as that bottom part. So the bottom part, it's not going to disappear before that part. They're going to shrink and disappear at the same rate.
You start watching my videos, man, because I showed Jose's channel where Jose and Ranty were on, and his viewer height was 5 feet, okay, or 6 feet. I mean, what am I talking about? His viewer height was 15 feet, okay. Now he's looking out at boats in a structure, a few boats in a structure about 2 miles out, right? And there's a spell that happens at this spot once a day. That spot he goes to, okay. And the swell gets toward the end of the 2 miles, and toward the horizon where it doesn't go no higher, and that 3 foot wave, it's a 3 foot wave. You know, he calls it 5. He says it's a 3 foot wave, but he'll call it 5 foot just to be nice. It's blocking like almost entire boat and blocking like half of a 2-story building. Okay, a 3 foot wave, call it 5 from his, and he's over the wave. He's at a 15-foot viewer height. And I could give other examples of how being over, you think that the ground can't block shit, bro. He gave a perfect example of how a 3 to 5 foot wave can block a fucking ship if it's at the horizon, and it can't go up any higher. Once the wave gets to the horizon, it's not going to, the ground don't keep rising up. You hit a point where that's as far as high as it'll go in your vision. So any wave on top of that is going to block, you know, whatever perspective wise. So a penny could block Empire State Building over enough distance, but y'all don't concede that because you think in mathematical orthographical view. But in reality, that's what happens, man. It's a perfect example.
Perspective doesn't allow something below your eye level to ever obstruct anything above your eye level.
You go watch the video.
There's nothing in perspective that will allow that.
Your own Glover giving a perfect.
There's nothing in perspective alone that allows it to do that. I'm telling you, there's no rule that says that. It actually says blatantly that things below your eye level converge. If things below your eye level converge to your eye level and things above it converge to your eye level, that means that things below it never overpass things above it.
Listen, no. Listen, Coach, this is where you're wrong. An object that you have on the bottom part of your eye, right? As you move away from it, and you make distance from that object is gonna move from the bottom part of your eye, and it's gonna move to the top part of your eye. Still on your eye, but it's in different sections of your eye. And again, that's the problem that you guys have.
Listen, what you're talking about is how things enter your eye. Things always enter your eye in reverse from how they appear.
No, I don't want to go
so
there.
Things they always enter your eyes in a reverse. So like everything that enters your eyes upside down, basically.
I'm not talking about that.
That doesn't change. That doesn't change with distance. That's always the case. And what was I saying? Yeah, and like again, things that are above your eye level, they don't ever converge. Things that are below your eye level don't ever overpass things that are above your eye level because they both converge at your eye level. And because they both converge at your eye level, they both never meet your eye level, and they definitely don't overjump that line. Only due to perspective. There's other mechanisms that allow that to happen, but it's not perspective.
In the video, Rumpus is like, no, that's impossible. And then they show it. Okay, so you can deny it like a fool, like Rumpus did, or you could go watch it and be like,
it doesn't matter if you have an observation that shows that. It doesn't say that's perspective though. Perspective doesn't allow for that. There's other things that can allow for that, like
you shouldn't be talking about perspective, Coach. You don't know what perspective is.
Perspective that's not a rule of perspective.
You don't know what perspective is, Coach.
In perspective, the things below your eye level converge to your eye level.
Say again?
That happens because of perspective. The things below your eye level converge to your eye level. The things above it converge to your eye level. Does that happen with perspective?
You call it whatever you want,
the distance.
but I'm calling it reality, bro.
Simple yes or no. Because you're claiming that doesn't happen.
I'm trying to understand your question. First, I need to understand your question. And perspective,
the things below your eye level converge to your eye level due to perspective. Is that
what does converge to your eye level mean?
Look it up and then get back to me.
Oh, so you're not gonna explain to me? So see, this is what happens, right? I'm trying to actually understand what you're talking about.
You used these terms earlier. You're the one who said that to me earlier. So why are you asking me what it means? If something's converging to your eye level, that means
because I don't know if that
upwards eye level. Things below your eye level move upward to your eye level. Things above your eye level move downward to your eye level as they go away in the distance.
Yeah, that's a function of perspective.
And then when I say that just now, you're saying just now that's not perspective. I don't understand perspective.
That's a function of perspective. Yes.
That's exactly my point. Perspective.
You said it's not.
Perspective says things converge at your eye level. So that means that things that are below your eye level are not going to go above your eye level all of a
Oh
sudden.
no.
They're going to
But,
converge at your eye level.
hold on, Kosho. But something that again, oh, man, something that is, how do I explain? I need to draw. I'm gonna leave this for another day, Kosho. I need to draw it so that you can understand. Because right now I'm gonna repeat the same words and you're not gonna understand what I'm saying. And that's a problem of me, right? My English is not that good. Right? It's not a problem that you don't
Are you
understand.
claiming now, even though you just agreed that things converge at eye level, you're going to claim that they don't do that anymore?
That they move from the bottom part to the top part of your eye. There's a distinct, and that's where the effect of losing things bottom up is you're gonna see that effect just because of that.
Bro, and that same video that I'm talking about, John Watson shows I think it's the first or fourth or whatever, and he's looking out about 15 miles across, and a little ripple, he said there was no wave, but they called it a 1 foot wave, but it's a ripple on the horizon, blocks the entire building, dude, and he's up above the water. Okay, now I don't care what your math is showing in your geometry. I'm talking about reality, actual observations, bro. In reality, little ripples and waves and shit do block distant objects. Okay, and Rumpus was like, "Well, that's Earth curve," and Jose's like, "Bullshit." He's like, "That boat's only 2 miles away, bro, and I'm 15 foot high. It's not Earth curve." So at least Jose was being honest. He still believes in the globe, but he's going to be honest about the observation. It does not match geometry on paper, bro.
When the wave was gone, could you see the boat or building
The
again?
entire, the entire building, the entire
So the
building.
wave
Go
came
watch
up
the
and
video,
then it
bro.
obstructed the
I'm gonna
building,
post.
and then it wasn't obstructed anymore.
I'm gonna go ahead
At
and
least
post it
50
for you,
feet
bro.
above the water.
Yeah, I'm gonna post it. It's 15 foot above the water. I'm gonna post it and let you see it, so you can make your own decision. It's short.
You're live streaming.
Just post it when you get a chance. I'll be right back. Okay.
Yeah, I just posted it, and the guy starts off the video saying exactly what Kosher is saying. He's talking all that shit, and then Rumpus backs him up, and then they shows a demonstration proving that everything he just said, and just like everything Kosher just said, is what we would expect if we seen in a perfect geometrical orthographic view. That's not reality, And so it just shuts Rumpus up. It shuts the guy up before him. I doubt it'll shut Kosher up, but at least he'll see what I'm talking about. That in fact, things below our feet, whatever. I mean, below our eyes, can block stuff above them, and can and do constantly.
I'm entering 40 Bros, West Memphis.
Is that above the mountains? I mean, are you north of the mountains?
What was that, Brian?
You're not in the mountains. You're north of the mountains, right?
Oh, I'm in West Memphis. Nah, I'm not. Going to Texas. Do you see what's going on, Brian? That now China is saying that they don't have enough power to keep the companies with power. That they're gonna need to reduce the energy consumption. So I don't know what's gonna happen, man. With all this shit, the prices are gonna go up. I think they're using this as a cover for what is happening with the money, the inflation that is happening. They're gonna blame the scarcity. I don't know how to say that word. Like that there's not inventory scarcity. I guess.
Yeah, 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 scarcity. That's perfect.
Yeah, they're gonna blame it. And they're gonna raise the prices so much. You will see. It's gonna be fucked up, man.
Yeah, it's not going to get any better.
No.
I can't wait for all these people on the other side of the debate to have something that they don't agree with, and where they get censored. They can't argue shit. That nothing they say can go out to anybody, because then they're gonna kick themselves in the ass for not standing up for First Amendment rights. Just because it's something you don't agree with doesn't matter. You got to have First Amendment, man. If you can't voice your opinions against the government, then you're in trouble. And they don't realize that because they're on the other side of it. But as soon as it happens to them, then they're going to be crying. It's going to be too damn late if we don't do something quick.
Well, you gotta remember, some people need to touch rock bottom, and so that they can react. Unfortunately, sometimes it's a little bit late. But yeah,
Probably is.
it's pretty sad though.
It done got late, man. I'm gonna have to take off, man. But tell Coach he's a dumbass and drive
I
straight,
think
brother.
he's eating. Come on, Brian.
All right, bro.
All right, take it easy, Brian. Have a good night. Anybody have a topic to talk about? The fuck? Oh.
Well, well, we all knew China was going to take over the world one day, but how we envisaged this takeover to be is exactly how they're doing it. Could you think of it in any other way? Because it's not going to happen with knives and guns.
Yeah. I don't think. Yeah, I think this is the first step that the. I mean, it's looking pretty bad though for everybody. I just saw the news that what I said is that they're claiming that they have not enough energy to keep all the factories going or running, so they're gonna start limiting, energy consumption or whatever, which is we know is bullshit, right? So, but I think that's a power move. What follows from that, I don't know, man. They have all these boats on the middle of the ocean, with all the produce stuck. The diesel so freaking expensive right now. I move auto parts. I have a lot of work, but I don't know about like produce and all the groceries. I don't know how the work is on that side of the logistics. Yeah, U.S. is completely destroyed though. It's not what it was. What up, Sanic?
What's up, guys?
What are you doing awake at this time, Sanic? You drunk?
Yeah, I've been drinking a little too much. A little Don Julio.
Oh, that's pretty good fucking tequila, man. Love that shit.
The best.
It is the best. You drinking the have you ever tried the 70, the black label?
I have a buddy that's like a full-on connoisseur of tequilas. I think he's probably made me drink it a couple times. We were down in Mexico, and we had the Mexican margaritas, just ice and tequila and lime.
All right.
That was not,
Oh
that was
yeah.
not a, it was not a pretty sight. I don't remember
Tequila.
that. I don't remember how I got home that night.
If you don't know how to handle tequila, it's gonna fuck you up.
That all right?
Yeah.
What are you up so late for? You're real late for you.
No, I'm driving. So, we were talking about perspective and, the same shit, Sanic.
Same stuff.
Same stuff over and over,
Will
man.
it ever end? All this time. It's been fun.
I mean, I enjoy the conversation with the people. That's why I'm here. At this point, I know that nobody, at least on these chats, nobody's gonna, jump size.
Concede.
So,
No, but they're great. I think it's really the contrarian questions against the know-it-all globers to see if they could articulate what they think they know and convince the flat Earth contrarians that things are the way they think they are.
I mean, I have learned a lot. The other day I was arguing with one of my friends. He's in the university, right?
Mm-hmm.
And I mean, he tried to argue with me, and I shut him down so fast.
Yeah,
and I told him, go learn a little more about your.
You're not equipped to argue with me.
Yeah, that's what I told him. You're not equipped at all to argue with me.
Yeah, I bet you could go ahead of a lot of people in that respect.
I didn't tell him that he was wrong just because of that, right? Because I'm honest, and I told him you just need to go learn your model because there's excuses for everything. For every question that we ask as flat earthers, there's an explanation. You just need to learn it.
That's true.
Right? Because he will be dishonest, right? To ask him a question and then claim victory over him not knowing the right answer.
Right. Well, most people at this stage in the game, especially if they've been working for 5-10 years, you start asking them, what's the difference between refraction and diffraction? They won't know. Talk about the Earth curve calculator. They'll have no clue what the curvature of the Earth is. They'll have no clue about any of the things you guys learned so much in this dialogue that we've had here. It's actually kind of funny.
Yeah.
Just like the astrophysicist that was interviewed by somebody, I can't remember who it was, and she said, why, how do butterflies fly if the water is being stuck to the earth? Well, that's because they have buoyancy. She started saying things like buoyancy and she got totally tongue tied and couldn't figure
That's
out
wrong.
what she was trying to say. So it was actually kind of, that's not her specialty. She worked in terrestrial physics. She works in astrophysics. So that's understandable that she would kind of mix up the concepts because she's probably never thought about them since she was in college, 30 years ago.
Mm.
Of course, if you explain it to her, she would get it immediately. But off the top of their head, a flat earther that's been in this conversation as long as you guys have with this particular group, because you guys are pretty good at it. She's not going to. Astrophysicist is not going to have a chance.
I know.
Because they're all going to fall back to, fuck you. We got pictures. Just shut up and go away. Oh, we don't accept pictures.
That's the thing, like you were saying before, it's like they've always got an answer for everything, and that's how it is. But it's not what they can show, it's what they don't show. It's what they don't show is the camera on the moon looking at us spinning around all day long.
Yeah, they should love some fun stuff like that.
It's what they don't show. They never show the fourth wall.
The fourth wall? What's the fourth wall?
The fourth wall is like when they're filming let's say people on the ISS, Danik, that they do a 360 camera rotation.
Well, I think they have.
They have done it after, but see, that's the funny part, Danik. Like I remember, we've been like probably 7 years by now on this conversation, yeah.
Long time.
And I remember how things were coming up from that part, the ISS and NASA, as we were making these arguments. That's why sometimes I got suspicious of people, on these conversations being shields, but I don't like going down that rabbit hole, man. Not at all. But yeah, it was funny because we will come with something like an argument, a good one. Then suddenly NASA will show something answering for that. And I was like, what? That was really weird to me. But
I mean, coincidentally, they'd have some
coincidental.
Yeah, they hear about this. I mean, obviously, these flat Earth stuff is if you dig down to this, you got to dig pretty deep to get down to this Discord server. But you can get a lot of articles and things and YouTube videos. Of course, I think you'll probably stumble upon Ranty and Nathan's channel, of course, QE. QE is just such an enigma. I mean, my God.
QE. Honestly, Sanic, I think QE could do better, man. I don't like how I don't like his attitude at all. But that's a personal thing that I have. I got into fights with him. I think you were there the one time. I just got away from the fucking server because I can't stand when he asks a question, he doesn't allow the people to answer. On that side, I agree with you guys on the global side.
I think a lot of other people have much better arguments than he does.
It's not even about the arguments themselves. You could have the best argument in the world, but the way that you talk to people, it'll make people, shy away from it. It'll purposely drive people away, even though your logic might be the pinnacle of it could be on point, but
he's got
the attitude.
He's got both. He's got the attitude, which is bad, and he's got the worst. Not the worst. He's got good arguments, and he backs them up. He structures the arguments well with his citations and all this, and then he calls people out. And basically, it always degrades down to, you don't know what a citation is. What does I say? That kind of pedantic.
I don't know what that.
Where you
definitely,
and the other guys,
your demeanor goes a long way.
You and the other guys at this on this server and a few others actually have pretty decent arguments. I mean, you're asking good questions, and a lot of times we go back and forth, but at least the argument, I think, they're very strong. They make you think. That's why I get excited, because I'm like, okay, that's a good question. I gotta fight back with equal force, and we go back. But he doesn't do that. He won't allow the dialogue. He's an asshole about it, and then he just mutes people. So it makes it even worse of a conversation.
So a little while ago, Jeremy and Riggs were trying to convince me that you would expect to see a curve as you go up, and I listened to their explanations and I was unconvinced, but I've been thinking about it now, and I think I'm convinced now that you would expect to see a curve as you go up.
Yeah.
Mm-hmm.
Of course.
If it's a disc, right?
It's no different. Well, no, it's
Yeah,
still
no, on a flat Earth, I mean, Zanuck.
well, that's when I talk about the
Okay,
curve
let me
away.
explain why. So here's like, you know, they were trying to explain it and I wasn't really getting it, but the more I thought about it, and I think I've kind of like nailed it down to a succinct kind of like way to explain it. Basically, the horizon, we know the necessary antecedent for horizon is an observer, right?
Mm-hmm.
But I don't think that's the only requirement. I think the necessary antecedent for a horizon is both an observer and atmosphere. Because if you don't have atmosphere to reflect the light, then you're not going to have a horizon. And as you raise in altitude and your atmosphere thins, then, you know, what you perceive as the horizon is going to stay where the atmosphere is. It's going to stay down there, right? Now, if the atmosphere was like, you know, isotropic and there wasn't no gradient, then that wouldn't be an issue. But the fact that there is a gradient and it's, you know, focused around the ground, because that's where the gas is made and stuff, then you would expect that what we know as the horizon would drop. It wouldn't raise to eye level. So that being said, and this, we're not making any claims about like the surface of the Earth or whatever. That being said, as you rise, you know, and you have thinner atmosphere, that, you know, and the light is going to be reflecting off of where the atmosphere is down there, you would expect that you would have, you know, this horizon that stays low. And if it stays low as you go up, since you see equal distances all around you in a circle, right, 360 degrees, you would expect that line as you go up would start to curve.
Only if that line. So there's two curves, and I always mention this in our discussions, in my discussions. You have the curve away from you, and you have the curve around you. And the curve around you can only be determined in arc radians, is if you are above the surface of that arc or line. Let's say you take a shot put ring or something. It's a circle on a kid's playground, and you're down at eye level. If you were to, you know, look around, it's going to be a flat line at eye level, even, you know, right at the surface. But as you go up, every little bit you go up, then that circle around you, because you're now the center axis. Picture the center line of a cone. As you go up and you're looking down, now you're seeing that line, that circle around you, which is the border circle, which would be the horizon, would have curvature in your field of view.
Mm-hmm.
The light, you don't need to have an atmosphere for a horizon, because that's being blocked by.
No, for the actual optical, you know, that's what horizon is. It's an optical phenomenon. You absolutely need.
Have to be. No, it could be on the moon. You can have a horizon on the moon.
What you're talking about is the geometric horizon or what
No,
have you.
yeah, there's a geometric. You look at the moon, you can see the horizon on the moon.
No, but that's not, for me, that's not the proper definition of horizon.
But
Horizon
it
is the optical effect, because then you could say, like, you know, when you see a tree, you know, on the horizon or blocking meeting the sky, then that's a horizon now.
You could say,
so it gets finicky.
Then you could say like mountain ranges in the distance. That's the setting of the horizon. That's not. We all agree that's not the horizon. The horizon is going to be the actual shape of the Earth blocking things behind it.
I don't agree with that.
And that's
the
only
shape
going to be
changes, right?
Well,
so I think
you can plot any kind of distortion by just going up and taking your measurements of the horizon drop. As you go up, the refractive value, which we know things will be angled down because the density gradient is down. As you go up, that angle that changes with every position, every level position has a different tangent, and every tangent will be moving no matter how far you want to make that tangent length and draw another plumb line. Every one of those will be a greater angle at the surface than if you go up, because it's a triangle. So as you go up, those small changes in the curve in that view to the horizon will be much less. And you can actually prove or plot using calculus what the refraction level is at the surface by the change as you go up. You can measure it.
Yeah, I would agree with that. Like you could, like I would think that even if you had like a rectilinear lens and you were relatively low down, and you could see, like you know, let's say we're keeping barrel distortion to like a negligible factor because we have this rectilinear lens, and you're lower down, and you still see a curve like this, you know, I would think that at that point there must have been very little, like for whatever reason, there's little atmosphere there. You know, maybe you're just a high altitude or what have you, and so
if it's at eye level,
you notice
only
that,
if it's eye level. Only if it's eye level, though. It has to be at eye level.
What do
Otherwise,
you mean eye level?
If you have a level perpendicular to plumb and you look out, and you see a horizon, if that horizon is at eye level, then around you it'll be a straight line. You will not be able to curvature. No matter if you go high and it's dropping down.
Yeah,
then
agreed.
You're going to see it curve. You're saying it's curving because you're not. The land is being hidden by the atmosphere in the great distances.
No, that's not what I'm saying.
Well, that's what you're insinuating.
No, I'm saying that the atmosphere is the necessary antecedent for having a horizon, which means that basically you need this gas to be reflecting light, right?
Why does it need to reflect light?
It needs to be reflecting light because if it doesn't, then it's just going to be black, right? And as you go up, you have this blackness from no atmosphere reflecting light, right? It's not reflecting light, so it just looks black, and that's gonna, as you go up, that's gonna be below you a little bit. You know, it's gonna go below your eye level because you're rising above into this like very thin atmosphere.
Right. Well, let me blow that out of the water then. So that's why I bring up the heads display, because the HUD display will show you not only level, but the sun and the moon below level. So the horizon you're seeing is not caused by the air, because if it was, you wouldn't be able to clearly see the moon or the sun, which is quite a bit further away than any horizon on the Earth. Yeah, I think you have to agree to that.
Well, run that by me again.
If you're up at altitude,
mm-hmm.
and what you're saying is true, then you're saying the atmosphere is not allowing you to see. There's not enough atmosphere to reflect the light to show you this horizon.
Yeah.
Okay, fine. But when I show you level, and I show you a moon and the sun that is below level in the distance, and then the horizon below that, you can't use that argument anymore because there is no atmosphere, and you're seeing the sun and the moon below level. So the horizon can't be up at eye level, and it'd have to be there if the Earth is flat. If that was a flat surface, then it would rise to eye level. Always would. You can't say it's not because of atmosphere.
No, it wouldn't. That's what I'm saying. It doesn't need to rise to eye level because the
absolutely
horizon
has to. That's how
stays.
perspective works. No,
Hold up. No, let me rephrase again.
Perspective works that way. If you have something at eye level, and however far that goes away, it'll always stay at eye level in the distance if the surface it's moving out on is flat.
I'm with you, but that's only if there's atmosphere to reflect the light.
No.
That's only if there's air to reflect the light. If there isn't, then it's going to stay where the air is. That haze from where it turns black to invisible is going to stay where the air is. You can't expect to see a horizon when it's all black because there's no atmosphere. You know?
No, that's not. You're not thinking of it clearly.
No, think about it some more, because this is what Riggs. He was telling me to think about it more. He wasn't like the explanation. I didn't get it right away. It was a little convoluted. But think about it, and I think you'll see that this is correct.
Well, it's not, because you go up and you're looking out at this horizon and it's below eye level.
Yeah.
And so it's below eye level because you're saying, okay, you're seeing so far that the atmosphere is blocking the light to reflect it back to me. So that's why you see it black. So the atmosphere.
No. It's not that you're seeing so far. It's that you're so high up that you're above basically where the atmosphere turns black, basically.
No, let's just go to. Well, we can talk about that in a second, but let's just go up to 1,000 feet. We see the horizon below eye level at 1,000 feet.
Yeah, it would be.
And you can see detail right up to the point where you can't see any detail anymore. You can see ships disappearing, hull first at looking at 1,000 feet up in the air.
Yeah, I'm not speaking about the obstruction.
Even 10,000 feet.
Hold up, Zanuck. You're jumping to a different topic. I'm not speaking of the obstruction that blocks things on the surface.
But the horizon is this line. It's this delineation between what you can see on the surface and what you can't see on the surface. And even then,
no.
At 10,000 feet.
I think you're confusing topics, man.
No, I'm not. I'm not. Even at 10,000 feet, you can clearly see that horizon, and you're saying it's just because light isn't being reflected off the on the atmosphere, but you're only 10,000 feet. So that light, there's plenty of atmosphere. It's very, very thick at 10,000. You can still breathe it. That's how thick
but you would expect that it's a gradient. It's like an incremental effect as you rise up.
It's only 50.
That line, hold up, that distinguishing, that point where the atmosphere is no longer reflecting enough light because there's not enough atmosphere, I should say. There's not enough. Hold up, let me finish, Zanuck. So as you're going up, you're incrementally getting less and less air that's reflecting light, right? So you would expect that as you're going up, that barrier, that line where the haze from like the atmosphere starts to turn into blackness from no atmosphere, it's going to stay low as you're going up. It's directly inversely proportional.
No,
Yeah,
because
Sonic. Well, he's saying
let me
if there's
finish.
no.
He went on
All
this
right, go ahead.
because real quick. So no, because we're at 10,000 feet and we're seeing over a 1.75 degree drop of the horizon. We know there's air because the air is only 30% less dense at 10,000 feet, so you can breathe it just fine. And you see objects, and then by the way, to prove this point, you can still see the sun setting below your level line. So you can see out level. It's level to 10,000 feet, and the surface of the Earth is not there, straight ahead.
What do you mean? You can see level? Is your horizon at your eye level or not?
No, it's below.
Okay, well then you're agreeing with me.
No, but between level and the surface, you see the sun. So why are you saying the sun then?
The sun is going to appear lower in your that's just perspective, how it appears in your field of view. We're not talking about the sun right now.
It's not
We're talking about the horizon.
If it's eye level, that's how high it is above the surface. Literally.
Wait, how do you know the sun is at eye level?
Because if it is below eye level, it's definitely below eye level. Because it can't be above eye level if it's not below
Where is your eye level? How do you gauge it?
It's a horizontal straight line that's perpendicular to plumb, wherever you are.
Okay, so how are you gauging it though?
Above a level. Straight out.
All right.
If the Earth is flat, then you're going to see everything that's at eye level, even if you're 10,000 feet, will be right at eye level. So anything at your eye level will be 10,000 feet. So you're saying that the sun is 10,000 feet.
Everything that's at your eye level everything that's level will be level. That's basically what you're saying.
No. Everything that is level, on that straight line level, an orientation perpendicular to plumb, will be at 10,000 feet, whatever your distance is above the surface.
Obviously, if it's level to you, then it's going to be on the same level as you.
No. Well, yeah, exactly. So you're right. So it'll be the same level as you.
Yeah, but I'm saying that the horizon is going to be lower.
Not obviously, but here I know you went astray. Yes, that's true. If the Earth was flat, everything that's the same level as you, because we'd have parallel plumb lines and we'd have parallel horizontal lines that are all perpendicular to plumb. So anything that is 10,000, anything that is in your vision that is level with you, this orientation that's perpendicular to plumb and it's as straight as an arrow line to that object, whether it be the sun or anything else, if you can line up and it's perfectly level, that's how high it is above the surface. That's how perspective works. No, there's nothing to think about. That is the actual.
How did you find out if the sun is at your eye level?
Because I measure it. If it's at your eye level, that's where it is.
So you have like a water level going to the sun?
A water level that points to the direction of the sun. You have an orientation.
Just points to the direction the sun doesn't do anything because you still have perspective.
No,
that lowers things according to their distance.
That's how perspective works. Anything that's at your eye level, everything in your center of vision is at your exact height above the surface if the surface is flat. Yes, because perspective works like this. Everything at the center outward will be at the center point. That's where the center focal point is. And everything at the sides, like looking down a hallway, will all converge to the center from the sides, and all go up from the bottom, and all come down from the top. But they all meet at one specific point that is eye level.
That's ridiculous, Zanuck.
No,
that's like me saying, hold up, that's like me saying you have a plane flying away from you, and it's descending into the horizon. Now I take this water level, and I hold it up to my, it's going to be close to the horizon, right? So I take the water level, and I find the level, and it's pointing basically at the horizon, and so therefore the plane is at the same altitude as me. What?
No,
it's ridiculous.
I didn't say that at all. No.
That's basically what you're saying, though. If you use a water level and you point to it...
Stop. I heard everything you said. Here's my answer to you.
Okay, go ahead.
That's because the Earth is round. Because you see the plane... Hold on. The plane's at 30,000... And I've seen this before, by the way. I've seen the planes from a 1,000-foot building in Honolulu, looking at planes sink into the horizon, which is below eye level. So they're below me. They're actually physically below me because of... Not below me. Below me. It's just below me, goddammit. In the distance, probably 200, 150 miles away, maybe 100 miles away, that plane is now below eye level, and it's below me. I literally,
Okay,
if I can zoom in, I can see like the tops of the wings. I'm so far above it. If you have that kind
I
of power,
understand the explanation, and it's a plausible a plausible explanation. But the issue is we have other explanations as well, which is that it could just be a matter of perspective. As things
no, but
go farther away, they get
that's
smaller
not
in
how
your field of view, even
but
though they
that's not how
maintain their
perspective.
altitude and everything,
But
right?
that's not how perspective works. No,
Hold up,
everything.
let me give you an example of why your explanation is a little bit weak. Because we have clouds that they're going far away, they're like, blending into the horizon, and the
Mhm.
angle of them, we don't see like the bottom of them or something like that. The angle of them to us isn't changing
Yeah,
as it
you
would if
don't
it
see the
was
bottom anymore. It's
rotating
exactly
around an
right.
Earth.
You don't see the
a
bottom
globe.
anymore, and that's a great point. You don't see when you have like these thunderclouds that are way far away. As storms leave Hawaii, that's a great place to look at things because you can see almost like 180 degree
No, hold up.
view of the ocean.
When I
Hold
said
on,
bottom,
let me
no, you
finish.
misunderstood me. Hold up, Zanuck.
No,
You
yeah,
misunderstood
the
me. When I
clouds are
said
still
bottom,
low.
Zanuck,
They're
1 second.
below.
1 second, Zanuck. When I said bottom, you misunderstood me. I didn't mean like you see the bottom of like the 2D image. I'm saying the underside. You're not seeing the underside of these clouds as they're, supposedly rolling around this globe, which you would expect to, right?
No, because you're above them. You're literally above them.
That doesn't matter. You're still saying
It
it's
does matter.
rolling.
If
No,
you
you're
have something
saying
in
it's
front of you,
rolling
if you have
around a globe.
if
You would
I have a
expect
box,
angle, like a difference in the viewing angle.
no, yes, the viewing is. Dude, you have to understand how perspective works. This is not that tricky. It's picture a triangle. You got a triangle. The bottom is flat. You are the upper. You're the adjacent on top of it of the 90-degree angle. That angle is looking down. It has to because it's a triangle. And if the bottom surface is flat, and you're 90 degrees opposed to that, that's the level surface. That angle will tell you exactly where that object should be. If you want to be straight in eye level, you won't have a triangle anymore. You have a box. You have a friggin' box, and you are at the top of the box looking straight ahead. That's how perspective works.
I don't think you addressed what I said at all.
Yes, I did. When you look at the clouds, for example, let's say you were able to sit there, you're in your little chair and you're going to watch for 2 hours, 3 hours as this fast moving storm leaves you. You see the bottoms of the clouds on top of you, and you see it go out in the distance, and you see more of the side, and then as it goes and it's really clear behind it, just this one big thundercloud. And as it goes farther and further away, it starts kissing and touching the horizon, and pretty soon all you see is the top of the thunderstorm. Now your eye level is at the top of this 30,000 foot thundercloud, but yet you're seeing the top of it. I've seen this before, by the way, also, where you see a thundercloud cut in half by the horizon, and it's below eye level because you're at this high building looking down at the horizon, and that's where the thundercloud is missing. So there's no lack of atmosphere. Everything, atmosphere's still there. Perspective works like I'm telling you it does.
I don't think you addressed what I was saying.
I am.
So imagine the cloud is a cat. Okay.
A what?
A cat.
A
And you're
cat?
seeing the cat. Yeah, a cat. It looks like a cat. All right. And has like the dimensions of a cat. 3D. Okay. This is a
Cloud
giant puffy cat.
Cloud cat with
Okay.
little thing streaming down.
So, you're looking at it initially when it's like close to you. You're
Mhm.
seeing it, and you have the 2D image, right? You just see the cat like in profile. You see one side of it, the head, body, tail,
You don't
right?
see the bottom. You don't see the bottom of its.
No, you just see like you see the feet, but you don't see the underside.
Why not? Because it's above you. Why wouldn't you see the underside?
I said close to you. I didn't say right above you.
Even if it's 5 miles away, you still see the underside of it.
No, so we're only seeing
What? How could you not see
the
the
angle
underside
that.
of the cloud 5 miles
Listen,
away?
the angle that the cat is, it's angled such that we
So it's
see the
angled away from
2D
you.
image. Okay.
So it's a cat, but it's angled away from you. So it's got a
Sure,
low
or
pressure,
or
it's
angled close
got
to
a
you.
low pressure front on the other side of it. So the cloud has actually got a dramatic angle away from you.
I would
Up.
say it's angled towards you, but
But if it's
whatever.
angled toward you, then you'd see the whole bottom of it. So it's angled away from you.
I don't know how you're
Picture your hand
imagine
out.
cats, but in any case,
Well, I mean, why are you using a cat? I mean, this is like the lamest. Come on, you're better.
don't worry about
This
it.
is unlike you. You give some.
I like cats, man.
Usually, you're pretty spot on with your.
Relax, man. I like cats. Maybe
Forget
you're a
the cat.
dog person, but
Give me a
dogs
how about a
stink.
box?
Dogs
How about a
literally
box?
stink.
How about
Anyways,
a box?
so the cat is angled such that you see the side of it. You
All right,
see the
yeah.
profile,
So it's angled away
right?
from you. Right.
As it's moving away, it's converging into the horizon.
The
If it's
feeder angle.
going, hold up, Zen.
Wait, no, the feeder angled away. Then the feeder angled away from you. The feet are farther away
Yeah,
than
that's
the top of
what
the
I
cat.
meant. That's why
Okay.
the cat is
That's
angled
an angle
towards you,
away.
because the torso
Angle
of
away, so you
everything,
don't. Yeah, so you don't
it's
see it.
angled towards
Got it.
you. Now you're getting
No,
it.
if it's angled toward you, then you'd be able to see the bottom of the feet. It's angled away from you. The legs of the cat are going to be moved away from you.
The
So it's
legs
gotta
are
be
away from you. The body's towards you. That's why it
very
looks
good.
profile.
Great.
So is a
Back.
cat more the like? Anyways, we're getting besides the point. So
You brought up
the
cat.
cat cloud is going towards the horizon, right?
Mhm.
And if the Earth is a globe and it's rolling around this, this globe, you would
Mhm.
expect that the feet relative to the torso would kind of like, straighten out, and then eventually you'll see the underbelly,
Oh, right, yeah.
the
Yeah.
belly of the cat, right?
Mhm, mhm.
There'd be a change in the viewing angle
Yes.
looking at this 3D object, right?
Mhm. Right.
But we don't see that with clouds. That's why I'm saying
Well,
your
thunderclouds.
explanation of it being a globe isn't necessarily, the strongest one.
Well, if you had you kind of so some storm systems, if they have they're local, they're small and they go away, but they have like maybe 5 or 10 miles in length. You will see the sun shine up, and you can see the underside of these things, and more than you would if you're above you. But you have to have a strong telescope and look at those clouds disappearing over a very clear day at a distance of probably 30, 40 miles. You might see that. But remember, we're only looking at a 1 degree change, so it's very difficult to see that 1 degree change over 60 miles. And you're not going to see much farther than 60 miles very clearly. I mean, you can. Actually, yeah, you can. It's actually pretty easy to see that, especially with the telescope. You see over 100 miles.
We would expect to see more of a degree of change if we're higher in altitude, right?
Well, that's only because you'd see it further. You see it further away. Wherever you are, it's 1 degree per 60 miles. So if you can get 120 miles, which is plausible, 2 degrees at 120 miles. If you can get a zoom in, strong like a plane.
So let's say we were in a hot air balloon, okay, and we're just floating there,
right?
And we're in the clouds, right?
Mm-hmm.
And then it gets
Now
to be
you
like
can-
the clouds.
Now you can see close to 300-400 miles.
Mm-hmm. So the clouds are moving, right? We're in the clouds.
No, you cannot.
These are like
Sure
some
you
sort
can.
of these
You
are
can-
like some
absolutely.
cumulus. Hold up a second. So these are like some like cumulus clouds. They're
If you're
moving,
at
right?
30,000 feet, you see
Lord.
250 miles. That's the ground. The things in the air, you see a lot farther. You can see up to 400 miles if you have a telescope on an airplane.
So I'm going to let percentage finish, but I'm also going to disagree with you and tell you it's about 120 miles at 30,000 feet. But we'll leave it there and let percentage finish.
Sounds good, and I appreciate that.
30,000 feet, I can see the sea. When I take off
Let's
SSO,
let him
hold
finish.
on. When I
Or-
take off when I take up FSO, I can't even talk this tonight. It's too late. Too much tequila. SFO, San Francisco. I can see the Sierras clear as day right when I take off. Right when we get up, we circle up before we take off and head to the east. And that's 240 miles away, so you can see them clearly.
I mean, let's not
Okay,
forget that
I
diffraction
agree with you.
plays
I agree with you, man.
All right. So you're up in a hot air balloon, right? And now the clouds have like died out. There's just one cloud beside you, and you see again the cat perfectly in profile. You're at the cat's level, so it's not angled away from you or anything, right?
Mm-hmm.
It's perfectly profile, and it's moving. And after a while, you would definitely expect, since you're so high up, you're at the level of the clouds, that
Mhm.
you would appreciate the angle change and see the belly of this cat cloud, right?
Right. So it's like let's say you get that'd be the perfect test for you, and this is what you need to do sometime in your life, your bucket list. Go
Well,
up.
Kosho's the one that was going to buy a hot air balloon, so.
Well, yeah. Well,
I
think you might want to do it on a day that maybe. Yeah, hell, it might work. You can get it to 10,000 feet, but that's actually pretty high for a balloon. But you probably can do it. 10,000 feet.
You don't have to be perfectly at the level of it. The point is
Well,
that you'll see more, so
bottom,
it'll be more of an angle change.
If the bottom of the thunderstorm is, you probably do this Midwest. A lot of these thunderstorms have a low ceiling, maybe a 2,000, 3,000 foot ceiling.
I don't think thunderstorms will be good for it.
Well, no, but the reason I like a thunderstorm is because you could get right to that level, because it's almost like a lot of these will be a straight line, and you can watch the thunderstorm move away, and then as it gets to be, 100 miles away, 150 miles away, 200 miles away, maybe if you go a little higher, you might start seeing the bottom side of the thunderstorm, and that would indicate curvature. Because now it's it's flat because you saw it when you lined up with it. When 5-6 miles away, you went up after the thunderstorm passed. You see it dumping rain. You see the flat bottom, the anvil shape of this thing, and as you wait, you see it. You can see that 1 or 2 degree change now of the bottom of the thunderstorm. That would be a good test. If you could zoom
What's
in.
it called when the winds afloat? So I think the best would be not thunderstorm or cumulonimbus clouds because they are like.
Yeah, we want a flat bottom. We want an anvil thunderstorm, right? Flat bottom.
I don't know about that. I think maybe cumulus clouds, like the puffy ones with like
there's no shape.
Fast winds aloft speed. Like you can check aviationweather.gov or whatever and get like.
Then there's no
day.
shape. You can't really see. Then you can't really tell.
No, the cumulus clouds are puffy. They do have
No, they don't have a flat. You want a flat bottom. That's what I'm saying. You want a flat bottom. So I'm trying to give you some meat here. You got the flat bottom of a thunderstorm, cumulonimbus cloud, and as it moves away from you, you'll start seeing this flat bottom start facing you. You'll start facing. It'll start tilting towards you.
Yeah.
That'd be a great test.
It's easier to.
But I mean, you got to get a telescope. You got to be on this hot air balloon. You got to be at the same height, which is not that hard to do. I think
not necessarily the same height, but you just have to be high enough to appreciate the angle change.
Because if you're too low, you'll see under it, and then as it goes away, you won't have the same effect. You want to be able to see the bottom of it when you couldn't see the bottom of it.
No. It doesn't matter if we see under it because if we're low and it's a flat bottom, even as it's rolling away, if we have enough of an angle change, we'll notice that the bottom is no longer flat. It's going to be taking on the shape of that front area, So edge, it's going to be taking on that shape.
You're going to have a very small angle to start with, and you're going to see if what the change of that angle is down the road, and that's going to be very difficult to detect because we're talking about 2 degrees. Now, if you have no angle to begin with, it's your level with it. Now it's going to be very easy to say, "Oh, I see the bottom now," where I didn't see the bottom before. So 1 or 2 degrees is very easy that way.
Do you
it's
think
like anything? You need to have a reference point. If you were looking at the bottom of the thundercloud and you're below it, you're not going to be able to tell. Because let's say it's the shape of a perfect trapezoid. Well, if that shape of the cloud changes as it moves, then you're not going to tell. You can't. There's no reference point. You'll be able to tell where you are. But if it's flat and you're at 10,000, it's more like 3,000 feet or 4,000. Let's say it's 5,000 feet. That's what you'd want, like 5,000 feet, because that gives you distance too to see 60 or 70 miles away, and it'll be closer.
This is a good talk and all, but you keep on saying like you need, and I'm just gonna let you know that it's your claim, and it's the burden of proof is on you. You should be doing this.
And I did something much. So I already did this, and I gave it much more simple. I have a heads-up display. I've shown you the sun and the moon at 40,000 feet well below level.
No, but that doesn't help us, man.
Yes, it does. That tells you
the sun and the moon are both circular. We can't really appreciate
the
undersides or whatever. You can't do that.
No, we're talking about where it is in your field of view. Because you still don't see. If you understand,
I'm not talking about where it is in the field of view. I'm talking about the actual angle change of a 3D object.
No, I know what you're trying to do. That's very difficult to do. It's like looking at camber from the side of a car to see what hey, hot rod, what's your camber setup? What do you think it is, tough guy? I don't know. I'm looking at the side of the car. How can I tell? Right?
No, it's not the same.
Did you go to another super spreader party?
Why? Does it sound congested?
Because it sounds like you did, man. Sounds like you had some more tequila at a super.
Oh,
super spreader party.
Super spreader party. I'm getting.
Like you were saying it earlier.
I know. I'm getting phone calls from all the people. Like, you got COVID? I know. I got a test comes in tomorrow. All right, let me know. I kind of have a runny nose. You think I got it? No, I can't got it. I don't know.
I just want to say, I disagreed. I mean, I agreed with you before for percentage's sake. I disagree with you, and I also want to predict that I think that you looked it up since then because it sounds like you gave a different distance. I think.
I've always been like 30,000 feet. Got 225 miles. That's what the. If you can have a glide path.
Okay, but I'm just saying, a hot air balloon you can't see 400 miles. That's what I'm saying.
No, I don't think so either.
I can't remember the exact height from 30,000 feet, but
I think hot air balloons probably go 5,000 feet. Can you get 10,000 feet?
Yeah, 5 to 10. Yeah.
If you got 10,000 feet,
10 would be pretty high.
What's the distance you can see at 10,000? See, I'm flying in a Cessna, so I thought you'd be good. I should know this. How far can
and
I
then
see?
also, I want to ask you a question. Whenever I don't want to take away from.
At least 100 miles, I'd say.
No, you're G, man. Go ahead.
Well, it's actually in the same realm of what y'all are talking about because me and Silent Zero were talking about this. Something similar as well. Let me look at. I'm still doing this math real quick. Yeah. Okay. I said 120. I was guess more like 200. All right, Janik. All right.
Yeah, you can just look at the plane when you take off, and you can see some pretty incredible
You said
landmarks.
400 from the balloon, but who cares about that? I
Looks like
posted a
both
picture.
right and both wrong.
Yeah, we're both right.
No, I didn't say
posted a
400 from the
picture.
balloon. I don't think I said 400 from the balloon.
You said 300 or 400, but you
From the
also did.
balloon? I said the balloon was at 30,000 feet, maybe.
Yeah, well, you did change what I'm saying. We
yeah.
Yeah, he
Oh,
revised the altitude.
no,
with
no,
the
no.
revised
I know what you misunderstood. So if you jumped
You're
in,
good,
then
man.
no. Kirsho.
Once again, I'm wrong, sir.
Hold on. No. I think you didn't hear what I said. So 400 miles away of something in the air. So if you're just watching an airplane or clouds, you can see clouds.
Oh yeah, so you guys are talking about clouds too.
Yeah,
That's true.
clouds, not the ground. Yeah, you're right.
All right.
I've always my canned answer since day one has always been like I think it's always said like 2.25 from 30,000 feet.
No, but at that point we were talking about the ground.
Yeah, no. I was talking about clouds in the distance. You see an airplane or a
I
cloud.
know Zanuck.
Go
That's what I like about
down.
knowing.
Okay.
You can see that
I know
cloud.
Zanuck, and the percentage is right, but I know that Zanuck in his head he was thinking about objects in the sky because we were
Yeah,
talking
that
about
makes
objects in the sky.
Yeah.
So
Everyone knows. Everyone in the globe Earth argument that's been here long enough knows this maximum distance we see on a flat plane is, what is it, 270, 250, whatever that record is, right?
273, yeah.
Yeah, and that's with
But that's
refraction.
mountains.
Yeah.
Still, that's mountains though. That's what's crazy about it. That's why I made the meme where I added their horizons together, because from the horizon of the observer and the horizon of the other mountain, if you add them together and they're the same distance as the distance between them, then surely you could see one another. That's my point. But regardless, I posted something a little while ago, Zanuck, and I posted it again just now because it's what you guys were talking about. But me and Silent Zero and Brian Leakey were talking about this.
Right.
And you're a smart guy, Zanuck. You're probably one of the smartest dudes in this arena. And
I don't know about that. We both,
yeah, well, they said,
yourself.
they said I was stupid. I don't understand this stuff. But the way I understand perspective strictly, not refraction or Earth's curvature, but perspective on a flat plane.
Mhm.
If the crux of all these angles there is the observer, and that blue object is some building, then that middle line is his eye line, right?
Okay,
And
it goes. It's like it's bisecting the green.
yeah, exactly. Exactly.
What are
Exactly.
those blue? What are the blue things? What are the blue things?
That whole blue thing is a building. The whole blue thing is a building. That green part is just a portion that that his eye line is bisecting.
That's the first 5 floors. That's like the big.
Yeah, no, well, let's say he's 6 feet. Let's say he's 6 feet, and then the bottom part of the building is 6 feet and below, and top part is 6 feet above that, right?
Okay.
So, due to what you understand about perspective and this drawing, both those portions, that's 5 degrees, by the way. So the 5 degrees above his eye line and the 5 degrees below his eye line, due to perspective, they should behave the same way in your vision as you move away from them. Due to only perspective, meaning they should decrease or shrink at the same rate. They should disappear at the same time. Like there shouldn't be anything special about that top part, that top angle, and that bottom 5 degrees. Like those 5 degrees should basically be doing the same thing in your vision.
Exactly.
Okay, yeah, that's exactly what I was saying. But they're saying for some reason, and as they were explaining to me, I said I don't understand it. But they're saying the bottom part does something different.
Well,
and I
Flat
understand.
Earth Data, he starts trying to conflate the Rayleigh criterion with perspective, and then he starts confusing the 1.22 value of the 1.2 foot observer for the 1.2 mile, or the 1 foot observer for the 1.2 mile distance, with the 1.21 value times the diameter of the aperture divided by the wavelength for the diffractive angle.
I know his whole argument.
Yeah, it's ridiculous. You have it dead on. You're looking at that door, and that mark is your eyes are right at 5 feet because you're a 6 foot guy or whatever. That's a big tall head, but you know what I'm saying. And above it would be looks like 3 feet above it, and looks like 3 feet below it for the 5 degree.
Sure, yeah.
And if you move away, that center line never moves if the surface is flat, and the two 5 degree angles will obviously scribe a point higher and lower on both on the building.
But they'll both still encompass the same portion of your vision, or they'll equal portions of your vision, even though as you move away, those portions will decrease. Obviously,
they will. Yeah, that's a good drawing. That point is what gets by a lot of people. Exactly right. That angle will always be 5 degrees, and you always have 5 degrees beneath it and 5 degrees above it. We know this because that'll be the angular size of you, 5 feet, divided by the distance to it, inverse tangent. That'll tell you the angle, and that'll tell you the size of that person or that door, or how much is above you and below you.
Yeah, and the point that was being made by one of them was correct about the bottom, about how the ground is going to be doing something different than the sky, because there's obviously the lines on the ground, the lines below your eye level are shorter than the lines above it, and so that's true for the lines that are below that 5 degrees. They're going to take up the whole bottom part of your vision, while the top part of your vision is going to be full of everything else that's up there. But that 5 degrees above and below it are going to be, or
compressed or something.
They're not going to be doing anything different than each other.
Yeah. Oh, I have a good test for it. Here's a response to that, Kosho. Invert it. So now you're the green person. The green person is the 6 foot tall person, and the center line's at 6 foot per height. And he's got a big tall hat that's 5-6 feet above his head. The center point is 6 feet. Okay, just like you said. If you take 6 feet and you take the distance to the left, that intersection of all those lines, you say that's 5 miles away. You take the height, or 3 miles away. You take the height of 6 feet and divide that by the 3 miles, 15,000 feet or so, and take inverse tangent, and that'll tell you exactly how high that person should be.
I'm making another drawing too. What the hell is that? I'm making another drawing too to try and.
Sorry, the angle. It would tell you the angular size of that person. So the angular size. Sorry, I misspoke. Angular size of that dot. So the dot that where all these lines converge to the ground, you would get an angular size of that value, and that angular size would be. Give me a distance. How far you think that dot is away from the green door, whatever you want to call that thing.
Let's make sure that it's on a globe and there'd be a horizon. So let's just say 10 miles. For the sake of it.
So it's 10 miles.
No, let's say it's got to be discernible, though. So let's just say it's closer, like 3 miles.
So 3 miles. So 3 miles is, call it 15,000 feet. So we're going to take 6 feet and divide it by 15,000 feet. And that gets us 6 feet divided by 15,000 feet. God damn this calculator. 3 miles. 1,500. That's not working. There it is. That's 0.000. 3 zeros and a 2. Now we take inverse tangent of that. Inverse tangent. That gets us 0.011 degrees. That would be the angular size of whatever's at your eye level to the base of that object. So let's say it was a big stick. And that stick was the same height as your eye level, which is that center line. The angular size would be 0.01 degrees. Or in other words, in other words, it'd be 0.01 degrees above the surface. But if you measure it, in reality, it's going to be lower than that. It's going to be right on the surface. In fact, the eyes would probably be right at the surface there, right? So you won't have that. It'd be 0.2 degrees, and there's that number we always come up with, 0.2 degrees, right?
Exactly. That's why I use that. I think because that's
0.02 degrees. So
yeah, exactly.
The angular size is 0.0.
I think I remember at about 3 miles, 0.02 degrees is about 6 feet.
Yeah. So I and you can do this test, and that's it's moved because it's refraction, blah blah blah. But yeah, as far as perspective goes, that's dead on. You got the exact right idea there.
Yeah, exactly. Because you can bring up other things like the curvature of the Earth, for example. Like just because you see an observation different than this one doesn't mean that perspective doesn't work this way. That just means that something else is, resulting in that the way you're seeing things. And we claim a lot of times the curvature of the Earth is going to obviously change how things appear to you, or even refraction. But if you're going to claim that something's happening due to perspective, then it's not going to do anything different than it's not going to be behaved differently than this.
Right.
I think what the claim was earlier was that the things disappear bottom up because the bottom part of the building or whatever it is going to scrunch up and become unresolvable before the top part does. And it's not true for similar portions above and below your eye line.
Yeah. Okay. I think I put the actual number in there. It's 15,750 feet rather than 15,000. I made a little difference. And you divide that, and then 6 feet divided by that. It's a bunch of zeros into something. Inverse tangent, 0.02 degrees. That gets you the angular size of whatever's in the distance at the same height as you to the surface, 0.02 degrees. Or in other words, if you're looking level, you'd be eye level with that stick at 6 feet, and the bottom, from the top to the bottom, be 0.02 degrees. Or you could say I have to dip to the feet of that thing, 0.02 degrees. The surface would be 0.02 degrees down. But when we measure it, we see 0.04 degrees, right?
Yeah.
So, and why does it point? So we just did the trig. Why is it 0.04 if it's supposed to be 0.02? That's a good number to kind of keep in your head from now on. I'll have to put that in a.
Well, that's why. Yeah. I mean, I remember from we did this thing before. Yeah.
But your point.
I don't want to. Yeah. Go ahead.
And your point, yeah, is pretty well taken because I forget who was over there on the 24/7 server. They were big on this whole. Remember, we took all their little drawings. They had the guy's eye, and he's looking at the building and why the bottom's compressed. I forget who that was. It was like
Indio was the big guy.
Yeah, Indio, that's right. Indio,
Yeah,
that was his deal.
He before Quantum Eraser and a few others. A lot of the arguments were kind of derived from him, and I thought some of them were pretty. They were enough to keep you talking about it for a while because they weren't that bad.
Well, then we pull up the but not the Pasatiempo Bridge, the Pontchartrain Bridge, and look at those. That's the biggest bit of evidence we got. I mean, that's really the most damning because that's like, look, we got these huge massive buildings, 60-story, 30-story, right next to each other. One's completely missing, and you can see all the floors of exactly that what is missing of the other building missing on that building as well, but it's still got 20 floors above it. Where did it go? Where'd the building go? I mean, you're just looking at it. It's not refracted. The windows aren't getting.
Oh yeah, right. Or that cruise ship. That cruise ship that doesn't change in size. You can still see the size hasn't changed, but you see the bottom part of it. Then you can only see the smokestacks at one point.
Oh, then he said, the smokestacks. Why are the smokestacks not going? This is the funny part, right? That they always bring up. Why the smokestacks not getting smaller when the ship is 10 miles further away? Because they're zooming in on it. They're zooming in more and more in on it. That's why. They don't get that part of it. They think, oh, I got you. I got you. If they were going further away, then that smokestack should be smaller. And it's not. So you're wrong.
Yeah. I just I got into it a little bit with Silent Zero and Brian. And truth be told, I don't know. I probably lost my cool a little bit, but I picked up this chick right after that. I was like, I gotta go, guys. I had to pick up this chick, and my mojo was all gone.
You're all edgy with her.
Yeah, well, I wasn't. I was just like, I don't know. I don't know. I felt like an idiot, so I had to come back and
Well, no,
I messed up, man.
So my girl, when she knows when something, she goes, "What's wrong with you? Why are you so keyed up?" Nothing. Everything's fine. Were you talking to those flat earthers?
I bet, man.
Why don't you just have a beer and relax? Yeah.
Every girl I've dated has always been like that. Every girl I've dated and my friends, and my family, everybody. I mean, it's they all see it. They all
my
see it.
God.
So
My son came up from college today. I unexpectedly, and he walks in. We had breakfast, hung out together. Then I got kind of bored. I was doing some work, and then I had a break, and I just clicked on the Earthling, what that other server is, and he was like, he stopped and had to listen. It was so funny because they had Broomy in there fighting like the Dickens about something just so crazy. I forget what it was today. Just screaming, and he's talking, because he talks over people more than anybody. He's a
yeah.
So here's this boxer. He's obviously, you see pictures of the guy. He's always been in these kick-ass fights, getting his face bashed in and beating other people up too. You figure his brain's got to be suffering, well, and it kind of shows.
Oh, Brummy, you're saying?
Yeah,
Oh, you said
Brummy.
your son was a boxer.
No, he was, my son.
What's your son studying?
He's computer science. He's the
Okay,
yeah.
that's cool, man. I know you got a talented family because I know you said some things about your predecessors.
Yeah,
Your
uncles.
grandpa, at least.
Yeah, there's some I don't know where I didn't get all those genes. They were amazing. Some of these people, but but here we are, man. We're still here, Coach. You and me against the world.
Yeah. Well, I think you're the same mind as me, man. Wherever, because people think that we're trying to change people's minds and like end the flat Earth or something like that. And of course, we're trying to make sure our arguments are constructive and people are finding them useful and stuff. But I don't think you or I, we don't want the flat Earth to end. We
No,
don't want
we
it to go
don't.
away or something. Yeah.
No way. What would we do in our spare time?
This is actually this is an amazing hobby. Most people I know could understand it, but this hobby for me is exactly what I like to do, man. This are all the topics I like talking about. You know what I mean?
Yeah.
Like all the subjects I like looking into, and
I like it because it really puts a name and a face to all the concepts that seem like they had no purpose when I was studying them. They're like, I'm going to use this. I don't need. I just just score the test, cheat, whatever you got to do, just get through this class. What's your answer for 17? Oh, B. Okay, great. And then
what do
you
you think?
get out and you realize, oh, I want to really understand this now. Like someone talks about entropy. I mean, I want to know it. I don't want to just give the canned answer.
Right, exactly.
I want to know the difference between a Boltzmann and a Clausian perspective of entropy. And I want to know.
Right.
I was looking at the Feynman paper. I hadn't seen that paper that Charlie had sent me today. And we've all seen a lot of his presentations and things and some of his writings, but I hadn't seen this particular one. And it was pretty. As an overview, it wasn't that complicated, but it was complicated in concept. Like some of the concepts were, especially the Carnot engines and things. And it just makes you think. Like I still don't have a total. I want to really know it like the back of my hand, not just pass the test, but I want to
understand
really know. Yeah. So it's fortunate to do that about a lot of things, right?
Exactly. I was going to do this before, but I never got the chance to actualize it. But I wanted to start like a camp, like a 2-week camp for kids and whatever, and I was going to use it as a theme because I think that's actually a really powerful motivation tool, a tool to motivate people, kids or whatever, to learn these things as opposed to learning them because you have to learn them or whatever. It's like there's actually like there's a mechanism or there's like a point to learning them. Like you want to actually learn it because you want to. Yeah.
And the nice thing about it, and I've said this many times, man, there's so many. We go over so many different topics. We've gone over all sorts of different physics, geometry, trigonometry, optical sciences. It's really great. So I was talking to you. Did you hear us talking to Silent earlier?
Yeah.
And he's like, that guy. Yeah, I was talking to one of my friends who's an engineer or something, and I asked him about. We were arguing about the shape of the Earth, and I basically he was outmanned. He was outgunned. He couldn't. I go, you go, dude. I'm not going to argue with you. You got to go study this and come back. We'll talk later. He's that. He's this truck driver. He never studied physics in school. Now suddenly he has all the information to really have a good argument with anybody that's even technical, and they won't be able to stand up to him. And he's one of the common Joe flat Earth guys. I think it's pretty cool.
Exactly.
That's great.
Yeah, there's definitely flat earthers, even a lot of globers. Well, especially both sides in the argument. a lot of these topics, they have definitely a dense vocabulary and understanding, I guess you'd say. I mean, maybe not everyone has the full understanding, but they at least they know all the terms and kind of how they relate to each other. And so yeah, when they're talking to somebody who's not that same experience, or they might even work in the field and they're just not used to talking about all these things, yeah, they're not gonna be able to hang. Like you've seen it with Dave. Allegedly, Dave, he had one against this like German astrophysicist or something like that,
Right.
and yeah, he at least made it look like the guy was stumped in everything he asked him because he never heard these questions before.
Well, yeah, I when I think that's when I first got started with flat Earth. Allegedly, Dave going, "Are you kidding me?" I knew I could shut this guy down immediately. And then the guy that says his buddy, I think they hung out together and did like these panel discussions together. Well, if the Earth, what was the presentation? He says, "Oh, if the horizon is down, then it's down over to the left too, and it's down behind me. Then what are we living on McDonald's?" It's like they're just so clueless. They're so clueless. But that was
he was stumped. He was stumped at almost every question just because it's like the question he had no idea how to answer it. And I mean, they're nonsensical
he's
questions.
good. He had a lot of them. If you weren't kind of prepped, you would, or knew something about flight or flying or some kind of at least a physics guy, you could get blown out by allegedly Dave because he sounds intelligent. It's making sense to him, but to me, it's like, Dave, come on, man, get another hobby. You're kind of clueless.
I saw a documentary about Bill Nye recently, and they talked about the part where he debated who was it, Ken Ham or
about evolution, and he's walking around.
Yeah, exactly.
Yeah, they're walking around the Noah's Ark thing. Remember?
Yeah. He went there twice though in the documentary at least, and there was people who were actually protesting against the museum, but they were actually against Bill Nye as well because, and Bill Nye, a couple other people on Bill Nye's side agreed that debating like a person like that, debating people with those like a belief like that, it doesn't do anything good for
either side.
For that side, yeah, because it just acts as ammunition against against him. They use their words against him, and they use the fact that he's debated him, to bolster up his position and all sorts of type of stuff.
Right.
They said that he made the museum more popular. That's what they were claiming. They said Bill Nye made the museum more popular.
Well, if people believe in Noah's Ark and they believe in creationism, it just gives them a platform to take it and run with it. But see, Bill Nye is not the right guy. He's not an expert in those areas. He's using all the arguments that all the flat earthers hate. Basically, because someone told you that, or you read that, or because 90% of the scientists believe this. That's even with climate change. He'll fight vehemently against climate change. You know me, my position on that. I'm totally.
You cut out Xanax. At least on my end. Maybe it's me.
No, it's that.
She already. Yeah, sorry. Where did I leave off at?
You said climate change. And then
There was on TV. There was a program. This gal was talking about. She was like an oceanographer or something, saying that we're worried that San Francisco is going to be a real big, a real bad spot if we have an earthquake and the sea levels are rising. They've already risen 8 inches, and now they're going to supposed to raise 61 inches. Where's the time scale? And what 8 inches over the last 100 years? So the next 100 years we'll see another 8. You're saying it's going to be 61. That data is not substantiated anywhere. No one's ever said that it's going to be 61 inches in the next 100. We're still on track to do another 7 to 8 inches per another 100 years. Is that going to be a problem? Yeah, absolutely. It's going to be a problem. So fucking deal with it. Don't blame man for doing it. That's just one aspect of climate change, by the way. But we all know it's going to happen. How can we blame man for it happening or being a little more than the 8 inches? There's nothing to panic over. You need to take care of it. Take care of it. Build a bigger wall.
Yeah. I got a big argument with this chick. This is 12 years ago or whatever. But yeah, I got this because she was a green. What is I don't know. One of those. The big. What do you call that?
Tree hugger.
I've got. Yeah, what is it? It's called like Greenpeace maybe or something like that. I don't know what it was. But yeah, she was on the ground on the streets, trying to get me and my friend to donate some money or whatever. And I was just we ended up getting a debate a little bit, not because I disagree with climate change, but she was trying to like pull my heartstrings, and she was saying things like she was actually cursing at me at one point. She said that she's like, my fucking family lives in Louisiana and they fucking have to or they live in New Orleans and they have to fucking like lose their house and all this other type of stuff and they have to worry about this and that. And my response is like, why don't they just move?
Why don't you move? Yeah, get out of there then.
Yeah, exactly. Yeah,
It's
because
like
that's true. There's places that are going to be better or worse for the oceans are going to rise and the weather's going to be bad at different times for different places, and you just kind of got to know the domain. You know what I mean?
They built a lot of that city below sea
But the
level.
oceans aren't rising on average.
No, they are rising. That's 7 inches. They've risen 7 inches, and they're going to raise another 7 inches. They're not changing. They haven't changed in all the years that we've had data for it. But they keep on saying it's going to be more. It's going to be more than that 7 this time. Well, why? Even the last 50 years, we haven't seen more than 3.5 inches, which is double the 3.5 before that 50 years. So we've seen during this massive CO2, injected into our atmosphere, we've only seen the 3.5 inch sea level rise. So why do you think it's going to, during all this going on and all these temperatures that have been, we know they're rising a little bit. A degree and a half is not a big deal.
Why? Because are we coming out of a mini ice age or something? And
well, yeah,
like,
we're coming
the
out.
ice is all melting.
Yeah,
I think we're in the middle of an ice age.
We're coming out of a mini ice age right now. We came out of the little ice age that we came out of. We know that's known, and we had the Roman warming, we had the medieval warming. So we know that there's been warmer times, faster rates of warming too, back in the 1900s to 1940 when man wasn't putting precipitous amounts of CO2 in the atmosphere. What caused the warming then? Is it possible? And maybe ask your friends this too. Is it possible that maybe whatever caused it then could be causing it now? The layman should say, of course it's possible. Now, do you know? No, because most of these people are idiots. Most people in the government are idiots. No one's studying this. Only the scientists are really studying this and have the data to make their decisions. But people are also confident they know the answer. Oh, yeah, it's man. Man's the cause. It's doing all. Man's got to be bad. Well, we have to do something. Here's my analogy. The favorite comeback is we have to do something. So what if we knew an asteroid was coming? Would we just start firing bullets in the air at it? Just because we have to do something? Or what if your car can't get wet and it's raining? Are you going to start trying to dry your car off while it's raining with a towel? That's what we're talking about.
This is smart.
It's just stupid.
What do you think then? Yeah.
It's not that we shouldn't do anything. We should understand what's going on. And either if we can change things, let's try to change it. We can't churn all the gas off and be carbon neutral by 2050. It's going to cost us $100 trillion to do that. It's just stupid.
Well, you would disagree with this, but I think that I agree with that we should do something. And I also agree with the fact that I disagree with the supposed mandates and all that kind of stuff about CO2, just because I think it's part of a different agenda. I think it's a part of an agenda to try to.
They're trying to build an industry.
Like a what?
They're trying to build industries. They're going to take credit for the
no. Well, not so much.
It's a wealth distribution plan.
I think they're trying to use it as a way to have a global tax, like a global tax structure, where they take it from any country indiscriminately to a single source, and it kind of just opens the door for like a kind of centralized system similar to our federal government. But
it's like every time there's been major problems in the past, whether it get political or wars, these kind of things. You're right, and this could spark one of those kind of movements where suddenly things are more centralized globally, and then they're allowed to take the other country's money or your money, and give it to the rest of the central organization.
But what you were saying about the 3.5 inches, I'm curious about that because I think that it's changing. I would if before talking to you, I would have thought, with my limited knowledge about that, it was increasingly Like it is changing at a faster rate than usual because of our CO2 output, because we're introducing CO2 that wasn't there.
Remember the CO2. It's only the CO2 is only 0.04% of our atmosphere. So
right.
Very, very small amount. And I don't like that argument either. That's I shouldn't even say that, but that it is a little bit up there. It's not the dominant global. It's not the dominant. Not the dominant greenhouse gas. Water vapors are dominant. That's 75% of the greenhouse gases is water vapor. And besides that, we've only seen a 1.5 degree temperature change. No, about 1 degree over the last 100 years. So pre-industrial era, we're looking at only a 1 degree change. The benchmark for doubling CO2 from the pre-industrial ages, guess what it was? The benchmark was 1.9 or 2 degrees. We've only seen since that period 1 degree, and we're already 3/4 of the way there. And they're expecting 2 to 3 degrees. They're talking 2 to 3 degrees now. Well, if we've already like almost 75 to 80% to doubling, which was like 200 parts per million, and that's just 250, so we're going to be like 500 parts per million. If we're doubling it, we should see 3 degrees, but we're only seeing 1 degree, 1.25 degree total change. So they're way off, and the models have been way off their predictions, completely off. So they're a little bit, they're trying to sell us something so they can weaponize the EPA, so they can tax carbon, grab our money, and create these new industries, which we need.
Can you hear me?
I can hear you.
Yeah, I'm gonna post something about all the crisis that has been happening through the years, right? I mean, look,